everyone and welcome to the Generative AI full course. Generative AI is one of the most exciting advancements in artificial intelligence, enabling machines to create text, images, code, audio, and much more. From chatbots and content creation tools to design automation and intelligent assistants, Generative AI is transforming industries worldwide. In this course, you will explore the fundamentals of Generative AI, understand how models like LLMs and generative network work, and learn how these systems are built and applied in real-world scenarios. The course covers key concepts, practical techniques, and modern tools that power today's AI-driven applications. And by the end of this course, you will have a strong understanding of how generative AI works and how it is used to build innovative, intelligent solutions across different domains. So before we begin, please like, share and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's Generative AI Masters program. It is designed to help you build strong expertise in Generative AI, Python, data science, NLP, ChatGPT, LLM prompt engineering and Agentic AI. The program focuses on hands-on learning through real-world projects, expert-led training, and industry-relevant tools. By enrolling in this Generative AI certification program, you will gain practical skills to design, build, and deploy modern GenAI applications. So check out the course link given in the description box below. Now, let us get started by understanding what Generative AI is.
Simply put, it's a type of artificial intelligence that can produce new content across various formats. Here are a few areas where it's making a huge impact. First, content creation. It is generating text, articles, and blog posts, saving hours for writers and content creators. Next, image generation. Creating visuals or art from the text prompts as seen in models like DALL-E, now on its third version. Next, coding assistance. Providing code suggestions and completions with tools like GitHub Copilot helping developers. Next, language translation. Breaking down language barriers in real time through advanced translation models. Then, personalized healthcare. Enhancing medical treatments by tailoring recommendations based on individuals' patient data. And finally, marketing and optimization. It helps establish marketing strategies in businesses. And these capabilities make Generative AI a versatile technology that is reshaping industries. So let's examine some real-world applications and see how they work. Generative AI is at the core of many revolutionary applications today. We have text generation. From producing entire articles to summarizing content, tools like GPT-4 are transforming content creation across industries. Next, language translation. AI-powered translation tools are improving cross-language communications by understanding context. Then, writing assistants. Grammarly or similar tools refine grammar, tone and clarity, assisting professionals and students alike. Next, we have business AI. Models are making business insights accessible, automating support, and enhancing decision-making. Next, music generation. AI is now venturing into creativity, composing unique tracks and musical elements. Finally, machine learning models. Platforms like H2O.ai are giving access to machine learning models, allowing users without deep expertise to create powerful models. Now that we understood the potential of generative AI, and now let's go deeper into how it actually works. So to understand how generative AI operates, let's break down the process. First, define objective. So start with a clear goal, whether it's generating text, creating an image, or assisting with code. Next, gather and pre-process data. So collect and prepare data, ensuring it's clean and structured with the model. Then, choose appropriate model. So select or design a model tailored to your needs, sometimes building on pre-existing models. Next, train the model. Feed data into the model so it can learn patterns and build into knowledge base. Next, evaluate and refine. So fine-tune the model as needed to optimize its efficiency and accuracy. Then, test and validate. Run tests to measure performance and accuracy, ensuring it aligns with the objectives. And finally, deploy and iterate. So once ready, deploy the model and continue refining it with user feedback and data. And this cycle ensures generative AI models stay relevant and improve over time. Now, moving on to the examples of generative AI tools. So many generative AI tools are available today, each with its own speciality. Tools like GitHub Copilot for coding, DALL-E 3 for image generation, and advanced language models like GPT are among the top players. And if you're curious to explore these tools further, check out the video link in the description covering popular generative AI examples. Now, let's look at the growing presence of generative AI across different sectors. First, in healthcare. Generative AI is projected to reach a $17.2 billion market by 2032, transforming clinical applications and healthcare systems. Next, education. The AI-driven education market is expanding, especially for students, teachers, and administrators, making personalized learning more accessible. And then, workspace. Generative AI adoption is rising with the highest impact in marketing and tech industries, followed by sectors like consulting and healthcare. Each graph shows a significant trend as generative AI is becoming integral in diverse fields and reshaping workplace roles. As we look ahead, generative AI is set to transform even more areas. And here are some key impacts we can expect. In AI-driven creativity, from art to music, AI will open new creative horizons. Next, AI personalizations. Tailored user experience will become the norm. Then, real-time generation. Real-time content generation will improve virtual assistants and automated responses. Next, AI in architecture. AI will assist architects in design and material optimization. Then, human-AI collaboration. As AI matures, humans and AI will work in tandems to maximize productivity and innovation. Then, advanced AI models. We will see even more sophisticated models pushing the boundaries of what AI can achieve. Generative AI's future is promising, so with potential benefits that will enhance lives and drive economic growth. Now, are you guys ready to get hands-on? Stick around for a mini LLM project where we will build a YouTube video summarizer. We will show you how to extract video transcript, and then we will use an LLM to generate summaries and build a user-friendly interface using Streamlit. Are you excited? So now, let's jump in. So first things first, we need a solid environment for our project. First, open your terminal and let's create a new Conda environment to keep everything organized. Let's run the code using VS Code. You can also use other code editors such as PyCharm, but let's use VS Code for now. Now, in the terminal, let's type the command for setting up the Conda environment in your editor. For that, run this command. Just type conda create -p virtual environment, which is venv python, and equal to, we are using 3.10, which is the Python version, and give -y. Here, the -p venv specifies the path and the environment name, while the -y skips prompt for a smoother install. So now, while that's setting up, let's create a few essential files. So first, we will create a .env file for our API keys and environment variables. Next, we will create a requirements.txt file for the libraries we will need, such as YouTube Transcript API to extract transcript from YouTube, and Streamlit for our front end, then Google Generative for accessing the Google Gemini API, also the python.env for handling environment variables, and pathlib for the better path management. Now, with our files in place, let's set up the Google Gemini API access. Now, head over to the makersuite.google.com, and as you can see on the screen in the top left corner, you will get the API key interface. And once you click that, it will redirect us to the API key interface. Here, you can see a button which is Create API Key. So simply click on that and select your model and press Create API Key in the existing project, and then your API key will be generated. Now, copy your API key, and once you have got the API key, open your environment file and add it there. So for that, let's create a variable Google_API_key. Over here, we will paste the API key. So once that is done, back in the terminal, activate your new environment with the command conda activate virtual environment / which is VENV. Since I've already installed Conda in my system, it's not taking much time. So while you're installing, it might take little time. Now let us install requirements.txt in our terminal. And for that, the command is pip install -r requirements.txt. So once you enter, the files present in the requirements.txt will get installed. Awesome. So now let's move to the main code setup. So for that, open app.py and start with imports. First, let us import some important libraries. So for that, import Streamlit as st. From .env, import load.env, and next load_.env, which will load environment variables. And next, let's import google.generative as GenAI, and also import OS, and from YouTube transcript API, import YouTube transcript API. So let's go to the YouTube transcript API and check if you're doing it correctly, because in some system it doesn't work. So you can simply go here and copy this command and paste it into your terminal. Now let's move on to configure the API key. So for that, just type genai.configure and inside the bracket, just type API_key equal to os.getEnv, and inside the bracket, let's add the Google API key here. Now, to prompt our model, we will use a template like this. So simply type, please summarize this YouTube video transcript in 250 words or less, highlighting key points. Now moving on to extracting YouTube transcript. So for that, to fetch the transcript, we will create a function. So here in this code, as you can see on the screen, the function extract transcript details takes the YouTube URL as an input and retrieves the transcript of the video if available. First, it extracts the video ID from the URL by splitting the URL at the equal sign and taking the second part. And using YouTube transcript API.getTranscript video ID, it fetches the transcript data for the video ID. And it then combines the text from each part of the transcript into a single string. And if there is an error, like example, no transcript available, it prints the error and returns none. So this function effectively converts a YouTube video URL into its textual transcript. Next, let's write a function to generate the summary. Here, the generate Gemini content function generates the content based on the combination of transcript text and a prompt. So it first initializes a generative AI model called Gemini, and then the model creates a content processing the combined input of prompt and transcript text. And finally, it returns the generated text from the model's response. So this function effectively uses the Gemini model to produce AI-generated content based on the specific text inputs. Now, let's move on to building the front end. Now to connect it all with Streamlit, first add a button labeled Get Detailed Notes. So when clicked, it prompts the user to enter a YouTube link in a text input field. And it uses the Extract Transcript Details YouTube link to get video transcript. So if the transcript is successfully retrieved, it generates a detailed summary with Generate Gemini Content, Transcript Text or Prompt. So finally, it displays the summary under the headings Detailed Summary. Now let's give a finishing touch to our app. So for that, let's make it look great. You can add headers and also you can give a footer, and maybe you can also add a YouTube icon to it, and even customize colors. And incorporating thumbnails, if the link is valid, will create an even richer experience. Now let us test the app. So finally, let's run a command, streamlit run app.py. As you can see on the screen, our app is successfully running, and now let's check if it's running fine. So for that, let's open our YouTube, and here select a video that you want a summary of. So copy the link, paste a YouTube link into the app and hit generate. As you can see on the screen, it is running, and in just a second, you will get the summary of the video. It has given us the summary of the video. Also, there is no limit to the app and it will consider even the longer videos. And that's it. With just a few lines of code, we created a powerful YouTube summarizer using Streamlit and Google Gemini. If you enjoyed building this, stay tuned for more AI projects.
In 1932, George Armstrong invented a machine he reportedly called the mechanical brain to translate between languages using a mechanical computer encoded onto punch cards. And then, in 1966, MIT professor Joseph Weizenbaum created the first chatbot, Eliza, which simulates conversation with a psychotherapist. And in 2011, Apple released Siri, a voice-powered personal assistant that generates responses and takes action in response to voice requests. Also, by the end of 2022, OpenAI developed ChatGPT, which was trained on 40 gigabytes of data and consists of 117 million parameters. GPT paves the way for subsequent language models in content generation, chatbots, and language translation. So, the preparation of generative AI started before 1932 and is still developing at much faster rate. So, let us now explore its real-world impact. Well, generative AI has a wide range of application across various industries, transforming the way we create and interact with content. So let's take a look at some of the most compelling use cases. The following image shows a flowchart of advancement in healthcare technology. So it starts with general healthcare and then moves to medical image synthesis for better diagnostics, and next is drug discovery and development, followed by personalized medicine, which tailors treatments to individual patients for better care and outcomes. And the next image displays a flowchart of developments in finance and trading. So it begins with general finance and trading, followed by algorithmic trading, which automates trades, and then it shows predictive market analysis to forecast trends, and finally, the high-frequency trading algorithms that quickly execute trades to take advantage of small market movements. And the next image shows the growth of AI-powered content creation. It starts with the basic content creation and then moves to generating art and music, followed by automating content for marketing, and finally, with the development of virtual assistants and chatbots, highlighting how AI is improving content production. And the last image illustrates the progression of AI in natural language processing. So it starts with basic NLP and then text generation for content creation, followed by sentiment analysis, and finally the language translation that includes sentiment analysis, showing how AI is becoming more advanced in understanding and interacting with human language. I hope you all got an idea now on how AI is shaping these industries and making tasks easier and more efficient. Now, moving on to the impact of generative AI on industries. So the image provides a breakdown of the impact of generative AI across various industries, categorizing tasks into 4 key areas, such as higher potential for automation, higher potential for augmentation, lower potential for augmentation and automation, and non-language tasks. So the data shows that the industries like banking, insurance, and software have a higher potential for automation, while the sectors like natural resources, the customer goods have a lower potential. So this analysis provides a valuable insights for businesses seeking to leverage AI for efficiency and innovation. Now, let us explore the forefront of generative AI with these powerful tools. From coding assistants like GitHub Copilot to text generators like Writesonic and image creators like Midjourney, these innovative platforms are transforming industries and unlocking new creative possibilities. So join us as we explore the diverse landscape of generative AI and its potential to transform how we work and create. First on the list, we have GPT-4. GPT-4 is a state-of-the-art language model capable of generating human-quality text, translating languages, writing different kinds of creative content, and answering your questions in an informative way. Its advanced features include improved factual accuracy, reduced bias, and the ability to handle more complex prompts. So GPT-4 can be used for various applications such as content creation, customer service, language translation, and education. So as you can see the screen, we are on the ChatGPT site, and on the left corner you can see 3 icons. So the first icon shows the history. So suppose you have deleted any prompt, you can go to this and you can check. And the second icon shows a new chat section. So here you can create multiple chats. And the third icon shows the ChatGPT updates. So you can get different updates related to the model here. Now, the text bar in the middle shows the area where you can write different prompts and press enter to get the answer or the solution you want. So I have a prompt for you guys. So let's test it on ChatGPT and evaluate its performance. So let me just enter the prompt and it starts generating. So it says that to create a chatbot using machine learning algorithms, here's a step-by-step guide to get you started. So as you can see on the screen, ChatGPT has created a complete response based on the prompt we gave it. Next on our list, we have GitHub Copilot. GitHub Copilot is an AI-powered code completion tool that suggests code snippet as you type. It leverages the massive dataset of public code repositories to provide contextually relevant suggestions. So this can significantly boost productivity by reducing the time spent on repetitive tasks. Copilot is particularly useful for writing code, generating unit tests, and exploring different coding approaches. So as you can see the screen, we are on the GitHub Copilot site. GitHub Copilot generates unit tests for a Python function that passes expenses. It includes test cases for valid input and empty input and ensures proper date formatting using the unit test framework. Copilot automatically assumes that the necessary imports like date time and unit test are in place. Moving on to the next generative AI example, that is DALL-E. DALL-E is a text-to-image AI model capable of generating highly realistic and creative images based on your textual description. With its ability to produce images in various styles and resolution, DALL-E is a versatile tool for artists, designers, and content creators. It can be used to generate concept art, product designs, illustrations, and even entire visual stories. So as you can see the screen, we are on the DALL-E site. DALL-E provides different functions related to generation. So the first is from text and next is from images. And in the prompt section, you write your prompt, then select the number of images you want, and maybe you can also select the image style and the orientation you wish to, which can be square, horizontal, vertical, or panoramic. So you can simply click on the generate and image will be generated. So now let us try by giving prompt and then click on generate. So DALL-E uses a powerful deep learning model to process your text prompt and generate an image that matches your description. So it can create images in various styles from realistic to abstract and can even generate images based on specific artistic movements or artists. The model is constantly being trained on a new data, so it can generate increasingly accurate and creative photos over time. And next is Midjourney. Midjourney is a cutting-edge AI platform that transforms your words into stunning visuals. So by simply typing a description, you can watch as a Midjourney generates unique and captivating images that brings your ideas to life. So whether you are an artist, designer, or storyteller, Midjourney offers a powerful tool to spark creativity and explore new visual horizons. Now we are on the Midjourney site, and on the left side, the icon shows the different features of Midjourney AI. Imagine you have a vivid ideas in your mind, but you are struggling to express it visually. So Midjourney is like a skilled artist who can interrupt your thoughts and translate them into stunning images. By simply providing a textual description, you are giving Midjourney a creative prompt. The AI then uses its vast knowledge of art and visual styles to generate images that align with your vision. It's like having a personal artist at your disposal, ready to bring your imaginations to life. The next example of generative AI on our list is Jasper.ai. Jasper.ai is an AI writing assistant designed to help users create high-quality content efficiently. It offers a wide range of features, including content generation, rewriting, summarization, and translation. So Jasper.ai can be used for various content creation tasks such as blog posts, social media content, marketing copy, and email campaigns. It's particularly useful for writers who needs to produce large volumes of content quickly and efficiently. Now we are on the Jasper site. So as you see in the navbar, we have different sections like features, resources, solutions, enterprises, pricing, etc. And Jasper.ai uses a powerful language model to understand and process your prompts. So when you provide a topic or a specific request, Jasper.ai generates a relevant content by drawing from its vast database of information and creative writing techniques. It can adapt its style and tone to match your desired output, ensuring that the generated content is engaging and effective. Our next example is Stable Diffusion. So Stable Diffusion is a text-to-image AI model that generates highly detailed and artistic images based on your textual description. With its ability to create images in various styles and resolutions, Stable Diffusion is a popular tool for artists, designers, and content creators. It can be used to generate concept art, product designs, illustrations, and even entire visual stories. Now we are at the site of Stable Diffusion so that you can see the different features on the navigation bar, such as prompt database, pricing details, and also the AI tools it includes. So the Stable Diffusion uses a powerful deep learning module to process your text prompts and generate an image that matches your description. So it can create images in various styles from realistic to abstract and can even generate images based on specific artistic movements or artists. So the model is constantly being trained on new data so it can generate increasingly accurate and creative photos over time. And the next example is Adobe Firefly. Adobe Firefly is a generative AI platform that empowers users to create stunning images, graphics, and text effects with ease. So it offers a wide range of features including text-to-image generation, image editing, and style transfer. Firefly is designed to streamline the creative process and inspire new ideas, and it's particularly useful for artists, designers, and marketers who need to create high-quality visuals quickly and efficiently. So now we are at the Adobe Firefly site, and if you click on the Create and Design, so you can find sections like Quick Actions, Create New, Featured Products, and Artificial Intelligence, etc. So if you click on the products, you will learn about the different products provided by Adobe. Adobe Firefly uses a powerful deep learning model to process your prompts and generate images, graphics, or text effects. It can understand and interpret your textual description, allowing you to create custom visuals that matches your specific needs. Firefly also offers advanced features for editing and manipulating images, such as removing backgrounds, changing colors, and applying artistic styles. By combining these capabilities, Firefly empowers users to create high-quality visuals with minimal efforts. Next on our list, we have Gemini. Gemini is a powerful AI model developed by Google that excels in a wide range of tasks, including natural language understanding, text generation, and language translation. It can process and generate text, code, images, and audio, making it a versatile tool for various applications. Gemini is particularly adept at complex reasoning, problem solving, and creative content generation. It can be used for tasks such as writing essays, translating languages, generating code, and even creating art. Now we are at the Gemini site, and you can see different sections here on the left side, and in the middle we have a text bar saying enter a prompt here, where you're going to write your question or the prompt you want and press enter to get your answer. You can also see different icons in the text bar here. So the image icon is for uploading the image and the voice icon is for speaking. So if the prompt is bigger, you can speak and it will convert your speech to text. So now let us try to upload an image and ask it to explain us. So let us take this and let us just write, please explain me about the image. So the Gemini functions by processing and analyzing large amount of data to understand and respond to prompts and questions. It uses a complex neural network architecture that allows it to learn and adapt to new information. So when you provide a prompt, Gemini processes it and generates a response based on its understanding of the language, context, and available information. So it can also perform tasks such as translation, summarization, and creative writing. Moving on to our next example, that is Runway. Runway AI is a powerful platform that provides a suite of AI-powered tools for creatives. It offers features such as image generation, video editing, and style transfer. Runway is designed to streamline the creative process and inspire new ideas, and it's particularly useful for artists, designers, and frame makers who need to create high-quality visuals quickly and efficiently. Now, we are on the site of Runway AI, and as you can see on the left side, the Runway provides many options, and in the library, you can see here, it provides workspace assets, favorite assets, custom elements, and many more. And in the tools section, we have generative videos, generative audio, text to image, and etc. Runway AI functions by leveraging advanced machine learning algorithms to process and manipulate visual data. Its tools can generate images from text description, edit and enhance existing videos, and applying various artistic styles to images and videos. And the platform offers a user-friendly interface that allows creatives to experiment with different techniques and create unique visual content with ease. Now let us get started and enter some prompt. As you can see my screen, over here you can simply drop an image or video. So let us try to drop any video. So over here it gives an option to edit. And also you have two options, maybe you can keep it in the landscape or maybe the portrait. Over here you can simply crop your video. So it's processing. Now let's try to give an image. So here you can also crop the image if you want. So if you simply click on portrait, it will change to portrait form. And you can adjust it wherever you want, however you want, and then click on crop image. So there we go. Moving on to our last example of generative AI, that is WriteSonic. WriteSonic AI is a powerful AI writing assistant designed to help users create high quality content efficiently. And it offers a wide range of features including content generation, rewriting, summarization, and language translation. WriteSonic can be used for various content creation tasks such as blog posts, social media content, marketing copy, and email campaigns. It's particularly useful for writers who need to produce large volume of content quickly and efficiently. Now we are at the site of WriteSonic, and you can see we have different features provided by WriteSonic such as creating content for advertising, general writing, video, e-commerce, social media, blog, emails, and many more. And in the text box, you write your prompt and just press create. Then it will redirect you to the next page, then select different parameters on which you want to create and press generate. So we will select the options as tech professionals, click next, and it's focusing on education. So click next, and here we can go with anything and then click on generate. WriteSonic functions by using a powerful language model to understand and process your prompts. So when you provide a topic or a specific request, WriteSonic generates relevant content by drawing from its vast database of information and creative writing techniques. It can adapt its style and tone to match your desired output, ensuring that the generated content is engaging and effective. Whether you are an artist, a writer, a developer, or just curious about the future of AI, the tools we have discussed offer endless opportunities to innovate and create. So whether you're looking to bring your ideas to life or just explore the cutting edge of AI technology, these generative AI tools are a great place to start. AI is evolving faster than ever, and 2025 has brought some of the most powerful generative AI tools we have ever seen. But with so many options, which one truly stands out? In this video, we are counting down the top 10 generative AI tools for 2025, covering everything from text and code generation to image, music, and even video creation. Whether you're a writer, artist, developer, or entrepreneur, you will discover which AI tool is the right fit for you to enhance your workflow and creativity. So first on the list of top 10 generative AI tools, we have GPT-4o, OpenAI's latest chatbot. It's free to use with some limitations, but still incredibly powerful for generating text, answering questions, and even assisting with creative writing. GPT-4o is OpenAI's latest flagship AI model. designed to excel in multimodal interactions across text, images, and audio. It offers enhanced real-time responsiveness, making conversations with AI smoother and more natural. The model features superior reasoning abilities, allowing it to handle complex problem-solving tasks with increased accuracy. With greater efficiency in processing, GPT-4o delivers high-performance outputs at reduced computational costs. Its versatility across applications from creative writing to coding and tutoring makes it one of the most advanced AI models available. Now, let us go to ChatGPT and enter a prompt. So let's say this is a prompt. Write a short blog post about the impact of AI on creativity. And as you can see, ChatGPT writes detailed content almost instantly. But what if we want to adjust the tone? So now let us type, make it more engaging and casual. So this flexibility makes GPT-4o perfect for writers, students, and professionals. Additionally, OpenAI offers other models like O1 Mini and High, which provide different levels of response speed and quality. Next on the list, we have Perplexity AI, an AI-powered search engine that not only answers your questions, but also summarizes complex topics with sources. Perplexity AI redefines search and research capabilities by providing highly accurate and context-aware responses. Unlike traditional search engines, it delivers citation-based results, ensuring that credible sources back all information. The tool also features real-time web browsing, allowing users to retrieve the most up-to-date information available online. With its AI-powered research capabilities, Perplexity AI is an essential tool for journalists, researchers, and professionals seeking precise and reliable data. So let's open it and let us give a prompt saying, summarize the latest advancement in AI for 2025. Well, Perplexity AI will generate a concise, well-structured summary, often pulling information from multiple sources and displaying references for credibility. Now, let's compare it with Google. So let us open Google and here let us enter the same prompt so you can easily see the differences. Unlike traditional search engines, Perplexity AI delivers instant, structured answers along with the cited sources, saving you time and effort. So whether you're a student, researcher, or just curious, this tool makes information more accessible and reliable. Next on the list of top 10 generative AI tools, we have Copy.ai, an AI-powered writing tool designed for marketing copy, blog post, and social media content. Copy.ai is a cutting-edge AI writing tool that automates content creation for businesses, marketers, and writers. It provides AI-powered writing assistance, generating engaging and high-quality text for blogs, ads, emails, and more. The platform allows users to adjust the tone and style of their content, ensuring alignment with brand voice or specific audience preferences. With multilingual capabilities, Copy.ai enables content creation in multiple languages. It also offers automated content generation, making it easy to produce well-structured articles and marketing copy in seconds. Well, now let us open Copy.ai and let us log into the free version. And over here, let us use the blog post wizard and select the feature and enter a topic. So let us enter 5 tips for boosting social media engagement. Alright. As you can see, Copy.ai will instantly create an outline and elaborate it into a full blog post. Now, let's try to adjust its tone. So let's say a casual tone, and here's the prompt. Write a fun and engaging social media post on how to get more likes and comments. And let us give the second prompt with the professional tone. So let's say, generate a formal blog introduction about strategies to improve social media engagement for businesses. And the third prompt is persuasive tone. And here's the prompt. Create a compelling marketing copy that convinces users to follow these 5 expert backend strategies for better social media engagement. Well, as you can see, Copy.ai is perfect for businesses, content creators, and marketers who need high-quality content in seconds. Whether it's a blog post, ad copy, or social media caption, this tool helps streamline content production with just a few clicks, giving you engaging copy that's ready to publish. And the next generative AI tool on our list is Gemini 2.0, Google's advanced AI model for writing and conversation. Gemini 2.0 is Google's latest AI model. It's designed to be highly efficient, offering powerful text generation, answering questions, and aiding in creative writing. Gemini 2.0 is Google's most advanced multimodal AI, built to process and understand text, images, and even audio with remarkable accuracy. It features state-of-the-art reasoning capabilities, making it an excellent tool for tackling complex problems. With faster processing and a more natural conversational flow, Gemini 2.0 enhances user experience across various applications. Whether for content creation, coding, research, or tutoring, it delivers high-quality outputs with improved efficiency. Now, let us go to Gemini and give a prompt saying, "Write a short blog post about the role of AI in education." Now, let us watch as Gemini 2.0 generates well-structured and insightful content almost instantly. But what if you need a different style? So, let us type, "Make it more engaging and friendly." Alright, this adaptability makes Gemini 2.0 perfect for students, professionals, and creatives. Plus, Google provides additional models like Gemini Nano and Gemini Pro, each optimized for different tasks, balancing speed and quality to meet your needs. Now that we have explored how AI can enhance text generation, so let's move on to our next category, that is code generation, where AI-powered tools are making programming faster, smarter, and more efficient. So first on the list, we have Coder. It is an advanced AI model that not only generates code, but can also explain and debug existing code. DeepSeek Coder is a powerful AI coding assistant designed to enhance software development efficiency. It features advanced code generation that can handle complex programming logic with high accuracy. With multi-language support, it assists developers across various coding languages, making it a versatile tool for diverse projects. The AI also includes real-time debugging capabilities, allowing users to identify and fix errors quickly. Additionally, its seamless IDE integration ensures a smooth workflow, making coding more intuitive and productive. Now, let us go to DeepSeek Coder, and over here, let us enter a prompt. Generate a Python function to sort a list of numbers using bubble sort. So, you can see how mind-blowing it is. Now, let us explain how this function works step by step. Well, DeepSeek Coder provides a detailed breakdown of the code logic. This is great for beginners learning to code or for professionals looking to generate and understand complex functions quickly. Next up, we have Qwen AI, Alibaba's cutting-edge AI for writing and conversation. This Qwen AI, Alibaba's advanced AI model, is built for high-performance text generation, answering questions, and assisting in creative writing with impressive accuracy. Qwen AI is a multimodal powerhouse capable of understanding and processing text, images, and even audio with remarkable fluency. It excels in logical reasoning, making it a great tool for solving complex problems, generating high-quality content, and streamlining workflows. With its fast response time and natural conversational abilities, Qwen AI enhances productivity across multiple fields, from businesses and education to creative industries. So let us open Qwen AI and type, "Write a short article on the benefits of AI in business." Well, you will see Qwen AI quickly craft detailed and insightful content. But what if you need a different style? So let us type, "Make it more conversational and engaging." Alright, this versatility makes Qwen AI an ideal choice for professionals, students, and content creators. Additionally, Alibaba offers Qwen Mini and Qwen Max, optimized for different levels of speed and depth, ensuring the best balance between performance and efficiency. Next up, we have Grok 3, the latest AI model from X, formerly Twitter, designed for high-speed text generation, deep reasoning, and engaging conversations. Grok 3 brings cutting-edge AI to content creation, research, and problem-solving.
Grok 3 is a multimodal AI capable of processing text, images, and real-time data with exceptional accuracy. It's built to understand context, generate insightful responses, and handle complex queries with ease. And thanks to its fast processing and natural conversational flow, Grok 3 enhances productivity across various industries, from media and technology to education and businesses. Let us open Grok and write a blog post about the future of AI in social media. Now, let us watch as Grok 3 instantly generates well-structured, thought-provoking content. But what if you want a different tone? So, let us make it more casual and engaging. This adaptability makes Grok 3 an excellent tool for professionals, writers, and researchers. Plus, X offers Grok Mini and Grok Pro, each optimized for different levels of speed, accuracy, and creative depth, ensuring the best AI experience for every user. Now that we have explored how AI is transforming code generation, so now let us move on to our next category, that is image generation, where AI can transform simple text prompts into stunning visuals with just a few clicks. First up, we have Canva AI, AI-powered graphic design, which is a user-friendly design tool that now features Magic Media, allowing users to generate AI-powered images directly within the Canva platform. Now, let's take a look at the features. Canva AI offers an easy-to-use interface, making it perfect for both beginners and professionals. With its text-to-image AI, you can simply enter a prompt and generate stunning visuals instantly. It also provides built-in editing tools, allowing you to customize AI-generated images effortlessly. So whether you're creating Instagram posts, YouTube thumbnails, or marketing materials, Canva AI is a great tool for social media and branding. So now, let us go to Canva. Now, let us click on Magic Media in the AI Tools section. And over here, let us enter a prompt. So let's say, for example, a futuristic cityscape at sunset with neon lights. So as you can see, this tool will generate the image and it is also creating multiple variations. So now, let us customize the image by adjusting brightness, adding text, or resizing elements using Canva's built-in tools. Alright, here it is. So with Canva AI, you don't need advanced design skills to create high-quality visuals. Just type in your idea and let AI handle the rest. Next, we have Crayon, a completely free AI image generator that quickly creates visuals from text prompts and no login required. So now, let's see the features of Crayon. Crayon is completely free and unlimited, allowing users to generate AI images without the need for sign-up. And it offers fast image generation, delivering results within seconds based on the text prompts. With multiple variations available, users can explore different artistic designs. Its simple and accessible interface make it an excellent choice for beginners experimenting with AI-generated art. So now, let us go to Crayon in your browser and enter a prompt, let's say, a cute robot playing guitar in a park. Now, click on Draw, and now let us wait for the AI to generate multiple images. Now, download the image for use in projects or social media. Alright, Crayon is great if you just want to test AI-generated images quickly without any setup or subscription. Whether it's fun artwork or concept sketches, this tool delivers results instantly. Lastly, we have Deep Dream Generator, an AI-powered tool that takes a simple image and transforms it into a dreamlike artistic visuals using neural networks. Deep Dream Generator offers unique artistic filters that transform images into surreal and abstract artwork. With neural style transfer, users can apply various artistic styles to existing photos, making it an excellent tool for digital artists and creators working on concept art and creative projects. Additionally, it provides customizable AI art, allowing users to fine-tune settings and refine AI-generated effects for a more personalized touch. Now, let us go to Deep Dream Generator. Now, let us upload an image such as a landscape or portrait. Now, let us choose an artistic style and apply the AI transformation and wait for the stylized output. And once it is generated, download and share your AI-enhanced artwork. Well,
Deep Dream Generator is a perfect for those who want to explore AI-powered creativity beyond simple text to image generation. If you love digital art and want unique styles, this tool is a must-try. Now that we have explored how AI can generate stunning images, so let's move on to our next category, that is video generation, where AI-powered tools can create and edit videos with just a few simple inputs. So first up, we have the Runway ML, an advanced AI-powered tool that allows users to generate, edit, and enhance videos using cutting-edge machine learning models. Now, let's take a look at the features. Runway ML offers an easy-to-use interface, making it accessible for both beginners and professionals. It features text-to-video AI, where you can describe a scene and the AI will generate video clips for you. Additionally, it provides AI-powered video editing tools including background removal, motion tracking, and style transfer. Whether you're creating short films, YouTube videos, or marketing content, Runway ML makes high-quality video production effortlessly. Now, let us go to Runway ML. Now, let us click on Text to Video in the AI Tools section. And here, let us enter a prompt. So let's say here's the prompt, a peaceful mountain landscape with flowing rivers at sunrise. Now let us wait it to generate the video. So once it is generated, you can also customize the video by adjusting colors, adding effects, or refining the scene. And with Runway ML, you don't need professional video editing skills to create stunning content. You can just enter a description and let the AI handle the rest. Now that we have explored how AI can generate and edit videos, so now let's move on to our next category, that is music and audio generation, where AI can compose original music, enhance video recordings, and generate realistic sound effects with just a few clicks. So first up, we have Suno AI, an innovative tool that generates original music tracks using AI. It is perfect for artists, content creators, and casual users looking to experiment with AI-generated music. So now, let's take a look at the features. Suno AI offers instant music composition, where users can input a description and the AI will generate a full track including melodies, harmonies, and beats. It provides various music styles and genre, allowing for diverse creativity. Additionally, it includes customization options, enabling users to tweak tempo, instrumentation, and effects. So whether you need background music for videos, podcast, or personal projects, Suno AI makes music creation effortless. Now let us go to Suno AI. So over here, let us enter a prompt. Now, let us wait it to generate a track and also a different variations. So as you can see, here's the music track. And also you can listen to different variations. And you can also customize the output by adjusting tempo, instruments, or adding effects. So once it is generated, you can download and use the track in your content. And with Suno AI, anyone can create professional quality music in seconds, no musical background required. So next up, we have SoundRaw AI, an advanced AI-driven music generator that empowers artists, content creators, and casual users to create original music effortlessly. So whether you need a soundtrack for your videos, podcast, or personal projects, SoundRaw AI makes music composition quick and seamless. Now, let us have a look at its features. SoundRaw AI provides instant music composition, allowing users to generate full-length tracks with melodies, harmonies, and beats tailored to their needs. It supports a wide range of music styles and genre, ensuring diversity in creative output. Additionally, it includes customization options, enabling users to adjust tempo, structure, and instrumentations to fine-tune their music. And with SoundRaw AI, generating royalty-free music has never been easier. So now, let us go to SoundRaw AI. Let us choose a music genre and select the mode or tone that fits your project. Now, let us wait it to generate a music track instantly with AI. And you can also customize the output by adjusting tempo, structure, and instruments. And you can also preview and refine different variations of the track. So once it is generated, you can download and use your custom generated music in your content. Alright, with SoundRaw AI, anyone can create high quality original music in seconds and no musical experience required. From writing and coding to image creation, video editing and music production, AI is transforming the way we work, create and innovate. Whether you're a content creator, developer or just AI curious, these tools open up endless possibilities. Now, which AI tool are you most excited to try? Let me know in the comments below.
Today, we are diving into the future, specifically the top generative AI trends that will define 2026. Generative AI has already changed how we write content, create images, and build software. But 2026 is not just about smarter AI models. It's about AI becoming part of everyday work, creativity, and decision making. From videos created by AI to intelligent assistants working like co-workers to responsible and sustainable AI, a lot is about to change. Now, let's explore the generative AI trends you need to know in 2026. First, let's talk about mainstream generative video and creativity. Generative AI will move beyond text and images. Video will finally come of age. According to forecasts, generative video tools are expected to be widely adapted across entertainment and marketing, reducing production time and cost in Hollywood and beyond. Leaders like Netflix have already experimented with AI-assisted creative workflows, and 2026 is expected to bring this into the mainstream. This means movies, ads, and online content could be created with unprecedented speed, enabling more immersive storytelling and personalized experiences. And moving ahead, let's talk about multimodal and agentic AI. Generative AI isn't just about text anymore. The future is multimodal, understanding and generating text, images, audio, and video together. Tools that reason across data types will become the baseline, allowing more natural interaction and richer outputs. Also, agentic AI, models that can plan, act autonomously, and coordinate tasks, is predicted to transform workflows. These AI agents won't just react. They will act on goals across applications, from customer service to research support. Another major shift in 2026 is the rise of domain-specific AI. Instead of one-size-fits-all models, 2026 will see a shift to domain-specific generative AI. Models trained for particular industries like healthcare, finance, engineering, and legal systems. This is driven by the need for accuracy, compliance, and measurable business value, replacing generic AI for critical enterprise tasks. Specialized models reduce errors like irrelevant outputs or hallucinations and improve trust in AI applications. Beyond specialization, AI is now driving large-scale automation. AI automation will evolve from simple task automation to complex workflow orchestration. Generative AI will power digital assistants that can autonomously perform tasks like writing contracts, preparing reports, coordinating schedules, or even optimizing supply chains. These AI agents could act as co-workers, not just tools, increasing productivity and transforming how we work. Along with automation, content creation is seeing massive change. Generative AI will dramatically transform content creation in business. From hyper-personalized marketing messages to dynamic customer engagement, AI can tailor content to individuals at scale. This hyper-personalization improves conversion rates and customer experience, making business communication more responsive and relevant. But AI's role doesn't stop at content. It's also reshaping research and innovation. In scientific and technical research, AI is expected to assist in discovery, helping scientists generate hypotheses, design experiments, and even run simulations. This same trend will extend into product design and development. Instead of replacing humans, AI will augment human creative and problem-solving, accelerating innovation cycles. As AI becomes more powerful, responsible use becomes critical. While capabilities grow, so does scrutiny.
Businesses are shifting from talking about responsible AI to putting governance, ethics, and safety into practice. In 2026, we should see more organizations adapting rigorous responsible AI frameworks to ensure fairness, privacy, and accountability. This trend is crucial as AI influences decisions that affect lives and livelihoods. At the same time, software development itself is becoming AI native. So models will assist in writing, testing, debugging code, and managing complex system dependencies, minimizing manual effort and opening opportunities for more innovation. This means developers will shift focus from repetitive work to design, architecture, and strategic problem solving. With all these capabilities, enterprises are now focusing on real ROI. While adoption accelerates, enterprises are becoming more cautious about ROI and integration challenges. According to industry predictions, 2026 will be the year where companies measure AI success not by hype but by real business outcomes. This pragmatism will drive better training, governance, and return on investment in AI projects. Finally, there is one concern that ties everything together, that is sustainability. Generative AI's growth also brings concerns about sustainability. AI systems consume significant energy and require efficient infrastructure and governance to reduce environmental impact. With rising global focus on energy efficiency, AI infrastructure will be optimized for sustainable in 2026. This means greener data centers and smarter allocation of computer resources. So to summarize, 2026 will be the year generative AI becomes deeply embedded in real-world systems, not just as a tool, but as a collaborator. From multimodal creativity and automated agents to responsible business integration and sustainability, this shift will define how we work, create, innovate, and interact with technology.
Okay, I will destroy humans.
This video sums up the perception of artificial intelligence for most of us, but at present we're at no risk of being destroyed by machines. However, the tech tycoon Elon Musk begs to differ. He quotes that AI is a fundamental risk to the existence of human civilization. Now, whether artificial intelligence is a threat or not is debatable. Let me know your thoughts in the comment section. For now, let me introduce you to artificial intelligence. The term artificial intelligence was first coined decades ago in the year 1956 by John McCarthy at the Dartmouth Conference. He defined artificial intelligence as the science and engineering of making intelligent machines. In a sense, AI is a technique of getting machines to work and behave like humans. In the recent past, AI has been able to accomplish this by creating machines and robots that are being used in a wide range of fields, including healthcare, robotics, marketing, business analytics, and many more. However, many AI applications are not perceived as AI because we often tend to think of artificial intelligence as robots doing our daily chores. But the truth is, artificial intelligence has found its way into our daily lives. It has become so general that we don't realize we use it all the time. For instance, have you ever wondered how Google is able to give you such accurate search results? Or how your Facebook feed always gives you content based on your interest? The answer to these questions is artificial intelligence. Now, before I go any further, let me clear a very common misconception. People often tend to think that artificial intelligence, machine learning, and deep learning are the same since they have common applications. For example, Siri is an application of AI, machine learning, and deep learning. So how are these technologies related? Artificial intelligence is the science of getting machines to mimic the behavior of humans. Machine learning is a subset of AI that focuses on getting machines to make decisions by feeding them data. On the other hand, deep learning is a subset of machine learning that uses the concept of neural networks to solve complex problems. So to sum it up, artificial intelligence, machine learning, and deep learning are interconnected fields. Machine learning and deep learning aids artificial intelligence by providing a set of algorithms and neural networks to solve data-driven problems. However, AI is not restricted to only machine learning and deep learning. It covers a vast domain of fields including natural language processing, object detection, computer vision, robotics, expert systems, and so on. Now, artificial intelligence can be structured along three evolutionary stages. Or you can say that there are three different types of artificial intelligence. First, we have the artificial narrow intelligence, artificial general intelligence, and finally artificial superintelligence. Artificial narrow intelligence, which is also known as weak AI, involves applying artificial intelligence only to specific tasks. Now, many currently existing systems that claim to use artificial intelligence are operating as a weak AI focused on a narrowly defined specific problem. Now, Alexa is a very good example of narrow intelligence. It operates within a limited predefined range of functions. There is no genuine intelligence or no self-awareness despite being a sophisticated example of weak AI. Other examples of weak AI include the face verification that you see in your iPhone, the autopilot feature at Tesla, the social humanoid Sophia, which was built at Hanson Robotics, and finally we have Google Maps. All of these applications are based on weak AI or artificial narrow intelligence. Now let's take a look at artificial general intelligence. Artificial general intelligence is also known as strong AI. It involves machines that possess the ability to perform any intellectual task that a human being can. You see, machines don't possess human-like abilities. They have a strong processing unit that can perform high-level computations, but they're not yet capable of thinking and reasoning like a human. There are many experts who doubt that artificial general intelligence will ever be possible. And there are also many who question whether it should be desirable. I'm sure all of you have heard of Stephen Hawking. Now, he warned us that strong AI would take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. Coming to artificial superintelligence, this is a term that refers to the time when the capabilities of computers will surpass human beings. Artificial superintelligence is presently seen as a hypothetical situation as depicted in movies and science fiction books where machines will take over the world. However, tech masterminds like Elon Musk believe that artificial superintelligence will take over the world by the year 2040. Now that you know the different types of artificial intelligence, let's take a look at how AI is used in the real world. From spotting an 8-planet solar system which is 2,500 light years away to composing sonnets and poems, the applications of AI have covered all possible domains in the market. In the finance sector, JP Morgan's Chase Contract Intelligent Platform uses artificial intelligence, machine learning, and image recognition software to analyze legal documents and extract important data points and clauses in a matter of seconds. Now, manually reviewing 12,000 agreements takes over 36,000 hours, but AI was able to do this in a matter of seconds. Coming to healthcare, IBM is one of the pioneers that has developed AI software specifically for medicine. More than 230 healthcare organizations worldwide use IBM Watson technology. In 2016, IBM Watson AI technology was able to cross-reference 20 million oncology records and correctly diagnose a rare leukemia condition in a patient. Coming to the next application, Google's AI Eye Doctor is another initiative taken by Google where they are working with an Indian eye care chain to develop an AI system which can examine retina scans and identify a condition called diabetic retinopathy which causes blindness. Coming to social media platforms like Facebook, artificial intelligence is used for face verification, wherein machine learning and deep learning concepts are used to detect facial features and tag your friends. Another such example is Twitter's AI, which is being used to identify hate speech and terroristic languages in tweets. It makes use of machine learning, deep learning, and natural language processing to filter out offensive content. The company discovered and banned 300,000 terrorist-linked accounts, 95% of which were found by non-human, artificially intelligent machines. The Google predictive search is one of the most famous AI applications. When you begin typing a search term and Google makes recommendations for you to choose from, that is AI in action. Predictive searches are based on data that Google collects about you, such as your location, your age, and other personal details. By using AI, the search engine attempts to guess what you might be trying to find. Next, we have virtual assistants. Virtual assistants like Siri, Alexa, and Cortana are examples of artificial intelligence. A newly released Google's virtual assistant called Google Duplex has astonished millions of people. Not only can it respond to calls and book appointments for you, it adds a human touch. Now listen to this clip and try to distinguish between the AI and the human.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we reserve for after 5 people. For 4 people you can come.
So which one do you think is a virtual assistant? Let me know your answer in the comments. Now another famous application of artificial intelligence is self-driving cars. AI implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. Elon Musk talks a ton about how AI is implemented in Tesla's self-driving cars and autopilot features. He quoted that Tesla will have fully self-driving cars ready by the end of the year and a robo-taxi version, one that can ferry passengers without anyone behind the wheel. So I can go on and on about the various AI applications. Since the emergence of AI in 1950s, we have seen an exponential growth in its potential. AI covers domains such as machine learning, deep learning, neural networks, natural language processing, knowledge base, expert systems, and so on. It has also made its way into computer vision and image processing. As AI is branching out into every aspect of our lives, is it possible that one day AI might take over our lives? And if it is possible, how long will this take? Well, it may be sooner than you think. It is estimated that AI will take over the world within the next 30 years. By then, I hope we develop some sort of teleportation machine that helps us escape our very own creation. Let us know your thoughts in the comments. History of artificial intelligence. The concept of AI goes back to the classical ages. Under Greek mythology, the concept of machines and mechanical men were well thought of. An example is Talos. Talos was supposedly a giant animated bronze warrior who was programmed to guard the island of Crete. Now let's get back to the 19th century. In 1950, Alan Turing proposed the Turing test. The Turing test basically determines whether or not a computer can intelligently think like a human being. The Turing test was the first serious proposal in the philosophy of artificial intelligence. 1951 marked the era for game artificial intelligence. This period was called Game AI because here a lot of computer scientists developed programs for checkers and for chess. However, these programs were later rewritten and redone in a better way. 1956 marked the most important year for artificial intelligence. During this year, John McCarthy first coined the term artificial intelligence. This was followed by the first AI laboratory, which was set up in 1959. MIT AI Lab was the first setup, which was basically dedicated to the research of AI. In 1960, the first robot was introduced to the General Motors assembly line. In 1961, the first AI chatbot called Eliza was introduced. In 1997, IBM's Deep Blue beats the world champion Garry Kasparov in the game of chess. 2005 marks for the year when an autonomous robotic car called Stanley won the DARPA Grand Challenge. In 2011, IBM's question answering machine, Watson, defeated the two greatest Jeopardy champions, Brad Rutter and Ken Jennings. So that was a brief history of AI. Now guys, since the emergence of artificial intelligence in 1950s, we have seen an exponential growth in its potential. AI covers domains such as machine learning, deep learning, neural networks, natural language processing, knowledge base, expert systems, and so on. So now let's understand the different stages of artificial intelligence. So basically, when I was doing my research, I found a lot of videos and a lot of articles that stated that artificial general intelligence, artificial narrow intelligence, and artificial super intelligence are the different types of AI. If I have to be more precise with you, then artificial intelligence has three different stages, right? The types of AI are completely different from the stages of AI. So under the stages of artificial intelligence, we have artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. So what is artificial narrow intelligence? Artificial narrow intelligence, also known as weak AI, is a stage of artificial intelligence that involves machines that can perform only a narrowly defined set of specific tasks. Right? At this stage, the machines don't possess any thinking ability. They just perform a set of predefined functions. Examples of weak AI include Siri, Alexa, AlphaGo, Sophia, the self-driving cars, and so on. Almost all the AI-based systems that are built till this date fall under the category of weak AI or artificial narrow intelligence. Next, we have something known as artificial general intelligence. Artificial general intelligence is also known as strong AI. This stage is the evolution of artificial intelligence, wherein machines will possess the ability to think and make decisions just like human beings. There are currently no existing examples of strong AI, but it's believed that we will soon be able to create machines that are as smart as human beings. Strong AI is actually considered a threat to human existence by many scientists. This includes Stephen Hawking. Stephen Hawking quoted that the development of full artificial intelligence could spell the end of human race. Moving on to our last stage, which is artificial superintelligence. Artificial superintelligence is that stage of AI when the capability of computers will surpass human beings. Artificial superintelligence is currently seen as a hypothetical situation as depicted in movies and science fiction books. You see a lot of movies which show that machines are taking over the world. All of that is artificial superintelligence. Now, I believe that machines are not very far from reaching the stage taking into consideration our current pace. However, such systems don't currently exist, right? We don't have any machine that is capable of thinking better than a human being or reasoning in a better way than a human. Artificial superintelligence, basically any robot that is much smarter than humans. Now, moving on to the different types of artificial intelligence. Based on the functionality of AI-based systems, artificial intelligence can be categorized into four types. The first type is reactive machines AI. This type of AI includes machines that operate solely based on the present data and take into consideration only the current situation. Reactive AI machines cannot form inferences from the data to evaluate any future actions. They can perform a narrowed range of predefined tasks. An example of reactive AI is the famous IBM chess program that beat the world champion Garry Kasparov. This is one of the most impressive AI machines built so far. Next, we have limited memory AI. Now, like the name suggests, limited memory AI can make informed and improved decisions by studying the past data from its memory. So, such an AI has a short lived, or you can say a temporary memory that can be used to store past experiences and hence evaluate your future actions. Self-driving cars are limited memory AI that use the data collected in the recent past to make immediate decisions. For example, self-driving cars use sensors to identify civilians that are crossing the road. They identify any steep roads or traffic signals, and they use this to make better driving decisions. This also helps in preventing any future accidents. Next, we have something known as theory of mind artificial intelligence. The theory of mind AI is a more advanced type of artificial intelligence. This category is speculated to play a very important role in psychology. This type of AI will mainly focus on emotional intelligence so that human beliefs and thoughts can be better comprehended. The theory of mind AI has not been fully developed yet, but rigorous research is happening in this area. Moving on to our last type of artificial intelligence is the self-aware artificial intelligence. So guys, let's just fold hands and pray that we don't reach the state of AI where machines have their own consciousness and become self-aware. This type of AI is a little far-fetched, but in the future, achieving a stage of super intelligence might be possible. Geniuses like Elon Musk and Stephen Hawking have constantly warned us about evolution of AI. So guys, let me know your thoughts in the comment section. Do you ever think we'll reach the stage of artificial super intelligence? Moving on to the last topic of today's session is the different domains or the different branches of artificial intelligence. So artificial intelligence can be used to solve real-world problems by implementing machine learning, deep learning, natural language processing, robotics, expert systems, and fuzzy logic. Now, guys, these are the different domains, or you can say the different branches that AI uses in order to solve any problem. Recently, AI has also been used as an application in computer vision and image processing. Right, for now, let me tell you briefly about each of these domains. Machine learning is basically the science of getting machines to interpret, process, and analyze data in order to solve real-world problems. Right, under machine learning, there's supervised, unsupervised, and reinforcement learning. If any of you are interested in learning about these technologies, I'll leave a link in the description box. You all can go through that content. Next, we have deep learning or neural networks. So deep learning is a process of implementing neural networks on high dimensional data to gain insights and form solutions. It is basically the logic behind the face verification algorithm on Facebook. It is the logic behind the self-driving cars, virtual assistants like Siri and Alexa. Then we have natural language processing. Natural language processing refers to the science of drawing insights from natural human language in order to communicate with machines and grow businesses. So an example of NLP is Twitter and Amazon. Twitter uses NLP to filter out terroristic language in their tweets. Amazon uses NLP to understand customer reviews and improve user experience. Then we have robotics. Robotics is a branch of artificial intelligence which focuses on the different branches and applications of robots. AI robots are artificial agents which act in the real world environment to produce results by taking some accountable actions. So I'm sure all of you have heard of Sophia. Sophia the humanoid is a very good example of AI in robotics. Then we have fuzzy logic. So fuzzy logic is a computing approach that is based on the principle of degree of truth instead of the usual modern logic that we use, which is basically the Boolean logic. Fuzzy logic is used in medical fields to solve complex problems which involve decision making. It is also used in automating gear systems in your cars and all of that. Then we have expert systems. An expert system is an AI-based computer system that learns and reciprocates the decision-making ability of a human expert. Expert systems use if-then logic notions in order to solve any complex problem. They do not rely on conventional procedural programming. Expert systems are mainly used in information management. They're seen to be used in fraud detection, virus detection, also in managing medical and hospital records, and so on.
So let us understand, when we have machine learning, why do we need deep learning? That is, we'll look at various limitations of machine learning. Now, the first limitation is high dimensionality of the data. Now, the data that is now generated is huge in size. So we have a very large number of inputs and outputs. So due to that, machine learning algorithms fail. So they cannot deal with high dimensionality of data, or you can say data with large number of inputs and outputs. Now, there's another problem as well, in which it is unable to solve the crucial AI problems, which can be natural language processing, image recognition, and things like that. Now, one of the biggest challenges with machine learning models is feature extraction. Now, let me tell you what are features. So in statistics, we consider features as variables. But when we talk about artificial intelligence, these variables are nothing but the features. Now, what happens because of that? The complex problems such as object recognition or handwriting recognition becomes a huge challenge for machine learning algorithms to solve. Now, let me give you an example of this feature extraction. Suppose if you want to predict that whether there will be a match today or not. So it depends on various features. It depends on whether the weather is sunny, whether it is windy, all those things. So we have provided all those features in our data set. But we have forgot one particular feature, that is humidity. And now our machine learning models are not that efficient that they will automatically generate that particular feature. So this is one huge problem, or you can say limitation with machine learning. Now, obviously, we have limitation, and it won't be fair that if I don't give you the solution to this particular problem. So we'll move forward and understand how deep learning solves these kind of problems. Now, as you can see that the first line on your slide, which says that deep learning models are capable to focus on the right features by themselves, requiring little guidance from the programmer. So with the help of little guidance, what these deep learning models can do, they can generate the features on which the outcome will depend on. And at the same time, it also solves the dimensionality problem as well. If you have a very large number of inputs and outputs, you can make use of a deep learning algorithm. Now, what exactly is deep learning? Again, since we know that it has been evolved by machine learning, and machine learning is nothing but a subset of artificial intelligence, and the idea behind artificial intelligence is to imitate the human behavior. The same idea is for the deep learning as well, is to build learning algorithms that can mimic brain. Now let us move forward and understand deep learning, what exactly it is. Now the deep learning is implemented with the help of neural networks, and the idea or the motivation behind neural networks are nothing but neurons. What are neurons? These are nothing but your brain cells. Now here is a diagram of neuron. So we have dendrites here which are used to provide input to our neuron. As you can see, we have multiple dendrites here, so these many inputs will be provided to our neuron. Now this is called cell body, and inside the cell body we have a nucleus which performs some function. After that, that output will travel through axon, and it will go towards the axon terminals, and then this neuron will fire this output towards the next neuron. Now the studies tell us that the next neuron, now, or you can say the two neurons are never connected to each other. There is a gap between them. So that is called a synapse. So this is how basically a neuron works like. And on the right hand side of your slide, you can see an artificial neuron. Now let me explain you that. So over here, similar to neurons, we have multiple inputs. Now these inputs will be provided to a processing element like our cell body. And over here in the processing element, what will happen? Summation of your inputs and weights. Now when it moves on, then what will happen? This input will be multiplied with our weights. So in the beginning, what happens? These weights are randomly assigned. So what will happen if I take the example of x1? So x1 multiplied by w1 will go towards the processing element. Similarly, x2 and w2 will go towards the processing element, and similarly the other inputs as well. And then summation will happen, which will generate a function of s, that is f of s. After that comes the concept of activation function. Now what is activation function? It is nothing but in order to provide a threshold. So if your output is above the threshold, then only this neuron will fire, otherwise it won't fire. So you can use a step function as an activation function, or you can even use a sigmoid function as your activation function. So this is how an artificial neuron looks like. So a network will be multiple neurons which are connected to each other will form an artificial neural network. And this activation function can be a sigmoid function or a step function. That totally depends on your requirement. Now once it exceeds the threshold, it will fire. After that, what will happen? It will check the output. Now if this output is not equal to the desired output, so these are the actual outputs, and we know the real outputs. So we'll compare both of that, and we'll find the difference between the actual output and the desired output. On the basis of that difference, we are again going to update our weights. And this process will keep on repeating until we get the desired output as our actual output. Now this process of updating weight is nothing but your back propagation method. So this is neural networks in a nutshell. So we'll move forward and understand what are deep networks. So basically, deep learning is implemented by the help of deep networks, and deep networks are nothing but neural networks with multiple hidden layers. Now what are hidden layers? Let me explain you that. So you have inputs that comes here. This will be your input layer. After that, some process happens and it'll go to the next node, or you can say to the hidden layer nodes. So this is nothing but your hidden layer 1. So every node is interconnected, if you can notice. After that, you have one more hidden layer where some function will happen. And as you can see that again, these nodes are interconnected to each other. After this hidden layer 2 comes the output layer. And this output layer, again, we are going to check the output, whether it is equal to the desired output or not. If it is not, we are again going to update the weights. So this is how a deep network looks like. Now there can be multiple hidden layers. There can be hundreds of hidden layers as well. But when we talk about machine learning, that was not the case. We were not able to process multiple hidden layers when we talk about machine learning. So because of deep learning, we have multiple hidden layers at once. Now let us understand this with an example. So we'll take an image which has 4 pixels. So if you can notice, we have 4 pixels here, among which the top 2 pixels are bright, that is, they're black in color, whereas the bottom 2 pixels are white. Now what happens? We'll divide these pixels and we'll send these pixels to each and every node. So for that, we need 4 nodes. So this particular pixel will go to this node, it will go to this node, this pixel will go to this node, and finally this pixel will go to this particular node that I'm highlighting with my cursor. Now what happens? We provide them random weights. So these white lines actually represent the positive weights, and these black lines represents the negative weights. Now this particular brightness, when we display high brightness, we'll consider it as negative. Now what happens when you see the next output or the next hidden layer, it will be provided with the input with this particular layer. So this will provide an input with positive weight to this particular node, and the second input will come from this particular node. Since both of them are positive, so we'll get this kind of a node. Similarly, this node as well. Now when I talk about these two nodes, the first node over here, so this is getting input from this node as well as from this node. Now over here we have a negative weight. So because of that, the value will be negative, and we have represented that with black color. Similarly, over here as well, we are getting one input from here which has a negative weight, and we another input from here which again has a negative weight. So accordingly, we get again a negative value here. So these two becomes black in color. Now, if we notice what will happen next, we'll provide one input here, which will be negative and a positive weight, which will be again negative. And this will be also negative and a positive weight. So that will again come out to be negative. So that is why we have got this kind of a structure. If you notice this is nothing but the inverse of this particular image. When I talk about this node over here, we are getting the negative value with a positive weight, which is negative, and a negative value with a negative weight, which is positive. So we are getting something which is positive here. Now, obviously, I want this particular image to get inverse. I want these black strips to come up. So what I'll do, I'll actually calculate the inverse by providing a negative weight like this. So over here, I've provided a negative weight, it will come up. So when I provide a positive weight, so it'll stay wherever it is. After that, it'll detect, and the output you can see will be a horizontal image, not a solid, not a vertical, not a diagonal, but a horizontal. And after that, we are going to calculate the difference between the actual output and the desired output, and we are going to update the weights accordingly. Now, this is just an example, guys. So guys, this is one example of deep learning where what happens, we have images here. We provide these raw data to the first layer, to the input layer. Then what happens, these input layers will determine the patterns of local contrast, or it will fixate those patterns of local contrast, which means that it will differentiate on the basis of colors and luminosity and all those things. So it will differentiate those things. And after that, in the following layer, what will happen, it will determine the face features. It will fixate those face features. So it will form nose, eyes, ears, all those things. Then what will happen, it will accumulate those correct features for the correct face, or you can say that it will fixate those features on the correct face template. So it will actually determine the faces here, as you can see it over here. And then it will be sent to the output layer. Now, basically, you can add more hidden layers to solve more complex problems. For example, if I want to find out a particular kind of face, for example, a face which has large eyes or which has light complexion, so I can do that by adding more hidden layers. And I can increase the complexity also at the same time if I want to find which image contains a dog. So for that also I can have one more hidden layer. So as and when hidden layer increases, we are able to solve more and more complex problems. So this is just a general overview of how a deep network looks like. So we have first patterns of local contrast in the first layer. Then what happens, we fixate these patterns of local contrast in order to form the face features such as eyes, nose, ears, etc. And then we accumulate these features for the correct face, and then we determine the image. So this is how a deep learning network, or you can say deep network, looks like. And I'll give you some applications of deep learning. So here are a few applications of deep learning. It can be used in self-driving cars. So you must have heard about self-driving cars. So what happens, it'll capture the images around it, it'll process that huge amount of data, and then it'll decide what action should it take. Should it take left, right, should it stop? So accordingly, it'll decide what action should it take. And that will reduce the amount of accidents that happens every year. Then when we talk about voice control assistants, I'm pretty sure you must have heard about Siri. All the iPhone users know about Siri, right? So you can tell Siri whatever you want to do, it'll search it for you and display for you. Then when we talk about automatic image caption generation, so what happens in this, whatever image that you upload, the algorithm is in such a way that it'll generate the caption accordingly. So for example, if you have, say, blue colored eyes, so it'll display a blue colored eye caption at the bottom of the image. Now, when I talk about automatic machine translation, so we can convert English language into Spanish, similarly Spanish to French. So basically, automatic machine translation, you can convert one language to another language with the help of deep learning. And these are just few examples, guys. There are many, many other examples of deep learning. It can be used in game playing. It can be used in many other things. And let me tell you one very fascinating thing that I've told you in the beginning as well. With the help of deep learning, MIT is trying to predict future. So yeah, I know it is growing exponentially right now, guys.
What is object detection? So object detection is a computer technology which is related to computer vision and image processing. Here, what we do in case of object detection is, for a given image, I'm going to check what are the objects that are present in the image, and not only what, I'm also going to say where exactly is that object is present. So that is what happens in place of object detection. An excellent example can be is Facebook photo tagging. So you might have observed the Facebook photo tagging feature. So when you upload a photo to your Facebook, so the Facebook will automatically recognize the people who are present in that particular uploaded image, and along with that it will also do one important thing. Along with that, it will also show you as where exactly that person is present. So if they like, it is going to draw a bounding box on top of that person's face to show it as, hey, this is your friend A and he's present over here, do you want to tag him? So that functionality that you would see in the Facebook, uh, that functionality that you see, so that is a typical example of object detection. Now I'm not sure what is the latest update, because it's been more than 2 years me using social media, but yeah, so 2 years back that was there, and I'm sure today it will be the same feature or it will be an upgraded feature. But the main concept is this: when you upload something for your Facebook or any social media, I'm giving it Facebook as a generalized concept because that's where I've seen. So it is going to tell us who are all the people that are present in the image, and also it is going to tell us as where that person is present. And that is what an object detection algorithm is going to do. It's going to identify the objects in the objects in a given image, and it also tells us as where exactly that object is present. So what and where, both of them will be identified in case of object detection. So here you can see the GIF animation that you would see over here on your left hand of the screen. So here it says what are the objects that are present in the image. So the objects are cap, bowl, Pepsi can, and so on. Now along with saying what are the objects, it is also drawing a bounding box. So you can see a green box that has been drawn on top of each and every object to tell us as where that particular object is present. And here on the another image that we have on the right hand of the slide, so here it's also doing a similar activity. It is saying there's a retriever dog, okay, and there is a built terrier dog. So there are, so it has identified the dogs that are present in the image, and along with identifying what is the breed of the dog, it is also drawing a box. See, it says, this is where my dog is, this is where my dog is, this is where my dog is. So this is how any typical object detection application would work. So it detects what, and also it also tells us as where exactly that particular object is present. Now, the next question is, where do we see these applications? So one obvious, face recognition. So this, we have been familiar with Facebook. So where we upload an image and we can identify who are all the people that are present in the image. And even Google Photos has a good face recognition feature. I mean, so we've been understanding about this, and even the Google Photos has a good face recognition, or yeah, voice recognition over there. So when we upload all the pictures, so it's going to group all the photos together, and it will ask us to name that particular one person, and it will automatically tag those names to all the similar people wherever that person is present. So that's also an application of face recognition. And we can also use this object detection concept for the people counting to understand as how many people are present over there in a given scenario. Or another example can be is whether that person is wearing a mask or not. So wearing a mask or not, so I can do it, and I can also use this special I can also use this mask detection, object detection, for checking whether people are following the COVID-19 protocols, that is social distancing. So all these are the applications of using object detection. And even we can use it for industrial purpose. It could be for industrial quality checking, to check whether the objects that has been done is a object that has been manufactured, is it as per the standards that are being expected by the industry. Or self-driving cars, So in case of self-driving cars, so the cars will identify what are the objects that are present in a given image, okay, or a given video feed, and on the basis of the object, it's going to drive. So that's another application of self-driving car, the application of object detection. And the another application that I could see is a security, the Face ID that we have in our Apple iPhones. So that uses the object detection to identify who is present in that image. And another thing is like identifying the objects on the road. I think you might have seen the latest Mahindra XUV 700. So they have an functionality to detect the they have the functionality to detect the objects that are in front of the car, and if the object is very close to the car, it is going to automatically apply the brake. Now here the object detection, obviously, like to detect the objects in front of the car, so they are making use of object detection over there. So that's another application. Okay, so these are some of the applications of using object detection in real life. Now coming to this object detection, let's look at the typical workflow and how does it work when we want to build an object detection algorithm using TensorFlow. When we are working with the applications like object detection, first we need to prepare the training data. I'll have to build the training data to such that to identify whether my given image has the required number of classes. So I'll have to build my classifier to identify as what is that individual object is present or what is my individual object contains. Now, after I have trained this, so this is my training data. I have the images of cars and I have the images of bike, and I have trained my machine learning model to identify whether my given image contains this car and bike. Now, once it's trained, I can obviously go ahead and send in my test data. And with that test data, I can detect whether my given input image contains bike or car. Okay, so this is the first step in preparing the object detection. Okay, first I'll build a classifier which will help me in identifying what is present in the image. Now, along with this while training, I'll also tell my machine learning, or in this case, deep learning system, to tell us where exactly that object is present. So my machine learning model, or in this scenario, it's a deep learning model. My deep learning model will do two things in parallel. One, it will identify what, and the another thing it will also do is where. It will learn where exactly that object is present in that given image. So it does both the things in parallel. So what happens is like I'll have some set of layers over here, and from this layer another set of another series of layers for detection to identify what is present over there, and another set of layers for detecting where exactly that object is present. Okay, so that's what it will be, the workflow of object detection. Now, once I have trained my object detection model, I can send in a new image. Now, when I send a new image, my deep learning model will be able to identify what is present in the image, and also it also tells me as where exactly that object is present in a given image. And that's how an object detection machine learning algorithm would work. Now, in order to build this deep learning models, which is capable of performing object detection, we have various frameworks. Now, one of the common framework that we would use is the TensorFlow. So this is one of the very common framework that we are currently using, which are in the latest scenario because of its ease of deployment using the TensorFlow extent. So because of this functionality, so now industries are preferring to use this TensorFlow framework. Now, apart from this, we have PyTorch, MXNet, Theano. So these are the various frameworks that are also available to us to build deep learning neural network. Now, let's get an understanding about this TensorFlow and what does this TensorFlow is made of. Now, as I mentioned already, TensorFlow is a deep learning framework which helps us in building the deep learning neural network. Now, just like my NumPy library has the array object, which is one of the basic object from this NumPy library. In case of TensorFlow library, or you can take any deep learning frameworks, we have an object that's called as tensors. Now, these tensors are the standard way of representing the data in case of deep learning. The reason that we used to prefer representing the data with tensors because one, it will help us to process the data with GPU. GPU means graphical processing unit, which we use it for gaming purpose. Okay, you know already what is computer gaming. So one like to, in order to get the speed and in order to get the good graphics, we know that we actually use the best and the best graphics card so that we can play the game in a very high setting. Now, using this deep learning frameworks and by creating the data inside the tensors, I'll be having the ability, I'll be having the ability to process those data that I have using these GPU cores. So just like we have a course in CPU, we'll also have the processing course in GPU, and we'll be utilize those GPU cores. And we have seen that we could get around 10 to 20x faster than what we could achieve in our CPU. So that's the advantage of working with deep learning frameworks and creating the data as tensors. And if I have a CUDA supported GPU, then I can also make use of this GPU cores to get 10 to 20 times of faster data processing compared to CPU. So that's the reason we want to represent the data in terms of tensors. Now, what is this tensors? Tensors are just a multidimensional array object. It's just an extension of two-dimensional tables to data with higher dimension. So that's what these tensors are. Now, in this TensorFlow, the computation is approached as a data flow diagram. So whenever I want to do anything over there in TensorFlow, so normally what we do, if you remember, in case of any machine learning model, I'm going to represent how my y hat is computed, and then from my y hat, I'm going to calculate the cost. So I'll have to manually specify how the cost should be done, and I have to mention as how the gradient should be calculated with reference to every parameter that I'm currently having in my model. But in case of TensorFlow, I don't have to worry about it. I can let my TensorFlow to do the magic. I can let my TensorFlow to track what are the operations that I'm doing on the data. And once I've completed the operation, I can just tell to my system as, okay, hey, I have finished doing the operation. Why don't you update the parameters? So in order to do that, we actually make use of data flow graph, or sometimes we also call it as TensorFlow graph. So it's going to track how the data is getting manipulated. Now, once I have done this data manipulation, I can make use of this TensorFlow graph to update the parameters of my model during the operation. And that's the advantage of using deep learning framework. Now, because of this feature, I don't have to worry about writing the complex equation. I can just start building the models which are as much as complex that I want, and I can let my TensorFlow to do the magic and find the gradients and update the parameters with just a single command. So that's the advantage of working with this TensorFlow. And we have the similar functionality in PyTorch library. So it's not just advantage in TensorFlow. I'm just giving it as an example as TensorFlow because we are discussing a TensorFlow. The similar functionality is also available in PyTorch as well. Okay. And yes, we represent the data in tensors, and once we represent the data in tensors, so here it is just a flow over here. So here the flow says, okay, for the given data, I'm going to add something and I'm going to perform matrix multiplication. So matmul is nothing but the matrix multiplication. So I'm doing some matrix multiplication and I'm getting the result. And on the basis of result, if I want to update something, I can just go ahead and perform some update using the TensorFlow data graph that I have, and then find the parameters over there, and I can do my required activity as per my preference. So what we do in case of building the model is, we'll start with the input data. We are going to convert it into the tensors. And once we convert the data into the tensors using TensorFlow library, we'll start training the model with TensorFlow model. Okay, so here the TensorFlow model is nothing but the deep learning model which I've created with TensorFlow library. Now, once that is done, I can go ahead and start training the model in depth. So here I'll create it as tensors, and then I'm going to train my TensorFlow model, which is a deep learning model. And once the model has been trained, I can send in a new data which is called as test data, to test how my model is performing. And once the testing is done, once I'm satisfied with the output, obviously I can use those test results to tell us as, okay, so this is an example of object detection. So for a given image, this is where the objects are, and these are the objects. So person, dog, and horse. So there are 3 objects that are present over here, and the bounding box tells us as where exactly those objects are present. So this is a typical flow when it comes to performing object detection. Now here, as a hands-on demo, we are going to look into a demo of YOLO model. Okay, so YOLO is one of the most commonly used object detection model when it comes to performing the object detection using deep learning models. So it's an object detection models. We'll use this already trained YOLO model, and we'll send in our data, and we'll see how the output would look like when I perform object detection with this YOLO. Okay, so let's go back to our Google Colab. Okay, now let's have a quick look at the implementation of TensorFlow. So this is a notebook that I've just shared in the chat window. You can refer that notebook. And this notebook has the implementation of object detection with YOLO. Now here, to get started, we are going to get the repository from the GitHub. So this is going to clone my repository, which is present over there. That is the darknet repository. And then I'm going to go inside the directory, that is cd darknet. And this is going to display the various files that we have in that directory. Now, once that is done, we are going to execute this command of make. So this will compile my library, and this is going to make sure that it is ready for us to execute. So this would take a while depending on the computer speed that we are running in. Now in this scenario, I'm using the free system that is provided by Google Colab. Hence this would take a while for it to become ready. And once that is done, I'm going to get the trained weights or already trained weights from the GitHub repository. So this is actually available under this link. So I'm going to download those weights. So here, the weights are nothing but the already trained data. So I'll use the already trained data, and I would get that data. And once I get the data, I can just go ahead and test my object detector. Now here, for the testing purpose, I'm going to make use of the image that is called as person's image, which is present inside my data directory. Okay, I'll show you what is that image that I'm talking about. So data. So there are various images. Now this time I'm using this image of person. So this is the image of person. So on this image, I'm going to identify what are the objects that are present in this given image. So let's see what will be the output if I just execute this line. So this is going to tell me, this would take a while to perform the prediction. Okay, and then it will give us the detection. Okay, so we have the output, and if you observe over here, currently I'm running on CPU, so it actually took 21,915 milliseconds. So I'll just note this number in a separate notepad. So this is the 21,050 milliseconds it took on my CPU. All right, and if I come down, so this is the predictions that has been given from my object detection model of YOLO. So it says where exactly that person is present, and it also displays about the class name. Here the class name says as person, and along with that it also displays the confidence score. So how much confident it is how much confident it is to saying it as okay, it belongs to the person. Okay, and it says 98% confidence that belongs to the horse, and this is 99% confident that it belongs to the dog classes. Now we are going to enable the GPU, and once we enable the GPU, we'll have to execute some commands again and prepare our model to make sure that it runs on GPU. And once that is done, this time we are going to use a new image. The new image is called as giraffe.jpg. So this is the image that I'll be testing out. So this is the image of giraffe, and I'll be using this image to detect the objects. So I'll just execute this to run the prediction, and I'm going to show how the objects would look like in this image. Okay, it's still configuring my system to make sure that it runs on the GPU. Now the system setup is complete. Now let's look at the logs. Now if I come down and look at the logs, it just took less than a second to complete the prediction. So it just took around 165 milliseconds. See, you can look into the comparison. Now if I just compare it, okay, 21915 divided by 165, so it's like 132 times faster than what I have got from my CPU. So that's the computation speed that we would get when we work with uh, GPUs. Okay, now if I see over here, so it says these are the objects that has been identified from a given image. So there's a giraffe with 100% confidence, and there is a zebra with 99% confidence. So clearly we would get the high speed computation when we are working with GPUs. Now below we have a code to test out about the various threshold values. So for that we are choosing an example image of horse, and on this example image of horse, so by default it has some threshold value. I think the threshold value is somewhere around 0.8 or something. Now if I reduce the threshold value, it is going to add some more images, and if I increase the threshold values, it is going to uh, stop like displaying about the this. In this example I've mentioned my threshold as 0.98. That means detect the objects for which you are confident with 98%. So here in the above image I had an object which had 90% confidence, and that has been omitted when I specify this threshold of 98%. And if I reduce the threshold value, then in such scenarios it would randomly assign the values like this, because the threshold is very less. Okay, so that is how we can make use of TensorFlow and that is how we can make use of TensorFlow and detect the objects in an image. And if I come down, there is a code which talks about as we can perform the object detection in videos. Now instead of connecting to the videos, we can also make use of OpenCV library and detect the starter webcam session, and then we can run this object detection on the video file as well, or we can run that object detection on the on the webcam stream as well to detect what are the objects that are present in the image. Now in order to do that, obviously we need a system which has a very good memory and the GPU, and you are free to check out at your end when you're exploring about videos. Okay, so the identification or the overall understanding that you need to have is when I talk about object detection. So object detection means for a given input data, I'll be doing two things. One, I'll be detecting where is my object is present. Okay, I'll detect where is my object and what is my object. I'll detect both the things when I'm performing object detection. So what and where, which is like what we have seen in this video. So in our current scenario, so we have made use of YOLO object detector to detect the objects from our end. And when you start your learning journey with TensorFlow, obviously you learn how you can create your own object detection model to identify the objects in a given image. So you learn that as well as you progress in your learning journey, when you start exploring TensorFlow and when you try to do some task on your own. Okay, so that's how you can plan out in your learning journey.
Keras is a Python-based deep learning framework which is actually the high-level API of TensorFlow. And now I have 4 major highlights for you guys, so let's check it out from the start. Well, Keras basically runs on top of Theano, TensorFlow or CNTK. Since it runs on top of any of these frameworks, Keras is amazingly simple to work with. You might be wondering why. Well, building models are as simple as stacking layers and later connecting these graphs. Guys, Keras attracts a lot of attention, but why? Since it is open source, it is actively developed by all the contributors across the world and the documentation is nearly endless. Well, we're good with the documentation, but how does Keras perform? Guys, since it is an API which is actually used to specify and train differentiable programs, high performance naturally follows through here. So now that we know what Keras actually is, who makes Keras what it is? Well, we need to check out some of the contributors and the backers to the deep learning framework. Well guys, Keras had over 4,800 contributors during its launch and the initial stages. And now that number has gone up to 250,000 active developers. Well, what amuses me is that there is a 2x growth ever since every year since its launch. Also, it holds a really good amount of traction among multiple startups. Big players like Microsoft, Google, Nvidia, and Amazon actively contribute to the development of Keras. Good enough? So at this point, I'm sure all of you are curious about who uses Keras. Well, Keras has an amazing industry traction and it is used in the development of popular firms like Netflix, Uber, Expedia, Yelp, and more. Well, now that you know, the next time you watch a movie on Netflix or book an Uber, you know Keras is being used. So guys, if Keras is getting all this attention, what makes it so special? What makes Keras stand out among all the top framework? Here I have for you top 10 snippets that makes Keras so special. Well guys, the focus on user experience has always been the major part of Keras. And next, large adoption in the industry, definitely. We just checked out all of the industry traction it gets and this holds well. And next, it is multi-backend and supports multi-platform as well. This helps all the coders come together and code easily. Next up, the research community present for Keras is amazing along with the production community. So this is a win-win for me guys. So what do you think? And moving on, all the concepts are really easy to grasp with Keras guys. And next up, it supports fast processing, which is really good. And guys, it runs seamlessly on both the CPU and the GPU, and it has support for both Nvidia and AMD as well. And the best part for me is the freedom to design on any architecture and then later implement it as an API for your projects, guys. This definitely is a major advantage for me. So next up, for all the beginners, Keras is really simple to get started with, and I'm here to help you guys with this tutorial for that. So stay tuned. And lastly, the easy production of models makes Keras that much special, guys. Now that we know Keras is special, guys, let's dig in a little bit about one of the major concepts which make Keras what it is, the user experience. Well, in my opinion, this is very important for anyone who wants to know more about Keras, or better, they want to start creating their own neural nets using Keras. So clearly, Keras is an API designed for humans. Well, why so? Because it follows the best practices for reducing cognitive load, which ensures that the models are consistent and the corresponding APIs are simple. And moving on, Keras provides clear feedback upon occurrence of any error, and this minimizes the number of user actions required for the majority of the common use cases, guys. And lastly, Keras provides high flexibility to all of its developers. Well, we all love high flexibility, right? So how is Keras doing this? Guys, it's very simple. It integrates with lower level deep learning framework languages like TensorFlow or Theano. So guys, this ensures that you can implement anything in Keras which you actually built in your base language, which is amazing. So next up, we need to talk about how Keras supports the claim of being able to support multi-platform and lets us work with multiple backends. You can develop Keras in Python as well as R. The code can be run with TensorFlow, CNTK, Theano, or MXNet totally based on your requirement. This almost feels like a tailor-made API for the framework, guys. The code can be run on the CPU or the GPU as well. Support for both the big players being Nvidia and AMD here. So this ensures that producing models with Keras is really simple. Total support to run with TensorFlow serving, GPU acceleration such as CUDA when using modules such as WebKeras and Keras.js, native support to develop Android and iOS apps using TensorFlow and Core ML, and yes, full-blown support to work with Raspberry Pi as well. So guys, moving on, we need to check one quick concept which forms the backbone as a working principle of Keras. So let's check out a computation graph. Here is an example for you guys. Just before decoding and working our way through the graph, let's look at the features. So guys, do note that computational graphs are used for expressing complex expression as a combination of simple operations for Keras to work with. It is mainly useful for calculating the derivatives during the phase of backpropagation, and hence it makes it easier to implement distributed computing on the whole. So all it takes is to specify the inputs, outputs, and to make sure that the graph is connected throughout. I hope you guys know what a connected graph is. So let's check out our graph. We'll be working our way from the leaf nodes to the top. So guys, here as you can see, E equal to C multiplied with D, where C is equal to A plus B and D is equal to B plus 1. So all we're doing is we're making sure we land at E equal to C cross T, which is the head of our tree, and we get to this by performing two operations on the leaf nodes. So as you can see, working down further, E equal to A plus B into B plus 1 actually makes sense now. And in our case, A and B are inputs. So guys, it is as simple as that. So next, let's dive a little bit deeper and check out the two major models, guys. So the first model is a sequential model. The working is basically like a linear stack of layers. So the first thing that comes into my mind when I think about the layered approach is the sequential model. It is majorly useful for building simple classification network and encoder-decoder model, guys. And definitely yes, this is the model which we all know and love. So here we basically treat every layer as an object that feeds into the next layer and so on. And now in the simple code, we'll import Keras into Python. We define the model as sequential, and with the hidden layers, we have 20 neurons and we'll be using ReLU here. ReLU is rectified linear unit, guys. It is one of the activation functions we'll be using. Well, model.fit is used to train the network. Here, by epoch, I'm sure all of you guys are familiar with it already. So it is basically the forward and the backward pass of all of our training examples. And batch size is really straightforward as well. It is the number of training examples in one forward and backward pass, guys. So higher the batch size, the more the memory you'll need. So next, we need to check out the functional model. It is widely used and it holds good for about 95% of the use cases. Well, imagine the concept of playing with Legos, guys. I'm pretty sure most of us have played with Legos in our childhood. It's pretty much the same here as well. Well, the highlights of the functional model is that it supports multi-input, multi-output, and an arbitrary static graph topology. We have branches, so whenever we have a complex model, the model is forked into two or more branches based on the requirement, guys. The code which we have here is pretty much similar to the previous one, but with subtle changes. We first import the models, we work on its architecture, and lastly, we train the network. Well, with functional models, we have this concept called as domain adaptation. So guys, what we did until this stage is that we train a model on one domain but test it on the other. This definitely results in poor performance on the overall test dataset because the data is different for each of the domains, right? So what's the solution for this? Well, we adapt the model to work on both the domains at the same time. And guys, we'll be looking at a very interesting use case using the functional models in the upcoming slides, so stay tuned for that. So moving on, we need to understand about the two basic types of execution in Keras, deferred and eager execution. It is also called as symbolic and imperative execution as well. Well, with deferred, we use Python to build a computation graph first like we previously discussed, and then this compiled graph gets executed. Well, with eager execution, there is a slight change, guys. It is here that the Python runtime itself becomes the execution runtime for all of the models. It is very similar to execution with NumPy. So if you're familiar with NumPy, then it's a cakewalk, guys. So on the whole, here is a quick note. Symbolic tensors don't have a value in the Python code as of yet, but eager tensors will have a value in the Python code. And with eager execution, we make use of a type of recurring neural networks called as trees. So guys, it is basically a value dependent dynamic topology structure. So what are you guys thinking about Keras at this point? Well, it is actually really easy to grasp, guys. Well, next, let's look at the steps needed to implement our own neural network using Keras. There are 5 major steps here, guys. So starting out, we need to prepare the inputs for the model. We do this by analyzing our requirements and specifying the input dimensions. Well, as you know it, the common inputs are images, videos, text, or audio based on your model requirement. The next step is to actually define the artificial neural network model. Here, we do everything from defining the model architecture to building the computation graph and also defining the style we'll be using for the model. It is as straightforward as that. Well, step 3 is to specify the optimizer. Think of it this way, a neural network is just a complex function. We need to simplify the process of making the machine learn. Well, the optimizer is just for that. There are many types of optimizers such as SGD, which is stochastic gradient descent. We have RMSProp, which is based on root mean square, and ADAM, and so on. And the next step is to define the loss function. So for every step in our training, we'll be checking the accuracy of prediction by comparing the obtained value with the actual one. We check for the difference between them and we print out the loss, guys. Well, the goal is to actually define a function which we will use to reduce the losses in each pass of the training phase. There are many types of loss functions such as MSE, which is mean squared error, and we have cross entropy loss, which is also called as the log loss in most cases, and so on. And the last step is to actually train the network based on the input data, which is also called as a training data. And after training, we will need to test the model based on the trained data to check if the model actually learned anything. So it is as simple as this, guys. What do you think? I would love to know your views on this, so head to the comment section. Let's have an interaction there. And now, guys, let's spice things up a bit. I'm sure you guys were curious about the use case, so let me walk you through the entire thing. Well, we'll be checking out a wine classifier in this use case, so let's begin by checking out our problem statement. So we're trying to predict the price of a bottle of wine just by knowing the description and the variety of wine. Well, we can work this out with the Keras functional API and TensorFlow. We'll be building a wide and a deep network using Keras to make predictions for us. Well, can we achieve this goal? Yes, we can. This is a problem statement suited for wide and deep learning networks, as I mentioned. Well, it involves textual input and there isn't any correlation between the wine's description and its price. Well, this is what makes it fun in my opinion, guys. So next we need to check out the model. A lot of Keras models are built using the sequential model API as I told you earlier. But let's make use of the functional API for our use case. Well, true, the sequential API is still the best way to get started with Keras. Why? Because it lets you define models easily as a stack of layers like I explained earlier. However, the functional model allows for more flexibility and is best suited for models with multiple inputs. So we need to know a little bit about wide and deep model, guys. Well, wide models are models with sparse feature vectors. Well, what I mean by sparse feature vectors is that it consists of mostly zeros and a little bit of ones. And deep networks are networks which do really well on tasks like speech and image recognition. So now that that's sorted, we need to take a look at the dataset. Well, for this case, we'll be using a wine dataset from Kaggle. So what's the data? Well, it's basically 12 columns of data and it's as follows. Here we'll be talking about the country that the wine is from. Next up is description, a few sentences from the sommelier describing the wine's taste, smell, look and feel. A sommelier is a person who is a professional wine taster, guys. Next up is designation, the vineyard within the winery where the grapes that the wine has been made from. Next up is points, the number of points that the wine enthusiasts rated the wine on a scale of 1 to 10. However, they only say that they post reviews for the wines which scores greater than equal to 80. Next up is price, the cost of the bottle of the wine obviously, followed by province, the province or the state where the wine is from. Next up I have something called as region 1. Well, with region 1, it's the wine growing area in a province or a state. Let's say for example India. Next I have region 2. Well, sometimes there are more specific regions within a specified wine growing area. For example, we can say Bangalore, India. But this value can sometimes be blank as well. Next up is taster's name. Well, as it suggests, it's the name of the person who tasted and reviewed the wine. Taster Twitter handle for the person who tasted and reviewed the wine. Well, the title of the wine review, which often contains the vintage if you're interested in extracting that feature. Variety, the type of the grapes that is used to make the wine. Let's say for example Pinot Noir, that's a type of the grape. And finally, the winery that made the wine. Guys, the overall goal here is to actually create a model that can identify the variety, winery, and the location of a wine based on the description alone. And this dataset offers some really great opportunities for sentiment analysis and other text-related predictive models as well. So now that that's clear, we need to take a look at the sample data case. So here we have a description for the wine such as scent, if it's tart, firm, or needs more decanting, etc. So this forms our input for the model, guys. And the output our model provides just from all of this textual information is the pricing that it predicts. How cool is that, guys? So basically, we need to check out some of the prerequisites before jumping into the code. Since you're working with Python, we'll require pandas, we'll require NumPy, scikit-learn, and Jupyter Notebook. So yes, Keras works on top of TensorFlow, so we'll require both Keras and TensorFlow to be installed on the machine. So now that that's done, moving on, let's look at a small piece of code. Here are all the inputs that we'll require to build the model. And lastly, we test the presence of TensorFlow by printing the installed version. Well, without TensorFlow, it wouldn't make any sense. So we go to Kaggle and download the data and end up converting the data to a pandas data frame, guys. Well, that's good enough to start. Let's look at the code for this model. I'll quickly open up Google Collaboratory, which is basically a Jupyter Notebook hosted on their Google Cloud. You can actually do this on your local machine as well by installing all of the frameworks that I've previously mentioned. So let me go ahead and open Collaboratory and let's begin, guys. So guys, we'll be executing each of these blocks and we'll be going on from there. So let us check out the first block. So here we import all of the modules that we require. So guys, let me run it. And that's done. So next we'll need to install the latest version of TensorFlow. Well, with Google Colab, it doesn't require any extra setup, so it's pretty much straightforward. So guys, that took about 2 minutes and TensorFlow is installed. And as I explained before, we need to import the models that we'll use to build the model. And after that, we'll actually run the code to check the version output of the TensorFlow that we just installed. And the output we're supposed to be expecting is version 1.7 because 1.7 is the TensorFlow version that we installed. As you can check out the output, you have TensorFlow version 1.7. So beautiful. So moving on, we need to download the data, which is from a CSV file hosted on the cloud. So let's go ahead and do that. Now that it is downloaded and ready, let us convert all the data from the CSV file into a pandas data frame as I mentioned. So now that that is done, let's go ahead and mix up the data by shuffling it. And yes, so let's start printing samples from our data set. So we'll be printing the first 5 rows, and as you can see, all the columns that we discussed earlier from country, price, province, all the way till a detailed description of the wine is present here. So now that that's done, next we need to do some pre-processing to limit the number of varieties of wine in the dataset. So let us go ahead and set a threshold of 500 in our case. So anything less than 500 will be removed from analysis in our model. We'll be replacing it with NaN, which is not a number, instead of letting it to be blank. So let me go ahead and run this. So now that that's done, the next step we need to do is actually split the data into a training dataset and a testing dataset. So let's go ahead and do that and print the size of both the training dataset and the testing dataset. So let me go ahead and run this code for you guys, and there it is. We have the training dataset size and the testing dataset size. Now that we have the size, we need to actually extract the testing and the training features and all of the labels. So let me go ahead and run this code and we can actually get the labels. And so that does it. The training and the testing features and the labels are known to our machine by now. So now it's very obvious that we're using a test description. Well, instead of looking at every word that we have found in our description in our dataset, let us limit our bag of words to, let's say, top 12,000 words in our dataset. So guys, don't worry, there is actually a built-in Keras utility for creating just this vocabulary. This is considered as wide because the input to our model for each description will be a 12k element wide vector with zeros and ones, indicating the presence of word from our vocabulary in a particular description. Well, Keras has some handy utilities for text pre-processing that we'll use to convert the text descriptions into a bag of words. With the bag of words model, we'll typically want to use only a subset of all the total words that we found in our dataset. And in this example, I used 12,000 words, but this is a hyperparameter that you can tune. Well, you can try out a few values to see what works best on your dataset. Well, we can use the Keras tokenizer class to create our bag of words vocabulary for us. So let me go ahead and run this to create the tokenizer. Guys, so now that that's done, we'll be actually using text to matrix function to convert each description to a bag of words vector. So let me go ahead and run it. Well, now that that's done, guys, in the original Kaggle dataset, there are about 632 total varieties of wine. To make it easier for our model to extract the patterns, we did a bit of pre-processing to keep only the top 40 varieties. Well, around 65% of the original dataset or 96k total examples. Well, we use a Keras utility to convert each of these varieties to integer representation. And then we'll create 40 element wide one-hot vectors for each input to indicate the variety. So let me go ahead and run it, guys. So now that that's run, guys, at this stage, we are ready to build our wide model. Well, guys, Keras has two APIs for building the models, the sequential API and the functional API. The functional API gives us a bit more flexibility in how we define our layers and lets us combine multiple feature inputs into one layer. It also makes it easy for our wide and deep models into one when we're ready. Guys, with the functional API, we can define our wide model in just a few lines of code as you see. Well, first we need to define our input layer as a 12k element vector, well, for each word in our vocabulary, and then we'll connect this to our dense output layer to generate the price prediction. So let me go ahead and run this. Well, now that that's done, we'll compile the model so that it is ready to use. If we were using the wide model all on its own, this is when we'd actually start training it with the fit function and evaluate later with the evaluate function. Since we're going to combine it with our deep model later on, we can hold off on training until the two models are combined, which is done later, guys. So let me go ahead and execute this so we define our wide model. And yep, our wide model is done. Let's go ahead and print out a summary from the wide model. Well, now that we have a summary, we can realize the total number of trainable parameters and non-trainable parameters. Well, in our case, the non-trainable parameters are 0, guys. So guys, that's the end to the construction of the wide model, and it's time to build our deep model. So let's go ahead and check that. Well, to create a deep representation of the wine's description, we'll represent it as an embedding. Well, there are a lot of resources on word embeddings, but the short version is that they can provide a map word to vectors so that the similar words are closer together in the vector space. Well, to convert our text descriptions to an embedding layer, we'll need to first convert each description to a vector of integers corresponding to each word in our vocabulary. We can do that with the handy Keras text to sequence method. And now we've got the integerized description vectors, we need to make sure that they're all the same to feed into our models. Well, Keras is fancy and it has a handy method for that too. We'll use part_sequences to add zeros to each description vector so that they're all the same length. Well, in this case, I used 170 as the max length, so no descriptions were cut short. So let me go ahead and run this. Well, with our descriptions converted to vectors that are all the same length, we're ready to create our embedding layer and then feed it into our deep model, guys. So let's start building our deep model. Well, there are two ways to create an embedding layer. We can use weights from the pre-trained embeddings as I previously explained, or we can actually learn the embeddings from our vocabulary. Well, it's best to experiment with both and to see which performs better on your particular dataset. Here, we'll consider using learned embeddings. Well, firstly, we'll define the shape of our input to the deep model. Then, we'll feed it into the embedding layer, and here I'm using an embedding layer with 8 dimensions. Well, you can experiment this with tweaking the dimensionality of your embedding layer as per your choice. And the output of the embedding layer will be a 3-dimensional vectors with the following shape. Well, it'll have a batch size, a sequence length. Well, in our case, the sequence length is 170. It'll have an embedding dimension. It is 8 in our example. And in order to connect our embedding layer to the dense, fully connected output layer, we actually need to flatten it first. So let's go ahead and define our model and then we can flatten our layer. Well, once the embedding layer is flattened, it's ready to be fed into the model and to compile it. So let's go ahead and compile it. And now that the compilation is done, as you can see, the loss function we've used in this case is MSE, which is mean squared error. The optimizer we'll be using is Adams and the metrics is accuracy. And at this point of time, we have established the wide model and the deep model. So once we have defined both our models, combining them is really easy, guys. We simply need to create a layer that concatenates the output from each of the model and then merge them into a fully connected dense layer, and finally define a combined model that combines the input and the output from each one. Well, obviously, since each model is predicting the same thing, which is the price, the outputs or the labels from each one will be the same. Also, guys, do note that since the output of our model is a numeric value, we will not need to do any pre-processing and it's already in the right format as well. How cool is that? Well, that's done, guys. It's time for the training and the evaluation. Well, you can experiment with the number of training epochs and the batch size that works best for your data set. Well, this is going to take some time, so I'll save you the pain by fast forwarding this a bit. So guys, as you can see, the training is actually done. So each of the epoch took about 100 seconds and we had 10 epochs for the same. So guys, here's the important thing that you have to notice. With every epoch, we were actually reducing the loss all the way from 1100 to 130, guys. And the accuracy of prediction went from 0.02 all the way till 0.0994, which is almost 0.1. Well, wow, that's definitely a breakthrough for just 10 passes, guys. And now that the training is done, it's time to evaluate it. So let me go ahead and run this piece of code for you guys. So that was quick. That took only about 5 seconds and we have evaluated the model. And now it's time for the most important part, guys, seeing how our model actually performs on the data that it has never seen before. To do this, we'll actually call the predict function on our trained model and we'll be passing it our data set. So let's go ahead and do just that. Well, now that that's done, we'll have to compare the predictions to the actual values for the first 15 wines from our test data set. So guys, as you can see, we have a set of predictions from the description and the predicted value is about $24 while the actual value is $22. Next up, we have $34 as a predicted one while the average is 70. Well, this is not a really good case, but okay, that's tolerable. And next up, we have predicted 11.9 when the actual value is 12. Wow, that is actually really close. So next up we have 15.7 versus 9. Well, this goes on and on for the first 15 and it's actually really good. Well guys, pretty well it turns out that there is some relationship between a wine's description and its price. Well, we might not be able to see it instinctively, but our machine learning models certainly can. So lastly, let's compare the average difference between the actual price and the model's predicted price. Well, the average prediction difference is about $10 for every wine bottle. Wow, that is really nice, guys.
So let's understand how exactly a computer reads an image. So this is an image of New York skyline. I personally love this picture. So when a human will see this image, he'll first notice there are a lot of buildings in different colors and stuff like that. But how a computer will read this image? So basically there will be three channels. One will be red, another will be green, and finally we have blue channel, which is popularly known as RGB. So each of these channels will they have their own respective pixel values, as you can see it over here. So when I say that image size is B cross A cross 3, it means that there are B rows, A columns, and 3 channels. All right. So if somebody tells you that the size of an image is 28 cross 3 pixels, it means that it has 28 rows, 28 columns, and 3 channels. So this is how a computer sees an image. And this is for colored images. For black and white images, we have only 2 channels. So let's move forward and we'll see why can't we use fully connected networks for image classification. So consider an image which has 28 cross 3 pixels. So when I feed in this image to a fully connected network like this, then the total number of weights required in the first hidden layer will be 2352. You can just go ahead and multiply it yourself. All right. But in real life, the images are not that small. All right. So whatever images that we have, they are definitely above 200 cross 3 pixels. So if I take an image which has 200 cross 3 pixels and I feed it to a fully connected network, so at that time, the number of weights required at the first hidden layer itself will be 120,000 guys. So we need to deal with such huge amount of parameters, and obviously we require more number of neurons. So that can eventually lead to overfitting. So that's why we cannot use fully connected network for image classification. Now let's see why we need convolutional neural networks. So basically, in convolutional neural network, a neuron in the layer will only be connected to a small region of the layer before it. So if you consider this particular neuron which I'm highlighting right now is only connected to 3 other neurons. Unlike the fully connected network where this particular neuron will be connected to all these 5 neurons. Because of this, we need to handle less amount of weights, and in turn, we need less number of neurons as well. So let us understand what exactly is convolutional neural network. So convolutional neural networks are special type of feed-forward artificial neural networks, which is inspired from visual cortex. So visual cortex is nothing but a small region in our brain which is present somewhere here where you can see the bulb. And basically what happened, there was an experiment conducted and people got to know that visual cortex is small regions of cells that are sensitive to specific regions of visual field. So what I mean by that is, for example, some neurons in the visual cortex fires when exposed to vertical edges. Some will fire when exposed to horizontal edges. Some will fire when exposed to diagonal edges. And that is nothing but the motivation behind convolutional neural network. So now let us understand how exactly a convolutional neural network works. So generally a convolutional neural network has 3 layers: convolution layer, ReLU layer, pooling layer, and fully connected layer. We'll understand each of these layers one by one. We'll take an example of a classifier that can classify an image of an X as well as an O. So with this example, we'll be understanding all these 4 layers. So let's begin, guys. Now there are certain trickier cases. So what I mean by that is X can be represented in these 4 forms as well, right? So these are nothing but the deformed images of X. Similarly for O as well. So these are deformed images. So even I want to classify these images either X or O. All right, because even this is X, this is X, this is X, this is X. But all these are deformed images, but they are in turn X, right? So I want my classifier to classify them as X. So basically that's what I want. So if you can notice here, this is a proper image of an X, and which is actually equal to this particular X, which is a deformed image. Same goes for this O as well. So now what we are going to do is, we know that a computer understands an image using numbers at each pixels. So what we'll do, whatever the white pixels that we have, we are going to assign a value -1 to it, and whatever black pixels we have, we are going to assign a value 1 to it. When we use normal techniques to compare these two images, one is a proper image of X and another is a deformed image of X, we got to know that a computer is not able to classify the deformed image of X correctly. Why? Because it is comparing it with the proper image of X, right? So when you go ahead and add the pixel values of both of these images, you get something like this. So basically our computer is not able to recognize whether it is an X or not. Now what we do with the help of CNN, we take small patches of our image. So these patches or these pieces are known as nothing but features or filters. So what we do, by finding rough feature matches in roughly the same positions in two images, CNN gets a lot better at seeing the similarity between the whole image matching schemes. What I mean by that is, we have these filters, right? We have these filters that you can see. So consider this first filter. This is exactly equal to the feature or the part of the image in the deformed image as well. So this is our proper image and this is our deformed image, all right? So this particular feature or this particular part of the image is actually equal to this particular part of the image. Same goes for this particular feature or filter as well. And similarly, we have this filter as well, which is actually equal to this particular part of the deformed image, all right? So let's move forward and we'll see what all features that we'll be taking in our example. So we'll be considering these 3 features or filters. This is a diagonal filter, this is again a diagonal filter, and this is nothing but a small X. So we'll take these three filters and we'll move forward. So what we are going to do is we are going to compare these features, the small pieces of the bigger image. We are going to put it on the input image, and if it matches, then the image will be classified correctly. Now we'll begin, guys. The first layer is convolution layer. So these are the beginning two steps of this particular layer. First, we need to line up the feature in the image and then multiply image by the corresponding feature pixel. Now let me explain you with an example. So this is our first diagonal feature that we'll take. We are going to put this particular feature on our image of X, all right? And we are going to multiply the corresponding pixel value. So 1 will be multiplied with 1, we'll get 1, and we'll put it in another matrix. Similarly, we are going to move forward and we're going to multiply -1 with -1. We're going to multiply -1 with -1, as you can see. Similarly, we multiply this as well, -1 into -1, then again -1 into -1. So we are going to complete this whole process when we are going to finish up this matrix. All right, and once we are done finishing up the multiplication of all the corresponding pixels in the feature as well as in the image, we need to follow two more steps. We need to add them up and divide by the total number of the pixels in the feature. So what I mean by that is, after the multiplication of the corresponding pixel values, what we do, we add all these values, we divide it by the total number of pixels, and we get some value, right? And then now our next step is to create a map and put the value of the filter at that particular place. We saw that after multiplying the pixel value of a feature with the corresponding pixel value of with that of our image, we get the output, which is 1. So we place 1 here. Similarly, we are going to move this filter throughout the image. Next up, we are going to move this filter here. After that, we are going to move it here, 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 everywhere on the image. We are going to move it, and we are going to follow the same process. All right, so yeah, this is one more example where I've moved my filter in between, and after doing that, I've got the output something like this, 1, 1, -1 and all. So over here, if you notice, I've got a couple of times -1 as well, due to which my output that comes is 0.55, right? So I'm going to place 0.55 here. Similarly, after moving the pixel, after moving the filter throughout the image, I got this particular matrix. All right, and this is for one particular feature. After performing the same process for the other two filters as well, I've got these two values. So we have these three values after passing through the convolution layer. Let me give you a quick recap of what happens in convolution layer. So basically we have taken three features, all right, and one by one we'll take one feature, move it through the entire image, and when we are moving it, at that time we are multiplying the pixel value of the image with that of the corresponding pixel value of the filter, adding them up, dividing by the total number of pixels to get the output. So when we do that for all the filters, we got these three outputs, all right? So let's move forward and we'll see what happens in ReLU layer. So this is ReLU layer, guys, and people who have gone through the previous tutorial actually know what it is. So let me just give you a quick introduction of ReLU layer. So ReLU is nothing but an activation function. All right, so what I mean by that is it will only activate a node if the input is above a certain quantity. While the input is below 0, the output is also 0. All right, and when the input rises above the certain threshold, it has a linear relationship with the dependent variable. Now I'll explain you with an example. We have a graph of ReLU function here. So my function says that when f of x is equal to 0 if x is less than 0, and it is equal to x when x is greater than 0. All right, so whatever values that I have which are below 0 will actually in turn become 0, and whatever values that are above 0, our function value will also be equal to that particular value. So f of x will be equal to x if it is greater than or equal to 0, and it will be 0 if it is less than 0. So if I have x value as -3, so definitely it is less than 0, so f of x becomes 0. Similarly, if I have -5x value, then again it is less than 0, so my f of x value becomes 0. But when I consider 3 as my x value, then my f of x becomes equal to x, which is nothing but 3. So over here I'll have 3. Again, if I take my x value as 5, then obviously it is greater than or equal to 0. Then my f of x becomes equal to x, so my f of x value becomes 5. So this is how a ReLU function works. So why are we using ReLU function here is we want to remove all the negative values from our output that we got through the convolution layer. So we'll only take the first output that we got by moving one feature throughout the image. So this is the output that we have got for only one filter. All right, so over here I'm going to remove all negative values. So over here you can see that it was -0.11 before, and I've converted that to 0. Similarly, I'm going to repeat the whole process for the entire matrix, and once I'm done with that, I get this particular value. Now remember, this is only for the output that we got through one feature. All right, so when we were doing convolution at that time, we were using three features, right? So this is the output only for one filter. After doing it for the output of the other two filters as well, we have got these two values more. So totally we have these three values after passing through ReLU activation function. Next up, we'll see what exactly is pooling layer. So in pooling layer, what we do, we take a window size of 2 and we move it across the entire matrix that we have got after passing through ReLU layer. And we take only the maximum value from there so that we can shrink the image. So what we are actually doing is we are reducing the size of our image. So let me explain you with an example. So this is basically one output that we have got after passing through ReLU layer. And over here we have taken a window size of 2 cross 2. So when we keep this window at this particular position, we see that 1 is the highest value. So we are going to keep 1 here. And we are going to repeat the same process for this particular window as well. So over here the maximum value is 0.33, so 0.33 will come. So if you notice here, earlier we had 7 cross 7 matrix, and now we have reduced that to 4 cross 4 matrix. So after doing that for the entire image, we have got this as our output. This output we have got after moving our window throughout the image that we have got after passing through ReLU layer, right? And when we repeat this process for all the 3 outputs that we have got after the ReLU layer, then we get this particular output after pooling layer, right? So basically we have shrinked our image to a 4 cross 4 matrix. Now comes the tricky part. So what we are going to do now is stack up all these layers. So we have discussed convolution layer, ReLU layer, and pooling layer. So I'll just give you a brief recap of what all things we have discussed. In convolution layer, what we did, we took 3 features, and then after that, one by one, we moved each filter throughout the image. And when we were moving it, we were continuously multiplying the image pixel value with that of the corresponding filter pixel value. And then we were dividing it by the total number of pixels. All right. With that, we got 3 output after passing through the convolution layer. Then those 3 output we passed through a ReLU layer where we have removed the negative value. All right, and after removing negative value, again we have got the 3 outputs. Then those 3 outputs we passed through pooling layer. So basically we're trying to shrink our image. And what we did, we took a window size of 2 cross 2, moved it through all the 3 outputs that we have got through ReLU layer. And after doing that, we were only taking the maximum value, pixel value in that particular window. And then we were putting it in a different matrix so that we get a shrinked image. And after passing it through pooling layer, we have got a 4 cross 4 matrix. And since we took 3 features in the beginning, so therefore we have got 3 outputs after passing through pooling layer. All right. Next up, we are going to stack up all the layers. All right. So let's do that. So after passing through convolution, ReLU, and pooling, we have got this 4 cross 4 matrix. This was our input image. Now when we add one more layer of convolution, ReLU, and pooling, we have shrinked our image from 4 cross 4 to 2 cross 2, as you can notice here. Now we are going to use fully connected layer. Now what happens in fully connected layer? The actual classification happens here, guys. Okay. So what we are doing here is we are going to take the shrinked images and put it into a single list. So basically this is what we have got after passing through 2 layers of convolution, ReLU, and pooling. And this is what we have got. So basically we are converting into a single list or a vector. How we do that? We take the first value 1, then we take 0.55, then we take 0.55, then we take 1 again. Then we take 1, then we take 0.55, 0.55, 0.55. Then we again take 0.55, 1, 1, and 0.55. So this is nothing but a vector, or you can say a list. If you notice here that there are certain values in my list which are high for X, and similarly if I repeat the entire process that we have discussed for O, there will be certain different values which will be high. So for X we have first, fourth, 5th, 10th, and 11th element vector values are high. For O we have 2nd, 3rd, 9th, and 12th element vector which are high. So basically we know now if we have an input image which has 1st, 4th, 5th, 10th, and 11th element vector values high, we know that we can classify it as X. Similarly, if our input image has a list which has the 2nd, 3rd, 9th, and 12th element vector values high, then we can classify it as 0. Now let me explain you with an example. So after the training is done, after doing the entire process for both X and O, you know that our model is trained now. Okay, so we have given a new input image, and that input image passes through all the layers. And once it has passed through all the layers, we have got this 12 element vector. Now it has 0.9, 0.65, all these values, right? Now, how do we classify it, whether it is an X or O? So what we do, we'll compare this with a list of X and O, right? So we have got the list in the previous slide. If you notice, we have got 2 different lists for X and O. We are going to compare this new input image list that we have got with that of X and O, right? So first, let us compare that with X. Now, as I've told you earlier as well, for X, there are certain values which will be high, which is nothing but 1st, 4th, 5th, 10th, and 11th value, right? So I'm going to sum 1st, 4th, 5th, 10th, and 11th value, and I've got 5. 1 plus 1 plus 1 plus 1 and plus 1. So 5 times 1, I've got 5. And now I'm going to sum the corresponding values of my input image vector as well. So the first value is 0.9. Then the 4th value is 0.87, 5th value is 0.96, 10th value is 0.89, and the 11th value is 0.94. So after this, doing the sum of these values, I've got 4.56. When I divide this by 5, I got 0.91, right? Now this is for X. Now when I do the same process for O, so in O, if you notice, I have second, third, ninth and 12th element vector values as high. So when I sum these values, I get 4. And when I do the sum of the corresponding values in my input image, I've got 2.07. When I divide that by 4, I got 0.51. And so now we notice that 0.91 is a higher value compared to 0.51. So when we have compared our input image with the values of X, we got a higher value than the value that we have got after comparing the input image with the values of O. So the input image is classified as X. Alright, so now let us move towards our use case. So this is our use case, guys. So over here, what we are going to do is we are going to train our model on different types of dogs and cat images. And once the training is done, we are going to provide it an input and it will classify whether the input is of a dog or a cat. Now, let me tell you the steps involved in it. So what we are going to do in the beginning is obviously first we need to download the data set. After that, we are going to write a function to encode the labels. Labels are nothing but the dependent variable that we are trying to predict. So in our training data and testing data, obviously we know the labels, right? So on that basis only we can train our model. So we are going to encode those labels. After that, we'll resize the image to 50 cross 50 pixel and we are going to read it as a grayscale image. Then we are going to split the data, 24,000 images for training and 50 for testing. Once this is done, we are going to reshape the data appropriately for TensorFlow. Now TensorFlow, I think everyone knows about TensorFlow. TensorFlow is nothing but a Python library for implementing deep learning models. Then we are going to build the model, calculate the loss. It is nothing but categorical cross entropy. Then we are going to reduce the loss by using Adam optimizer with a learning rate set to 0.001. Then we are going to train the deep neural network for 10 epochs. And finally, we are going to make predictions. All right, so I'll just quickly open my PyCharm and I'll show you the code, how it looks like. So this is the code that I've written in order to implement the use case. In the beginning, I need to import the libraries that I require. And once it is done, what I'm doing, I'm defining my training data and the testing data. So train and test one contains both my training data as well as testing data respectively. Then I've taken my image size as 50 and learning rate I've defined here. And I've given a name to my model. You can give whatever name you want. All right, so first thing that we saw, we need to encode the dependent variable. That's what we are doing here. We are encoding our dependent variable. So whenever the label is cat, then it will be converted to an array of 1, 0, and when it is dog, it will be converted to an array of 0, 1. So why we're actually encoding the label? Because our code cannot understand the categorical variable. So we need to encode it, right? Next, what I'm doing is I'm resizing my image to 50 cross 50 and I am converting it to a grayscale image, right? And once this is done, I'm going to split my data set into training and testing parts. So yeah, we are basically splitting the data set into two parts for training and testing. And here we are defining a model. So you can I can just go ahead and throw in a comment here. Building the model. Yeah. So this is where we are building the model. So basically what we have done here is we have resized our image to 50 cross 50 cross 1 matrix. And that is the size of the input that we are using, right? This input that I'm talking about. Then what we have done, a convolution layer we have defined with 32 filters and a stride of 5 with an activation function, a ReLU. And after that, we have added a pooling layer, max pool layer. Okay. Again, what we have done, we have repeated the same process, but over here we are taking 64 filters and 5 stride, passing it through a ReLU activation function, and after that we have a pooling layer, max pool layer. Then we have repeated the same process for 128 filters. After that, we have repeated for 64 filters, then for 32 filters. Then after that, we are using a fully connected layer with 1024 neurons. And finally, we are using the dropout layer with key probability of 0.8 to finish our models. This is where our model is actually finished. And then what we are doing is we are using the Adam optimizer to optimize our model. So basically, whatever the loss that we have, we are trying to reduce it. And this is basically for your TensorBoard. So we are creating some log files, and then with that log file, TensorBoard will create a pretty fancy graphs for us that helps us to visualize the entire model. And then what we are doing is we are trying to fit the model. And we have defined epochs as 10. That is the number of iterations that will happen will be 10. And yeah, so this is pretty much it. Model name we have given. Then input is x_test to check the accuracy. Similarly, the target will be y_test. The labels associated with that test data will be a y_test, and which we have encoded basically. So this is how we are going to actually calculate the accuracy, and we'll try to reduce the loss as much as possible in 10 epochs. So till now our model is complete. We are done with it. Next, what I'm doing is I'm feeding in some random input from the test data and I'm validating whether my model is predicting it correct or not. All right. So I've already trained the model because it takes a lot of time and yeah, I cannot do it here. So I've already trained the model and you can see that the loss that came after the 10th epoch is 0.2973 and the accuracy is somewhere around 88%, which is pretty good, guys. And yeah, and I've done the prediction on the test data as well. So let me just show it to you that. So this is the prediction that it has done on few of the images in the test data. So yeah, it is a cat predicted as cat, cat predicted as cat, 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 and dogs as well. There are certain dogs as well. So this is the problem statement, guys. We need to figure out if the banknotes are real or fake. And for that, we'll be using artificial neural networks. And obviously, we need some sort of data in order to train our network. So let us see how the data set looks like. So over here, I've taken a screenshot of the data set with few of the rows. In it, data were extracted from images that were taken from genuine and forged banknote-like specimens. After that, wavelet transform tools were used to extract features from those images. And these are few features that I'm highlighting with my cursor. And the final column or the last column actually represents the label. So basically, label tells us to which class that pattern represents, whether that pattern represents a fake note or it represents a real note. Let us discuss these features and labels one by one. So the first feature or the first column is nothing but variance of a wavelet transformed image. The second column is about skewness. The third is curtices of wavelet transformed image. And finally, fourth one is entropy of the image. After that, when I talk about label, which is nothing but my last column, over here, if the value is 1, that means the pattern represents a real note. Whereas when value is 0, that means it represents a fake note. So guys, let's move forward and we'll see what are the various steps involved in order to implement this use case. So over here, we'll first begin by reading the data set that we have. We'll define features and labels. After that, we are going to encode the dependent variable. And what is a dependent variable? It is nothing but your label. Then we are going to divide the data set into two parts, one for training, another for testing. After that, we'll use TensorFlow data structures for holding features, labels, etc. And TensorFlow is nothing but a Python library that is used in order to implement deep learning models, or you can say neural networks. Then we'll write the code in order to implement the model. And once this is done, we will train our model on the training data. We'll calculate the error. Error is nothing but your difference between the model output and the actual output. And we'll try to reduce this error. And once this error becomes minimum, we'll make prediction on the test data and we'll calculate the final accuracy. So guys, let me quickly open my PyCharm and I'll show you how the output looks like. So this is my PyCharm, guys. Over here, I've already written the code in order to execute the use case. I'll go ahead and run this and I'll show you the output. So over here, as you can see, with every iteration, the accuracy is increasing. So let me just stop it right here. So we'll move forward and we'll understand why we need neural networks. So in order to understand why we need neural networks, we are going to compare the approach before and after neural networks. And we'll see what were the various problems that were there before neural networks. So earlier, conventional computers use an algorithmic approach. That is, the computer follows a set of instructions in order to solve a problem. And unless the specific steps that the computer needs to follow are known, the computer cannot solve the problem. So obviously we need a person who actually knows how to solve that problem, and he or she can provide the instructions to the computer as to how to solve that particular problem, right? So we first should know the answer to that problem, or we should know how to overcome that challenge or problem which is there in front of us. Then only we can provide instructions to the computer. So this restricts the problem solving capability of conventional computers to problems that we already understand and know how to solve. But what about those problems whose answer we have no clue of? So that's where our traditional approach was a failure. So that's why neural networks were introduced. Now let us see what was the scenario after neural networks. So neural networks basically process information in a similar way the human brain does. And these networks, they actually learn from examples. You cannot program them to perform a specific task. They will learn from their examples, from their experience. So you don't need to provide all the instructions to perform a specific task. And your network will learn on its own with its own experience. All right, so this is what basically neural network does. So even if you don't know how to solve a problem, you can train your network in such a way that with experience, it can actually learn how to solve the problem. So that was a major reason why neural networks came into existence. So we'll move forward and we'll understand what is the motivation behind neural networks. So these neural networks are basically inspired by neurons, which are nothing but your brain cells. And the exact working of the human brain is still a mystery though. So as I've told you earlier as well, that neural networks work like human brain, and so the name. And similar to a newborn human baby, as he or she learns from his or her experience, we want a network to do that as well. But we want it to do very quickly. So here's a diagram of a neuron. Basically, a biological neuron receives input from other sources, combines them in some way, perform a generally non-linear operation on the result, and then outputs the final result. So here, if you notice these dendrites will receive signals from the other neurons. Then what will happen, it will transfer it to the cell body. The cell body will perform some function. It can be summation, it can be multiplication. So after performing that summation on the set of inputs, via axon, it is transferred to the next neuron. Now let's understand what exactly are artificial neural networks. It is basically a computing system that is designed to simulate the way the human brain analyzes and processes the information. Artificial neural networks has self-learning capabilities that enable it to produce better results as more data becomes available. So if you train your network on more data, it will be more accurate. So these neural networks, they actually learn by example. And you can configure your neural network for specific applications. It can be pattern recognition, or it can be data classification, anything like that, all right? So because of neural networks, we see a lot of new technology has evolved. From translating web pages to other languages, to having a virtual assistant to order groceries online, to conversing with chatbots. All of these things are possible because of neural networks. So in a nutshell, if I need to tell you, artificial neural network is nothing but a network of various artificial neurons. All right. So let me show you the importance of neural network with two scenarios, before and after neural network. So over here we have a machine, and we have trained this machine on 4 types of dogs, as you can see where I'm highlighting with my cursor. And once the training is done, we provide a random image to this particular machine which has a dog. But this dog is not like the other dogs on which we have trained our system on. So without neural networks, our machine cannot identify that dog in the picture, as you can see it over here. Basically, our machine will be confused. It cannot figure out where the dog is. Now, when I talk about neural networks, even if we have not trained our machine on this specific dog, but still it can identify certain features of the dogs that we have trained on, and it can match those features with the dog that is there in this particular image, and it can identify that dog. So this happens all because of neural networks. So this is just an example to show you how important are neural networks. Now I know you all must be thinking how neural networks work. So for that, we'll move forward and understand how it actually works. So over here, I'll begin by first explaining a single artificial neuron that is called as perceptron. So this is an example of a perceptron. Over here, we have multiple inputs, x1, x2, dash, 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 till xn. And we have corresponding weights as well, w1 for x1, w2 for x2, similarly wn for xn. Then what happens, we calculated the weighted sum of these inputs. And after doing that, we pass it through an activation function. This activation function is nothing but it provides a threshold value. So above that value, my neuron will fire, else it won't fire. So this is basically an artificial neuron. So when I talk about a neural network, it involves a lot of these artificial neurons with their own activation function and their processing element. Now we'll move forward and we'll actually understand various modes of this perceptron or single artificial neuron. So there are 2 modes in a perceptron. One is training, another is using mode. In training mode, the neuron can be trained to fire for particular input patterns, which means that we'll actually train our neuron to fire on certain set of inputs and to not fire on the other set of inputs. That's what basically training mode is. When I talk about using mode, it means that when a taught input pattern is detected at the input, its associated output becomes the current output, which means that once the training is done and we provide an input on which the neuron has been trained on, so it will detect the input and will provide the associated output. So that's what basically using mode is. So first you need to train it, then only you can use your perceptron or your network. So these were the 2 modes, guys. Next up, we'll understand what are the various activation functions available. So these are the 3 activation functions, although there are many more, but I've listed down 3. Step function. So over here, the moment your input is greater than this particular value, your neuron will fire, else it won't. Similarly for sigmoid and sine function as well. So these are 3 activation functions. There are many more that I've told you earlier as well. So yeah, these are the 3 majorly used activation functions. Next up, what we are going to do, we are going to understand how a neuron learns from its experience. So I'll give you a very good analogy in order to understand that. And later on, when we talk about neural networks, or you can say multiple neurons in a network, I'll explain you the maths behind it. I'll explain you the maths behind learning, how it actually happens. So right now I'll explain you with an analogy. And guys, trust me, that analogy is pretty interesting. So I know all of you must have guessed it. So these are two beer mugs, and all of you who love beer can actually relate to this analogy a lot. And I know most of you actually love beers, so that's why I've chosen this particular analogy, so that all of you can relate to it. All right, jokes apart. So fine guys, so there's a beer festival happening near your house and you want to badly go there. But your decision actually depends on three factors. First is how is the weather, whether it is good or bad. Second is your wife or husband is going with you or not. And the third one is any public transport is available. So on these three factors, your decision will depend whether you will go or not. So we'll consider these three factors as inputs to our perceptron, and we'll consider our decision of going or not going to the beer festival as our output. So let us move forward with that. So the first input is how is the weather. We'll consider it as x1. So when weather is good, it'll be 1, and when it is bad, it'll be 0. Similarly, your wife is going with you or not, so that'll be your x2. If she is going, then it's 1. If she's not going, then it's 0. Similarly, for public transport, if it is available, then it is 1, else it is 0. So these are the three inputs that I'm talking about. Let's see the output. So output will be 1 when you're going to the beer festival, and output will be 0 when you want to relax at home. You want to have beer at home only. You don't want to go outside. So these are the two outputs, whether you're going or you're not going. Now what a human brain does. Over here, okay, fine. I need to go to the beer festival. But there are three things that I need to consider. But will I give importance to all these factors equally? Definitely not. There'll be certain factors which will be of higher priority for me. I'll focus on those factors more. Whereas few factors won't affect that much to me. Alright, so let's prioritize our inputs or factors. So here our most important factor is weather. So if weather is good, I love beer so much that I don't care even if my wife is going with me or not, or if there is a public transport available. So I love beer that much that if weather is good, then definitely I'm going there. That means when x1 is high, output will be definitely high. So how we do that, how we actually prioritize our factors, or how we actually give importance more to a particular input and less to another input in a perceptron or in a neuron. So we do that by using weights. So we assign high weights to the more important factors or more important inputs, and we assign low weights to those particular inputs which are not that important for us. So let's assign weights, guys. So weight W1 is associated with input X1, W2 with X2, and similarly W3 with X3. Now, as I've told you earlier as well, that weather is a very important factor, so I'll assign a pretty high weight to weather and I'll keep it as 6. Similarly, W2 and W3 are not that important, so I'll keep it as 2, 2. After that, I've defined a threshold value as 5, which means that when the weighted sum of my input is greater than 5, then only my neuron will fire, or you can say then only I'll be going to the beer festival. Alright, so I'll use my pen and we'll see what happens when weather is good. So when weather is good, our x1 is 1, our weight is 6, we'll multiply it with 6. Then, if my wife decides that she is going to stay at home and she will probably be busy with cooking and she doesn't want to drink beer with me, so she's not coming. So that input becomes 0. 0 into 2 will actually make no difference because it will be 0 only. Then again, there is no public transport available also. Then also this will be 0 into 2. So what output I get here? I get here as 6. And notice the threshold value, it is 5. So definitely 6 is greater than 5. That means my output will be 1, or you can say my neuron will fire, or I'll actually go to the beer festival. So even if these two inputs are 0 for me, that means my wife is not willing to go with me and there is no public transport available, but weather is good, which has very high weight value and it actually matters a lot to me. So if that is high, it doesn't really matter whether the two inputs are high or not. I will definitely go to the beer festival. Alright, now I'll explain you a different scenario. So over here our threshold was 5, but what if I change this threshold to 3? So in that scenario, even if my weather is not good, I'll give it a 0. So 0 into 6. But my wife and public transport both are available. Alright, so 1 into 2 plus 1 into 2, which is equal to 4. And it is definitely greater than 3. Then also my output will be 1. That means I will definitely go to the beer festival even if weather is bad. And my neuron will fire. So these are the two scenarios that I have discussed with you. Alright, so there can be many other ways in which you can actually assign weight to your problem or to your learning algorithm. So these are the two ways in which you can assign weights and prioritize your inputs or factors on which your output will depend. So obviously in real life, all the inputs or all the factors are not as important for you. So you actually prioritize them. And how you do that in perceptron, you provide high weight to it. This is just an analogy so that you can relate to a perceptron to a real life. We'll actually discuss the math behind it later in the session as to how a network or a neuron learns. All right. So how the weights are actually updated and how the output is changing, that all those things we'll be discussing later in the session. But my aim is to make you understand that you can actually relate to a real life problem with that of a perceptron. All right. And in real life, problems are not that easy. They are very, very complex problems that we actually face. So in order to solve those problems, a single neuron is definitely not enough. So we need networks of neurons. And that's where artificial neural network, or you can say multi-layer perceptron, comes into the picture. Now let us discuss that. Multi-layer perceptron or artificial neural network. So this is how an artificial neural network actually looks like. So over here we have multiple neurons present in different layers. The first layer is always your input layer. This is where you actually feed in all of your inputs. Then we have the first hidden layer. Then we have second hidden layer, and then we have the output layer. Although the number of hidden layers depend on your application, on what are you working, what is your problem. So that actually determines how many hidden layers you'll have. So let me explain you what is actually happening here. So you provide in some input to the first layer, which is nothing but your input layer. You provide inputs to these neurons. All right. And after some function, the output of these neurons will become the input to the next layer, which is nothing but your hidden layer 1. Then these hidden layers also have various neurons. These neurons will have different activation functions. So they'll perform their own function on the inputs that it receives from the previous layer. And then the output of this layer will be the input to the next hidden layer, which is hidden layer 2. Similarly, the output of this hidden layer will be the input to the output layer. And finally, we get the output. So this is how basically an artificial neural network looks like. Now let me explain you this with an example. So over here, I'll take an example of image recognition using neural networks. So over here, what happens, we feed in a lot of images to our input layer. Now this input layer will actually detect the patterns of local contrast, and then will feed that to the next layer, which is hidden layer 1. So in this hidden layer 1, the face features will be recognized. We'll recognize eyes, nose, ears, things like that. And then that will be again fed as input to the next hidden layer. And in this hidden layer, we'll assemble those features and we'll try to make a face. And then we'll get the output, that is the face will be recognized properly. So if you notice here, with every layer, we are trying to get a more abstract version or the generalized version of the input. So this is how basically an artificial neural network, how it works. All right. And there's a lot of training and learning which is involved that I'll show you now. Training a neural network. So how we actually train a neural network. So basically the most common algorithm for training a network is called backpropagation. So what happens in backpropagation, after the weighted sum of inputs and passing through an activation function and getting the output, we compare that output with the actual output that we already know. We figure out how much is the difference. We calculate the error. And based on that error, what we do, we propagate backwards. And we'll see what happens when we change the weight. Will the error decrease or will it increase? And if it increases, when it increases by increasing the value of the variables or by decreasing the value of variables. So we kind of calculate all those things and we update our variables in such a way that our error becomes minimum. And it takes a lot of iterations. Trust me guys, it takes a lot of iterations. We get output a lot of times and then we compare it with the model, with the actual output. Then again we propagate backwards, we change the variables, then again we calculate the output, we compare it again with the desired output of the actual output. Then again we propagate backwards. So this process keeps on repeating until we get the minimum value. All right. So there is an example that is there in front of your screen. Don't be scared of the terms that I used. I'll actually explain you with an example. So this is the example over here. We have 0, 1 and 2 as inputs and our desired output or the output that we already know is 0, 1 and 4. All right. So over here we can actually figure out that desired output is nothing but twice of your input. But I'm training a computer to do that, right? The computer is not a human. So what happens, I actually initialize my weight, I keep the value as 3. So the model output will be 3 into 0 is 0, 3 into 1 is 3, 3 into 2 is 6. Now obviously it is not equal to your desired output, so we check the error. Now the error that we have got here is 0, 1 and 2, which is nothing but your difference. So 0 minus 0 is 0, 3 minus 2 is 1, 6 minus 4 is 2. Now this is called an absolute error. After squaring this error, we get square error, which is nothing but 0, 1 and 4. All right. So now what we need to do, we need to update the variables. We have seen that the output that we got is actually different from the desired output. So we need to update the value of the weight. So instead of 3, our computer makes it as 4. After making the value as 4, we get the model output as 0, 4 and 8. And then we saw that the error has actually increased. Instead of decreasing, the error has increased. So after updating the variable, the error has increased. So you can see that square error is now 0, 4 and 16, and earlier it was 0, 1 and 4. That means we cannot increase the weight value right now. But if we decrease that, make it as 2, we get the output which is actually equal to desired output. But is it always the case that we need to only decrease the weight? Definitely not. So in this particular scenario, whenever I'm increasing the weight, error is increasing, and when I'm decreasing the weight, error is decreasing. But as I've told you earlier as well, this is not the case every time. Sometimes you need to increase the weight as well. So how we determine that? Alright, fine guys, this is how basically a computer decides whether it has to increase the weight or decrease the weight. So what happens here, this is a graph of square error versus weight. So over here what happens, suppose your square error is somewhere here, and your computer, it starts increasing the weight in order to reduce the square error. And it notices that whenever it increases the weight, square error is actually decreasing. So it'll keep on increasing until the square error reaches a minimum value. And after that, when it tries to still increase the weight, the square error will increase. So at that time, our network will recognize that whenever it is increasing the weight after this point, error is increasing. So therefore it will stop right there, and that will be our weight value. Similarly, there can be one more scenario. Suppose if we increase the weight, but then also the square error is increasing. So at that time, we cannot increase the weight. At that time, computer will realize, okay, fine, whenever I'm increasing the weight, the square error is increasing. So it'll go in the opposite direction. So it'll start decreasing the weight, and it'll keep on doing that until the square error becomes minimum. And the moment it decreases more, the square error again increases. So our network will know that whenever it decreases the weight value, the square error is increasing. So that point will be our final weight value. So guys, this is what basically backpropagation in a nutshell is. Fine, so we'll move forward, and now is the correct time to understand how to implement the use case that I was talking about at the beginning. That is how to determine whether a node is fake or real. So for that, I'll open my PyCharm. This is my PyCharm again, guys. Let me just close this. All right. So this is the code that I've written in order to implement the use case. So over here, what we do, we import the first important libraries which are required. Matplotlib is used for visualization. TensorFlow we know in order to implement the neural networks. NumPy for arrays, pandas for reading the data set. Similarly, sklearn for label encoding as well as for shuffling, and also to split the data set into training and testing parts. All right, fine guys. So we'll begin by first reading the data set, as I've told you earlier as well when I was explaining the steps. So what I'll do, I'll use pandas in order to read the CSV file which has the data set. After that, I'll define features and labels. So X will be my feature and Y will contain my label. So basically X includes all the columns apart from the last column, which is the fifth one. And because the indexing starts from 0, that's why we have written 0 till 4th. So it won't include the 4th column. All right. And so our last column will actually be our label. Then what we need to do, we need to encode the dependent variable. So the dependent variable, as I've told you earlier as well, is nothing but your label. So I've discussed encoding in TensorFlow tutorial. You can go through it and you can actually get to know why and how we do that. Then what we have done, we have read the data set. Then what we need to do is to split our data set into training and testing. And these are all optional steps. You can print the shape of your training and test data. If you don't want to do it, it's still fine. Then we have defined learning rate. So learning rate is actually the steps in which the weights will be updated. All right. So that is what basically learning rate is. Then when we talk about epochs, means iterations. Then we have defined course history. That will be an empty NumPy array, and its shape will be 1, and it will include the float type objects. Then we have defined ndim, which is nothing but your X shape of axis 1, which means your column. Then we'll print that. After that, we have defined the number of classes. So there can be only 2 classes, whether the node can be fake or it can be real. And this model path I've given in order to save my model. So I've just given a path where I need to save it. So I'll just save it here only in the current working directory. Now is the time to actually define our neural network. So we'll first make sure that we have defined the important parameters like hidden layers, number of neurons in hidden layers. So I'll take 10 neurons in every hidden layer, and I'm taking 4 layers like that. Then X will be my placeholder, and the shape of this particular placeholder is none, comma n underscore dim. N underscore dim value, I'll get it from here, and none can be any value. I'll define one variable W, and I'll initialize it with zeros, and this will be the shape of my weight. Similarly for bias as well, this will be the particular shape. and there will be one more placeholder y dash, which will actually be used in order to provide us with the actual output of the model. There'll be one model output and there'll be one actual output, which we use in order to calculate the difference, right? So we'll feed in the actual values of the labels in this particular placeholder y dash. And now we'll define the model. So over here we have named the function as multi-layer perceptron, and in it we'll first define the first layer. So the first hidden layer, and we are going to name it as layer underscore 1, which will be nothing but the matrix multiplication of x and weights of h1, that is the hidden layer 1, and that will be added to your biases b1. After that, we'll pass it through a sigmoid activation function. Similarly, in layer 2 as well, matrix multiplication of layer 1 and weights of h2. So if you can notice, layer 1 was the network layer just before the layer 2, right? So the output of this layer 1 will become input to the layer 2. And that's why we have written layer underscore 1. It'll be multiplied by weights h2, and then we'll add it with the bias. Similarly for this particular hidden layer as well, and this particular layer as well. But over here we are going to use the ReLU activation function instead of sigmoid. Then we are going to define the weights and biases. So this is how we basically define weights. So weights h1 will be a variable which will be a truncated normal with the shape of n underscore dim and n underscore hidden underscore 1. So these are nothing but your shapes. All right. And after that, what we have done, we have defined biases as well. Then we need to initialize all the variables. So all these things actually I've discussed in brief when I was talking about TensorFlow. So you can go through TensorFlow tutorial at any point of time if you have any question. We have discussed everything there. Since in TensorFlow we need to initialize the variables before we use it. So that's how we do it. We first initialize it and then we need to run it. That's when your variables will be initialized. After that, we are going to create a saver object. And then finally, I'm going to call my model. And then comes the part where the training happens. Cost function. Cost function is nothing but you can say an error that will be calculated between the actual output and the model output. All right, so y is nothing but our model output and y dash is nothing but the actual output or the output that we already know. All right, and then we are going to use a gradient descent optimizer to reduce the error. Then we are going to create a session object as well. And finally, what we are going to do, we are going to run the session. So this is how we basically do that. For every epoch, we will be calculating the change in the error as well as the accuracy that comes after every epoch on the training data. After we have calculated the accuracy on the training data, we are going to plot it for every epoch how the accuracy is. And after plotting that, we are going to print the final accuracy, which will be on our test data. So using the same model, we'll make prediction on the test data. And after that, we are going to print the final accuracy and the mean squared error. So let's go ahead and execute this, guys. All right, so training is done. And this is the graph we have got for accuracy versus epoch. This is accuracy, y-axis represents accuracy, whereas this is epochs. We have taken 100 epochs and our accuracy has reached somewhere around 99%. So with every epoch, it is actually increasing. Apart from a couple of instances, it is actually keep on increasing. So the more data you train your model on, it will be more accurate. Let me just close it. So now the model has also been saved where I wanted it to be. This is my final test accuracy and this is the mean squared error. Alright, so these are the files that will appear once you save your model. These are the 4 files that I've highlighted. Now what we need to do is restore this particular model. And I've explained this in detail how to restore a model that you have already saved. So over here what I'll do, I'll take some random range. I've taken it actually from 754 to 768. So all the values in the row of 754 and 768 will be fed to our model and our model will make prediction on that. So let us go ahead and run this. So when I'm restoring my model, it seems that my model is 100% accurate for the values that I've fed in. So whatever values that I have actually given as input to my model, it has correctly identified its class, whether it's a fake node or a real node. Because 0 stands for fake node and 1 stands for real node, okay? So original class is nothing but which is there in my data set, so it is 0 already. And what prediction my model has made is 0. That means it is fake. So accuracy becomes 100%. Similarly for other values as well. Fine guys, so this is how we basically implement the use case that we saw in the beginning. So in the slide you can notice that I've listed down only 2 applications, although there are many more. So neural networks in medicine. Artificial neural networks are currently a very hot research area in medicine, and it is believed that they will receive extensive application to biomedical systems in the next few years. And currently the research is mostly on modeling parts of human body. and recognizing diseases from various scans. For example, it can be cardiograms, CAT scans, ultrasonic scans, etc. And currently the research is going mostly on two major areas. First is modeling and diagnosing the cardiovascular system. So neural networks are used experimentally to model the human cardiovascular system. Diagnosis can be achieved by building a model of the cardiovascular system of an individual and comparing it with the real-time physiological measurements taken from the patient. And trust me guys, if this routine is carried out regularly, potential harmful medical conditions can be detected at an early stage and thus make the process of combating disease much easier. Apart from that, it is currently being used in electronic noses as well. Electronic noses have several potential applications in telemedicine. Now let me just give you an introduction to telemedicine. Telemedicine is the practice of medicine over long distance via a communication link. So what the electronic noses will do, they would identify odors in the remote surgical environment. These identified odors would then be electronically transmitted to another site where an door generation system would recreate them. Because the sense of the smell can be an important sense to the surgeon, telesmell would enhance telepresent surgery. So these are the two ways in which you can use it in medicine. You can use it in business as well, guys. So business is basically a diverted field with several general areas of specialization such as accounting or financial analysis. Almost any neural network application would fit into one business area or financial analysis. Now there is some potential for using neural networks for business purposes, including resource allocation and scheduling. I've listed down two major areas where it can be used. One is marketing. So there is a marketing application which has been integrated with a neural network system. The airline marketing tactician is a computer system made of various intelligent technologies, including expert systems. A feed-forward neural network is integrated with the AMT, which is nothing but airline marketing tactician, and was trained using backpropagation to assist the marketing control of airline seat allocation. So it has wide applications in marketing as well. Now the second area is credit evaluation. Now I'll give you an example here. The HNC company has developed several neural network applications, and one of them is the credit scoring system, which increases the profitability of existing model up to 27%. So these are few applications that I'm telling you guys. Neural network is actually the future. People are talking about neural networks everywhere, and especially after the introduction of GPUs and the amount of data that we have now, neural network is actually spreading like plague right now. Why can't we use feed-forward networks? Now let us take an example of a feed-forward network that is used for image classification. So we have trained this particular network for classifying various images of animals. Now if you feed in an image of a dog, it will identify that image and will provide a relevant label to that particular image. Similarly, if we feed in an image of an elephant, it will provide a relevant label to that particular image as well. Now if you notice, the new output that we have got, that is classifying an elephant, has no relation with the previous output, that is of a dog. Or you can say that the output at time t is independent of output at time t minus 1. As we can see that there is no relation between the new output and the previous output. So we can say that in feed-forward networks, outputs are independent to each other. Now there are a few scenarios where we actually need the previous output to get the new output. Let us discuss one such scenario. Now what happens when you read a book? You'll understand that book only on the understanding of your previous words. Alright, so if I use a feed-forward network and try to predict the next word in a sentence, I can't do that. Why can't I do that? Because my output will actually depend on the previous outputs. But in the feed-forward network, my new output is independent of the previous outputs. That is, output at t plus 1 has no relation with output at t minus 2, t minus 1 and at t. So basically, we cannot use feed-forward networks for predicting the next word in a sentence. Similarly, you can think of many other examples where we need the previous output, some information from the previous output, so as to infer the new output. This is just one small example. There are many other examples that you can think of. So we'll move forward and understand how we can solve this particular problem. So over here, what we have done, we have input at t minus 1. We'll feed it to our network. Then we'll get the output at t minus 1. Then at the next timestamp, that is at time t, we have input at time t that will be given to our network along with the information from the previous timestamp, that is t minus 1, and that will help us to get the output at t. Similarly, at output for t plus 1, we have two inputs. One is a new input that we give. Another is the information coming from the previous timestamp, that is t, in order to get the output at time t plus 1. Similarly, it can go on. So over here, I have just written a generalized way to represent it. There's a loop where the information from the previous timestamp is flowing. And this is how we can solve this particular challenge. Now let us understand what exactly are recurrent neural networks. So for understanding recurrent neural network, I'll take an analogy. Suppose your gym trainer has made a schedule for you. The exercises are repeated after every third day. Now this is the order of your exercises. First day you'll be doing shoulder, second day you'll be doing biceps, third day you'll be doing cardio. And all these exercises are repeated in a proper order. Now what happens when we use a feed-forward network for predicting the exercise today? So we'll provide in the inputs such as day of the week, month of the year, and health status. All right, and we need to train our model or our network on the exercises that we have done in the past. After that, there'll be a complex voting procedure involved that will predict the exercise for us. And that procedure won't be that accurate. So whatever output we'll get won't be as accurate as we want it to be. Now what if I change my inputs and I make my inputs as what exercise I've done yesterday? So if I've done shoulder, then definitely today I'll be doing biceps. Similarly, if I've done biceps yesterday, today I'll be doing cardio. Similarly, if I've done cardio yesterday, today I'll be doing shoulder. Now there can be one scenario where you are unable to go to gym for one day. Due to some personal reasons, you could not go to the gym. Now what will happen at that time? We'll go one timestamp back and we'll feed in what exercise that happened day before yesterday. So if the exercise that happened day before yesterday was shoulder, then yesterday there were biceps exercises. Alright, similarly biceps happened day before yesterday, then yesterday would have been cardio exercises. Similarly, if cardio would have happened day before yesterday, yesterday would have been shoulder exercises. Alright, and this prediction, the prediction for the exercise that happened yesterday will be fed back to our network, and these predictions will be used as inputs in order to predict what exercise will happen today. Similarly, if you have missed your gym say for 2 days, 3 days or 1 week, so you need to roll back. You need to go to the last day when you went to the gym. You need to figure out what exercise you did on that day, feed that as an input, and then only you'll be getting the relevant output as to what exercise will happen today. Now what I'll do, I'll convert these things into a vector. Now what is a vector? Vector is nothing but a list of numbers. Alright, so this is the new information guys along with the information from the prediction at the previous timestamp. So we need both of these in order to get the prediction at time t. Imagine if I have done shoulder exercises yesterday. So this will be 1, this will be 0, and this will be 0. Now the prediction that will happen will be biceps exercise because if I have done shoulder yesterday, today it will be biceps. So my output will be 0, 1 and 0. And this is how vectors work guys. So I hope you have understood this guys. Now this is how a neural network looks like guys. We have new information along with the information from the previous timestamp. The output that we have got in the previous timestamp will use certain information from that, will feed into our network as inputs, and then that will help us to get the new output. Similarly, this new output that we have got will take some information from that, feed in as an input to our network along with the new information to get the new prediction, and this process keeps on repeating. Now let me show you the math behind the recurrent neural networks. So this is the structure of a recurrent neural network guys. Let me explain you what happens here. Now consider at time t equals to 0, we have input x naught and we need to figure out what is h naught. So according to this equation, h of 0 is equal to wi weight matrix multiplied by our input x of 0 plus wr into h of 0 minus 1, which is h of minus 1, and time can never be negative, so this particular equation cannot be applied here, plus a bias. So wi into x of 0 plus bh passes through a function g of h to get h of 0 over here. After that, I want to calculate y naught. So for y naught, I'll multiply h of 0 with the weight matrix wi and I'll add a bias to it and pass it through a function g of y to get y naught. Now in the next timestamp, that is at time t equals to 1, things become a bit tricky. Now let me explain you what happens here. So at time t equals to 1, I have input x1. I need to figure out what is h1. So for that, I'll use this equation. So I'll multiply wi, that is the weight matrix, by the input x1 plus wr into h of 1 minus 1, which is 0. H of 0, we know what we got from here. So wr into h of 0 plus the bias, pass it through a function g of h to get the output as h1. Now this h1 will use to get y1. We'll multiply h1 with wi plus a bias and we'll pass it through a function g of y to get y1. Similarly, in the next timestamp, that is at time t equals to 2, we have input x2. We need to figure out what will be h2. So we'll multiply the weight matrix wi with x of 2 plus wr into h of 1 that we have got here plus b of h and pass it through a function g of h to get h of 2. From h of 2, we'll calculate y of 2, wi into h of 2 plus by that is the bias, pass it through a function g of y to get white. And this is how recurrent neural network works, guys. Now you must be thinking how to train a recurrent neural network. So a recurrent neural network uses backpropagation algorithm for training. But backpropagation happens for every timestamp. That is why it is commonly called as backpropagation through time. And I've discussed backpropagation in detail in artificial neural network tutorial, so you can go through that. Over here, I won't be discussing backpropagation in detail. I'll just give you a brief introduction of what it is. Now with backpropagation, there are certain issues, namely vanishing and exploding gradients. Let us see those one by one. So in vanishing gradient, what happens? When you use backpropagation, you tend to calculate the error, which is nothing but the actual output that you already know minus the model output, the output that you got through your model, and the square of that. So you figure out the error. With that error, what do? You tend to find out the change in error with respect to change in weight or any variable. So we'll call it weight here. So change of error with respect to weight multiplied by learning rate will give you the change in weight. Then you need to add that change in weight to the old weight to get the new weight. All right. So obviously what we are trying to do, we are trying to reduce the error. So for that, we need to figure out what will be the change in error if my variables are changed, right? So that way we can get the change in the variable and add it to our old variable to get the new variable. Now over here, what can happen if the value dE by dW, that is a gradient, or you can say the rate of change of error with respect to our variable weight, becomes very small than 1, like it is 0.00 something. So if you multiply that with the learning rate, which is definitely smaller than 1, then you get the change of weight, which is negligible. All right. So there might be certain examples where you are trying to predict, say, a next word in a sentence, and that sentence is pretty long. For example, if I say I went to France dash dash dash, I went to France, then there are certain words, then I say few of them speak dash. Now I need to predict speak, what will come after speak. So for that, I need to go back in time and check what was the context, which will be very complex. And due to that, there will be a lot of iterations. And because of that, this error, this change in weight will become very small, very small. So the new weight that we'll get will be actually almost equal to your old weight. So there won't be any updation of weight that will be happening. And that is nothing but your vanishing gradient. All right, I'll repeat it once more. So what happens in backpropagation, you first calculate the error. This error is nothing but the difference between the actual output and the model output and the square of that. With that error, we figure out what will be the change in error when we change a particular variable, say weight. So dE by dW, multiply it with learning rate to get the change in the variable or change in the weight. Now we'll add that change in the weight to our old weight to get the new weight. This is what backpropagation is, guys. All right, I'm just giving you a small introduction to backpropagation. Now consider a scenario where you need to predict the next word in a sentence. And your sentence is something like this. I have been to France. Then there are a lot of words. After that, few people speak. And then you need to predict what comes after speak. Now, if I need to do that, I need to go back and understand the context. What is it talking about? And that is nothing but your long-term dependencies. So what happens during long-term dependencies, if this dE by dW becomes very small, then when you multiply it with n, which is again smaller than 1, you get delta W, which will be very, very small. That will be negligible. So the new weight that you'll get here will be almost equal to your old weight. So I hope you're getting my point. So this new weight, so there will be no updation of weights, guys. This new weight will always be almost equal to our old weight. So there won't be any learning here. So that is nothing but your vanishing gradient problem. Similarly, when I talk about exploding gradient, it is just the opposite of vanishing gradient. So what happens when your gradient or dE by dW becomes very large, becomes greater than 1, all right? And you have some long-term dependencies. So at that time, your dE by dW will keep on increasing, delta W will become large, and because of that, your weights, the new weight that will come will be very different from your old weight. So these two are the problems with backpropagation. Now let us see how to solve these problems. Now exploding gradients can be solved with the help of truncated BTD, backpropagation through time. So instead of starting backpropagation at the last timestamp, we can choose a smaller timestamp like 10. Or we can clip the gradients at a threshold. So there can be a threshold value where we can, clip the gradients. And we can adjust the learning rate as well. Now for vanishing gradient, we can use a ReLU activation function. Similarly, we can also use LSTM and GRUs. Now let us understand what exactly are LSTMs. So guys, we saw what are the two limitations with the recurrent neural networks. Now we'll understand how we can solve that with the help of LSTMs. Now what are LSTMs? Long short-term memory networks, usually called as LSTMs, are nothing but a special kind of recurrent neural network. And these recurrent neural networks are capable of learning long-term dependencies. Now, what are long-term dependencies? I've discussed that in the previous slide, but I'll just explain it to you here as well. Now, what happens sometimes we only need to look at the recent information to perform the present task. Now, let me give you an example. Consider a language model trying to predict the next word based on the previous ones. If we are trying to predict the last word in the sentence, say, the clouds are in the sky. So we don't need any further context. It's pretty obvious that the next word is going to be sky. Now, in such cases where the gap between the relevant information and the place that it's needed is small, RNNs can learn to use the past information. And at that time, there won't be such problems like vanishing and exploring gradient. But there are few cases where we need more context. Consider trying to predict the last word in the text, I grew up in France. Then there are some words. After that comes, I speak fluent French. Now, recent information suggests that the next word is probably the name of a language. But if we want to narrow down which language, we need the context of France from further back. And it's entirely possible for the gap between the relevant information and the point where it is needed to become very large. And this is nothing but long-term dependencies. And the LSTMs are capable of handling such long-term dependencies. Now, LSTMs also have a chain-like structure like recurrent neural networks. Now, all the recurrent neural networks have the form of a chain of repeating modules of neural networks. Now, in standard RNNs, the repeating module will have a very simple structure such as a single TANH layer that you can see. Now, this TANH layer is nothing but a squashing function. Now, what I mean by squashing function is to convert my values between -1 and 1. All right, that's why we use TANH. And this is an example of an RNN. Now we'll understand what exactly are LSTMs. Now, this is a structure of an LSTM. Or if you notice, LSTM also have a chain-like structure, but the repeating module has different structures. Instead of having a single neural network layer, there are 4 interacting in a very special way. Now, the key to LSTM is the cell state. Now, this particular line that I'm highlighting, this is what is called the cell state. The horizontal line running through the top of the diagram. So this is nothing but your cell state. Now, you can consider the cell state as a kind of a conveyor belt. It runs straight down the entire chain with only some minor linear interactions. Now, what I'll do, I'll give you a walkthrough of LSTM step by step, all right? So we'll start with the first step. All right, guys. So the first step in our LSTM is to decide what information we are going to throw away from the cell state. And you know what is the cell state, right? I've discussed in the previous slide. Now, this decision is made by the sigmoid layer. So the layer that I'm highlighting with my cursor, it is the sigmoid layer called the forget gate layer. It looks at ht-1, that is the information from the previous timestamp, and xt, which is the new input, and outputs a number between 0 and 1 for each number in the cell state ct-1, which is coming from the previous timestamp. 1 represents completely keep this, while a 0 represents completely get rid of this. Now, if we go back to our example of a language model trying to predict the next word based on all the previous ones, in such a problem, the cell state might include the gender of the present subject so that the correct pronouns can be used. When we see a new subject, we want to forget the gender of the old subject, right? We want to use the gender of the new subject. So we'll forget the gender of the previous subject here. This is just an example to explain you what is happening here. Now let me explain you the equations which I've written here. So ft will be combining with the cell state later on, that I'll tell you. So currently ft will be nothing but the weight matrix multiplied by ht-1 and xt and plus the bias, and this equation is passed through a sigmoid layer. All right, and we get an output that is 0 and 1. 0 means completely get rid of this, and 1 means completely keep this. All right, so this is what basically is happening in the first step. Now let us see what happens in the next step. So the next step is to decide what information we are going to store. In the previous step, we decided what information we are going to keep, but here we are going to decide what information we are going to store here. All right, what new information we are going to store in the cell state. Now this has 2 parts. First, a sigmoid layer, this is called a sigmoid layer, and which is also known as an input gate layer, decide which values we'll update. All right, so what values we need to update. Then there's also a TANH layer that creates a vector of the candidate values C bar of t-1 that will be added to the state later on. All right, so let me explain it to you in a simpler terms. So whatever input that we are getting from the previous timestamp and the new input, it will be passed through a sigmoid function which will give us I of t. All right, and this I of t will be multiplied by ct, which is nothing but the input coming from the previous timestamp and the new input, that is passed through a TANH, that will result in CT. And this will be later added on to our cell state. And then the next step will combine these two to update the states. Now let me explain the equations. So I of t will be what? Weight matrix, and then we have ht minus 1 comma xt multiplied by the weight matrix plus the bias, pass it through a sigmoid function, we get I of t. C bar of t will get by passing a weight matrix ht minus 1 xt plus bias through a TANH squashing function, and we'll get C bar of t. Alright, so as I've told you earlier as well, in the next step we'll combine these two to update the state. Let us see how we do that. So now is the time to update the old cell state CT minus 1 with the new cell state CT. Alright, and the previous steps we have already decided what to do. We just need to actually do it. So what we'll do, we'll multiply the old cell state CT minus 1 with FT that we got in the first step, forgetting the things that we decided to forget earlier in the first step, if you can recall. Then what we do, we add it to IT and CT, then we add it by the term that will come after multiplication of IT and C bar T, and this new candidate value scaled by how much we decided to update each state value. Alright, so in the case of the language model that we were discussing, this is where we would actually drop the information about the old subject gender and add the new information as we decided in the previous steps. So I hope you are able to follow me, guys. Alright, so let us move forward and we'll see what is the next step. Now our last step is to decide what we are going to output, and this output will depend on a cell state, but it will be a filtered version. Now finally what we need to do is we need to decide what we are going to output, and this output will be based on our cell state. First we need to pass ht minus 1 and xt through a sigmoid activation function so that we get an output that is OT. Alright, and this OT will be in turn multiplied by the cell state after passing it through a TANH squashing function or an activation function. And why we do that? Just to push the values between -1 and 1. So after multiplying OT, that is this value, and a TANH CT, we'll get the output H2, which will be our new output, and that will only output the part that we decided to. Whatever we have decided in the previous steps, it will only output that value. Alright, now I'll take the example of that language model again. Since it just saw a subject, it might want to output information relevant to a verb, and in case that's what is coming next. For example, it might output whether the subject is singular or plural, so that we know what form of a verb should be conjugated into. All right, and you can see from the the equations as well. Again, we have a sigmoid function. Then that whatever output we get from there, we multiply it with TANH CT to get the new output. All right, guys. So this is basically LSTMs in a nutshell. So in the first step, we decided what we need to forget. In the next step, we decided what are we going to add to our cell state, what new information we are going to add to our cell state, and we were taking an example of the gender throughout this whole process. All right, and in the third step, what we do, we actually combined it to get the new cell state. Now in the fourth step, what we did, we finally got the output that we want. And how we did that? Just by passing ht minus 1 and xt through a sigmoid function, multiplying it with the TANH CT, the TANH new cell state, and we get the new output. Fine, guys. So this is what basically LSTM is, guys. Now we'll look at a use case where we'll be using LSTM to predict the next word in a sentence. All right, let me show you how we are going to do that. So this is what we are trying to do in our use case, guys. We'll feed a LSTM with correct sequences from the text of 3 symbols. For example, had a general and a label that is council in this particular example. Eventually, our network will learn to predict the next symbol correctly. So obviously, we need to train it on something. Let us see what we are going to train it on. So we'll be training our LSTM to predict the next word using a sample short story that you can see over here. All right, so it has basically 112 unique symbols. So even comma and full stop are considered as symbols. All right, so this is what we are going to train it on. So technically, we know that LSTMs can only understand real numbers. All right, so what we need to do is we need to convert these unique symbols into a unique integer value based on the frequency of occurrence, and like that we'll create a dictionary. For example, we have had here that will have value 20, A will have value 6, general will have value 33. All right, and then what happens, our LSTM will create a 112 element vector that will contain the probability of each of these words or each of these unique integer values. All right, so since 0.6 has the highest probability in this particular vector, it will pick the index value of 0.6, then it will see what symbol is attached to that particular integer value. So 37 is attached to council. So this will be our prediction, which is absolutely correct, as a label is also council according to our training data. All right, so this is what we are going to do in our use case. So guys, this is what we'll be doing in our today's use case. Now I'll quickly open my PyCharm and I'll show you how you can implement it using Python. We'll be using TensorFlow, which is a popular Python library for implementing deep neural networks or neural networks in general. All right, so I'll quickly open my PyCharm now. So guys, this is my PyCharm, and over here I've already written the code in order to execute the use case that we have. So first we need to do is import the libraries, NumPy for arrays, TensorFlow, we know TensorFlow.contrib. From that we need to import RNN, then random collections and time. All right, so this particular block of code is used to evaluate the time taken for the training. After that we have log underscore path, and this log underscore path is basically telling us the path where the graph will be stored. All right, so there will be a graph that will be created, and then that graph will be launched. Then only our RNN model will be executed. Then that's how TensorFlow works, guys. So that graph will be created in this particular path. All right, and we are using summary writer. So that will actually create the log file that will be used in order to display the graph using TensorBoard. All right, so then we have defined a training underscore file, which will have our story on which we'll train our model on. Then what we need to do is read this file. So how are we going to do that? First is read line by line whatever content that we have in our file. Then we are going to strip it. That means we are going to remove the first and the last white space. Then again we are splitting it just to remove all the white spaces that are there. After that we're creating an array, and then we are reshaping it. Now during the reshape, if you notice, this -1 value tells us the compatibility. All right, so when you're reshaping it, you need to make sure that we are providing in the correct parameters to reshape it. So you can convert a 3x2 matrix to a 2x3 matrix, right? So just to make sure that it is compatible enough, we add this -1 and it will be done automatically. All right, then return content. After that, what we are doing, we are feeding in the training data that we have, training underscore file. We are feeding in our story and calling the function read underscore data. Then what we are doing, we are creating a dictionary. What is a dictionary? We all know key value pairs based on the frequency of occurrences of each symbol. All right, so from here collections.counter words.most common. So most common words with their frequency of occurrence, there will be a dictionary created. And after that, we'll call this dict function, and this dict function will feed in word, and which is equal to length of dictionary. That means whatever the length of that particular dictionary is, how many times it is repeated. So we'll have the frequency as well as a symbol. That will be our key value pair, and we are reversing it as well. Then what we are doing, we are calling it build underscore data set, and we're feeding in our training data there. This is our vocabulary size, which is nothing but the length of your dictionary. And then we have defined various parameters such as learning rate, iterations or epochs. Then we have display step and underscore input. Now learning rate, we all know what it is. The steps in which our variables are updated. Training underscore iterations is nothing but your epochs, the total number of iterations. So we have given 50,000 iterations here. Then we have display underscore step, that is 1000, which is basically your batch size. So batch size is what? After every 1000 epochs, you'll see the output. All right, so it'll be processing it in batches of 1000 iterations. Then we have n underscore input as 3. Now the number of units in the RNN cell will keep it as 512. Then we need to define x and y. So x will be our placeholder that will have the input values, and y will have all the labels, all right, vocab size. So x is a placeholder where we'll be feeding in our input dictionary. Similarly, y is also one more placeholder, and it'll have a shape of none, comma, vocab size. Vocab size we have defined earlier, as you can see, which is nothing but the length of your dictionary. Then we are defining weights as well as biases. After that, we have defined our model. All right, so this is how we are going to define it. We'll create a function RNN when we'll have x, weights, and biases. And after that, we are calling in RNN.multi-RNN cell function. And this is basically to create a 2-layer LSTM, and each layer has n underscore hidden units. After that, what we are doing, we are generating the predictions. But once we have generated the prediction, there are n underscore input outputs, but we only want the last output. All right, so for that, we have written this particular line. And then finally, we are making a prediction. We are calling this RNN function, feeding in x, weights, and biases. After that, we are calculating the loss and then we are optimizing it. For calculating the loss, we are using reduce underscore mean, softmax cross entropy. And this will give us basically the probability of each symbol, and then we are optimizing it using RMS prop optimizer. All right, and this gives actually a better accuracy than Adam optimizer, and that's the reason why we are using it. Then we are going to calculate the accuracy, and after that we are going to initialize the variables that we have used. As we have seen in TensorFlow that we need to initialize all the variables, unlike constants and placeholders in TensorFlow. All right, and once we are done with that, we are feeding in our values, then calculating the accuracy, how accurate it is, and then when optimization is done, We are calculating the elapsed time as well. So that will give us how much time it took in order to train our model. Then this is just to run the tensor board on local host 6006. And this particular block of code is used in order to handle the exceptions. So exceptions can be like whatever word that we are putting in might not be there in our dictionary or might not be there in our training data. So those exceptions will be handled here, and if it is not there in our dictionary, then it will print word not in a dictionary. All right, so fine guys, let's input some values and we'll have some fun with this model. All right, so the first thing that I'm gonna feed in is had a general. So whenever I feed in these three values, had a general, there will be a story that will be generated by feeding back the predicted output as the next symbol in the inputs. All right, so when I feed in had a general, so it will predict the correct output as council. And this council will be fed back as a part of the new input, and our new input will be a general council. So it will be a general council. All right, so these three words will become our new input to predict the new output, which is 2. All right, and so on. So surprisingly, LSTM actually creates a story that, somehow makes sense. So let's just read it. Had a general council to consider what measures they could take to outwit their common enemy, the cat. By this means, we should always know when she was about and could easily. All right, so somehow it actually makes sense when you feed in that. So what will happen when you feed in these three inputs? It will predict the next word, that is council. After that, it will take council and it will feed back as an input along with a general. So a general council will be your next input to predict 2. Similarly, in the next iteration, it will take general council 2 and predict consider for us. And this will keep on repeating.
So over here, what we're going to do is we're going to download the MNIST dataset from Keras.datasets, and we'll just take the X dataset. That is the features that are present only in the X train part. And what we're going to do is we're going to create a generator and a discriminator model, and then we're finally going to combine them in order that they can work together. And as GANs are being a pretty intense topic, I would really recommend you people to check out or have a good understanding of the real basics of what deep learning is and how machine learning works. Although you won't be using any concepts from the machine learning. So if you want the playlist for our deep learning or the full course link, the description for that will also be provided in the description box below. So talking about the problem statement, as I mentioned earlier, first off, we are going to load our dataset, and the source that I'm going to use over here will be Keras.dataset. Apart from that, we are supposed to create two types of model here. One would be the generator model, another one is going to be the discriminator model. Generator model, it is there for performing sampling, and the discriminator model is basically there for downsampling, and then we are going to combine this up. It's very important for you to know how GANs work, and the reason for this is because we have to write our own loss function over here. So moving ahead, let me quickly just show you what are the different tools and frameworks that we are going to use. As GANs are really intense when it comes to training them, we're going to need a good performing GPUs. So what I'm going to do is, we all know Google Colab gives me a good performing GPU for free. So let me quickly use that up, and we're going to use Google Colab. Apart from that, talking about the different frameworks and libraries that we're going to have, the generic ones would remain the same. We are going to use NumPy, Matplotlib, and Pandas. Apart from that, a deep learning framework that is TensorFlow and Keras, that's a framework that we are going to use here to train a model and also to develop our model. Alright guys, so now that we know brief of what we are going to do now, let me quickly jump to my code editor, that is Google Colab, and show you how we can get started with this project. So this is the interface of a Google Colab. First thing that I'm going to do over here is come down to the runtime and change the runtime type to GPU. Because training GANs requires a huge amount of compute power. So once we're done with that, let's connect this to the server. So it will take some time. So once this is connected, let me zoom in for you guys. First off, what we'll do is we'll load our libraries. So load libraries. So let's do one thing. Let's import from Keras.datasets, import MNIST, and let me execute this. It's okay, we are getting this error. Let me quickly, I think I might have done some typo here. So first off, Keras.datasets, import MNIST. So this is where I'll be having my datasets. Then we also need some layers. So it will be Keras.layers, import. We know we have different types of layers. So for our simplicity's sake, I'll import all our layers over here. And then we have from Keras.layers.activation or advanced activation. We'll import this later. So let me just have something like models, import sequential model, and then also import functional API, that is model. Now we also need some optimizers, that is from Keras.optimizer import Adam. And as you can see, I've done a small typo here. Let me fix this as well. And let's also add this advanced model again from Keras.layers.advanced model. It's going to be advanced activation, import leaky ReLU. Usually the activation function that we would use in normal CNN is going to be like ReLU or TANH. But here we're going to use leaky ReLU. ReLU is just that, in the lower level. So let me show you what this means. So if I take this thing, ReLU goes something like this. Oh yeah. So this goes here and it ends at 0 and then there's exponential growth. So either it is at this point or at this point. But when it comes to leaky ReLU, the graph over here is going to be same over here. But on this coordinate, it will be a small dip. So we have a small space here. So this is called as leaky ReLU. And apart from this, let's also get some generic ones. So import NumPy as NP and also import matplotlib as PLT. So let's execute this. That's great. What we'll do is, sometimes we do get the warnings. So let me ignore the warnings. So import warnings. So now warnings, let me execute this. Then we have warnings dot filter warning and just pass here ignore. This looks great. So now we are supposed to get our data set. So for getting a data set, I just have mnist, which we have loaded, and then we just have to do load data. We all know that this gives us tuple, 2 values. So that's xtrain, ytrain, and again xtest, ytest. So what we're going to do is we're going to have something in this format. And now we'll just have xtrain here. So now let me quickly execute this up. And now if I show you xtrain dot shape, it's going to be 60,000 and 28,28 is the picture size. And now what I'm going to do here, in order to normalize my image, what we'll do is xtrain is equal to xtrain minus 127.5. Divide this by the same 127.5. So print, we want the maximum value and the minimum value, that is xtrain dot minimum, and similarly print xtrain dot max. And now you can see it would be ranging from -1 to 1. If I divide this by like 255, then everything over here would be from 0 to 1. So this is what we have done. And now we're supposed to create the batches. What we're going to do here, we're just going to use the train images or the images present in this train to learn. And then we are going to generate our own very own MNIST data. So it will be total epochs. Let's keep it as 50. Then we have the batch size. Batch size basically means in one go how many images can be there. So it will be 256. Then we have half batch. That's going to be half of this. That's 128. And then number of batches. This would be in xtrain.shape, which is present in index 0. Divide this by batch size. And then let's also add some noise here. So noise dimension. So it's going to be 100. And finally, for our optimizer, what we're going to do here is Adam. We just change the learning rate here. So LR, this would be equal to -4, and then beta 1 would be 0.5. So this basically means 0.0002. And now let's execute this. We are done. So what we're going to do now, we are going to create a generator model. So generator model. And here we are basically trying to do upsampling. So first off, as this is the model, right? So we'll give the name here as generator. We'll keep this as a lowercase generator. And this is going to be the sequential model. This is pretty similar to what we are going to have. So we'll have now let me just execute this. And now we'll have generator dot add. Now we'll add dense layer here. And now we'll call units. Number of units that I need over here, it'll be 7 times 7 times 128. And then we have input shape. And this would be noise dimension, comma. So basically this thing, noise dimension is 100, right? So this is going to give me the batch size. And then comma is basically telling me the values. And then again, we have generator dot add. Now we'll do the reshape here. So it'll be 7, 7, 128. Then again, generator dot add. We're going to add a leaky ReLU. And the value that I'm going to give here is going to be 0.3. That's the alpha value. Or 0.2. It's totally up to you. And then we'll do some batch normalization just to prevent overfitting. So this would give me like the size over here is going to be 7 cross 7 cross 128. Now we'll try to decrease this and increase these values. So let me write that down. 7, 7, 128. We will try to do 14, 14, 64. So this is going to be generator.add. So we'll have convolution 2D transpose. Number of layers that we're going to add is going to be 64. Then we have kernel size, that will be 3 cross 3. Stride will take 2. And even after that, padding would remain the same. So now we'll do generator.add leaky relu, and we'll give the beta value here would be 0.2. And again, we'll try to add batch normalization. Now again, we'll try to do the upsampling. What we'll do is we'll change this. We'll change this to 28, 28, 1. This is the actual image that we need. So this is the size of the image that we have over here. So for this, we'll do generator.add. It's going to be the same thing that's over here. It's just that we'll change the dimensions. So instead of 64, it's going to be 1. And rest everything remains the same. And just a small change that I'm going to do here, add an activation function, tanh. This looks great. And finally, we are going to compile a model. So generator.compile. So we'll have loss. This will be Keras. So what we'll do here, we'll also import Keras. So import just Keras. So now we'll come here, Keras dot losses dot binary cross entropy. And then we have optimizer. We'll use our custom optimizer, that is Adam. We have used this Adam over here, somewhere in the top. And finally, we'll try to do general.summary. That's our model.summary. And let's execute this now. So as you can see here, first off, we have the batch size. We have 7 cross 7. And finally, we'll do the upsampling and we get this image 28, 28, 1. Now we're going to do discriminator model, or you can say downsampling. The input size over here is going to be 28, 28, 1. If you're unable to understand what's happening here, I would highly recommend you to check out any of the Edureka's GAN tutorial projects. The reason for this is because GANs are pretty high level models that requires you to have some fundamental knowledge over here. So finally, what we're going to do, now we are going to do downsampling. So the input shape here is going to be 28. Let me just copy this from here. And we are going to downsample this to 14, 14, 64. So this basically we are trying to do the reverse of this model, generator model. So here we'll have discriminator, and this would also be a sequential model. And let me execute this so that I start getting the recommendations here. So now that we have done with this, so we'll have discriminator dot add, let's say conv2d. And now the number of layers I need here is going to be 64. Then I have kernel size 3, 3. Then I have strides. This will also remain the same, 2, 2. We have padding. We want the padding to be same. And as this is the first layer, we are going to add our input shape as well. And this is going to be 28, 28, 1. So now that you're done with this, let's also try to add some other layers. So we have discriminator is equal to dot add. And now we are just going to add leaky relu and give an alpha value here to be 0.2. Try this with a different alpha values like 0.3 and whichever suits you. And now what we'll do, we will again do the downsampling. So we give this as a comment, and we're going to downsample this thing to 128, and this should be 7, 7. We're going to perform the same step. I'll just copy this for now. And as we all know, there's slight changes that we need to do. First off, instead of 54, this is going to be 64, right? Not 54. And instead of here of 54, we are going to have 128. And we don't have to provide the input shape over here as well. The rest everything remains the same. And finally, we will downsample this again from this vector to a scalar value. That is, scalar here is going to be 6272. And now we'll do discriminator dot add. So this is going to be flattened here. We'll do some discriminator dot add dense, and we'll pass here 100. And we'll also give some leaky relu here. Let me just copy this. And finally, we'll do discriminator dot add dense layer. And we just want the output for this to be 1. And the activation, as this is just 1, it's going to be sigmoid. So this is it about the model. And now we are going to compile this. So it's going to be discriminator dot compile. So the loss function that I'm going to use here is binary cross entropy again. So it's going to be Keras dot losses dot binary cross entropy. Optimizer that I'm going to use will be Adam, the one which you have defined, Adam. And finally, let's compile this. This is not going to be compiled. This is going to be summary. And let's execute this now. So as you can see here, we are doing the reverse process of what we did in our generator. It's usually 28,28, and then every time I pass this through a convolution layer, obviously there's a change in size. And as I move down, the size decreases and we are presented with 1. So this is about like building our generator model and even our discriminator model. So fine, in the next stage or the final stage of model creation, we are going to combine it. Combined model. So over here we have describer.trainable. We'll give this as false. Then we have GAN input. So this is the name of a model. That's a GAN input. And I have input, and this will be shape, and this is going to be noise dimension. And then finally we have generated image. This will be generator of GAN input. And finally we have GAN output. This should again be discriminator, and we're going to pass here generated input or image. And now we'll use a functional API. We are using this to create a final model. So it'll be model. This will be model. We are supposed to pass the inputs, right? So it'll be GAN input, and the output will be GAN output. And finally, just like others, we are supposed to compile a model. That will be model.compile. So here loss we are going to use is binary cross entropy. So Keras.losses, not binary cross entropy. And optimizer will be Adam. Looks great. Let me execute this. The reason why we're getting this error is because of this, and let's try to execute this. And now as you can see, we don't have any errors. Let's quickly see how this model would look like. So model.summary, and let's run this. So as you can see, we have input shape, and this is the output, and then finally this is the input over here. So now we are going to come back to our data set, that's train. We'll reshape this. So it will be train.reshape. We're going to have -1, then 28. That is on the x-axis, 28 on the y-axis, and 1 is a channel. And if I run this and add here xtrain.shape, you will see it looks like 60,000, 28, 28, and 1. This is the batch size, and then we have 28, 28 is the size of the image, and 1 is the number of channels. So this is all there is about building a model. Now finally we are supposed to create a training loop. Let me give a comment again, training loop. So we'll have discriminator loss. At the same time, we'll also have generator loss. We'll have a for loop here for epoch in range, total epochs. Here we'll have one value, that is epoch discriminator losses. There will be 0.0. Similarly, epoch generative loss, and even this will be 0.0. So now we're going to have mini batch gradient descent for step in range, number of batch. Let me give some comments over here just so that it's easier for you guys to understand. So in the step 1, we're going to train discriminator. So for this, what we're going to do is we're going to have discriminator.trainable will be equal to true. That is, how do I do this is by this part. Okay, discriminator. So first off, we need to get the real data. So this will be index. This will be equal to np.random.randend. So we'll have 0, 60,000, half batch. And then we'll have real images. This will be xtrain present in that index, idx. And now get the fake image, or you can say data. So we'll have noise. This will be equal to np.random.normal. So we'll have 0, 1, noise should range. Size, this will be half batch, noise dimension. So now it will be fake image. This will be generator.predict noise. And now we'll do labels. So now we need the label. So it will be real y is equal to np.ones. So this would be half batch, 1 times 0.9. So times 0.9, and then fake y. This would be np.zeros. Then we have half batch, 1. So now it's time to train d underscore loss underscore real. This would be equal to discriminator.train on batch. So here we are going to pass real image and then real y. And then for the fake, d underscore loss underscore fake. This would also be the same. It's just that instead of real, it's going to be y. So let me do this. Fake images, and then this is going to be fake y. And finally, d loss. This would be 0.5 times d loss underscore real plus 0.5 times d loss underscore fake. And then finally we have to do epochs dloss, that is epochs per loss plus equal to dloss. So this is the stage 1. In the stage 1 we are gonna just train this part over here. And now coming down to the stage 2, that is, let me give a comment here, train generator. And when I'm training generator, obviously my discriminator has to be false or disabled. So here we have noise. There will be np.random.normal. So here we are going to pass 0, 1, size. This would be batch size, noise dimension. And now we have ground truth. So this will be np.ones. And let's provide a batch size, the size for this, 1. And then we have epochs g loss plus equal to g loss. So finally we have to print this out. So what we're going to do, we're going to write a function to display the images that we have created. But before that, let me quickly write here print. So it will be epoch and we'll pass this data here. Then we have disc loss, that is discriminator loss. We'll provide this over here, and generator loss. We'll provide this over here. So here we'll have epoch plus 1. And then over here we are going to have epochs underscore d underscore loss. Divide this by number of batches. And finally for our loss over here, that is generator loss, I'm going to add something similar. Let me give this on the next line just so that it's easier to read. So here it's going to be the similar thing, but instead of d it's going to be g. So let me copy this and paste this over here. And finally we'll have d underscore losses dot append. We're going to append the same value. So we are going to append this for the discriminator loss. Let me copy and paste here. And then this would be d underscore losses dot append. It's going to be g, not d. And we're going to add this value here. And finally, if generator, it's going to be like this. If the number of epochs plus 1 percentage 10 is equal to 0, then save it. Give a extension as generator.h5. And now we also want to display the images. So what we'll do, display image, we'll write a function display image, and we'll just have to display this image here. So what's going to happen is for every 10 images, so for every 10 image, it will display the epochs, losses, and then the images. For us to display the image, we have to write another function here. We'll do that as well. This now will have a small function def display image images, and we'll give samples is equal to 25. Now we have noise. This would be np.random.normal. Here we'll have 0, 1, size. The size would be number of samples. That's 25, noise dimension. So generator image, this would be equal to generator.predict noise. And finally, we'll just plot the figure here. So plt.figure, we'll give you a figure size. Let's say 10, 10. And I want the images to be plotted next to each other. So for I in range samples, as it's 25, no, it's going to be 5 in row and 5 in columns. So plt.subplot 5, 5, that's 5 rows, 5 columns, and then we just have to provide the index, that's I plus 1. Then we have plt.imshow generated image, which is present in index I dot reshape 28, 28, and I want the C map to be gray. You can either keep it gray or binary, totally up to you. I'll give it as binary. Then plt.axis, we'll keep this as off. And plt.show, and yeah, this is it. So let me quickly give you a walkthrough of what we are doing here. Let me zoom out. First off, we try to get our data. First off, we are trying to ignore the warnings. Then we import the libraries. Then we get our data, try to reshape it. Oh, here I want my data to range from -1 to 1. I hope now you understand why you're using leaky ReLU. And now we are trying to create the batch size, noise dimension, and customize our function. Oh, here there are two models that are involved. The generator model, where we are basically trying to do the upsampling, and then we have also done downsampling using discriminator model. Both of these models are combined over here. As you can see, we are combining them to create a GAN model. That's our final model. And the way we train our model is quite different. Like usually we use fit and provide all the values, but here we are trying to write a customized training loop. For every 10 epochs, this function would be called, and this would actually generate the images. So let me do one thing. Let me quickly run this up now. Before you start, make sure you remove this comment from here. And first off, we are going to train our discriminator, as I mentioned earlier, and then we are going to give this a false, right? Discriminator.trainable would be false. And let me quickly run this and see what happens here. This would take quite some time, as training generators, adversarial neural networks are pretty intense. This would take quite some time over here, and let's see what happens. Alright guys, so as you can see here, we have successfully created our images. And now if I tell you this, right, this is not the image which is present in our data set here. This is the beautiful concept of GANs, where this image over here, we have generated this by ourselves. And this is what GANs does. So let's wait for another batch over here. Let's wait for another 10 batches and let's see what happens and how that thing would look like. Alright guys, so as you can see here now, this is the second batch of the image that we have received. Let me zoom out a bit. Let me zoom out over here. So as you can see, the images over here are better. So we can see this 5, 6, 3, 6, 7, and all of these are the images that was generated by our model. And as you can see, all this is pretty simple and short, but there's a huge amount of complications that go in for developing this particular model. So if you have this kind of project in your arsenal, you can crack out any interview or question that is being posed to you.
Generative AI is transforming multiple creative fields.
Image generation tools power visual design, music compositions algorithm create original scores,
and AI assists video editors in automatic tasks. LLMs help generate and translate text, while code generation tools like GitHub Copilot boost developer efficiency. AI-generated voices are even being used in audiobooks and voice assistants. So now, let's take some of these tools and check. So this time, we will use Pictory AI and Flicky AI.
First, let's explore Pictory AI. So for that, let's go to its site and check its functions. So we are at the Pictory AI site.
And on the left side, we have the home, project and brand kits. And on the main screen, we have different features Pictory AI provides. So let's choose text to video. Here, let's write some names and description and press generate.
Pictory AI is a tool designed for video creators that helps transform long-form content, such as articles or blog posts, into short, engaging videos.
It uses AI to automatically extract key highlights and create professional-looking videos with minimal efforts.
Due to its simplicity and time-saving capabilities, Pictory AI is popular for social media content creation and marketing.
Now, let's see our next tool, which is Flicky AI. So now, we are at the Flicky.ai site. Here, we have different features like videos, where you can create videos from all of these blogs, prompts, etc. You can also create audios from these features, and then we also have a design feature. And on the left-hand side, you can see options like files, templates, brand kits, voice clones, etc. So now, let's take an idea and convert it into a video. Now, let's write our topic and generate. Flicky AI is a content creation tool that turns text into videos using AI-generated voices and visuals. It helps users create professional videos quickly by pairing written content with stock images, animations, and voiceovers. Flicky is ideal for marketers, content creators, and educators looking to create engaging video content efficiently. Now that we have seen the applications, so let's step back and look at the journey that brought us here. So basically, our journey starts in 1947 with Alan Turing's concept of intelligent machines. By 1961, Joseph Weissenbaum introduced ELIZA, the first chatbot. The 1980s saw the birth of recurrent neural networks, while 1997 brought long short-term memory networks to tackle sequential data. And then GANs emerged in 2014, transforming creative tasks. Fast forward to 2017 when transformers like GPT entered the scene. By 2023, GPT 3.5 and Google's Palm marked significant milestones. And by 2025, we are on the brink of AI breakthroughs in chemistry and genome editing. So, what exactly are these LLMs and why are they so powerful? An LLM or large language models analyzes and understands natural language using machine learning. Examples include OpenAI's GPT, Google's Palm, and Meta's Llama. These models drive applications such as chatbots, language translation, and more by learning from extensive data to predict and generate text sequences. But before this, there was a very famous term called language model. A language model is a machine learning model that uses probability statistics and mathematics to predict the next sequence of words. Suppose you have a sentence like, I have a boy who is my dash. Here, if we ask a language model to predict the next word, it considers the context provided by the words before the blank. Based on common usage patterns from its training data, it may predict words like boyfriend, brother, or friend, which fit naturally. However, it's less likely to predict colleague or sibling, as those words may not commonly follow this type of phrases. So this process shows how language models predict text by calculating probabilities for each possible word based on their likelihood in context. So, when a language model is trained on massive amounts of diverse text, it gains a wider vocabulary and more understanding of language, enabling it to make more accurate predictions. For example, if we give it a phrase like, you are a dash to me, a model trained on extensive data might suggest various fitting words, for example, friend, inspiration, or anything else. So based on this sentiment or context, it has learned from the data. Now here, reinforcement learning is used to improve the model's responses over time. By giving feedbacks, be it positive or negative on the responses, we help the model learn which type of responses are preferred in specific contexts. For example, if the model frequently misinterprets the tone or intent, the reinforcement learning helps adjust its predictions to be more contextually appropriate and aligned with the intended meaning. But what do these models look like under the hood? Well, LLMs are built on neural networks composed of input, hidden, and output layers. The hidden layer processes information to learn complex patterns, and more layers means the model can capture deeper insights. This structure allows LLMs to perform tasks from generating text to complex code completions. Now, how do these layers interact and function in real time? Now, LLM is based on the transformer, and a transformer uses deep learning to process any information coming to it. Now, let me tell you a story of three friends. Imagine we have three characters. First is our friend, the next character is Minion Bob, and the third character is Gru. So our friend asks Bob, what's the price of the jet? It must be $50,000. Minion Bob isn't sure, so he goes to Gru and asks, is the jet $50,000? Gru replies, no, it's $70,000. In this back and forth, Minion Bob is like the neural network layer trying to make an accurate guess. So, each time he goes back to Gru, like receiving more data or feedback, he gets corrected if his guess is wrong, leading him to refine his response. Now, after the first check, Minion Bob returns to our friend saying, I guess it's more than $60,000. Our friend assumes it might be around $65,000 and sends Bob back to Gru to verify. Again, Gru corrects him, no, it's actually $70,000. So this process repeats with Bob adjusting his guess each time. Eventually, he learns that the correct answer is $70,000 and updates his knowledge. So, just like Minion Bob, neural networks make initial guesses based on available information. With each feedback loop, like Bob going back to Gru, the model's hidden layers adjust the parameters to refine its guesses, ultimately arriving at the most accurate prediction possible. So, after getting corrected multiple times, Minion Bob's guesses improve until he knows the price is $70,000. Similarly, in a neural network, gradually learning the correct answer through training. So, once the network learns, it can give accurate answers in future cases without checking every time. Now, let us move on to understand how LLMs work. LLMs begin the collection of datasets, then tokenize text and break it into manageable pieces. Using a transformer architecture, they process the data sequence all at once, leveraging vast training data. LLMs contain millions of learned parameters that predict the text tokens and generate coherent outputs. Models often undergo pre-training for general knowledge and fine-tuning for specific tasks. So now, let's see some practical uses of LLMs. LLMs power content generation, creating anything from articles to code. They excel in language translation, enhanced search engines, personalized recommendations, code development assistance, and sentiment analysis, which also owe much to LLM's predictive capabilities. So guys, are you ready to use all that knowledge in coding and witness how these LLMs come together to drive innovation? Whether through developing applications, analyzing data, or building smart assistants, the gear of technology keep turning to unlock AI's full potential. So now, let us look at our problem statement. So, one of the difficulties in the healthcare industry is effectively evaluating medical pictures such as MRIs, CT scans, and X-rays in order to identify anomalies and illnesses. This procedure takes a lot of time and calls for specialized understanding. Automated methods must be developed to help medical personnel recognize possible health problems in medical imaging. In order to provide better patient care, a system that integrates cutting-edge machine learning models with image analysis can greatly help in the early detection of diseases, including cancer, infections, and other illnesses. So the method uses generative AI to evaluate medical photos and generate a thorough diagnosis report based on the findings. This technology allows users to upload medical images, which the AI model then processes. Now, let us build our project on a medical image analysis application using Streamlit, Python, and an LLM of Google Gemini AI. So this app helps healthcare professionals analyze medical images such as X-rays, MRIs, and CT scans to detect anomalies and diseases. First, let's import the necessary libraries. So first, import Streamlit as ST. So if this is not working or showing an error, then open the terminal and write pip install Streamlit. And from pathlib, import path. Next, import google.generative.ai as GenAI. So, we are importing Streamlit for the app interface and path from pathlib for handling file paths and Google Generative AI, which allows us to interact with the Gemini AI model. Next, we will configure Google's Gemini API by setting up our API key. So this will allow us to connect to the AI model and generate insights from medical images. So before proceeding, let's get our API key and we will go to the Google to generate an API key. So on your left, there is an API key option and after clicking, you will get the Create API option. So just select your model and create your API key. So as you can see the screen, just copy this API key and go back to terminal. So now let's configure our model. So just type genai.configure and inside the bracket, give API underscore key equal to and over here paste the key. Now we set up the system prompt which defines the role of the AI model. So the prompt specifies that our AI is a medical image analysis system capable of detecting diseases like cancer, cardiovascular issues, neurological conditions and more. So guys, I have already researched the prompts and written here. So basically, the system prompt should be inside the triple quotes. So this prompt guides the model to analyze medical images for conditions such as cancer, fractures, infections and more, making it a valuable tool for healthcare professionals. Now, let's configure the model settings for generating responses. We define parameters like temperature and top K to control the creativity of the model's output. So first type generation underscore config equal to and inside the double quote we will give temperature which is 1, then top underscore P which is 0.95, next top underscore K 40, then max underscore output underscore tokens which is 8192. Next, response underscore MINE underscore type which is of text or plain. So over here the temperature 1 that controls randomness, a value of 1 given balanced output diversity. Next, top P 0.95 uses nucleus sampling, selecting tokens from the top 25% cumulative probability distribution for diverse responses. Next, the top K 40, which limits token selection to the top 40 tokens based on the probability, narrowing possible outputs to high probability tokens. Next, max output token. This setting allows for longer responses by limiting the maximum length of the generated text to 8,192 tokens. And then we have response MIND type, which specifies the format of the output as plain text. So for more information, read the Google Gemini documentation. Next, we will also configure safety settings to ensure that the model doesn't generate harmful content. So for example, we block categories like harassment, hate speech, and sexual explicit content. Here, we are using two things. First, categories, and then the threshold. Then, copy this 4 times like harassment, hate speech, and sexual explicit content. Now, let's set up the layout for our Streamlit application. So for that, we will configure the title and the layout of the page and even add a logo to make the interface more user-friendly. So first, type st.set _ page _ config, and inside the bracket, let's give page _ title equal to, and inside the double quotes, we will give diagnostic analytics, comma, page _ icon equal to robot. Now let us type column 1, comma, column 2, comma, column 3 is equal to st.columns, and inside the bracket give 1, 2, 1. 1, 2, 1. Next, with column 2, so I'll be using Edureka and medical images. So this will show you how to set up images using Streamlit. Now type st.image and give a bracket, and inside the double quotes, let's type edureka.png and give a comma and give width is equal to 200. Now let us copy and paste it for medical. So let's type medical.png. Here we are using Streamlit's column to center the logo and title, and this makes the app look professional and visually appealing. Next, let's allow the user to upload medical images for analysis. So we use Streamlit's file uploader widget to accept image file in PNG, JPG or JPEG formats. So for that, let's type upload _ file equal to st.file _ uploader, and inside the bracket, inside the double quotes, let's type please upload the medical images for analysis, comma, type is equal to, so basically the image type is equal to, and inside the bracket, inside the double quotes, let's give PNG, comma, JPG and JPEG. Next, let us type submit _ button equal to st.button, and inside the bracket, let's give generate image analysis. So here, when the user uploads a file and click the generate image analysis button, the model processes the image and prepare it for analysis. So once the user submits the image, we send it to the AI model for analysis, and then the model generates a response based on the prompt and image, which we then display in the app. So here, as you can see the screen, we have another function. So the if submit button, which runs the code when the submit button is pressed. Next, the image _ data is equal to upload file.getValue. This actually gets the raw image data from the uploaded file. And next we have the image parts, where it creates a list with the image data in a structured format. Then we have the prompt parts. So this combines the image data and a text prompt for the model. So this part of the code actually sends the image and text prompt to the model to generate a response. And then we have the st.write, which displays the model's responses in the app. So here we use the image data and system prompts to generate content with the Gemini AI model. The result is displayed as a detailed report with insights about the medical image. Now it's time to test the code. So open the terminal and type streamlit run main.py. So once you enter, it will redirect you to our model interface. And there you go. So the model is ready. So here's a live demo of the app. We will upload a sample image and the app will analyze it and provide a detailed diagnosis based on the AI models inside. So this is how we use Streamlit and Google's Gemini AI model to create a medical image analysis app. So this app can help medical practitioners by offering precise and thorough analysis of medical photos. Now it is the time for testing. So let's take one image of any disease and test it. So upload the image from your computer. Then we will select an image and press the generate button. So as you can see, it's running. So it generates fabulous response and can help doctors in assisting their patients, saving time and money. So this is how we built a real-time medical diagnostic helper using Streamlit, Python and Google Gemini AI.
So what is a transformer? Transformers operate on a concept called sequence-to-sequence learning. Essentially, they take a sequence of tokens as an input and predict the next token in the output. A great example of this is language translation. Imagine inputting "good morning" in English, and the transformer processes this and outputs the translation in languages like Japanese, Korean, or German. The key is how it efficiently processes the relationship between words. Since we know what a transformer is, let's dig a bit deep about them. A transformer has two primary components, encoder and decoder. Encoder identifies relationship between parts of the input sequence, whereas the decoder uses these relationships to generate the output sequence. This division is what allows transformers to handle tasks like text translation or summarizations with remarkable accuracy. Now that we have the idea of transformers, let's discuss how they evolved. Before transformers, there were other neural networks like RNN, recurrent neural networks, invented by David Rumelhart in 1986. However, RNNs faced significant challenges. They would forget early parts of the sequence as they processed longer ones and couldn't handle dependencies efficiently. Additionally, RNN relied on recurrence, which made them inefficient and incapable of parallelization. Then came long short-term memory, introduced by Howiter and Schmidhuber in 1997. Long short-term memory improved by remembering sequences for a longer duration and addressing some of the memory issues in RNNs. However, they were slow to train and difficult to manage at scale. Finally, transformers transformed neural networks. First introduced in the landmark paper, "Attention is All You Need." Transformers addressed all the problems faced by RNNs and LSTMs. They used a completely attention-based mechanism, eliminating reliance on recurrence. This made transformers capable of remembering context efficiently, training faster, and being parallelized, enabling multitasking and significantly speeding up processes. Now let's discuss on the attention mechanism. Think about this sentence: "This cat wants to jump on the box." The attention mechanism identifies the most relevant parts of this sentence, like cat, jump, and box, and focuses on these elements while processing the data. Now that we know how transformers have evolved, now let's discuss their architecture. A transformer consists of two main components, an encoder and a decoder, each typically consisting 6 layers. Inside the encoder, there is one attention layer and one feed-forward layer, while the decoder contains 2 attention layers and 1 feed-forward layer. The magic of parallelism comes from how data is fed into the network. In the attention layer, all the words are processed simultaneously, with each word forming combinations with other in the sentence. This allows the model to capture relationships and context efficiently. After processing in the attention layer, the data is sent to the feed-forward layer, where it is learned layer by layer. The input to the encoder and decoder are the raw input embeddings, which are numerical representation of words. On top of these embeddings, positional encodings are added to help the model understand the position
and the order of each word in the sequence. If we simplify embeddings, there are essentially vector representation of words in an n-dimensional space. At the top of the architecture, there are two layers of the output probabilities, converting the final output into the form of human can understand. These inputs are represented as vectors with their length corresponding to the size of vocabulary. Now, what truly makes transformer unique is the inclusion of normalization layers, which normalize the output from sublayers. Additionally, skip connections, the dark arrows in the architecture, forward critical information that bypasses self-attention or fed-forward layers directly to the normalization layers. This ensures the model does not forget important details and effectively passes vital information further into the network. Now, moving forward, let's discuss why transformers are important. Transformers are vital because they utilize semi-supervised learning. They are trained on massive unlabeled datasets, enabling them to generalize across a wide range of tasks. Unlike older models, transformers don't need to process data sequentially. Their attention mechanism allows them to focus on the most relevant context, which significantly speeds up training. Transformers revolutionize data processing by eliminating the need to handle data sequentially, allowing for parallel processing and significantly enhancing efficiency. The attention mechanism lies at the core of transformers, enabling the model to focus on the most relevant parts of the input sequence and improving accuracy and understanding of context. Furthermore, transformers excel at providing context, ensuring that the meaning of each word or token is accurately interpreted within its surroundings. Lastly, these models dramatically speeds up the training process, making them faster and more efficient compared to traditional neural networks, thus redefining AI's capabilities across diverse applications. Now that we know why transformers are important, let's discuss some applications. We have OpenAI's GPT, a groundbreaking model that leverages the power of transformers for natural language processing tasks. Additionally, Google has developed several transformer-based models including Vision Transformer for image recognition, BERT, bidirectional encoder representations from transformers for understanding the context of words in a sentence, and T5, which stands for Text-to-Text Transfer Transformer for a wide range of text generation tasks. Microsoft has also contributed with DBERT, decoding enhanced BERT with disentangled attention, a model designed to improve contextually understanding and enhance NLP applications. These models demonstrate the versatility and impact of transformer architecture across various domains. Now that we know the application of transformers, how about checking their real-time products? Transformers have become an integral part of many real-world products that we use daily. Examples include Grammarly, which leverages transformers for advanced grammar and writing assistance. Google Search and its translation tools powered by models like BERT and T5, and ChatGPT, OpenAI's conversational AI that relies on the generative pre-trained transformer architecture. Additionally, Meta's deepfake detector uses transformer-based models for facial recognition tasks. These applications highlight how transformers have revolutionized technology, seamlessly integrating it into tools that enhance our everyday lives. In conclusion, transformers are changing the tech world by enabling smarter, faster, and more efficient AI systems. Whether it's generating text, translating languages, or enhancing search engines, these models are the cornerstone of modern AI. Have you seen how tools like ChatGPT with Vision can look at an image you upload and describe it? Or how DALL-E and Midjourney can generate stunning images from just a text prompt? And now, some AI models can even do both at the same time. They can see, read, listen, and even create all in one go. So how is that possible? Well, that's because of something called Multimodal AI. AI that doesn't just work with one type of data like only text or only images, but can understand and combine multiple types of information together, just like we humans do. So in this video, we are going to break down what multimodal AI really means and how multimodal AI works, and explore some amazing real-world examples that you are probably already using without even realizing it. So first, let's break down the word multimodal.
So multi means many and model refers to the modes of information like text, images, sound or video. So multimodal AI is an AI that can understand and work with multiple types of data at the same time. For example, a single AI model that can read text, look at images, listen to audio, watch videos and combine all of this to give a better answer. It sounds a bit like how humans process information, right? So why do we need multimodal AI? So think about how we interact with the world. If you're watching a movie, you're seeing visuals, listening to dialogue and understanding the story together. Or when you're explaining a recipe to someone, you might show pictures, describe steps and maybe even play a video. So humans naturally combine different scenes to understand things. So old AI models were single model. They could only process one type of data. Like a text model could only read and write and a vision model could only look at images. But real-world problems are not just text or just images, they are mixed. So multimodal AI bridges this gap and it lets AI connect the dots between text, visuals, audio and more. So how does multimodal AI work? In simple terms, it works like this. It takes different types of input. For example, it could take a photo and a text question about that photo. Then, it converts them into a common language inside the AI model. So think of it like translating text, images and audio into one shared understanding. Next, it reasons over all the data together. Then it gives you a smart answer that considers all the inputs. So for example, you show AI a picture of a dog and ask, what breed is this? So it looks at the image, understands the features and responds, that looks like a golden retriever. So it's combining vision plus language to answer. Now, let us go through a working diagram of a full multimodal pipeline. So as you can see the screen, first, it takes different inputs. It could be a text, image or even a video. Then, it encoders for each modality. Later, these inputs will be translated into common AI language. Then, a multimodal transformer uses cross-attention to connect relationship across text, images and audio. And finally, the model generates a response. So let me take another example to explain this diagram. So as you can see, we have different inputs. So the model can take text, images, audio or even video as input. Next is the encoders for each modality. That means a text encoder converts words into vectors and an image encoder converts pixels into vectors and then an audio encoder converts sound waves into vectors. Next is the shared embedding space, where all these different inputs are translated into a common AI language, which is a vector space where similar meanings are close together. For example, the word car and the picture of a car are mapped close together. Next is the fusion plus reasoning layer, where a multimodal transformer uses cross-attention to connect relationship across text, images and audio. For example, it links the word red to the red region of the car image. Next is the output generation. So finally, the model generates a response, which could be text, a caption, an image like DALL-E or even sound. Alright, I hope this is clear now. So now let's look at some real-world examples that make it easier to understand. So first we have ChatGPT with vision. So if you upload an image to ChatGPT and ask what's in this picture, then it can describe the objects, text, or even analyze data like a chart. So that's multimodal AI. It's using both image understanding and text generation together. The next example is Google Lens. So when you point your camera at something, Google Lens can recognize the object, read the text in the image, and translate into another language. Again, it's a vision plus language plus translation all in one model. The next example could be a self-driving cars. So autonomous cars like Tesla's uses multimodal AI because they have to see the road through cameras, read traffic signals, hear alerts and also process maps and text instructions. So they combine all these modes to make driving decisions. Next is the healthcare AI. So doctors now use AI that can look at medical images like X-rays and also read patient reports, combining the information to help diagnose diseases more accurately. But why is multimodal AI a game changer? Multimodal AI is powerful because it's closer to human intelligence. We don't rely on one sense, we combine many. And it makes AI more flexible because one model can handle text, images, audio, and more. It can solve more complex problems like explaining what's happening in a video or understanding a full conversation with context. Alright, now for those of you who want a bit more technical depth, here's a quick peek behind the scene. So as I discussed earlier, a multimodal AI uses transformer-based models, the same type of models behind GPT. So the text, images, and audio are all converted into a common representations, like a shared language of numbers called embeddings. For example, a picture of a dog and the word dog are both mapped into a similar space, so the AI knows they mean the same thing. Then, the model can reason across all modalities together and generate an output. A great example is Clip from OpenAI, which connects images and text. Another is Google Gemini, designed from the ground up as a truly multimodal model. So what is the biggest challenge? So, the different types of data have different formats and complexity. Combining them efficiently without losing meaning is still an ongoing research area. So it's not just a magic, so it's smart design that lets the AI translate everything into one common understanding. Let's now look at some of the most important multimodal models, how they work and where they are used. So here are the key multimodal models. So first on the list we have CLIP, which is CLIP, which stands for Contrastive Language Image Pre-Training from OpenAI. So let's see how it works. So it has two encoders, a text encoder and an image encoder. So both encoders map inputs into the same embedding space. So during training, it learns this caption matches this image and this caption does not match that image. So it uses contrastive learning. It pushes correct pairs closer and incorrect pairs further apart. So here is the working diagram. So it takes the input, be it image or text, and then it encodes. So an image is a vision encoder and for text is a text encoder. Then it is shared to an embedding space. And finally, it generates the output. So let's have a look at the use cases. So it is used in DALL-E and Stable Diffusion to align text prompts with images. Next, it is used in zero-shot classification, where you give it a photo of a dog versus a photo of a cat, and it recognizes which one matches the image without retraining. And then it is used in search, where it finds images similar to this caption. Next, moving on to second model, which is BIP2. It stands for Bootstrapping Language Image Pre-Training. So let us see how it works. So first, it connects a frozen vision encoder, for example, a CLIP or VIT, with a frozen large language model, which is LLM. A query transformer acts as a bridge, where it converts visual features into a language-friendly representation. So here is the working diagram. The AI first looks at the image and turns it into a features, like objects, color, and shapes. Then, a small bridge model called QFormer takes those visual features and converts them into a format the language model can understand. Next, the large language model then reasons about the image features just like it reasons about text. And finally, it generates a text answer or a caption describing the image. So, vision encoder sees and QFormer translates and the LLM explains. So let's have a look at the use cases. So first, it is used in visual question answering. For example, what's in this picture? Next, in the image captioning, where it can give it like a man riding a horse on a beach. Next, in a chatbots with vision, for example, where you upload an image and ask questions. Okay, the next model on our list is Flamingo from DeepMind. So let's have a look at its working. So here's how it works. So first, it's a few short multimodal model. It doesn't need huge fine-tuning for a new task. And then, it uses gated cross-attention layers to integrate image plus text inside a frozen LLM. And it can reason across multiple images and a long text sequence. So, it looks at the image, reads your question, connects both through cross-attention and then explains it. So, let's have a look at the use cases. So, it is used in multimodal chatbots like look at these 5 images and now answer this question. Next, it is used in educational AI where it reads diagrams plus answer questions. Next, in document understanding, where it reads text plus images in a PDF. And the next multimodal on a list is PaLM-E from Google. So here's how it works. So as you can see, this is the working diagram. So first, the AI gets both visual input like a photo or a live camera feed, and the text instructions like pick up the red apple on the table. Next, the vision transformer understands what's in the image like objects, colors and position, and the PaLM language model understands the instruction and reasons about what needs to be done. So it's combining both. The AI creates a step-by-step action plan for the robot like move forward, grab the red apple and place it in the basket. So here are the use cases. It is used in robotics, like pick up the red apple on the table. Next, it is used in real-world reasoning for embodied AI. Then, it is also used in visual navigation tasks. And the next multimodal is Google Gemini. So here's how it works. It's a natively multimodal trained from scratch on text, images, audio and video. So unlike Clip, which aligns two encoders, Gemini has a single model handling all modalities, and it uses joint training with cross attention. So this is the working diagram. So let me explain this. The AI takes in all types of inputs at once, such as written text, pictures, sound and even video. Then, instead of using separate models for each type, it uses one powerful transformer model that can understand and combine all these inputs together. And from that combined understanding, it can give any kind of output, a text answer, a generated image, or even an audio response. So basically, it understands everything together and responds in any form you need. So let us have a look at its use cases. It is used in complex queries, such as summarize this video and create a chart. It is used in advanced digital assistants and also in future AR, VR multimodal applications. The next model is GPT-4o from OpenAI. It's an optimized multimodal model. It accepts text, images, audio in real time. And it uses fused embeddings and parallel processing for speed. And it works as a true interactive assistant. So here are its use cases. It is used in conversational AI with vision plus audio and in real-time assistance where you upload an image and get explanation instantly, and also in accessibility tools. For example, describe surroundings for visually impaired users. So these models represent different approaches to multimodality. Some align separate encoders like Clip, some bridge vision plus LLMs like BLIP2, and some are natively multimodal like Gemini and GPT-4o. So now let us see how are multimodal models trained. So training multimodal models is much more complex than training single model models. So first is the dataset alignment. So you need paired datasets such as images plus captions, videos plus transcripts and audio plus text. So this challenge is the text and images don't always align perfectly. Next is the contrastive learning. So train the model to pull matching pairs closer and push non-matching pairs apart. For example, image of a cat plus caption, a cat, is a matching pair, whereas image of a cat plus caption as a dog is not a matching pair. Next is the masked modeling. Mask parts of the input such as image patches, text tokens, as model predicts missing information. Then it forces the model to reason across modalities. For example, mask the object in a caption, a dash is sitting on the table plus providing image. Next is the fusion and cross-attention training, where models like Flamingo or Gemini train cross-attention layers to integrate modalities. It requires huge compute clusters. Next is scaling laws. Like LLMs, multimodal models get better with size and data diversity. Gemini plus GPT-4o trained on massive multimodal corpora. So here are the training requirements. You need to have high quality paired dataset, billions of parameters, and TPUs, GPUs for weeks or months, and advanced optimizations such as mixed precision or shade training. So, why is true multimodal AI still hard? It's because of data mismatch. Text is sequential, images are spatial, and audio is temporal. So aligning them perfectly is difficult. Next is limited high quality data. So billions of image text pairs exist but have noises and bias. Next, bias and fairness. Models learn cultural and social biases from multimodal data. For example, stereotypes in images and captions. The next challenge is compute cost. So training needs huge GPU clusters. For example, hundreds of A100 GPUs. And fine-tuning multimodal models is even more expensive than text only. And the final challenge is the evaluation difficulty. So how do you measure reasoning across modalities? So there's no single easy benchmark. So while multimodal AI is powerful, it's also data hungry, compute heavy, and still evolving. So in simple words, the multimodal AI can process and combine multiple types of data such as text, images, audio, and video. It's already in use such as GPT Vision, Google Lens, self-driving cars, and healthcare AI. It's a big step towards AI that can understand the world like humans do. So what do you think? Will multimodal AI make AI more human-like? So drop your thoughts in the comments.
Let us understand what are GANs. So we are going to start with generative models. So generative models are nothing but those models that use an unsupervised learning approach. In a generative model, there are samples in the data, that is input variables x, but it lacks the output variable y. And we use the only input variables to train the generative model, and it recognizes patterns from the input variables to generate an output that is unknown and based on the training data only. In supervised learning, we are more aligned towards creating predictive models from the input variables. And this type of modeling is also known as discriminative modeling. And in a classification problem, the model has to discriminate as to which class the example belongs to. And on the other hand, unsupervised models are used to create or generate new examples in the input distribution. To define a generative model in layman terms, we can say generative models are able to generate new examples from the sample that are not only similar to the examples but are indistinguishable as well. And the most common example of a generative model is a naive Bayes classifier, which is more often used as a discriminative model. Other examples of generative models include Gaussian mixture model and a rather modern example, that is generative adversarial networks. So let us try to understand what exactly are GANs, or generative adversarial networks. Generative adversarial networks, or GANs, are a deep learning based generative model that is used for unsupervised learning. It is basically a system where two competing neural networks compete with each other to create or generate variations in the data. It was first described in a paper in 2014 by Ian Goodfellow, and a standardized and much stable model theory was proposed by Alec Radford in 2016, which is also known as DGCAN, also known as DCGAN, or we can call it as Deep Convolutional General Adversarial Networks. And most of the GANs today use Deep Convolutional General Adversarial Networks. The GANs architecture consists of two submodels known as the generator model and the discriminator model. So a generator network takes a sample and generates a sample of data. A discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the form or the range 0 and 1. So let us go ahead and take a look at how GANs actually work. To understand how GANs work, let's break it down. So generative means that the model follows the unsupervised learning approach and is a generative model. When we talk about adversarial, the model is trained in an adversarial setting. And network simply means for the training of the model, we use the neural networks as artificial intelligence algorithms. In GANs, there is a generator network that takes a sample and generates a sample of data. And after this, the discriminator network decides whether the data is generated or taken from the real sample using a binary classification problem with the help of a sigmoid function that gives the output in the range 0 to 1. The generative model analyzes the distribution of the data in such a way
that after the training phase, the probability of the discriminator making a mistake maximizes. And the discriminator, on the other hand, is based on a model that will estimate the probability that the sample is coming from the real data or not the generator. The whole process can be formalized in a mathematical formula. So G over here is generator, D is equal to discriminator, P data X is the distribution of real data, P data Z is the distributor of generator, X is the sample from the real data, and Z is the sample from generator, where DX is the discriminator network and GZ is a generator network. So let's take a look at the flowchart once again, guys. So we have the training data, which is going to give the real sample, and the generator network is going to generate the sample from the random noise or the examples. And then it will go to the discriminator network, where it's going to check if the sample that is coming is real or fake. So that is how a GAN actually works. Now let's take a look at the training phase, like how a generative adversarial network is actually trained. So it happens in two phases, guys. So the first phase is where we train the discriminator and we actually freeze the generator, which means that the training set for the generator is turned false and the network will only do the forward pass and there will not be any back propagation. Basically, the discriminator is trained with real data and checks if it can predict them correctly. And the same with the fake data to identify them as fake. After this, there's the second part where we train the generator and freeze the discriminator. So we get the result from the first phase and we use them to make better from the previous state to try and fool the discriminator better. So to understand this in the layman's term, I'm gonna tell you a few steps for training, like how you should start. So the first step is you have to define the problem. You have got to define the problem and collect the data. After this, the second step is you have to choose the architecture of GAN. So in this step, depending on your problem, you have to choose how your GAN should look like. The third step is training the discriminator on real data. So we train the discriminator with real data to predict them as real for n number of times, or we call it epochs as well. And then we generate the fake inputs from the generator. So in this step, we are going to generate the fake samples from the generator. And the next step is we train the discriminator on fake data. So whatever samples are generated from the generator network, you're going to train the discriminator to predict the generated data as fake. So that's how we know that discriminator is actually predicting the values as correctly. And the last step is we train the generated with the output of discriminator. So after getting the discriminator predictions, we train the generator to fool the discriminator. So that's how we train the GAN to actually get our solution from the problem, which is like defining the problem. So you'll understand this when I'm talking about the applications, guys. So no worry. Now let's go ahead and take a look at a few challenges of generative adversarial networks. So the concept of GANs is rather fascinating, but there are a lot of setbacks that can cause a lot of hindrance in its path. Some of the major challenges faced by GANs are, the first one is the stability. So there has to be a stability that is required between discriminator and the generator network. Otherwise, the whole network would just fall. For example, in case, let's say, if the discriminator is too powerful, the generator will fail to train altogether. Won't be able to push fake samples to the discriminator and it will always identify them as fake. And let's say if the network is too lenient, the discriminator network is too lenient, so any image that would be generated by the generator network would make the network useless. The next challenge that is faced by GANs is GANs fail miserably in determining the positioning of the objects in terms of how many times the object should occur at that location. Suppose we have an image in which we have, let's say, 3 dogs with 2 eyes, and sometimes a GAN will fail to determine the positioning of the objects in terms of it will generate an image with like 1 dog and 6 eyes. So that's kind of a problem that we face while working on GANs. And the next challenge is 3D perspective troubles GANs, as it is not able to understand the perspective also. So it will often give a flat image for a 3D object. So that's one challenge that we face with GANs as well. And GANs have a problem of understanding the global objects, and it cannot differentiate or understand a holistic structure. Like if you're talking about trees or if you're talking about flowers, that's a problem that GANs will follow. And last but not least, newer types of GANs are more advanced that I've talked about that is deep convolutional generative adversarial networks, and are expected to overcome these shortcomings altogether. So we don't have to worry about these. These are the shortcomings that we face with normal GANs, the initial generative adversarial networks. Now that they have become more advanced, they actually overcome these shortcomings, so you don't have to worry, guys. So last but not the least, I want to talk about a few applications of generative adversarial networks. So the first one is prediction of next frame in a video. So let's say the prediction of future events in a video frame is made possible with the help of GANs, and DVD GAN, or we can call it as dual video discriminator GAN, can generate a 256 by 256 videos of notable fidelity up to 48 frames in length. And this can be used for various purposes, including surveillance, in which we can determine the activities in a frame that gets distorted due to other factors like rain, dust, smoke, etc. So the possibilities are immense with this. If you are able to predict the next frame in a video, that actually helps in a lot of things like surveillance, security, and we can predict outcomes based on these frames that we generate from a video. After this comes the text to image generation. So basically object driven attentive GAN, which is also known as object GAN, performs the text to image synthesis in 2 steps. So the first step is generating the semantic layout, and then generating the image by synthesizing the image by using a deconvolutional image generator is the final step. So this could be used intensively to generate images by understanding the captions, the layouts, and refine details by synthesizing the words. And there is another study about the story GANs that can synthesize the whole storyboards from mere paragraphs. So that's actually a very good idea if you're talking about GANs. So you can just give a few layouts and captions. Based on that, it will generate an image for us. Talking about the next application, we have image to image translation. So Pix2Pix is a model which is designed for general purpose image to image translation. So let's say we have 3 images. We have a real image, then we'll be having a generated image, which is basically a fake, and then it will be reconstructed to the previous image, which was real. So this is how image to image translation work, guys. And after this, we have enhancing the resolution of an image. So super resolution generative adversarial network, or also known as SR-GAN, is a GAN which can generate the super resolution images from low resolution images with finer details and better quality. So this is actually a very good application of GANs, guys. The applications can be immense. So you imagine a higher quality image with finer details generated from a low resolution image. The amount of help it would produce to identify details in low resolution images can be used for wider purposes, including surveillance. We can use it for documentation, security. We can use it for detecting patterns, etc. And last but not least, we have interactive image generation. So GANs can be used to generate interactive images as well. And computer science and artificial intelligence library, also known as CSAIL, has developed a GAN that can generate 3D models with realistic lighting and reflections enabled by the shape and texture editing. And more recently, researchers have come up with a model that can synthesize a reenacted face animated by a person's movement while preserving the appearance of the face at the same time. There are a lot more applications we can work on.
Imagine you're developing a virtual assistant application using a large language model such as GPT-3. The goal is to provide users with an engaging and helpful experience by designing effective prompts that generate informative and relevant responses from the model. So let's consider a scenario in which the virtual assistant assists users with the travel planning. So here's how prompt engineering plays a major part. So the scenario is you're planning a trip to Paris and want the virtual assistant to provide recommendations for activities, restaurants, and landmarks to visit during your stay. So let's say you're looking for a help with a traditional prompt and you ask for, what should I do in Paris? And the virtual assistant will assist you here, like, here are some recommendations for activities in Paris. And here's how the enhanced prompt through prompt engineering respond to your queries. So if you input a query that goes like, hey there, I'm super excited about my upcoming trip to Paris. So could you please recommend some must-visit places and activities for me? Then the virtual assistant will generate the response as something like this. So of course, Paris is an amazing city with so much to offer. So here are some must-visit places and activities, and it continues with the explanation about each place. I hope you got the idea of how Enhanced Prompt provides users with an engaging and helpful experience by designing effective prompts that generate informative and relevant responses from the model. So now let us understand what exactly is prompt engineering. Prompt engineering is a method used in natural language processing, that is NLP, and machine learning. It's all about crafting clear and precise instruction to interact with large language model like GPT-3 or BART. So these models can generate human-like responses based on the prompts they receive. Think of prompt engineering as giving direction to these models. By crafting specific and concise prompts, we guide them to produce the response we want. So to do this effectively, we need to understand the capabilities of the model and the problem we are trying to solve. Fine-tuning prompts allows researchers and developers to improve the performance and usability of LLMs for a variety of applications, including text generation, question answering, language translations, and others. Effective prompts engineering necessitates a thorough understanding of the underlying model's capabilities as well as the problem domain and desired result. Now, let's find out why prompt engineering matters for AI. So, prompt engineering is important in AI because it improves model performance, customization, and reliability. By creating clear and tailored prompts, developers can help AI models produce more accurate and relevant results, reduce biases, improve user experience, and address ethical concerns. In simple terms, prompt engineering ensures that AI systems produce useful and reliable results that meets the needs of users while adhering to ethical principles. So now let's consider an example in the context of text generation for generating product description. Assume you're using an AI model to create product description for an online store. So without prompt engineering, you may issue a generic prompt such as generate a product description for a smartphone. So without prompt engineering, you would get something like this. This smartphone has a high resolution display, powerful processor, and a long-lasting battery life. The given prompt is less effective because it lacks specificity. So it simply says generate a product description for a smartphone. So this may make it difficult to come up with an idea and write something engaging and informative. So having a good prompt can make a significant difference in your writing. They give you a clear idea of what you need to write about and keep you focused and organized, making it easier to generate ideas and express yourself. On the other hand, by using prompt engineering techniques, you can provide more specific instructions or constraints that will tailor the generated descriptions to the target audience or brand style. So with prompt engineering, if you input a query such as create a product descriptions for a budget-friendly smartphone perfect for the young professionals, highlights its affordable, sleek, and packed with the top-notch camera features, and the generated response would be something like this. Introducing our sleek and affordable smartphone designed for young professionals with its stylish design and advanced camera features, capturing life's moments and have never been easier, and it goes on giving its key features along with it. So through this example, we understood that prompt engineering enables the creation of a product description that is useful to the target audience and highlights specific features based on the instructions provided. So this shows how prompt engineering can improve the importance and effectiveness of AI-generated content for specific applications. To help AI models give accurate answers, it's important to create clear prompts. So here are some simple rules for generating effective prompts. First, make it clear. So clearly explain what you want the AI to do. Unclear prompts might confuse the AI and lead to wrong answers, so make sure that the prompt is clear. For example, the unclear prompts is something like write about cars. So where we have not mentioned which type of car or anything much in details. Whereas the clear prompt is write a description of a red convertible sports car. Next, give context. So provide enough information so that AI understands the task. So this helps it give accurate response that makes sense in the given situation. So for example, prompt without context is write a story. Prompt with context is write a story about a girl who discovers a magic book in her attic. Next, show examples. Use examples to show the AI what you are looking for. So this helps it understand the type of response you want. So for example, the prompt without example is Describe a beach scene. So prompts with examples is describe a beach scene with the palm trees, crashing waves, and the people playing volleyball. Next is keep it short. So don't overload the AI with too much information. Short prompts help the AI focus and give quicker, more accurate responses. For example, long prompts are like this. Write a detailed essay discussing the impact of climate change on biodiversity and ecosystems in tropical rainforest. And short prompts look something like this. Write about climate change effects on rainforest. Next, avoid biases. So make sure your prompts are fair and don't include any unfair assumptions. So biased prompts can lead to biased answers, which isn't helpful. So for example, write about a woman who struggles with her weight. So unbiased prompts are write about a person overcoming challenges. Next, set limits. So tell the AI any rules or restrictions it needs to follow. This helps guide its response and ensures they meet your specific needs. For example, prompt without limits are write a story, and prompt with limits are write a story set in a haunted house with a maximum word count of 500 words. And I hope it's very clear. Next, moving on to some example of prompts for generating text using ChatGPT. For text generation tasks, prompts usually consist of a textual instructions or starting point that directs the model to produce coherent and relevant text. Prompts can be story prompts, questions, or incomplete sentences. Text generation prompts provide context and directions to the model, allowing it to generate human-like text responses. They influence the generated text tone, style, and context. So let's say the prompt is write a short story about a character who discovers a hidden treasure. So by providing a specific storyline and theme in the prompt, the model is guided to generate a coherent and engaging narrative centered around the discovery of a hidden treasure. So the picture illustrates how ChatGPT crafts stories with an engaging touch, making them more captivating and interesting for readers. Next, question answering. So prompt is, can you describe the common signs and symptoms of COVID-19 along with any precautions that can be taken to stay safe? And just like that, it can generate answers to all your questions in mere seconds. So by framing the prompt as a question, the model is directed to provide a concise answer regarding the symptoms of COVID-19, ensuring relevant and informative responses. Next, language translation. Translate the given English sentence, the quick brown fox jumps over the lazy dog, into Spanish while maintaining its original meaning. So by specifying the source and target language in the prompt, along with the input sentence, the model is instructed to perform a precise translation task, ensuring accurate language conversion. Next, code auto-completion. Using OpenAI Codex or ChatGPT, you can perform code auto-completion task. So here we go with ChatGPT. Code generation prompts are usually partial code snippets or descriptions of programming tasks. They specify the desired functionality or behavior that the model should show. Code generation prompts allow the model to generate code that satisfies specific programming requirements, such as implementing algorithms, defining functions, or solving coding problems. So the prompt is, complete the following Python function to calculate the factorial of a number. And here you have also added the function. So, by presenting an incomplete code snippet along with clear instructions, the model is directed to suggest appropriate code completion, helping developers write code more efficiently. Now moving on to the text to image generation. Image generation prompts specify the visual sense, objects, or concept that the model should generate. They may include textual descriptions, keywords, or images. So image generation prompts allow the model on what visual content to generate. They influence the generated image's composition, style, and detail. For example, the prompt is, imagine a tree where the branches are made of stacks of books. So can you paint me a picture of that? And for the given prompt, we got the image generated as something like this. An imaginative portrayal of a tree with branches composed of stacked books, each book representing a leaf and covers visible. And the next prompt is, picture a cloud in the sky that looks like a huge heart. Can you draw that for me? And here we go. These AI tools leverage prompt engineering techniques to generate text
perform language translation, code auto-completion, and text-to-image generation, demonstrating the versatility and power of prompt based on interactions with AI models. Next, why is machine learning useful in prompt engineering? Machine learning is very helpful in prompt engineering, especially in linguistic and language models, because it helps create better prompts and interactions by analyzing lots of data and finding patterns. So first, understanding language patterns. Machine learning algorithms can analyze large amounts of text to understand linguistic patterns like grammar, syntax, semantics, and context. So this understanding is critical for developing effective prompts that generate desired responses from language models. Next, generating relevant prompts. Machine learning models can suggest or generate prompts based on input data and user preferences. These prompts can be tailored to specific tasks, domains, or user requirements, making them more useful and efficient for guiding language models. Next, optimizing prompts design. Machine learning techniques can be used to optimize prompt design by comparing the performance of various prompts and selecting the one that produces the best result. This iterative process improves prompt engineering practices and the overall performance of language models. And the next is personalizing interactions. Machine learning enables personalized interaction by creating prompts to individuals' users' preferences, history, and context. This personalization increases user engagement and satisfaction with the language model interaction. Next, improving model performance. Machine learning algorithms can be used to fine-tune language models based on prompt response pairs, increasing their performance and accuracy over time. Language model can be trained on a variety of datasets and prompts to produce more relevant and contextually appropriate responses. And next, mitigating bias and misinformation. Machine learning techniques can help identify and mitigate preferences in prompt engineering by examining prompt responses pairs for potential biases or inaccuracies. Language models can produce more fair, inclusive, and reliable results by detecting and correcting for preferences. And I hope it is clear why machine learning is useful in prompt engineering.
What is prompt engineering for code generation? Prompt engineering is a process that creates a specific prompts or instructions for AI language models to generate a code snippets or scripts. It involves defining objects, using relevant keywords, providing examples, and being specific and concise. This process enhances the accuracy, efficiency, and relevance of code generation tasks performed by AI models. Understanding how prompts LLMs can lead to more powerful and efficient applications. Now, let's understand the principles of prompt engineering. These principles provide a basic guidelines that can create a consistently used to increase prompt engineering effectiveness when it comes to code generation tasks. First one is clarify objective and understand task or goal. And second one is utilize keywords and specificity. And the third one is provide examples for context. Next one is conciseness and relevance. And the last one is encourage creativity and adaptability. Let's understand them in brief. First one is clarify objective and understand task or goal. Here, understanding what you want from code output, including inputs, outputs, evaluation criteria, and any constraints or difficulties is essential before creating a prompt. It is easier to develop prompts that accurately guide the model towards a desired outcome where there is a clarity. And the second one is utilize keywords and specificity. Including an appropriate keyword in a prompt helps to communicate the specifics of the task to the model. By avoiding inconsistency and using a clear language and instructions, you can make sure that the model produces a precise and focused code. Rather than requesting a function to process data, for example, be explicit about the kind of data and expected actions. And the next one is provide examples for the context. The model can better understand the expected output format and functionality by referring to the examples. Prompts are made more understandable by providing a specific examples of the desired code, which helps the models to understand the task. This will increase the probability of producing a code that is in line with the expectation. And next one is conciseness and relevance. The prompts needs to be brief, concentrating on relevant information that is crucial to the assignment and excluding unnecessary informations. Code generation is made more efficient by the model's simplified decision-making process, and clear and concise prompts reduces the confusion. Removing irrelevant information lowers noise and improves the timely efficiency. And the last one is encourage creativity and adaptability. Flexible prompt formulation allows for experimentation with the various strategies, such as linguistic structures, constraints, or templates. Continuous improvements in prompt by tracking a model outputs and iteratively improving prompts. This design creativity maximizes the code generation results by adapting to a various scenarios. Now, how prompt engineering is employed in various tools for code generations. First one is GitHub Copilot. Based on given prompts, GitHub Copilot suggests completions, creates documentations, and suggests new features to help developers write code. And second one is Google AI Code DaVinci. This helps developers to write code in a variety of programming languages by using prompt engineering, producing code snippets in line with the predefined prompts, facilitating a variety of tasks from web development to a natural language processing and machine learning. And the third one is OpenAI Codex. Codex assists developers with the coding task in a variety of domains, such as data science, web development, and game development by utilizing prompts engineering. It creates a code in a number of programming languages based on the precise instructions that users provide. Now, prompt engineering is crucial for guiding AI models in generating code accurately. Let's explore practical examples across different complexity levels. First, we will try for universal starter code, that is hello world program in Java. So for that, we have to give a prompt like generate a hello world program in Java. Hit the enter button, you will get a code of hello world program in Java. Next, we will look into the basics one, that is sum of two numbers. For this, we have to give a prompt like generate a function in Python that takes two numbers as input and returns their sum. So now you can see here the Python code is generated with a function name add numbers. So now we have seen how easy level task works. Let's move on to the medium level examples. We'll try to turn the comments into code. First, we'll create a list of countries and then generate a list of their respective capitals. After that, merge the list to create a dictionary mapping each country to its capital. To get this, we have to give a prompt as generate Python code to create a list of countries and generate their corresponding capitals and combine them into a dictionary mapping countries to capitals. Hit the enter button. Here is the generated Python code for given prompt. Here you can see the country's name and also generated a corresponding capitals. So this function defined generate capital, which gave us dictionary mapping countries to capitals. Next one, complete function or next line. If I want to complete a function to calculate the area of rectangle, then we have to give a prompt as write a Python function named calculate rectangle area that takes a two parameter as length and width and returns the area of rectangle. And to include the comments, we just have to type it as include comments to explain each step of the function. So in this code, you can see the function name which we have given in the prompt, that is calculate rectangle area with the parameters length and width. You can also see the comments here. If you use this code, you can get an area of rectangle value. Next, we will try for MySQL code generation. To get the names of employees, we have to give a prompt like generate a MySQL query to retrieve the names of all employees from the employee table. This also generated a MySQL query with a select statement. You can see here. The last example is about how to get an explanation of generated code. To get the explanation of a code, you have to give a prompt as provide a line-by-line explanation of the Python function named calculate factorial, which takes a parameter n and returns the factorial of n. Here in this code, you can see a function name so-called calculate factorial, which we mentioned in our prompt. After that, you can see a line-by-line explanation of a code. This is how you can get the explanation of a code. To become a prompt engineer, you have to follow certain steps. Before that, to accomplish this role, you need to be knowledgeable in a number of fields, which includes artificial intelligence, and then natural language processing, after that natural language understanding, and then programming languages, and finally UI UX design. And here are the steps to become a prompt engineer. First one is educational foundation, and the next one is programming proficiency. After that, AI and NLP knowledge, and the fourth one is networking and continuous learning. And last one is build a portfolio and specialize. Let's explore them in brief. First step is educational foundation. So here you have to obtain a degree in computer science, artificial intelligence or NLP for a quick entry into engineering roles and gain a thorough understanding of basics of NLP and AI concepts. And also, you have to focus on the courses covering NLP, machine learning and also programming languages during your studies. And then, apply theoretical knowledges to a real-world scenarios by engaging in projects and courses related to AI applications and continuous learning to stay updated and handle prompt engineering challenges in the evolving of AI field. And the next step is programming proficiency. For those who want to become a prompt engineers, knowing how to program is essential, especially in languages like Python. And also, gain a hands-on experience by working on coding projects, by implementing prompt engineering strategies and testing models. After that step, we have AI and NLP knowledge. Gain in-depth knowledge of AI, machine learning and NLP to become a proficient prompt engineering. And then, acquire a practical experience by working on projects and apply fundamental concepts and tools in a real-world scenario. And also, utilize the acquired fundamental knowledge for efficient and effective prompt engineering practices. And the fourth step is networking and continuous learning. Connect with AI and NLP professionals to build a network and gain valuable insights. And also, you should participate in conferences to stay updated on the latest developments in AI. And engage in online forums to discuss ideas, challenges and advancements with peers. And you have to stay informed about the latest AI advancements to enhance prompt engineering skills continuously. And finally, you have to regularly develop your knowledge and skills to become a proficient prompt engineering. And the last step is build a portfolio and specialize. Here you have to create a project that emphasizes your abilities, forming a strong portfolio to enhance employability as a prompt engineer. And then, showcase your prompt engineering skills through your portfolio. by providing tangible evidence of your capabilities to potential employers. And also, strengthen your credentials by obtaining relevant certifications and validating your expertise in prompt engineering. Now, let's understand demand of prompt engineering. The demands for prompt engineering is increasing due to the growing adoption of AI and NLP technologies in various industries. These professionals are crucial in optimizing languages models and ensuring accurate contextual relevant and ethical responses. As AI evolves and finds application in multiple sectors, the demand for skilled prompt engineers is expected to grow as they contribute to the successful deployment of AI technologies. Now, let's see the salary details for prompt engineering. The annual salary range for junior or entry-level prompt engineers with a 0.2 years of experience is between Rs 3 lakhs to 6 lakh. And then, the annual salary range for mid-level prompt engineers with a 2 to 5 years of experience is around 6 lakh to 12 lakhs per annum. The annual salary for senior prompt engineer is 12 lakhs per annum. It completely depends upon the individual skills and the salary policies of the organization. In USA, according to the ZipRecruiter report, the salary for entry-level prompt engineer is $31,000. And then, the average annual salary for mid-level prompt engineer is around $59,500. And finally, for senior prompt engineer with a 5 or more than 5 years of experience, it can exceed up to $91,500. Let us know which companies are hiring for prompt engineers. Amazon, Facebook, Microsoft, OpenAI, and Google.
Embarking on the creation of AI persona chatbots opens up a thrilling and financially rewarding chapter in the realm of artificial intelligence chatbots. This innovative venture stands out because it normalizes the field of AI, removing the barrier of technical expertise. In other words, you don't need to be a programmer or have any coding background to dive into this creative process. Platforms like Flowise are at the forefront of this revolution, offering intuitive tools that simplify the creation of these sophisticated chatbots. With such platforms, the process becomes accessible to everyone, empowering users to bring to life digital avatars of well-known personalities, celebrities, or influencers. These virtual entities can serve various roles, acting as personal assistant, ready to manage tasks, or offering guidance and tailored advice to users' needs. Hello everyone, Edureka welcomes you all once again to our YouTube channel, and this time, let's build a chatbot using prompt engineering. In this tutorial, we'll craft an AI persona chatbot inspired by Steve Harvey, offering a tailored advice on life motivation and personal growth. We'll start from the ground up with the Flowise, guiding you through each step to build your own AI persona chatbot. But before we begin, kindly consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for training and certification courses, the link to which is in the description box below. So coming back to our video, firstly we need to equip our systems with some tools. So let's proceed with installing Flowise. Now, in order to install Flowise, we need to visit the Flowise official website. So let's check that out. So I'm going to type Flowise. Okay, so here's the official website of the Flowise. I'm also going to add this link to the description. You guys can also access it from there. Then in this official website, you can see the GitHub link over here. So we'll go on GitHub, then we'll scroll down, and here we see the quick start option. And this quick start, we have all the steps to start with the Flowise. So firstly, it says to install Node.js. So we'll do that. So over here, based on your system, you can just download the Node.js. So I have already downloaded the Node.js in my system. So I'm not going to repeat the step, but you guys can follow on that. Then again, over here, these are the commands which we have to type on our command prompt. And over here, the first command that you see on your screen is to install the Flowise. Okay, I have already installed Flowise in my system, but you guys have to follow this step if you are new into the Flowise. I have already installed the Flowise in my system, but for the first timers, you have to put this command in your command prompt. So I will go directly with the start Flowise. So this command I'm going to copy and I'm going to put it on my command prompt. You might have to wait for some time. Okay, so over here we can see the Flowwise is listening at port 3000 and data source is being initialized. So after getting these two messages, you can directly go to port 3000. So we'll go into that. And here is the Flowwise user interface in front of us. Okay, so very firstly, we have to start gathering the data to feed into our chatbot. Okay, so you can choose any of the mediums. You can refer any blogs, any of the YouTube videos or anything. For us, we are going to take some Steve Harvey motivational videos. So we'll go to YouTube. And over here, I'm going to type as Steve Harvey motivation. We'll try to look for longer videos because the larger the transcript is, the more accurate your data is going to be. So this is pretty long. So in order to download the transcripts, what you have to do is just copy the link of this video. Copy. I'm going to mute it. Not this one. And then we need to go to the site YouTube transcripts. Then over here, we need to paste a URL. Go. And over here, you have the access to the complete transcript. So what we're going to do is just copy the transcript from here. And then we need to save it to our system. So I've already prepared a folder called transcripts. And you can see 2 transcripts I have already written. So you can seek the transcripts in any of the documents. I have put it in text documents. You can even prefer as PDFs or docs or anything. Now, this was for the previous chatbots that I have prepared. So let's delete those because I don't need them. And we'll prepare a new one. So new text document I need. And let's save it as Steve Harvey part 1. Yes. So over here, I'm going to paste the entire transcript. Control S, it got saved. Yeah, and we are ready to go. For this particular video, I'm going to take one more video of Steve Harvey. So let's search one more video. This we already took. Any other? Yeah, this one looks good. Just pause it for now. Copy link. Again to the same site. We're going to paste the URL. Yeah. And we are going to copy the entire transcript. Then again, we're going to go to our system. New text file. Let's give it Steve Harvey part 2. Open, Control V, Control S. Yeah, and we are ready to go. So after downloading this transcript, let's go back to our Flowwise. So here we have Flowwise. Then I'm going to click on Add New. And here's the canvas where we are going to make our chatbot. So in order to start that, go to Add Nodes. Go for Chains. And here we have Conversational Retrieval QA chain. Just drag and drop it to the canvas. So this Conversational Retrieval QA chain is a tool that is used in creating chatbots, which helps the chatbot to find and provide answer to the questions in a conversation. You can think of it like a library system inside the chatbot that helps in understanding what you're asking and then search through its knowledge to give you best possible answer. This chain is a sequence of steps that the chatbot follows to make sure it understands the questions correctly and retrieves the right information to help you. And over here in the Conversational Retrieval QA chain, you can see as chat model, vector store retriever and memory as the inputs. And the final output is a Conversational Retrieval QA chain. So let's find the input of these. Okay. So our first input is chat model. So we are going to go to Add Nodes and we'll look for chat models over here. And for this chat model, we are going to choose chat OpenAI. Again, drag and drop. We are going to put it here. Now, you can check out the output as chat OpenAI. We are going to connect its output to the input of conversational retrieval QA chain, especially to the chat model section. Yes. Now, let's check the second input, which is vector store retriever. So we're going to go to plus nodes. Then we're going to look for the vector stores, and where is it? We need in-memory vector store. This one. So drag and drop over here. Now, this in-memory vector store is actually a database that our chatbot is going to follow through. In this document section particularly, we are going to put our transcripts. So let's connect its output to the vector store retriever input of conversational retrieval QA chain. So, as I already told you, in this document section, we are going to store the transcripts that we have downloaded. So how to do that? Again, add nodes, go to document loaders, and then select folder with files. Drag and drop, put it over here, output to the input. Now, in the folder path section, we have to put the path of our transcripts. So over here, Control C, and again to our flow-wise, folder path, Control V. Okay. Now, we can also see one input as text splitters. So let's also take care of that. So we go down, here we have text splitters, and we're going to take cursive character text splitter. Drag and drop over here. The chunk size is already 1000, which is good enough. And chunk overlap, let's put it to 200. Again, it's output to the text splitter input of folders with files. Yeah. Now, we have one more thing called embeddings. So, we are also going to add embeddings. So, okay, over here we have embeddings. And we have OpenAI embeddings. We're going to put it over here. Yeah. So, our chatbot is almost ready. So, over here you can see this connect credentials part. So, let's also check that. We have to add a credential, and for that we are going to take the API keys of the OpenAI. How to do that? Let's check that out. So, we are going to go at OpenAI website. So, I'll type just platforms.openai accounts and API key. This one. Now, for the API keys, we are going to go to platform.openai. So, this particular link, I'm going to paste it to the description. You can get it from there. And here we have the access towards the API keys. So, just click on create new secret key. You can type anything like test key or anything like that. Create secret key. And it's going to generate a secret key for you. So, I'm just going to copy that. And then I'll come back to the flow-wise. Yeah, I'm going to save it. Let's save that as AI Steve Harvey. Save. Okay, our chat flow got saved. Back and go to credentials. Let's set this one. Just go to add credentials. Put here as OpenAI API. No. And here it asks for credential names and OpenAI API key. So just paste your API key and let's put here as OpenAI. Add. Yeah. So here we have our credentials. Now again we are going to go to our chat flow. And over here in the connect credentials part, we're going to paste as OpenAI. One in our chat model and another one we have in our embedding section. Again, we have OpenAI. So, our chat flow is fully ready. So, again, we are going to save it. And then, we can go to the section of chat. So, it already shows a message. Hi there, how can I help you? firstly I'm gonna say hello. Now it's gonna take some time and it's going to show error. Okay, it showed how hello I can assist you. I'll tell him to introduce yourself. Okay, I'm an AI assistant. I'm here to provide you with information assistant. So our chatbot is kind of working, but we want our chatbot to have a personality of Steve Harvey. How to do that? Let's check that out. Now, in order to give that personality of Steve Harvey, let's go to the additional parameters of the retrieval QA chain. And over here, you have a space. Now, put a prompt similar to like this. So, this is a prompt like you are Steve Harvey, an American television host. All this I have gathered from different sources like Wikipedia or like Steve Harvey personality blogs or anything like that. You can get it from there. So, I'm going to select it all. I'm going to copy and I'm going to paste it over here. You can also pause the screen and read the full prompt. But what I want you to read is the last line because it's important. So the last line is like, if you have no relevant information within the context, just say, I'm not sure. Or don't try to make up an answer, never break the character. Again, the same thing, answer the user question as you are Steve Harvey and only answer questions found in the context. If you don't have any answer, just respond with something like, I have no idea. Or could you please rephrase that? Or I'm not sure. So yeah. So this prompt will help a model to stick to the relevant information and answer it as Steve Harvey. So again we are put, okay, so firstly we need to save it. Yeah, we saved it. Chat. Again we're gonna put something like hello. Okay, hi there. And again I will say introduce yourself. Okay, so here you can see now I'm Steve Harvey, and television host, producer, actor, comedian. I'm known for my hosting shows like Family Feud and all, like whatever we have given in the prompt. So now I'll tell him to, just tell me a joke. Okay, sure thing. Here's a joke for you. Why did the scarecrow win an award? Because he was outstanding in this field. Okay, let's tell him I need a motivation. What does I need? A motivation. I need some motivation, I'll tell. As I am feeling lazy. So here we have our answer. Don't worry, I have got you covered. Remember, success requires a tremendous work ethic and faith. Imagination is the key to achieve your dreams. So dream big, believe in yourself, and take action to make those dreams a reality. You have the potential within you to achieve great things. Keep pushing forward. Okay, so it is working properly. So our chatbot actually got a personality of Steve Harvey. Imagine how it would be for you if you got a virtual side pair alongside you while you're coding. The side pair is helping you to automatically generate code and improve your code by making it faster and more efficient. You can chat with him, you can ask questions, ask suggestions, and much more. Sounds good, right? Well, GitHub Copilot is that AI side pair of yours that makes it all possible. It is an AI coding assistant that helps you to write code faster and with less efforts, allowing you to focus more energy on problem solving and collaboration. GitHub Copilot is proven to provide 55% faster coding and also proven to increase developers' productivity and accelerate the pace of software development. If we take a look at the industry standards, then we can see that around 50,000 plus businesses have adopted GitHub Copilot. 1 in 3 Fortune 500 companies use GitHub Copilot, and 55% of developers preference GitHub Copilot. Now, if you want to learn more about this and you want to know how to use this amazing AI tool, then you just clicked on the right video. In this GitHub Copilot tutorial, you will learn how to use GitHub Copilot and how it can be your trusty navigator guiding you on your flight path to a coding career that really takes off and goes up high. So now, let's open up our code editors and get started with the GitHub Copilot. Now, very firstly, let's check how you can install the GitHub Copilot into your system. So very firstly, we have opened our Visual Studio Code, and in order to install the GitHub Copilot, go to the extensions, and as an extension, type GitHub Copilot. You can see over here. Now, I have already installed GitHub Copilot in my system. But over here, you can just click on the install button and it will start installing in your system. After that, once you have installed GitHub Copilot, you have to create an account in the GitHub. So over here, you can see the GitHub link. Click on that and it will redirect it to a page of GitHub. Now I've already installed GitHub. Now, one more thing comes is that this GitHub Copilot needs a paid subscription. So if you want to check the paid subscription for the GitHub Copilot, we can visit this particular website. I'll be putting the website in the description. You can check it out from there. Now, once you come to this website, which is the GitHub Copilot official website, you can scroll down and over here, you can check the subscription plan for GitHub Copilot. For the $10, you can start a free trial over here. Then according to your usage, you can check whichever plan you want. So once we have installed GitHub Copilot and we have subscribed to the GitHub Copilot, it's time for us to use the GitHub Copilot for our coding. So once we are done with the installation part of GitHub Copilot, you can check this icon over here of GitHub Copilot. This icon basically portrays that your GitHub Copilot is active and it's ready to run. And in case if you don't see this icon, just restart your Visual Studio Code. And once you restart, you're going to see this icon over here. Now, I have already created a folder of GitHub Copilot in which we are going to store our files, in which we are going to check the capabilities of GitHub Copilot. So, before we jump into the coding part, let me show you something interesting. So, for example, let me create a Python file. So, I'll put edureka.python. Now, if I put a comment over here, comment, and if I put a question like, what is inheritance in Python? So as you can see that it is already predicting my question. I'll put enter and it's gonna generate an answer for me. You can see the answer over here. If I want to accept that answer, I have to just click on tab button, and for the convenience I'll put Alt plus Z, and over here you can check the answer for this particular question. Inheritance is a mechanism in which one class acquires a property of another class, and has also given us an example. Now, if I check another question, so see, over here it's also predicting my next question. It's already asking an example of inheritance in Python. So if I accept that, I put enter, and it gave me the example of inheritance. It also gave me a piece of code. So for now, I won't get into the coding part. So this is how you can check that GitHub Copilot is also good in predicting our next questions and predicting our next moves. So this is how you can also put a Q&A with GitHub Copilot. So now let's move to the coding part. Let me make a index.html file. I'm gonna put the tags over here. Then I'm gonna put the title as, let's say, Edureka. And in the body, let's say if I make a container. Now, over here, you can also see the H1 and para that GitHub Copilot is suggesting us for the title Edureka. So, the text which is appearing over here is called as a ghost text. Now, if I want to accept this ghost text, I have to click on the tab. And if you just want to reject, just click on escape button. So, for this, it has already given an H1 and a para for this. I'm going to put Alt plus Z to put it in a better format. Now, let's add a style sheet into that. So if I put style.css, and in style.css, I want h1 tag as, let's say, blue in color. Now I have to link the style sheet into a HTML file. So for that, it's already giving a code for us. So if I click on tab button, it's gonna link the style sheet. And then if we run this whole file, you can see it has applied the style sheet. It has given the heading in blue color, welcome to Edureka, and also given us the text. So here you can see how GitHub Copilot is helping us with HTML and CSS. Now let's check some other capabilities and features of GitHub Copilot. So after playing with the HTML and CSS using GitHub Copilot, let's check some more interesting features in GitHub Copilot. So again, we'll go to the .py file, which we created in the initial stages of our tutorial. And you can see this option of Ctrl plus I. Now, if you press Ctrl plus I, it's going to open an option of inline chat feature in GitHub Copilot. So let's say we give it a prompt of generate a code for calculating the number of days
between two dates. Let's keep it simple. Once you press enter, it will start generating the code snippet for you. Now, if you are satisfied with the code snippet, just click on accept, and you can see the code snippet is appearing in your code editor. Now, let's say there is some error in this particular code. So let's say if I remove this end date from here, and I don't know what is the error in this particular piece of code, how to find it. Now, in order to find this, GitHub Copilot helps you with this particular feature of fix this. Now, if I select the whole code, right click, I'll go to Copilot, and if I click on the fixes option, it's gonna fix the whole code by giving you the suggestion and giving you the solution for this particular problem that you are facing. So it already says that your problem is with the function is expecting one argument, but two are provided. So if I accept this, you can see again it put it the last argument over here, which is of end date. Now, GitHub Copilot sometimes gives the accurate code snippet which you want, and sometimes it might differ from what you actually want. Now, in order to do that, just select the whole code and put Control plus Enter. Now, once you press Control plus Enter, you can see GitHub Copilot coming up with a lot of suggestions for this particular piece of code. Now, if you are satisfied with any of the suggestion, you can just accept the suggestions and it's gonna implement the particular suggestion for your code. Now, let's check one more feature. Now, you can even ask GitHub Copilot to explain the whole code snippet. Now, in order to do that, again go to the Copilot and go to this option of explain this. Now, once you click on the explain this option, now you can see in the chat box, it comes up with the whole explanation of this particular code. Now, this chat box is very much similar to the other AI chatbots that you use like ChatGPT or Google Gemini or Google Bot. Now, you can even ask for more questions to this chat box. So, let's say if I ask him, write a code for bubble sort algorithm, let's see. So, here you can see that is coming up with a code snippet of bubble sort algorithm. Now, this is very much similar to what we do in ChatGPT or other AI bots like Google Gemini and all. But the main feature is that this chatbot is appearing in your code editor and you can just directly copy paste this particular piece of code. You don't need to go to the separate browser, then you have to copy paste the whole code from there. So in short, it makes your job more easy. Now, to make it visually more appealing, you can even drag this chat box anywhere in the code editor. For example, if I put it over here, you can see the chat box appearing over here, or you can make it appear anywhere in the code editor according to your convenience. Now, after checking these basic features, let's check how these features of GitHub Copilot actually help us while we build something. So for now, let's try to make a simple chatbot using Python with OpenAI API, and let's see how quickly we can complete building this chatbot. So very firstly, we're gonna start by importing OpenAI library. Now, to install this OpenAI, you have to go to your terminal and type pip install OpenAI. So after that, let's put our API key. And now you can see that GitHub Copilot is already ready with its suggestions in the form of a ghost text. So we're gonna type tab and let me change my API key. Now, in case if you don't know how to generate the OpenAI keys, then you can just simply visit the OpenAI website and over here in the platforms you can generate your API key. I'll be putting this link in the description. You can go to this website and make your API keys. So I'm gonna copy my API key and then I'm gonna paste it over here. Then let's make a function of def chat with GPT. And you can see once we write the function, it's already ready with the code. And in this case, we exactly want the same code. Response equal to OpenAI completion, create, engine is GPT 3.5 instruct, exactly. Prompt is from, max tokens is 150. Decent enough. Now, what is this code about? What is this function about? Let's understand. Now, this function will generate text based on the input prompt using OpenAI's language model. The parameters for the completion model include the engine, prompt, and the max token. This engine basically specifies which version of the language model to use. In this case, it's using the GPT 3.5 Turbo Instruct engine, and then it comes to the prompt. Now, this prompt is a text provided to the model to generate a response. It's what the user wants to chat about or to get information on.
Then we have the max token. Now this parameter limits the number of tokens in the generated response. Here it is set to 150. It means that response won't be too long. Now, once the response is received from the OpenAI API, the function returns the generated text. The .choice.text strip part extracts the generated text from the response object and removes any extra white spaces from beginning and the end. Now, let's move forward and create the main function. So, we are going to put if name.main, and you can see again it came with the course text, which is exactly I want. Now, what is this main function? Let me explain you. Now, over here, the code first checks if it's being run directly. Then it enters a loop where it continuously prompts the user for input. If the user inputs an exit command, the loop breaks. Otherwise, it prints the user input and the bot responses. So now, let's go and run our chatbot. We're going to run it in the terminal. So over here, I'm going to ask, who are you? So over here, you can see the generated response. It's like I'm opening a GPT-3 language model programmed to assist you with a variety of this. Okay, great. So you can see that our chatbot is working. Let's say one more question of like, what is the difference between a class and an object? Let's say. Again, it came with an answer. A class is a template or blueprint that defines the characteristics and behaviors of a type object, while an object is an instance of class. So it typically answers the question which you want. Now, you already witnessed that how easily we built this chatbot with just a few clicks by accepting the recommendations from the GitHub Copilot. Now, after the chatbot, let's also try to make a linear regression model for us. So we'll start off by importing required libraries. So firstly, I'm going to start by import matplotlib.pyplot as PLT. Then I'm going to import NumPy. It is already showing me over here. I'm going to click on tab. Then I don't need torch, but from scikit-learn, I need to import the data sets and the linear model. And then from scikit-learn, I need mean squared error. Yes, I do need mean squared error. So I'm going to accept that. And then I will start by loading the diabetes datasets, which is already showing me over here. So I'm going to tab, and then it's going to give me a code. So again, I'm going to click on tab. So again, I'm going to click on tab. Now, what I want is, this is exactly what I want. I just wanted to use only one feature of it. So again, I'm going to click on tab, enter. It's going to give me a code for that. It's already did it slicing, and then I'm going to print it. So print diabetes X. And let's check the data set. This is the exact data set which we wanted, or this one feature we are taking to train our model. So I'm going to delete that. I'm going to move forward by building a model. So after that, we have to split the data into training and test. It already knows what we are planning to do. But enter. Yes. So over here, it is taking the first 80 elements for the training data set. So I was like, so I'm okay with that. And then for testing, it's taking the last 20. I'm even okay with that. Then for target, I need training and testing. Yes. Again, I'm going to split the target into training and testing. So diabetes by train, diabetes by test, exactly what I want. And then I'm finally going to create the linear regression object or the model. So as you can see, I'm just writing the comments and it is already showing me the code for that. So for this particular model, I don't even have to code a single line, or rarely maybe a line or two I have to code. But everything GitHub Copilot is suggesting me. So I'm going to click on tab. Then I have to train my model exactly what I wanted to do. Enter. So it's going to fit diabetes X train, diabetes Y train. Enter. And after that, I'm going to make some predictions. Again, exactly. Enter. So diabetes Y predict. Good. I'm going to predict the X testing set. So this is exactly what I want. And then I also want the coefficients. It's giving me the code to print the coefficients. And then again, the mean squared error I want. It's giving the code for mean squared error. Tab, enter, tab, enter. And then I'm going to give the plot outputs. For that, we need the
plt.scatter exactly, and then plt.plot for that one straight line, and then I want plot to show plt.show. So a linear regression model is ready, and as you can see how much coding I did it by myself or manually. GitHub Copilot made the job as easy as it can be. So I'm gonna run the Python file in the terminal. So you saw how conveniently and quickly we made these projects using GitHub Copilot. However, these were just the basic projects we built in order to give you an idea about GitHub Copilot.
Now, let us understand what LangChain is and why it is a valuable tool for building AI applications. You must be aware of popular applications such as GPT and Gemini. These applications utilize APIs, and GPT uses OpenAI's API while Gemini operates through the Gemini API. To process prompts, they leverage models like GPT 3.5, GPT 4, Palm, and Gemini 1. Additionally, these are other advanced models such as Llama, Gemini, Cohere, Cloud version 1, Falcon, Palm, GPT-4 and GPT 3.5. LangChain is a framework designed to help developers build flexible and powerful AI-driven applications by integrating and utilizing these diverse models effectively. But why exactly do we need LangChain? You must be thinking, if LangChain is this important, then why do we need LangChain? So let's break down this question using some real-world examples. So imagine simply asking an LLM a prompt and getting an answer. That's easy. But what happens when the complexity increases? For example, let's say you're working with data from SQL databases, CSV files, PDFs, or Google Analytics, and you need the model to write code, perform searches, or send emails. Handling such intricate workflows manually can get overwhelming. This is where LangChain steps in. It simplifies the process by offering components like document loaders, text splitters, vector databases, prompt templates, and tools. So these helps you assemble tasks such as document summarization, question and answer systems, or even advanced workflows like Google searches or customer support automation. Let's visualize this process with a diagram. Here's how it works. So first, you load a document like a CSV file using a document loader. Then, use a text splitter to divide it into smaller chunks and then store those chunks into a vector database and add a prompt template to guide the model. And finally, use a LLM like a GPT-4 or Llama to perform tasks like searching the web or automating workflows. And LangChain also offers chains that will help you assemble components to achieve single tasks such as summarization and an agenda to figure out what each component must do, like password, customer services, etc. Now that we understand LangChain's core components, now let's explore how it streamlines the LLM application lifecycle. So it typically involves three key stages. First is the development, where you build and test your application. Then productionization, where the system is fine-tuned for a real-world use. And finally, deployment, where the final product is launched for users. So LangChain simplifies this lifecycle, allowing you to focus on building without worrying about the underlying complexity. Now let's take a step back and understand the role of APIs in powering these LLM applications and how LangChain effectively integrates them. In all these applications and models, one thing is common, that is, they use API. So now let's discuss APIs. APIs act as an intermediaries that enable different systems to communicate with each other. For example, they allow apps like Swiggy or Blinkit to display your delivery driver's location in real time. So now let's look at the steps to explain APIs and API keys. So apps like Zipto, Swiggy and Blinkit use APIs to show the location of your delivery driver. So these apps don't communicate directly with Google Maps but follow a layered process involving servers and security mechanism. First, the app sends a request to Google Maps API. Then, the API forwards the request to Google servers. Then, the servers validate the request with the system. So once approved, the response follows back through the servers, APIs, and finally to the app. So previously, apps like Swiggy allowed login using phone numbers. Now, they use API for login via platforms like Google or Facebook. So this demonstrates the versatility of APIs in enabling seamless user interactions. To prevent misuse, APIs require API keys, which are unique identifiers for secure access. So these keys authenticate requests and ensure that only authorized users can interact with the APIs. Next, security systems closely monitor API usage to detect and prevent misuse. This ensures that APIs remain safe and functional for their intended purpose. And these steps simplify the explanation of how APIs and API keys work in real-world applications. So this is how LangChain leverages APIs to connect your LLM applications with external tools, making them versatile and secure. Now that we understand the role of APIs, so let's explore some real-world applications of LangChain. So, what can you build with LangChain? Here are a few applications. First application we have is customer support. So, customer support for your shopping websites to interact with customers. Next, conversational chatbots for helping you study. Content generation tools for blogs or social media. We also have question answering systems for knowledge bases, and then document summarizers for legal or academic content. LangChain simplifies AI development by integrating LLMs with various data sources and tools. Its applications are vast, from chatbots to document summarization. So, let's examine a practical example to see LangChain in action. Alright, in today's data-driven world, understanding and effectively using SQL queries is crucial for managing and analyzing large datasets. However, beginners and even experienced users often need help with complex SQL queries, their syntax, and how they work. This creates a barrier to efficiently interacting with databases and limits their potential to solve real-world problems. To address this challenge, we propose a SQL query fetcher application that leverages the Gemini AI, Python, and Streamlit to simplify SQL learning and usage. The application allows users to input or select a query, generates the SQL syntax, and provides a detailed explanation of its components and functionality. This tool bridges the gap between technical understanding and real-world database operations, empowering users with an initiative and interactive SQL learning experience. Let's jump right into the code. So the first step is setting up your dependencies. Here, we import Streamlit for the user interface, and then Google Generative AI for using Gemini. So first, import Streamlit as ST, and next import Google.Generative AI as GenAI. So to get this API, you have to go to the Google Gemini API key, and here click on Get a Gemini API key in Google AI Studio, and then once you scroll, there is a button on the left called Create API. Now click on it and select your model here, and let's copy it. And now let's go back to our VS Code editor and paste it here. So to paste, let's type Google_API_key, and inside the double quote, let's paste it. And now let's type GenAI.configure, and inside the bracket, let's keep it as API_key equal to, and give it as Google_API_key. Now let's type model equal to GenAI.generative model, and inside the bracket, let's keep it as Gemini Pro. So we use the Google Gemini API to generate SQL queries dynamically. So make sure to configure your API keys securely. Now let's display the Streamlit layout code. Now let's set up the app's user interface. So we use Streamlit to create an interactive page where users can input plain English queries and get SQL code in return. So we write st.set_page_config, and inside the bracket, let's give it as page_title, and inside the double quotes, let's give a title as Edureka SQL Query Generator, and give a comma, and let's type it as page_icon equal to, and inside the double quote, let's keep it as robot. Now let's put some images. So I'm using Edureka image and SQL logo, and also to make them center, we will type it as column 1, comma, column 2, comma, column 3 equal to st dot columns. And inside the bracket, let's keep it as 1, comma 2, comma 1. Next, let us type with column 2 colon, and let's type it as st dot image, and inside the bracket, let's give the image address, and then width is equal to 200. Now let us add another image, so let's copy the same and give the other image address. Our layout includes a title, logo and text input box to keep the interface simple and intuitive. So here's where the magic happens. So when a user clicks the Generate SQL Query button, we format their input into a prompt for the Gemini model to generate SQL code. So let's create template by writing template equal to, and inside the triple quotes, let's type it as create a SQL query snippet using the below text. Next, let us also give text input, and we'll also type I just want a SQL query. Now let's type the response. So type response equal to model.generate, generate underscore content, and let's keep it as template.format, and inside the bracket, let's give text underscore input equal to text underscore input. And next, let's type the SQL query. So give SQL underscore query equal to response dot text dot. So let's give the strip function dot lstrip function dot rstrip function. So the AI generates the SQL query and we clean up the output for display. So once the SQL query is ready, we take it a step further by generating a sample expected output and a clear explanation of the query. Now let's type the logic for showing explanation and output. So let's type st.markdown, and inside the bracket, we will give HTML tags. So first, div style is equal to, we will align the text in center. So text align center. And next, let's give h1 tag, and inside h1 tag, we will write SQL query generator, and let's close the h1 tag. Next, let's open h3 tag and write I can generate SQL queries for you, and let's close the h3 tag, and inside the h4 tag, let's type it as with explanation as well. Now close the h4 tag and let's open the paragraph tag, which is the p tag, and inside the p tag, let's type it as this tool allows you to generate SQL queries based on your data. Now let us close the p tag. Also close the div tag. Now to make the markdown visible, let us type unsafe underscore allow underscore HTML equal to true. Now let's write text input equal to st.text underscore area, and inside the bracket, let's give it as enter your query here in plain English. Now let us give a submit button. So for that, let us type submit underscore button equal to st.button, and inside the bracket, let us give generate SQL query. Now if submit button colon, write it with st.spinner, and inside the bracket, let's give generating SQL query, and then let's create a template, and inside the triple quotes, let's type it as create a SQL query snippet using the below text. Now using the above template, we will write 3 more templates for SQL query, which are text input and then SQL query, which will include expected output and also explanation output. Now to merge all the templates together, we will make a container. So we will write with st.container. So it's a function, And let us also write it as st.success, and inside the bracket let us keep it as SQL query generated successfully. Also, we will give here is your query below. Next, st.code, and inside the bracket let us give SQL underscore query and comma language equal to SQL. Now let us give once again st.success, and inside this let us keep it as expected output of this query will be, and now let us keep it as st.markdown and inside the bracket a output. Once again st.success, and inside this let us keep it as explanation of this SQL query. Next, let us give st.markdown, and inside this function let us keep it as explanation. So over here this shows a green success message indicating the SQL query was generated successfully. And next, the show SQL query, this displays the SQL query as a formatted code block highlighting it as a SQL. Next is the display expected output. So this provides a success message for the query's expected output, followed by st.markdown e output, which displays the expected output in markdown format, and followed by st.markdown e output, which displays the expected output in the markdown format. So now this line of code introduces an explanation, and st.markdown explanation displays that it is in markdown format for clarity. So this makes the tool valuable for both learning and debugging SQL. So now let's see it in action. So open the terminal and let us type streamlit run and give your file name. Now, as you can see the screen, your SQL query generator is ready to go. Now, let's test it. So for that, here I will input a prompt asking for a query, which is give me the query for create table. Now, let's click on generate SQL query, and as you can see it's running. So let's wait for it to generate. So as you can see on the screen, the app generates a SQL query, expected output, and even a plain English explanation in seconds. So how cool is that, right? And that's it. Our SQL query generator powered by LangChain, Gemini API and Streamlit is complete. So this project is perfect for simplifying SQL learning and enhancing productivity. Now, let's begin by understanding what RAG is and how it works. RAG is a hybrid approach in artificial intelligence that combines retrieval systems with generative models to produce highly accurate, contextually relevant responses. It brings the gap between factual accuracy and natural language generation. Now let's understand it with the help of diagram. So, it's a hybrid approach involving artificial intelligence that combines a retrieval system with a generative system to produce highly accurate responses. Now that we know what RAG is, so let's explore why it is crucial for large language models and see a real-world example. So, RAG addresses several limitations of traditional LLMs. It mitigates illusions by grounding responses in factual, retrieved data. By dynamically accessing up-to-date information, RAG stays relevant in rapidly challenging domains. It improves accuracy and relevance by fetching specific, relevant documents during inference. By outsourcing factual knowledge retrieval, RAG enables smaller, more efficient models, and it can adapt to domain-specific knowledge bases for specialized applications. Additionally, RAG provides explainability by showing the retrieved documents or data sources, increasing trust and transparency. Now let us see some of the use cases. So without RAG, the sentence would be, when was the last Mars rover launched? So this is just the incorrect response. So with RAG, the sentence would be dynamically retrieved from NASA's database. And it would be, the Perseverance rover was launched on July 30, 2020. Now that we have seen why RAG is important, so let's dive into how it works. Well, RAG operates in three-step process. A user submits a query, which triggers the retrieval stage. Here, a retriever searches a database or knowledge base using tools like BM25 to fetch the most relevant information. The retrieved data is then fed into a generative model like GPT or T5, which processes it and generates a coherent, contextually grounded natural language response. Now, let's take an example. Here, the query is, who wrote 1984? Retrieve would be fetching a document containing George Orwell wrote 1984. Now, generative response would be, the author of 1984 is George Orwell. This hybrid approach makes RAG ideal for real-world applications like chatbots and knowledge systems. Now that we understand how RAG works, let's explore some of its real-world applications. RAG's versatile applications span various domains. In knowledge management, it can summarize large databases or documentation, aiding corporate teams. Legal and compliance tasks benefits from RAG's ability to answer queries based on case law and regulations, while in healthcare, it can support medical professionals by summarizing research papers and guidelines. Education and e-learning can leverage RAG for virtual tutoring, providing detailed explanations based on the textbooks and research papers. Interactive virtual assistants like Alexa and Siri can utilize RAG to generate accurate and informative responses to user queries such as news headlines or product recommendations. RAG's unique ability to combine retrieval and generation makes it essential for tasks demanding both factual accuracy and fluent natural language responses. Now, let's compare retrieval augmented generation with traditional AI model across 3 features. First, we have factual accuracy. RAG provides highly accurate responses by using real-time data, whereas traditional models may give less accurate answers and may give errors. Next is the context adaptability. So here, RAG adapts quickly to new queries using live data, whereas traditional models offer fixed answers based only on pre-trained knowledge. Next, we have knowledge updates. RAG is easy to update, just change its data source, whereas traditional models need retraining, which takes time. Then we have scalability, whereas traditional models are limited by their size and training data. And then we have use cases. RAG is great for tasks like legal advice or customer support, whereas traditional models work well for creative writing or casual queries. So here I want to conclude that RAG is ideal for knowledge-based tasks needing accuracy and flexibility, while traditional models are better for creative users. While RAG offers significant advantages, it's essential to acknowledge its limitations. So let's discuss the challenges and future of RAG. So the first challenge is the latency. RAG systems can suffer from latency issues, especially when dealing with large datasets or complex queries. Next is the data quality dependency. The quality of the generated responses heavily depends on the quality of the underlying data. The next challenge is complex integration. Integrating RAG systems with existing applications and infrastructure can be challenging due to the need for data synchronization, query optimization, and model management. And finally, scalability issues. As RAG systems become more complex and are deployed at scale, they can face scalability issues. This includes handling increased query loads, maintaining data freshness, and ensuring model performance. Now, while RAG faces limitations, its potential is undeniable. So now let's discuss RAG's future. The future of RAG holds immense potential. It will power dynamic, real-time applications like news summarization, financial analytics, and live sports commentary. RAG will be customized for specific domains like healthcare, law, and science through integrations with specialized knowledge bases. Advances in retrieval models and compression techniques will reduce latency to enhance efficiency. RAG will expand to handle multimodal data, enabling use cases like multimedia question answering. Additionally, RAG will facilitate personalized AI assistance and improve transparency and explainability by attributing sources and providing clear explanations. Now, let us move on to Generative AI project using RAG. So imagine you're working with a massive library of documents. You need a way to quickly search and answer questions based on the content. So manually, flipping through pages takes time and effort. Wouldn't it be great to have a system that retrieves relevant information and answers your questions directly within those documents? So that's where our Streamlit app comes in. This app utilizes the power of natural language processing and advanced retrieval techniques to turn your complex document collections into a powerful question and answer system. So let's take a look at the code behind this app. This app will allow users to ask questions about a collection of PDFs and get answers directly from the documents using the power of natural language processing. Now, first, let's create a virtual environment. Now, in the terminal, let's type the command for setting up the Conda environment in your editor. For that, let's type Conda create -p. Let's type VENV Python and its version give equal to 3.10-y. Okay, let's enter. In this command, the -p VENV specifies the path and the environment name, while -y skips the prompts for a smoother install. Now, while that's setting up, let's create a few essential files. So, let's activate your new environment with the command conda activate VENV and /. So as you can see, our environment is ready. Now let's import libraries. So let's start by importing the libraries we will need. In the first line, we will import Streamlit as st. This gives us access to all the functionalities of the Streamlit for building our web app interface. So next, we will import OS for various operating systems functionalities. After that, now we will import libraries from LangChain, which is a framework for building NLP pipelines. So we will use these for tasks like text splitting, for document chain creation, prompting, retrieval, and more. So we will explain each library in detail as we use them. So let's type from LangChain_group import chat group, that is GROQ. And next, we will type from LangChain.textSplitter import recursive character text splitter. So let's type recursive character text splitter. Again, let us type from LangChain.chains.combine documents import create staff documents chain. Again, from LangChain core.prompts, let's import create_retrieval chain. Next, import FAIS, import FAISS, FAIS from LangChain community.vector stores. So this will help us to create a vector index for efficient document retrieval. So let us type from LangChain_community.vector stores import FAISS. Similar imports will follow for other functionalities like document loading and generating embedding, but we will introduce them as they appear in the code. But before this, go to the Group Cloud website and on your left you have API key option. So select and create your API key and copy this, and if you want to check your model, then go to the playground and at the top right corner click on the llama model and check. There are so many of them, latest also. So choose your model and generate your free API. Now go to the terminal and paste it in .env file using variable group API key. Now again go to the Gemini AI Studio. On your right you have the create API option. So select your model and create your API key now. Now copy the key and paste it into your environment variable, that is the .env file, using a variable Google_API key and paste it here. Now we will load environment variables from a .env file that will securely store our API keys. So for that, use .env to achieve this. Let's type from .env import load_.env. Also, let's type load_.env function. Next, we use OS to retrieve the Grok API key and Google API key from the environment variables.getEnv. So let us type Grok GROQ_API_key equal to os.getEnv, and inside the function let's type it as GROQ_API key, and inside the single quote let us type GROQ API key. And in the next line, let us type os.environ and inside the bracket under double quotes, let us type Google _ API _ key and equal to os.get env, and inside the function under the double quotes, let us type Google _ API _ key. So here these keys are the required to use specific NLP services. Now let us write code for displaying app title and images. So for that, load your image. Since I am using Edureka image name edureka.png along with the app title Edureka document question and answer, we will use st.image and st.title for this purpose. So for that, let us type st.image. So inside the double quotes, let us keep the image name and comma width is equal to 200. And let us also keep the title. So for that, st.title and let us type Edureka document question and answers. Now the next step is to initialize chat group and prompt template. Now it's time to interact with the LangChain group API. So initialize the chat group object using group API key and specify the Llama 3 8B8192, which is the language model we will be using for our NLP task. So for that, let us type LLM equal to chat group and inside the bracket give the group _ API _ key equal to group _ API _ key, comma, we will give the model name as well. So for that, type model name equal to and inside the double quotes give the model name. So here we are using Llama 3 -8B -8192. Alright. Now let us define a prompt template using chat prompt template. So this template ensures that AI responses are based on the context provided and user questions. So keeping answers accurate and concise. So for that, we will type prompt equal to chat prompt template dot from template. And inside the bracket, let us paste the prompt. So here we have the prompt which says, please answer the question strictly based on the provided context. Also, ensure the response is accurate, concise, and directly addresses the question. Now, let's create function for embedding vectors. For that, let's define vector embedding function. So type def vector _ embedding function and give colon. Next, in the next line, give if and under the double quotes give vectors not in st.session state colon, then type st.session _ state dot embeddings equal to Google Generative AI embeddings. Give equal to Google Generative AI embeddings, AI caps. And inside the bracket, give the model equal to and inside the double quotes, let us type models / embedding -001. Now, make a folder where you will load your PDF. So I am creating ed_pdf and paste your PDF here. Now set the sessions. So that is, let us type st.session _ state.loader equal to py_pdf directory loader. Here inside the double quotes, let us paste the path of the PDF. Next is the data ingestion. For that, let us type st.session _ state.docs equal to st.session _ state.loader.load function. So this particular line of code is for data ingestion and here this particular line is for document loading. Next, let us type st.session _ state.text splitter and give equal to recursive character text splitter. And inside the bracket, let us give chunk _ size and mention the size here. I'll give equal to 1000 and comma chunk _ overlap is equal to 200. Now here, these are for the chunk creation. Now let us type st.session _ state.final _ documents equal to st.session _ state.final _ documents. And inside the bracket, let us give chunk _ size and mention the size here. I'll give equal to 1000 and comma chunk _ overlap is equal to 200. Now here, these are for the chunk creation. Now let us type st.session _ state.final _ documents st.session underscore state dot text splitter dot split underscore documents. Now inside the bracket, let us give st.session underscore state dot docs. Let us give bracket colon 20. So this line of code is for splitting. Now let us type st.session underscore state dot vectors equal to VAEs dot from documents. And inside the bracket, let us again type st.session underscore state dot final documents, comma, type st.session underscore state dot embeddings. Okay, so this line of code is for vector OpenAI embeddings. Now to input field for question, let us type prompt 1. So give prompt 1 equal to st.text underscore input, and let us type here, enter your questions from any document. Now to create a button to load embeddings, let us type if st.button, and inside the function let us give under the double quotes load Edureka db, give colon, and in the next line let us type vector underscore embedding function. Next type st.success, and the message would be Edureka db is ready for queries. If the question is asked, then if prompt 1 is true, then type document underscore chain equal to create underscore staff underscore document chain, and inside the bracket let us give LLM comma prompt. And in the next line to retrieve, let us type a retriever equal to st.session underscore state dot vectors dot as underscore retriever function. And in the next line, let us type retrieval underscore chain equal to create underscore retrieval underscore chain, and inside the bracket, let us give retriever comma document chain. Now to measure response time, let us type start equal to time dot process underscore time function. So for response, type response equal to retrieval underscore chain dot invoke, and inside the bracket give input prompt 1. And in the next line, let us type response underscore time equal to time dot process underscore time function hyphen start. Next, let us write code to display the response. So for that, let us type st dot markdown, and inside the bracket, let us keep it as AI response. Now, in the next line, let us type st.success, and inside the bracket, give response and give answer inside the single quotes. And in the next line, write st.write. Let us type f inside the bracket, and inside the flower bracket, let us type as response underscore time colon 2f and seconds. Now moving on, let us write the code to display similar documents in an expander. So for that, let us type with st.expander. Inside the bracket under double quotes, type document similarity search results and give colon. And in the next line, let us type st.markdown, and inside the bracket, let us type it as below are the most relevant document chunks. So type below are the most relevant document chunks. Give colon inside the bracket, close the double quotes, and come to next line. Here let us type for I, comma, doc in enumerate, and inside the function give response.get context. Now in the next line, let us type st.markdown, and inside the bracket give f, and let us give the HTML tag, which is div class is equal to card, and open the p tag, and inside the p tag let us give doc.page underscore content, and now close the p tag. Now let us close the div tag as well. Now let us come outside the triple quote and give comma and type unsafe underscore allow underscore HTML equal to true. So you can also add inline styles and HTML tags and also icons and emojis to make your application fabulous for the user. Now it's time for testing. For that, open your terminal and write streamlit run and give your file name. So once you enter, and there we go. Here's our document question and answer loader. Now select the question from the PDF you have loaded in the file and ask your loader. So as you can see, this is my PDF. So I'm going to copy some question from here. So let me just copy this. Okay, once copied, so I'm going to paste it here. So I'm going to click on the load Edureka DB. So guys, as you can see, it provides an answer in context given in the PDF. So this is our answer that it has generated. So that's all. We have used simple Python code and LangChain techniques of RAG and some inline HTML and styles.
This is something I was going through recently and I found it so interesting that I wanted to share it with you. Now most of y'all must have heard of ChatGPT, the super trending AI text generator that generates responses based on user prompts. This technology was developed by a company called as OpenAI, and along with ChatGPT, they released a few APIs that are super convenient to use in your code. You can find these models if you search for openai.com/API/pricing. Once you're in this page, if you scroll down a bit, you will be able to see a section called as Language Models. Now this section has a collection of base models that you can directly use in your code. There are currently 4 options available, which is Ada, Babbage, Curie, and DaVinci. Now each of these models has slightly better capabilities than the previous one, and depending on these capabilities, prices can also differ. Now the Ada model, which is the least capable out of these 4, has the fastest response time, and DaVinci is the most capable while being the slowest out of all these options. Now coming to the pricing, you can see that the prices are mentioned per 1000 tokens. So what is tokens? You can think of tokens as words, and like it is mentioned over here, 1000 tokens is approximately 750 words. You will be charged based on how many tokens you use in your program. If you want to look at the differences, then there is a separate page for that too. Over here, you can see the details, capabilities, and restrictions of each of these models. All these models are developed on the GPT-3 models, and the DaVinci model, which is the most capable, has a max request limit of 4000 tokens, and the training data was taken up to June of 2021. The Curie model is slightly less capable than the DaVinci model, but it is faster and costs way less than DaVinci. It has a max limit of 2048 tokens, and you can also see that it was trained only until October of 2019. The Babbage model is another option which is capable of straightforward tasks and is very fast while giving your answers at a fraction of the cost. And the Ada model is super fast while being restricted to very simple tasks. Now, just because the capabilities differ doesn't really mean that the Ada is worse than DaVinci. It all depends on your use case. If your use case is very simple and straightforward, you would be better off using Ada or Babbage. And if you have some complex mathematical tasks, then you can use a text generator like DaVinci. While using these models in code, you will also have to insert some parameters. Based on this parameter, the prices can also heavily differ. To use the OpenAI APIs, you will first need to head over to openai.com. Once you are in here, you will find an option called as API on the top. Click on that and then log into your account. If you don't have an account yet, then I highly recommend that you make one. Now once you log into OpenAI, you will find yourself in a web page similar to this. What you need to do right now is head over to your account and then click on View API Keys. Once you're here, click on this button that says create new secret key. Once this key has been generated, make sure that you copy this key. Let's just name this key as OpenAI.API key. Now before we execute this code, we will need to install a library called as OpenAI. So let's just do that by using the pip command. As you can see, I have already installed OpenAI in my system, but if you haven't already, then this command will install OpenAI library in your system. Once that is done, you can get rid of that cell and import the OpenAI library into your code. Now let's run this. Yes, your key needs to be passed as a string. Now let's run it again, and you can see that it has executed successfully. Now let's define a simple prompt. We'll say variable prompt is equal to, and then a message. Let me just type, "Hi, how are you today?" Now this will be our prompt. Now that we have access to OpenAI and we have defined our prompt, the only thing left is to generate a response. Now to generate the response, let's start by typing variable response equal to OpenAI.completion.create. Now this is the function that you use to generate responses. Inside the create method, we will start defining our parameters. The first parameter that we are going to define is the type of engine that we will use. So you can just type engine equal to, and then you can specify the model that you will use. If you want the details of the models, you will find it over here. These are the models that you can use in your code. Let's first start with the ADA model. The next parameter that you will need to specify is your prompt. This parameter will be passed to your model to generate a response. Since tokens are expensive, it's best practice to set a max limit to your tokens. You can do this by typing the max tokens parameter and setting a value for it. Let me just set it to 50. And one more interesting parameter is the number of responses that you want to generate. So we can set it as n equal to 1. This will tell the model to generate only one response. Another interesting parameter is the temperature parameter. This parameter will tell the model how flexible it can be with the response. This value can be anywhere between 0 and 1. A temperature of 1 will make the generated response quite formal, while a value of 0.1 will keep the response extremely creative. Keep in mind that lesser temperatures can also make your responses factually incorrect. And when I say 1, it will show 1. When I say 0, it will show 0. And then 0.1. For now, let's keep the temperature value at 0.5. With this, we have generated the response. To view this response, you will just need to write one more line of code. This can be done by using the print function and then typing response.choices. Now, choices is a list of generated response. Since we have set n as 1, we'll be getting only one output. So our response's choice index is 0. We also need to see the text format of the response. So we type .text at the end. Once we execute this code, you can see that our model has generated a response. You can also change the model or the number of responses if you don't find the answer satisfactory. And now you can see that our response is more friendly. So guys, this is how we use OpenAI API in Python.
What is Agentic AI? Agentic AI denotes artificial intelligence systems capable of autonomously executing actions to attain designated objectives. Unlike reactive AI, which only responds to the inputs, Agentic AI is proactive, capable of planning, adapting, and making decisions autonomously. So let's explore deep into Agentic AI and see its capabilities. Agentic AI is a type of artificial intelligence that exhibits autonomous behavior, enabling it to take actions and operate without continuous human guidance. It is goal-driven, actively working towards achieving specific objectives rather than passively responding to inputs like reactive AI. And with advanced decision-making capabilities, it can evaluate multiple options, select the optimal course of action based on current conditions and acquired knowledge, and adapt its strategies dynamically in response to unforeseen changes in its environment. Moreover, Agentic AI demonstrates proactiveness by taking the initiative to act rather than waiting for external triggers, making it highly effective in dynamic and complex scenarios. Now, let us see its relevance in the current AI market. When AI systems can act autonomously to accomplish predefined objectives, we call that Agentic AI, making it highly relevant in the current AI market. Its autonomy allows it to operate without continuous human guidance, making decisions and adapting dynamically to achieve objectives. This capability is complemented by its advanced problem-solving skills, enabling it to evaluate complex situations, strategize, and respond effectively to challenges. However, the growing adoption of Agentic AI also raises important ethical considerations, such as ensuring responsible behavior, minimizing unintended consequences, and maintaining transparency in its decision-making processes. Now that you know about Agentic AI, so let us discuss how it differs from other AI systems. Agentic AI differs significantly from other AI systems in its autonomy, decision-making, and adaptability to achieve long-term goals. Unlike reactive AI, which performs predefined tasks only when prompted, such as spam filters or image classifiers, Agentic AI takes the initiative and operates independently. It also contrasts with the generative AI, which focuses on creating content like ChatGPT generating text, but it is not goal-driven. By combining autonomous behavior, strategic decision-making, and the ability to adapt dynamically, Agentic AI stands out as a powerful system designed to achieve specific objectives in evolving environments. Now, since we know a bit of differences, let us see the comparison between generative AI and Agentic AI. Generative AI and Agentic AI differ in several key aspects that define their functionality and applications. Generative AI is primarily focused on creation, excelling in output-focused tasks such as generating text, images, or other form of content. Its adaptability is limited as it relies heavily on prompts for guidance and lacks the ability to operate independently. In contrast, Agentic AI emphasizes autonomy, making it goal-driven and capable of dynamically adapting to changing environments. Unlike the prompt-dependent nature of generative AI, Agentic AI is self-directed, enabling it to take the initiative and execute strategic tasks effectively. These differences highlight the complementary roles of both AI types in addressing distinct challenges. Now, let us see the impact of Agentic AI on various industries. Agentic AI has had a profound impact across various industries, transforming operations and solving long-standing challenges. Autonomous logistics systems such as those in Amazon warehouses have significantly improved operational efficiency by 30 to 40%. In healthcare, AI-enabled surgical robots like the Da Vinci system have performed over 10 million less invasive procedures worldwide, enhancing precision and patient outcomes. Scientific advancements have also been transformed by systems like DeepMind's AlphaFold, which successfully solved the decades-old protein folding problem. On a global scale, the World Economic Forum predicts that by 2025, AI will displace 85 million jobs while creating 97 million new ones, reshaping the labor market. And in the energy sector, AI-powered smart grids can reduce electricity waste by up to 10%, promoting greener energy solutions. Additionally, over 90 countries are investing in AI-enabled military technology to modernize their defense systems, showcasing the strategic importance of Agentic AI in global security. Now, let us see the applications of Agentic AI. Agentic AI is transforming various industries by enabling systems to make autonomous decisions, adapt to changing environments, and achieve specific goals. Autonomous vehicle powers self-driving cars and drones to navigate roads, avoid obstacles, and make real-time decisions, as seen with Tesla Autopilot and autonomous delivery drones. In robotics, Agentic AI allows industries, healthcare, and exploration robots to perform complex tasks independently, as demonstrated by Boston Dynamics robots used in logistics and rescue operations. Personalized virtual assistants like Google Assistant and Amazon Alexa leverage Agentic AI to predict user needs, manage schedules, and execute tasks without direct commands. And in gaming, adaptive AI agents enhance the experience by creating challenging, human-like opponents, such as AlphaGo and AI bots in the real-time strategy games. In healthcare, Agentic AI supports personalized treatments, accurate diagnostics, and surgical assistance with examples including AI-driven surgical robots and systems for remote patient monitoring. These applications demonstrate the transformative potential of agentic AI across diverse domains. Agentic AI is making a significant impact across various industries by enabling autonomy, adaptability, and efficiency in diverse applications. In finance, it powers algorithmic trading systems and fraud detection tools, optimizing financial operations such as managing investment portfolios and identifying fraudulent activities. In smart cities, AI systems manage energy consumptions, optimize traffic flow, and enhance public safety with examples like smart traffic lights adapting in real time and autonomous energy grid optimization. In space exploration, autonomous spacecraft and planetary rovers such as NASA's Mars rovers perform exploration tasks independently. In education, AI-powered tutors like Carnegie Learning provide personalized instruction by adapting to individual learning styles. In military and defense, autonomous drones and surveillance systems improve situational awareness and decision-making, such as AI-driven surveillance drones in defense applications. Now, let us see the challenges and risks associated with agentic AI. While agentic AI offers tremendous potential, it also faces several challenges and risks that must be addressed to ensure its safety and ethical deployment. So one key concern is misalignment with human goals, where AI systems may pursue objectives that conflict with human intentions due to poorly defined parameters or unintended consequences, such as autonomous robot prioritizing efficiency over safety. Ethical questions arise regarding accountability and decision-making, demonstrated by the challenge of determining who is responsible when an autonomous vehicle causes an accident. The complexity of decision-making in agentic AI can also lead to a lack of transparency, making it difficult to understand or explain its actions, particularly in sensitive fields like healthcare or finance. Ensuring safety and reliability is another challenge, as AI systems must operate effectively in unpredictable environments, such as autonomous drones encountering extreme weather or medical failures. Additionally, agentic AI systems often require substantial computational resources, making their deployment costly as seen in advanced robotics and self-driving cars. Security vulnerabilities pose further risk, as autonomous systems could be targeted by cyber attacks, potentially leading to harmful consequences like the manipulation of autonomous vehicles. Lastly, overdependence on AI may reduce human oversight or lead to skill degradation in critical areas, such as relying too heavily on autonomous systems for medical diagnosis without human validation. These challenges highlight the need for robust design, rigorous testing, and ethical frameworks to mitigate risk and maximize the benefits of agentic AI. Now, let's see the future of agentic AI. The future of agentic AI is said to be transformative, with advancements across various domains influencing its deployment. Future systems will exhibit increased autonomy and adaptability, enabling them to make complex decisions in real time and operate effectively in dynamic environments without human intervention. The integration of agentic AI with advanced technologies like quantum computing, IoT, the edge computing will further enhance its capabilities, allowing for faster decision-making and real-time processing at the edge. These systems will have the widespread applications in sectors such as healthcare, where they will enable autonomous medical diagnostics, personalized treatment plans, and robotic surgery. Climate action with advanced systems for environmental monitoring and response, and space exploration, where smart rovers and spacecraft will carry out missions on their own. As these technologies evolve, ethical concerns and accountability will need to be addressed, promoting the development of regulatory frameworks to ensure responsive AI usage. Additionally, agentic AI will foster human-AI collaboration, enhancing productivity and creativity in the fields such as education, engineering, and research.
Imagine asking ChatGPT for a poem and it writes one instantly. Now think about an AI assistant planning your entire day, booking meetings, and even handling emails without your constant input. That's the difference between generative AI, which creates content, and agentic AI, which acts with autonomy, making decisions. In 2025, as AI becomes more than just a tool, understanding this shift is very critical. Are we heading towards just smarter chatbots or truly independent digital agents? Let's break it down through this video. Let's see the key differences between generative AI and agentic AI. Generative AI and agentic AI serve different purposes, each with unique strengths and applications. The key distinction comes down to creativity versus decision making. As previously discussed, generative AI focuses on producing content, whether it's text, image, or code. It enhances creativity by assisting writers, designers, and developers. But it lacks true autonomy. It only works when prompted and doesn't make any decision on its own. Agentic AI, on the other hand, is designed for interactions and execution. Instead of just generating responses, it can analyze situations, make decisions, and take actions. While it may not create content like generative AI, it can manage workflows, automate tasks, and adapt to real-world conditions. Another key difference is user dependency. Generative AI is entirely reactive, meaning it requires human input to function. It waits for prompts before generating anything. In contrast, agentic AI is proactive. It can initiate actions independently, setting reminders, optimizing schedules, or even solving problems without human intervention. The applications of these AI types also differ. Generative AI is widely used in content creating, marketing, entertaining, and software development. And agentic AI powers autonomous systems like self-driving cars, AI-powered customer service, and personal assistant that can handle complex workflows. Both AI types are transforming the industries, but when they work together, they unlock even greater potential. Imagine an AI that not only generates a marketing campaign, but also launches it, tracks engagement, and refines the strategy automatically. The future isn't just about choosing between generative AI and agentic AI. It's about combining them two to build truly intelligent systems. Now that we understand the key differences between these two, let's explore the future of AI by asking, will generative AI be replaced? As AI continues to evolve, one big question arises. Will agentic AI replace generative AI? Right now, generative AI is everywhere, helping people write, design, and code faster than ever before. But it has one major limitation. It relies entirely on human input. Agentic AI, on the other hand, takes things further. It doesn't just generate, it decides, plans, and even acts. It's the next step towards the true autonomous intelligence. Does that mean generative AI will be obsolete? Not necessarily. The future of AI isn't about one replacing the other. It's about coexisting. Generative AI will keep getting more creative and even sophisticated, producing even higher quality content. Agentic AI will become even more autonomous, integrating deeper with industries like healthcare, finance, and robotics. But this shift does come with some risk. As AI takes on decision-making power, we face new challenges, ethical concerns, unintended consequences, and the need for accountability. If an AI agent makes a bad decision, who is responsible? And how do we ensure it aligns with the human values? The answer lies in balance. The real future of AI is hybrid approach, where generative AI fuels creativity and agentic AI drives intelligent action. Imagine an AI system that not only writes a research paper, but also submits it to journals, responds to reviews, and refines it automatically. And this is where we are headed. Not just smarter AI, but AI that truly works with us as both a creator and an agent. The question isn't whether agentic AI will replace generative AI. It's how we'll harness both to shape the future of intelligence. Now that we have explored the differences between generative AI and agentic AI, let's move on to building an intelligent AI agent that can interact with our database using natural language. This means you can simply ask a question like, show me all the students who have scored above 80, and the agent will automatically convert it into an SQL query, fetch the data, and return the exact result from the database. No need to write complex SQL queries manually. Just ask and the AI responds. Let's dive in and build this powerful system. First, we need to set up a Conda environment to manage our project dependency. To do this, we open the terminal and run the following command. We'll write conda create -p vnv python equals to 3.10 -y. So, Conda creates a new Conda environment, and -p-vnv specify the environment path as vnv. Python equals to 3.10 installs Python version 3.10 inside the environment, and -y automatically confirms the installation without asking for approval. Once the process is complete, our virtual environment is ready, and we can move forward with setting up our Agentic AI project.
Next, we'll create a file named requirements.txt, where we'll list all the necessary libraries for our project. This will help us easily install dependencies in one go. Additionally, we'll create a .nv file to securely store our Google Generative AI API key, keeping sensitive information separate from our main code. With these files in place, we ensure a well-structured and organized setup for our Agentic AI project. First, we will work with SQLite, a lightweight self-contained database engine to create and manage a student database. Let's break it down step by step. So we'll create a file named sql.py and import the SQLite 3 module, which allows us to work with SQLite databases. We'll write import SQLite 3. This module provides all the necessary functions to create a database, insert records, retrieve data, and manage connections. Next, we create a connection to an SQLite database file named student.db. We'll write connection equals to SQLite3.connect, connection equals to SQLite3.connect, in the bracket, in double inverted comma, student.db. If this file doesn't exist, SQLite will automatically create it. The connection object will allow us to interact with the database. Now, we create a cursor object, which is used to execute SQL commands in Python. We'll write cursor equals to connection.cursor. Think of the cursor as a tool that helps us send queries to the database and retrieve results. Now, we define a SQL command to create a table named student with 4 columns. We'll write table_info equals to triple inverted commas. Next, we'll create a table. For that, we'll write create table, then student. We'll write in the bracket name type varchar, and we'll have 25 characters, comma class type varchar, and the same 25 characters, comma section type varchar with 25 characters, and marks type integer. Then we'll write cursor.execute in the bracket table_info. The name stores the student's name string up to 25 characters. The class stores the class's name. And the section stores the section of the student. And lastly, the mark stores the marks obtained as integer. Executing this command creates the table in the database. Next, we insert 5 student records into the student table using SQL insert statements. I've already created and inserted 5 values in the table. You can create as much as you can. Each insert command adds a new role with the student's name, class, section, and marks. Now we retrieve and display all records from the student table. For that, we'll have to write print in the bracket the inserted records are. In the next line, we'll write data equals to cursor.executed in the bracket 3 single inverted comma select star from student, closing the inverted commas in the bracket. Then we'll write for row in data colon print in the bracket row. The select star from student query fetches all the data from the table. The for loop iterates through the records and prints them one by one. And finally, we commit our changes and close the database connection. For that, we'll write connection.commit and then connection.close. The .commit function ensures all the changes are saved in the database. The .close closes the connection, freeing up the system resources. And that's it. We have successfully created a student database, inserted records, and retrieved them using SQLite and Python. Now, let's build an interactive Streamlit app that converts natural language questions into SQL queries using Google's Gemini model. It then retrieves data from an SQLite database and displays the result. Let's break it down step by step. But before we start, we have to activate the environment. For that, we'll write activate venv /. And here our environment is activated. First, we'll create a file named app.py and load environment variables using .env. For that, we'll write from .env, we'll import load_.env. Next, we'll write load_.env. It will load all environment variables. This ensures that sensitive information such as API keys is securely stored and accessed. Next, we import the necessary modules. For that, we'll write import Streamlit as st, then import OS, then import SQLite 3, and then import google.generative AI as GenAI. Streamlit here powers the web interface. OS helps access the environment variables. SQLite 3 allows us to interact with the database, and Google Generative AI enables the conversion of natural language into SQL queries. Now, we configure the Google Gemini API key. But before that, we'll have to create an API key through Google Studio itself. I've already generated one. You can create yours through Google Studio itself. Then we'll write genai.configure in the bracket API_key equals to os.getEnv, and in another bracket Google_API_key. This allows the app to use Gemini 1.5 Pro to generate SQL queries. Then we define a function to generate SQL queries from natural language input using GemAI. For that, we'll write def get_Gemini_response in the bracket question, prompt. Next, we'll write model equals to GenAI, generative model. In the bracket, we'll write models / Gemini version 1.5 Pro. Then we'll write response equals to model.generate_content in the bracket and in square brackets prompt in the square bracket 0 and question, and then we'll write return response.text. The function initializes the Gemini model. It takes a question and predefined prompt as input, and the AI model generates an SQL query as output. Next, we define a function to execute SQL queries on the database and retrieve results. For that, we'll write def read_SQL_query in the bracket SQL, DB. Next, we'll write con equals to SQLite3.connect in the bracket DB. Then cur equals to con.cursor, and then cur equals to execute in the bracket SQL. Then we'll write rows equals to cur.fetchCall, then con.commit, and then con.close. And then we'll create a loop by writing for row in rows, and then we'll print it, and then return rows. The function connects to the student.db database. It executes the given SQL query, and it fetches all the retrieved records and prints them. Now, we define the AI prompt that instructs Gemini on how to convert the questions into SQL queries. As you can see, I've already created a prompt for my own, and you can create yours according to how you want your model to function. If you want the prompt which I've used over here, you can just comment on the video and I'll send it to you. This prompt ensures the Gemini AI generates SQL queries accurately without unnecessary text. Now, we'll set page configuration with a title and icon. For that, we'll write st.set_page_configuration in the bracket page_title equals to SQL query generator, Edureka, page_icon. Then we'll display the Edureka logo and header. For that, we'll write st.image in the bracket 123.png, width equals to, let's keep it as 200. st.markdown in the bracket logo plus Edureka's Gemini app / your AI powered SQL assistant. Next, we'll write st.markdown, then the logo, and ask any questions, and I'll generate the SQL query for you. The page title and the icon are set. A logo is displayed at the top, and the app's purpose is to introduce to the user. And before we import the logo, just make sure that you have the logo in your folder. We take user input for a natural language query. For that, we'll write question equals to st.text_input in the bracket enter your query in plain English, key equals to input. This allows users to type their questions, such as show all students with marks above 80. A submit button triggers the SQL generation process, and for that we'll write submit equals to st.button in the bracket generate SQL query. When clicked, the app processes the query and retrieves the result. Now, we define what happens when the submit button is clicked. For that, we'll write
If submit, in the next line, response equals to get underscore Gemini underscore response, in the bracket, question comma prompt. This is to convert the question to SQL. And then we'll print the response. Then we'll write response equals to read underscore SQL underscore query, in the bracket, response comma student.db, and this is to execute SQL on the database. Then we'll write st.subheader, in the bracket, the response is brackets closed. Next, we'll include a loop for, then row in response. Then we'll write st.subheader, in the bracket, the response is, and then we'll include a loop for row in response. Then we'll print row, and then st.header, and in the brackets, row. The user's question is converted into an SQL query using Gemini AI. The SQL query is executed on the StudentDB database, and the retrieve records are displayed on the Streamlit app. And that's it. The AI-powered Streamlit app allows users to ask natural language questions, which are automatically converted into SQL queries and executed on a student database. Now, let's open the terminal and run our Streamlit app. To do this, we simply type streamlit run app.py and hit enter. It's running, and as you can see, our Agentic AI is up and running, ready to interact with our database. Let's test it by asking a simple question. We'll ask, give me the names of all the students. The AI processes our request, converts it into an SQL query, and retrieves the student names from the database. Perfect. As you can see, the response is generated. Now, let's try another query. We'll say, give me the average of marks. And just like that, the AI calculates and returns the average marks. The response which is provided is 72.2. So in this video, we successfully built an Agentic AI that can understand natural language, generate SQL queries, and interact with our data seamlessly.
Midjourney is a generative AI tool that turns your text description into stunning images. Now, let's see how IT industry can use Midjourney. Users can generate mockups with simple text prompts and visualize idea before the development. Marketers can create eye-catching visuals for their campaign, test multiple concepts, and quickly personalize content for their targeted audience. Midjourney even helps create illustrations, build fictional worlds, visualize data for content creator, and help them go beyond. Midjourney is a game changer, streamlining design, marketing, and content creation within the IT industry. Before we go and explore it, let's see some of its products. A realistic portrait of a woman holding a white cat, an anime-like character with powerful effect, drawing of an ideal scenery, and cinematic view of soldier in middle of war. Let's see why use Midjourney. I would just say 3 points. It's easy to use, boost creativity, explore different style, and find the one you like. So, to get started, let's see how to sign up for Midjourney. Go into your favorite search browser, then go to search bar and type Midjourney. Let's go ahead and click enter. So, we'll see the Midjourney's official website. Go ahead and click on that. There, you'll see a landing page that will look something like this. To join Midjourney, we'll go ahead and click on join the beta. After clicking this will take us to their Discord invite. For this, you have to have one Discord account. Since we have already created one, we'll go ahead and just sign into it. As soon as you join, you will see something like this. Midjourney's icon you will find on the left hand side of your screen that will look something like a sailing boat. Now to go ahead, we'll just scroll down and join any of the newbie channels. There, you can see so many creation of so many people. This is an open channel. Anyone can come and write a prompt. They'll get their image generated right over here. But in this, you'll lose your image as soon as you create it because there's so much content over here. So to go ahead and add Midjourney bot to your server or directly message it, we have to go on left hand side and click on symbol that will look something like this. Here, you can see Midjourney bot. Right click on it. There, you can see the profile. Click on profile. It will open a menu like this. If you click on send message, it will directly take you to the Midjourney bot. There, you can message directly and get your results. So, let's go ahead and see our information. To do that, we have to type /info, then just hit enter. Here, we can see user ID, our subscription, and even the fast time remaining. Here we can see how many images we have created and fast images that has been generated by Midjourney. To go ahead and join Midjourney bot to a personal server, we have to create a server first. Let's go ahead and create a server. On the left hand side of your screen, you can see something like this. Click on it. Then you can select create my own. You can choose for me and my friends and go ahead and name it. For now, we'll name it Edureka server 3. We'll go ahead and create. Here, we have landed on our page. Now, to add bot to a server, we will just go ahead and click over here. We can see Midjourney bot. When you click on it, you can see an option of add app. Click on it and then you can choose a server you want to add it to. We'll go ahead and choose Edureka server 3. Then click continue. After that, you would have to select the permission you want to give Midjourney bot. Then go ahead and authorize it. Here we got success. After adding Midjourney bot to your server, you can see a message like this. Let's go ahead and click on Edureka server 3. So we'll go to Edureka server. We can see the Midjourney bot has landed. Let's go ahead and create a first image. To do that, we would have to type in /imagine. Then hit enter. Here you can see a prompt like option. Now, following prompt, you have to give the description of the image you want. For now, we'll go ahead and type this. A bustling city street in modern era. Let's go and see what does Midjourney generates. So the image has been generated. Let's go ahead and click on it to get a better view. The images will be generated in the grid of 4 in order 1, 2, 3 and 4. Below the generated image, you can see multiple options like this with U and V, where the number would correspond to the image. Here we can see a reroll button that will look something like this. The U stands for upscaling and the V stands for vary. If you like an image, for instance, I like the image 2, we'll go ahead and click U2. As we can see, the image has been generated. This is the exact image that I have selected, the second number. If you like it, you can just go ahead and download it. To do that, click on Open Browser. You can zoom in, zoom out to get a better view and right click on it to save it. We'll go ahead and save it as image. Just click on save and it will be downloaded to your disk. Let's go back to our Discord. Here, below the image, we can see multiple options again, but this time the options are different. Here we can see upscale subtle and upscale creative. Both are used to upscale the current image, but in a different manner. It will slightly upscale your image, whereas creative will change something in the image. Vary. Vary has multiple options, subtle and strong. Strong will generate a totally different image, but with similar reference. Whereas vary region, if in the image you want to change something, you can select it by the region and then change it. We will dive into that later. So let's go ahead and see zoom out. There's an option of zoom out 2, zoom out 1.5 and custom zoom out. If you want to zoom out, you can click on any of these, and if you want to customize your zoom, you can click on this. We'll dive into that later. Moving ahead, we can see multiple arrows pointing in different directions. What does this mean? Let me tell you. If you click on the arrow, it will pan out the image in the direction which the arrow is pointing. If the arrow is pointing left, the image will pan out on the left side. If the arrow is pointing at right, the image will pan out on the right side. Similarly, on the top and the bottom. Now, let's go ahead and test out our zoom. We'll click on zoom out 2.0 and see what it generates. The image has been generated. We'll go ahead and click into it. To get a better view, we'll upscale all of these. This is our original image. Let's go ahead and see our zoomed out images. In our fourth image, these parts have been added, which were originally not here. In our third image, we can see a different scenario over here. There's a zebra crossing, whereas in fourth image, it is not. In every scenario, we can see a different vehicle or a different building. Nothing has changed from the original image, but to zoom out, it had to create new objects that we can see. Now, let's go ahead and see pan out. To go to our original image, we can click on this and it will take us to our original image. Now, let's go ahead and see pan out. Now, I want to see what's up there in that image. To do that, we'd have to click on pan out with top arrow. We'd go ahead and do that. It will give us a prompt window. Now, you can choose what you want. As we are talking about sky, we can have moon or sun over there, or a plane flying. Let's go ahead and do a sun in cloudy weather. And click on submit. As we can see in our newly generated images, there is sun, there are clouds, and even both of them. Now, to create perfect prompt, you need to use proper keywords and even give description as much as you can. For that, we'll go ahead and generate this image in painting format. To do that, we'll type /imagine and then prompt. Our prompt will be same as previous one, and we have just added oil painting. Now let's go ahead and hit enter. Here, the Midjourney has used vibrant color in oil painting. All the images look stunning. Now we'll see some of its advanced feature. One of those was released recently by Midjourney, that was Describe. Describe feature of Midjourney allows you to use an image to get its prompt. You can use the prompt to generate new images similar to that one. For that, we'll go ahead and type /describe. Now there are two options, image and link. You can go ahead and click on image to upload image from your system. If you go ahead and click on link, you can provide link from anywhere that can be used by Midjourney to generate description for that image. For now, we'll go ahead and click on image. You can either drag or drop your picture, or you can go ahead and select it. Now, I have selected the image. Just go ahead and hit enter. As a reply to your image, Midjourney bot will generate several of its prompts that can be used to generate images similar to that one. Scrolling down, you can generate any of the images based on the prompt number given. Or you can imagine them all. Let's go ahead and imagine all. Here we can see all the images generated by all 4 prompts. Those are similar to the one we had given. Now let's go ahead and talk about settings in the Midjourney. To check those, type setting. Here we can select the model that we want for our Midjourney and so many other, like style is. Style is low, medium or high. Controls the amount of Midjourney's creative influence on our pictures. Next is public mode. Public mode allows your picture to be seen in Midjourney's public collection. Then comes the remix mode. Remix mode allows you to give extra prompt during variation in image. If you have turned it off, it won't ask you for prompt again, just vary your current image based on its prompt. Then there is variation mode. When we choose variation, it will go ahead and check our preferences, either it is low or high. Based on that, it will give us a varied image. Then we have different modes: relax mode, fast mode and turbo mode. All these 3 modes define the speed at which Midjourney will generate your images. For relax mode, it will generate very slow. But for fast mode, it will use your fast hours but will generate faster. And for turbo mode, your results would be instant but consume more fast hours. You can click on reset setting and set your setting to default. At last, raw mode. Raw mode accesses a more literal interpretation of your prompt. Now, let's go ahead and design some logos. I have chosen logo for a bakery. Here, the Midjourney has given us some amazing logos. We can select any one of those and use it our own. Now, let's go ahead and explore different parameters that Midjourney allows. For starters, we'd use a new prompt. To add a parameter, we just need to add / followed by the parameter. For the first parameter, we would select aspect ratio. Now, aspect ratio is the ratio between height and width of an image. Let's go ahead and type in 16:9 and hit enter. Now, as we can see, the aspect ratio of the image has changed from the previous ones. Those images were in square and this is a widescreen image. Now, let's go ahead and discuss a different prompt, that is negative prompt. For that, we'll go ahead and type the same prompt. You can add multiple parameters in a single prompt. For negative prompting, you use no and followed by the object you want to remove. We want to remove clouds. We'll type in clouds and hit enter. The clouds have been removed from our original image. Here, cloud, cloud and cloud. Even here. But in our newly generated images, there are no clouds because it has taken a unique approach of making our dolphin underwater. So let's go ahead and check out the parameter that controls imagination of a Midjourney. That is stylus. Now we'll go ahead and type in same prompt. For stylus, the range is from 1 to 1000, and to use stylus, we would type single S followed by the value we want to, 0 being the lowest and 1000 being the highest. We would go and type in 1000 and see the result. This is a fine result and it is stunning. I am amazed. Moving to another parameter, chaos. Higher value of this parameter lead to unexpected and unique outcomes. So let's go ahead and try it. With the chaos value 1, we get results something like this. Now let's move to using reference images to create our own images. For that, we need to go ahead and upload one of our photos. So let's go upload a file. I'm going to use this picture. We'll go ahead and open in browser. Copy its link. For our next one, we would go ahead and type imagine. Paste the copied link. Then type the prompt we want to. Near a lake with rocky mountain and cloudy sky. Here are our generated images. Now let's go ahead and see another parameter, image weight. It controls the weight of referenced image on our newly generated image. Values ranging from 0 to 2, 0 being the lowest and 2 being the highest. Image weight parameter is given by IW and value I have given as 0. Let's hit enter. With the image weight being 0, the reference has not been taken into consideration. Now let's try it with value 2. Our reference image is the first priority and the prompt is second. With that, let's see how to create stock images. To create stock images, we need to use words like realistic and describe as much as we can in that image. Photography of adult Caucasian female wearing a white shirt and black tie, smiling cross-handed. Studio shot, cinematic look, clean background and white background. Adding all these, now we'll just hit enter. You can see there are multiple keywords that represent stock image. So here are generated images. Let's go ahead and upscale first one. It's a stock image. It's a real looking. Let's create a second stock image in a group. Photo of a diverse team. Remember the keyword photo. Photo of a diverse team celebrating a successful project in a co-working space. Let's hit enter. We'll go ahead and upscale the fourth image. It's a stock image, definitely one. With that, we'll conclude our video and now I'll show you in Midjourney how you can use. When you enter Midjourney website, you can see collection of photos like this that has been generated by multiple Midjourney users. So, you can find all your generated images in archive. You can see all of these images right over here. You can join the rooms, those are based on themes, or read the images as you like. Midjourney has recently introduced Midjourney's Web Creation Alpha that allows you to create images on the web. This is currently available only for the users those have created more than 100 images already. You can type your prompt directly here without giving any command like /imagine or anything. Let's just go ahead and type shark in mechanical suit. Now our image is being generated in Create. We'll go ahead and check it out. These are the images of shark in mechanical suit. You can even vary both of these, subtle or strong, or you can use rerun button to re-roll the images. You can even see the prompt that you have given for previously generated images by you.
What if you could create personalized eye-catching ads in minutes instead of hours? Or generate dynamic content that speaks directly to your audience no matter where they are? Sounds like the future, right? But the future is now. Take Starbucks for instance. They are using generative AI to tailor marketing messages based on customer preferences and behaviors, creating personal and relevant campaigns. Sephora has jumped on board too, with AI-driven product recommendations that engage customers in a way that feels like they are speaking to a personal beauty advisor. In this video, we are diving into how generative AI is not just improving marketing campaigns, it's transforming them, making them smarter, more efficient, and more impactful. From targeted emails to hyper-personalized ads, AI is changing the game. So, want to know how? Stick with us to learn how your brand can ride the AI wave and boost engagement like never before. So, let's get started. Now, without any further delay, let us get started with the generative AI use case. So, for this use case, I have used the popular company Amazon, and we will see how Amazon uses generative AI. Amazon started as an online bookstore and has since become a global leader in e-commerce, cloud computing, streaming, and artificial intelligence. The Everything Store is among the big 5 United States tech companies, along with Alphabet, Apple, Meta, and Microsoft. But what if I told you that Amazon has also faced challenges because of its extensive reviews make it difficult for customers to extract insights, restricting decisions and satisfaction? Now, let me tell you in details what challenges they faced. First is in terms of the volume and diversity of reviews. With approximately 1.5 billion reviews and ratings contributed annually, distilling meaningful information from such a large and diverse dataset is complex. Next, due to its identifying common themes. Manually summarizing prevalent sentiments and frequency mentioned product features across numerous reviews is impractical. Next is the maintaining authenticity. Ensuring that summaries accurately reflect genuine customer opinions without introducing bias or misrepresentations is crucial. And to address these challenges, Amazon explored advanced technologies capable of processing and summarizing extensive textual data. Generative AI emerged as a promising solution due to its ability to analyze large datasets and generate coherent summaries. The company sought tools that could efficiently process vast amounts of review data, then identify and extract common themes and sentiments, then generate concise summaries that are both informative and reflective of authentic customer opinions. Now let us see what are the tools implemented. Amazon implemented a generative AI-powered features designed to analyze customer reviews and produce concise summaries. This AI model was trained to evaluate the frequency and context of specific product features mentioned in reviews. Then, assess customer sentiment associated with these features and generate a brief paragraph highlighting key insights, which is displayed directly on the product detail page. And the solution is, the AI-generated review highlights provide customers with a concise overview of common themes and sentiments expressed in reviews. For example, a customer interested in a product's ease of use can quickly see if this aspect is frequently praised or criticized. Additionally, customers can tap on specific product attributes to view all reviews mentioning those features, allowing for a more targeted and efficient review reading experience. And this implementation not only streamlines the decision-making process for shoppers, but also enhances their confidence in purchasing by providing quick access to relevant insights. By leveraging generative AI, Amazon has improved the accessibility and utility of customer reviews, ultimately contributing to a more satisfying shopping experience. But why do we need generative AI to enhance marketing campaigns? Well, generative AI enhances marketing campaigns by improving personalization, automating creative tasks, and optimizing targeting strategies. It saves time, boosts engagement, and ensures higher ROI by creating tailored content, streamlining workflows, and delivering data-driven insights. But what exactly is generative AI? Generative AI is a subset of artificial intelligence that focuses on creating new content or idea rather than simply analyzing existing data. Unlike other types of AI that rely on pre-programmed rules or patterns, generative AI uses algorithms to learn from data and generate new outputs. This technology is often used in tasks such as image generation, task generation, and even music composition. But how has AI impacted marketing? AI is transforming the marketing industries partly because of its vast applications. AI tools can automate routine tasks, freeing up valuable time and allowing you to focus your efforts on strategizing. But task automation is just one example of AI use cases in marketing. AI improves you to analyze vast amounts of data, better to understand your target audience, consumer preferences, and behaviors. You can use this data to predict customer behavior, optimize campaigns in real time, and deliver highly personalized content to mold an exceptional customer experience. Beyond analytics and reporting, generative AI tools can support content creation. And this dual impact of enhanced personalization and increased efficiency is transforming business decisions and how brands engage with customers. Now let us see what will happen to marketing in the age of AI. First, let us discuss about the hyper-personalization in marketing. AI helps businesses analyze vast amount of data to understand customer behavior, preferences, and needs. This allows for personalized marketing strategies such as targeted ads, tailored messages based on browsing history, purchase patterns, and demographics. Next is the dynamic content, such as emails, websites, or app interfaces that adapts in real time for each user. Then comes the customer segmentation, identifying specific groups of users for highly relevant marketing efforts. Next is the enhanced efficiency through automation. AI automates repetitive marketing tasks such as ad placements and binding. AI tools optimize budgets by selecting where and when to display ads for maximum ROI. Next is the email campaigns. Tools like MailChimp use AI to determine the best time and content to engage users. Next is the chatbots. AI-powered assistants provide instant, round-the-clock customer support and can upsell or cross-sell products. Next, AI as a creative partner. AI tools like ChatGPT, DALL-E, and Midjourney assist in creative tasks, writing engaging ad copy or scripts, designing visuals or creating mockups, and producing ideas for campaigns based on data insights. Next, let us talk about the ethical and privacy challenges. AI in marketing comes with the risk and responsibilities, such as data privacy, where companies must handle consumer data ethically, adhering to regulations like GDPR. Next is the bias in AI. AI might perpetuate biases if trained on biased datasets. Next is the transparency. Marketers must ensure AI-driven decisions are clear to consumers. Next, let us see the future implications. First is the emotion AI. Tools that analyze emotions via facial expressions or voice to tailor experiences. Next is the voice search and assistance. AI like Alexa and Google Assistants impact SEO and product discovery. Next is the customer-centric focus. Despite AI, brands must remain authentic and human in their storytelling to build trust. Now, let us see the benefits of generative AI for digital marketing. Well, generative AI offers several benefits for digital marketing. So, let us see what are the benefits. Generative AI is transforming digital marketing by improving efficiency and personalization. It automates tasks like content creation, enabling businesses to produce high-quality content at scale while saving time and resources. By analyzing customer data, AI tailors marketing messages and offers increasing engagement and conversion rates through personalized interactions. Additionally, generative AI enhances creativity and customer experiences. It helps businesses explore innovative strategies and solutions, such as new marketing approaches or product ideas. AI-powered tools like chatbots also deliver engaging, interactive support, ensuring better customer satisfaction and stronger connections. Now, let us have a look at the impact of generative AI on SEO and search marketing. Generative AI is transforming SEO and search marketing by analyzing SERPs to uncover patterns and optimize website elements like meta tags and content. This enhances search engine ranking, driving more organic traffic. AI also generates high-quality, keyword-rich content based on search data, improving visibility and engagement. In addition, generative AI automates landing page creation for SEM campaigns by analyzing campaigns data and optimizing for conversions. This streamlines marketing efforts, increases efficiency, and ensures businesses attract and retain more visitors effectively. The future of generative AI in digital marketing is promising. So let us see how. Generative AI is shaping the future of digital marketing by enhancing voice assistants and chatbots to make interactions more natural. It also plays a key role in predictive analytics, helping businesses make informed decisions based on the data insights. These advancements can improve customer experience, optimize marketing strategies, and predict market trends. Moreover, generative AI can transformize user-generated content by allowing users to create richer, more diverse media such as videos and virtual reality, helping brands build stronger and more engaging communities. What skills do you need to succeed in generative AI? Here's a breakdown of the key technical skills that are essential. First, we have programming skills. Mastery of programming languages like Python is a must. Python is particularly popular in AI due to its versatile and the availability of libraries like TensorFlow and PyTorch. Next, machine learning expertise. You should have a strong understanding of machine learning concepts and algorithms. Familiarity with different machine learning frameworks is also beneficial. Next, data handling skills. Comfort in working with large datasets is crucial. This includes data cleaning, pre-processing, and visualization. Next, deep learning knowledge. Understanding neural networks, convolutional networks, and recurrent networks is vital, as generative AI heavily relies on these concepts. Next, mathematics and statistics. A solid foundation in linear algebra, calculus, and statistics will help you understand how algorithms work and optimize them effectively. Finally, creativity and critical thinking. Don't forget the importance of creativity. Being able to think outside the box will enable you to come up with innovative solutions in generative AI. By building these skills, you will not only prepare for technical challenges but also become a valuable asset in the job market. Now, if you are eager to jump into generative AI, here's a roadmap based on what I have learned along the way. First, start with the basics. Let's kick things off by building a strong foundation in AI. I recommend Edureka's AI certification course as a great starting point. In this course, you will get hands-on with core tools like Python and data handling, plus set up basic AI tools like the OS module and NLTK for natural language processing. These essentials gives you a solid base for a more advanced AI skills. Next, get certified. Certifications really help you stand out and make sure you are covering industry-relevant topics. A few key ones to consider are the Responsible AI certification, where you will dive into the ethical AI and tools for fairness like IBM's AI Fairness 360. Next, the Prompt Engineering course. If you're interested in making AI chats more intuitive with optimized prompts using OpenAI's APIs. These certifications build your skills while highlighting your knowledge to potential employers. Next, gain hands-on experience. Next up is a real-world practice, which is a must. Edureka's Mastering Generative AI Tools course is a great option here. You will learn popular tools like TensorFlow and PyTorch and work on projects like image synthesis and text generation. This gives you the confidence to apply AI in real-world scenarios. Networking is super valuable in AI. It opens doors and keeps you updated. Through Edureka's ChatGPT training course, you get more than just skills. You connect with other AI learners and share insights. Plus, you will work with tools like OpenAI API and learn to build customer support bots, which is a great asset. Next, specialize yourself. To stand out, consider specializing in a specific area. Here are some courses to consider. First, AI for software developers, which is focused on using GitHub Copilot and deploying models with AWS. Next,
AI in retail. This one covers personalized recommendations and other retail-focused AI solutions using TensorFlow recommenders and Google's Vertex AI. Next, GitHub Copilot training. Learn how to use this AI-powered coding assistant for enhanced productivity. Now, let us move on to the job opportunities in generative AI. As you prepare, consider these various roles you can pursue in generative AI. First, we have AI research scientist. Specializes in advancing AI technology by developing new methodologies and exploring cutting-edge innovations. Next, AI product manager. Manages the development of AI-driven products, ensuring they meet user needs and align with business objectives. Next, NLP engineer. Focuses on natural language processing, enhancing human-computer interaction through language-based technologies. Next, AI solutions architect. Designs AI-based solutions tailored to address specific organizational goals and challenges. Next, AI ethics researcher. Investigates the ethical implications of AI technologies, ensuring responsible and fair AI development. Next, AI consultant. Provides expert guidance to businesses on effectively implementing and utilizing AI strategies for growth. Now, let's talk about a question that's on many people's minds. Is generative AI taking over jobs, or is it just reshaping them? The answer to the question is no, it's not eating our jobs. Instead, generative AI is reshaping jobs by automating repetitive tasks in areas like customer service, design, and content creation. While it handles routine work, jobs that require creativity, emotional intelligence, and complex decision-making remain secure as AI struggles with all these complex tasks. Generative AI boosts productivity as a partner, helping us focus on strategy and creativity. Let's learn what Nvidia is all about. Nvidia is a multinational technology company that specializes in graphics processing units and other products for gaming, automotive, data center, and professional visualization markets. Nvidia's role as a leader in AI and graphics technology features its iconic headquarters and cutting-edge hardware products like the RTX and series GPUs. Nvidia's innovations are transforming industries from gaming to AI, making it a key player in the tech advancement. Their commitment to powerful processing and AI solutions is reflected in both their infrastructure and product lineup. Well, Gen Z started their journey with Nvidia's gaming experience by powering popular titles with advanced graphics and AI technology. As you see, Nvidia's GPUs are often used to optimize these games, enhancing visual quality and performance, which creates a seamless and stunning visual experience for players. For Gen Z who played games and used PCs containing Nvidia elements, the company is like a friend to them. So, let's see what the news is all about Nvidia. Nvidia recently announced several key advancements, including the launch of its large language model cloud services to accelerate AI applications across industries. The NeMo LLM service empowers developers to customize large models, while the BioNeMo service is specifically designed for biological and genetic predictions. Additionally, a new NeMo framework has been introduced to improve training efficiency for large language models, and the powerful H200 supercomputer is set to enhance LLM training capabilities, further positioning Nvidia as a leader in AI innovation. These announcements position Nvidia as a top innovator in AI infrastructure. So now, let's explore one of their global collaborations. 2025 predictions, AI finds a reason to tap industry data lakes. Every industry, every company, every country must produce a new industrial revolution, says Nvidia CEO Jensen Huang at the AI Summit in Japan. Now, let's look at what Nvidia exactly achieved. Nvidia's next-generation AI hardware, Hopper and Blackwell, offers unmatching performance, enabling faster training of complex models. Now, let's look closer at what makes Hopper a game-changer in AI processing. The Hopper chip, built with 80 billion transistors and manufactured with the TSMC's 4nm process, delivers unprecedented processing power and high clock speeds. It is specifically designed to accelerate large language models and generative AI. And
The Blackwell chip containing 104 billion transistors and a peak performance of 1.4 exaflops is equipped with 30 TB of high bandwidth memory, making it ideal for handling large AI workloads. Moving forward, let's discuss Nvidia's software innovations in large language models. Nvidia has launched NeMo LLM, a framework that supports diverse NLP tasks, and BioNeMo LLM, which specializes in biological and genetic research. Together, they bring AI's power to life science. Now, let's discuss the first model, that is NeMo LLM. Nvidia's NeMo LLM, powered by the RT-LLM engine, is a robust 12 billion parameter model with a 128,000 token context window, enabling optimized performance for diverse NLP tasks. Transitioning to life science, BioNeMo is transforming the field with its unique capabilities. Nvidia offers a diverse range of AI models on its website, likely under nvidia.build. You can explore these models and their capabilities. Now, let's take NeMo AI demo as an example. On the NeMo AI website, you will find information about how to interact with the model through APIs, potentially using OpenAI standards, and a temperature setting to control its creativity. You can even input code like cout, hello world in Python, and the model will translate it into different programming languages, showcasing its capabilities. The second model is BioNeMo LLM for biological research. It is trained on molecular, protein, and DNA data. BioNeMo LLM accelerates drug discovery and advances genetic research, driving breakthroughs in biology. Now, let's see the BioNeMo impact on science. BioNeMo is a breakthrough tool tailored for biological data, revealing hidden patterns that could revolutionize drug discovery. Now, let's move on to the BioNeMo's research applications. BioNeMo identifies complex biological relationships, transforming genetics research and advancing research through collaborative human-AI insights. BioNeMo analyzes protein and DNA sequences to fuel new scientific insights, enabling researchers to uncover critical discoveries faster. So, following the above news, let's see what happened in AI Summit in India. At the Nvidia's AI Summit India, CEO Jensen Huang shared his vision for AI's potential in India. He highlighted the country's promising future in AI innovation supported by Nvidia's technology. He stated the world's digital future will be written in AI and India has a lead role. Jensen Huang and Mukesh Ambani discussed India's potential as a global AI hub. Huang envisions AI-enabled super employees driving future advancements. He stated AI will amplify human capabilities and create super employees of the future. Nvidia's global reach connects innovators and leaders worldwide. With 306.995 trillion metrics of computational power, Nvidia leads the AI revolution. Nvidia's ongoing innovations in AI hardware and software are reshaping industries and pushing the limits of what's possible. And with this, we have come to the end of this video on Nvidia's breakthrough in AI chips. I hope you enjoyed about Nvidia and its new advancements through this video. Did a Chinese AI model just shake up the entire US market? Let me tell you what happened. On January 27, 2025, the stock market took a serious hit. Tech stocks dropped hard, and the biggest shock was that the Nvidia, a prominent player in the AI hardware sector, saw its stock crash by 17%. And that's a $590 billion loss in a market value. And it was because of an AI model called DeepSeek R1. Yes, you heard that right. A Chinese AI model just sent shockwaves through the industry, raising big concerns about China's growing AI dominance and what it means for companies like OpenAI, Google, and even Nvidia. So why is DeepSeek R1 such a big deal? Well, it's not just another AI model. It's a game changer. And with models like DeepSeek R1, DeepSeek V2, and DeepSeek Coder, and it's going head-to-head with the top players like OpenAI and Google, offering powerful AI at the fraction of the cost. Here, I have added a screenshot for your reference, and this table compares the large language models based on their accuracy and calibration error. And among the models mentioned, DeepSeek R1 has the highest accuracy with 9.4%, outperforming O1 with 9.1%, Gemini Thinking with 6.2%, and other models such as GPT-4o with 3.3% and Group 2 with 3.8%. Furthermore, DeepSeek R1 has the lowest calibration error with 81.8%, indicating improved confidence calibration over other models with errors greater than 88%. This demonstrates that DeepSeek R1 not only produces the most accurate results but also has a higher forecast reliability. And this benchmark graph will show the DeepSeek R1's expectational performance across a variety of evaluation tasks, solidifying its position as a top-tier LLM. Notably, DeepSeek R1 achieves the highest scores in AI ME 2024 with 79.8%, Codeforces with 96.3%, Math 500 with 97.3%, and MMLU with 90.8%, indicating superior reasoning, problem solving, and coding skills. When compared to OpenAI's O1 models and DeepSeek V3, DeepSeek R1 consistently outperforms or equals top models, particularly in domains requiring precise logical reasoning and mathematical skills. Furthermore, its high Sweben's verified score is 49.2% demonstrates its suitability for software engineering applications, and this finding supports DeepSeek's R1's advancements in AI research, establishing it as a formidable competitor in the LLM space. First, let's talk about DeepSeek R1.0 and its successor DeepSeek R1. So let's break it down. In reinforcement learning, there are two main components, the agent and the environment. The agent interacts with the environment, and based on its actions, it receives rewards or penalties. The goal of the agent is to maximize these rewards by learning from its mistakes and improving over time. Now, let's talk about the DeepSeek R1.0. This model was a pioneering attempt to use reinforcement learning without supervised fine-tuning. And the idea was to let the model learn entirely through interaction with its environment without any pre-labeled data. However, this approach had some challenges. DeepSeek R1.0 faced two major issues. First is the poor readability. The model's outputs were often hard to understand. And next, the language mixing with Chinese. The model sometimes mixed languages, especially Chinese, which affected its performance in English tasks. And to address these issues, the team introduced DeepSeek R1. This new model not only solved the problems of readability and language mixing, but also achieved remarkable performance. In fact, DeepSeek R1 matched the accuracy of OpenAI's GPT-O1 model, especially the OpenAI 01217 model on reasoning tasks. That's a huge milestone. But that's not all. DeepSeek R1 is also 24 to 28 times cheaper to train compared to other state-of-the-art models. And this makes it not only highly effective but also cost-efficient, opening up new possibilities for research and applications. So, to recap, here we have. The DeepSeek R1.0 was an ambitious attempt to reinforcement learning without supervised fine-tuning, but it faced challenges with readability and language mixing. DeepSeek R1 addressed these issues, achieving top-tier accuracy and being significantly most cost-effective. Now, as far as GPT is concerned, ChatGPT combines unsupervised learning, supervised fine-tuning, and RLHF, making it more aligned for text-based reasoning and safe AI interactions. Now, we will look at the model comparison. DeepSeek and GPT are both pushing the boundaries of what AI can do, but they take a very different approaches. So let's break it down. We asked the GPT-O1 model and DeepSeek R1 model to generate a Python code where a ball bounces inside a rotating triangle. Sounds cool, right? Well, let's check out the result. First up, here's what GPT-O1 came up with. It works, but the physics seems a bit off, and the movement isn't as smooth as you would expect. Not bad, but it's not quite there yet. Now, let's look at what DeepSeek R1 generated. Wow, this one looks way better, right? The ball's movement feels more natural and the rotation of the triangle is much smoother. The overall gameplay experience is just more polished. So, if we compare the two, DeepSeek R1 definitely outperformed GPT-O1 in this challenge. Of course, both models are impressive in their own ways, but when it comes to designing this specific game, DeepSeek R1 takes the win. Now, we will distinguish the differences in detail. So first, let's talk about the architecture. DeepSeek uses a mixture of experts design. Think of it like a team of specialists. Only the relevant experts are activated for each task. So for example, DeepSeek V3 has 671 billion parameters, but only 37 billion are activated per token, making it super efficient. And on the other hand, GPT model uses a dense transformer architecture where all the parameters are active at once. GPT-4, for instance, has 175 billion parameters, all working simultaneously. And this makes GPT powerful but also computationally expensive. Now, let's talk about cost and efficiency. DeepSeek is a game changer here. It was developed on the budget of just $5.5 million due to its efficient MOE design. And that's a fraction of what other models cost. GPT models like GPT-4 requires massive computational resources. Training GPT-4 cost over $100 billion, making it a heavyweight in terms of both performance and expense. And when it comes to performance, both models shine in different areas. DeepSeek is a powerhouse in tasks like coding, translation, and solving complex math problems. And in fact, DeepSeek R1 has been shown to match the performance of advanced systems from OpenAI and Google despite its smaller budget. GPT models like GPT-4 are known for their natural language understanding, creative writing, and complex reasoning. And they are incredibly versatile and can handle a wide range of tasks with ease. Next, accessibility is another key difference. DeepSeek is an open source, meaning its code is available to the public. And this promotes transparency, collaboration, and innovation within the AI community. GPT models, on the other hand, are primarily proprietary. While OpenAI has released some tools and models, many advanced versions are restricted and accessed through APIs. Finally, let's talk about the ethics and censorship. DeepSeek implements strict content moderation, especially for politically sensitive topics. This ensures compliance with regulatory standards but can sometimes limit its responses. GPT models also have moderation mechanisms to prevent harmful outputs, but they strive to balance open access to information with ethical guidelines. Now, we will install the DeepSeek R1 and run a short demo on it. So let's see how the DeepSeek R1 model can be installed. First, let's open up our browser and head over to the ollama.com. And once you're there, you will see a download button. So go ahead and click on that. Now, select download for Windows to start the download. And keep in mind, it's a pretty big file, so it might take a minute to download. So let's give it some time. Once the download finishes, go to the download folder and find the installation file. Now here, double click on the file to open the installation window and you will see an install button. So simply click on that and Ollama will start installing on your system. So once Ollama is installed, let's head back to the Ollama website. Now click on the models tab at the top of the page and here you will see a list of available models. And for this video, we are going to use the DeepSeek R1 model. So we will select the 1.5B model, but if you want, you can also choose the latest 7B model too. Now, once you have selected the model, you will find the installation command here. So go ahead and copy that command. Now, open your terminal on your Windows system and paste the command we copied earlier. So this is the command and this command will start pulling the model. So depending on your internet speed, this might take a little time, so be patient. And that's it. Once the process is done, your DeepSeek R1 model will be all set up and ready to use on your system. Alright, now let's try out some commands here. So let's say hello. Okay, we got some response here. Now, let's ask it to tell something about himself. Alright, so it responded saying that I am DeepSeek R1 and AI assistant. Next, let's ask it to design a Python code to list all the files in a directory. So as you can see, it has provided up the code we asked for. Great, right? So what does all of this means for the future of AI? Well, AI is becoming more accessible. Like for years, AI development was mostly controlled by big companies with massive budgets. But now, with open source models like DeepSeek R1, anyone, whether you have a small startup or you are an independent developer or a student, you can build AI solutions without paying huge API fees. This means faster adoption and innovation worldwide. Next, the global AI race is heating up. The AI race between the United States and China is getting even more competitive. While the United States tries to limit AI chip exports, China is finding ways to keep up. No matter which side you support, one thing is clear. AI is evolving rapidly and staying informed is more important than ever. Next, AI is becoming more sustainable. Training AI models consume massive amounts of energy. But with advancements in optimization, we are seeing a shift towards more efficient and eco-friendly AI. This means lower CO2 emissions and a reduced environmental impact, something that was once a major concern in AI development. Next, career opportunities are growing. And if you're a developer, AI engineer, or a data scientist, this is your moment. Companies will need skilled professionals to build and deploy AI solutions at a faster pace than ever. So if you have been thinking about getting into AI, now is the time to start. Well, DeepSeek is making big moves, but can it really compete with OpenAI in long run? Which one do you think will dominate the future of AI? So let me know your thoughts in the comments below. Did Alibaba just do the impossible? Their latest AI model has outperformed both GPT-4 and DeepSeek in some key benchmarks. But how did they manage to do it? And what does this mean for the AI race? Stick around as we dive into the shocking details behind this breakthrough and what it means for the future of AI. Alibaba just dropped a bombshell during the Lunar New Year, a new AI model called Qwen 2.5 Max. And they say it outperforms OpenAI's GPT-4o, Meta's Llama, and even China's own rising star, DeepSeek. Is this the new benchmark in AI? Let's break it down. First off, what exactly is Qwen 2.5 Max? Developed by Alibaba Cloud, this model is being hyped as a major rival to GPT-4o. According to their benchmarks, it crashes competitors in reasoning, coding, and multilingual tasks. So let's look at the numbers. In Arena Hard, a benchmark for complex problem solving, Qwen 2.5 Max scored 85.3%, beating GPT-4o's 80.2% and DeepSeek's V3's 77.5%. But here's the twist. It's not just about the raw power. Alibaba built this model for businesses. Think customer service bots that speak 10 languages, or AI coders that debug Python faster than your engineering team. And unlike OpenAI's premium pricing, Alibaba's offering Qwen 2.5 Max at a fraction of the cost. But why drop this during the Lunar New Year, when half of the China's on vacation? Well, that's where the discussion begins. Meet DeepSeek, the 20-month-old startup that's been shaking up Silicon Valley. 3 weeks ago, they dropped DeepSeek V3 and the R1 model. And the secret is insanely low cost. We are talking $0.14 million per tokens. That's like charging pennies for a Lamborghini. DeepSeek's cheap open source models triggered an AI price war in China. Alibaba reduced price by up to 97% overnight. But DeepSeek's founder, Yang, isn't sweating it. In a rare interview, he said, "We don't care about the price wars. AGI is our goal. AGI, that's Artificial General Intelligence. AI that can overthink humans." And here's the twist. DeepSeek isn't some corporate giants. They are a tiny team of grad students and researchers working out of Alibaba's hometown, Hangzhou. Meanwhile, Alibaba's got 200,000 employees. So, how does Qwen 2.5 Max actually stack up? Let's compare. First, let's talk about reasoning. Qwen takes the lead here. Next, when it comes to coding, Qwen continues to shine. And if multilingual support is what you're after, Qwen speaks Mandarin, English, Spanish, or whatever you name it. But DeepSeek V3 still holds the crown for affordability. And GPT-4o, it's holding on to its reputation. But even OpenAI's Sam Altman admitted DeepSeek's progress is impressive. But Alibaba's timing is strategic. Releasing Qwen 2.5 Max during Lunar New Year when everyone's distracted is a power move. It's like dropping a diss track on the Christmas day. No one's looking, but everyone will hear it. So, here's why this matters. DeepSeek's R1 model wiped $1 trillion of US tech stocks in a day. Nvidia, Meta, Microsoft all dropped. Why? Because if a tiny Chinese startup can match GPT-4 at 100 the cost, inventors wonder, Are we overspending on AI? And China's giant aren't sitting still. ByteDance updated its AI model days after DeepSeek's launch. Tencent and Baidu are in the price-cutting frenzy. Meanwhile, Alibaba's betting big on Qwen to dominate enterprise AI. Think hospitals, banks, and mega corporations. And the real question is, who's closer to AGI? DeepSeek's agile team or Alibaba's corporate powerhouse? Share your thoughts in the comments. So, is Qwen 2.5 Max the new AI champion? Maybe, but this isn't just about benchmarks. It's a glimpse into the future. A future where AI isn't just built by Silicon Valley giants, but by startups in Hangzhou and open source communities worldwide. A game-changing development has taken the tech world by surprise.
I think we should take the development out of China very, very seriously.
A free open source AI model emerged seamlessly out of nowhere. It not only matched but surpassed some of the most advanced systems on the market. What made this even more remarkable was its origin. It wasn't a new release from OpenAI, nor a breakthrough from Anthropic. It was a DeepSeek, an AI model developed in China. And its development left top AI researchers in the United States in amazement, especially when they learned about the staggering cost behind it.
It's opened a lot of eyes of what is actually happening in AI in China.
The training cost for DeepSeek version 3 was just $5.576 million. And in comparison, OpenAI spends a massive $5 billion annually. While Google's capital expenditures are projected to exceed $50 billion by 2024. Microsoft, on the other hand, invested over $13 billion just in OpenAI. And yet, DeepSeek's model outperformed these highly funded AI models from leading American companies. And the contrast is truly mind-blowing.
To see the DeepSeek new model, it's super impressive in terms of both how they have really effectively done an open source model that does what is this inference time compute, and it's super compute efficient.
DeepSeek didn't stop at the success of its powerful open source AI model. Instead, it quickly introduced R1, a next-generation reasoning model that has already surpassed the advanced OpenAI O1 model in several third-party benchmarks. This rapid innovation highlights DeepSeek's ability to surpass even the most well-funded United States AI giants, proving that agility and creativity can disrupt the established leaders in the race of the AI dominance. As we dive deeper into this, let's hear from Martin Veshev, the director of Bulgarian Institute for Computer Science, Artificial Intelligence and Technology. He recently made some interesting statements about the AI industry, and they are shaking things up. So he pointed out that a Chinese AI startup claimed to have developed its R1 LLM model with less than $6 million, while other companies are pouring in billions. That announcement alone caused Nvidia's stock to drop. And according to Martin, these models are built by strong researchers and engineers in the field, many of whom actively publish their work. But developing these AI models can be incredibly expensive. Just to give you an idea, running 2048 H800 GPUs could cost anywhere between $50 to $100 million. And he also mentioned that the company handling the data center is backed by a massive Chinese investment fund, with far more GPUs than just those 2048 H800 units. As for the architecture behind DeepSeek's R1 and V3 models, Martin explained that they use a mixture of experts, MOE approach. Simply put, this means that at any given time, only a small percentage of the model is active, making it much more efficient in real-time use. This raises a lot of questions about the cost efficiency, AI development strategies, and how companies are competing in this space. Now, the question is, if DeepSeek's development is being reported to have cost only $5 to $6 million, how does this figure align with the extensive infrastructure, data center operations, and substantial backing from Chinese investment funds? Could there be more to the story that isn't being disclosed? Let us know in the comment section below. As far as the research indicates, DeepSeek V3 has been utilized as the base model for DeepSeek R1. And this progression highlights DeepSeek's strategic approach to building on its existing architecture while pushing the boundaries of AI capabilities. DeepSeek R1 distinguishes itself by relying entirely on reinforcement learning fine-tuning, a focused and efficient method that contrasts sharply with OpenAI's GPT infrastructure.
OpenAI's GPT, Generative Pre-trained Transformer Framework, employs a combination of supervised learning, unsupervised learning, and reinforcement learning to train its models. While this multifaceted approach has proven effective, it also requires significant computational resources and time. In contrast, DeepSeek R1's exclusive use of reinforcement learning fine-tuning demonstrates a more streamlined and targeted methodology, which not only reduces cost but also enhances performance in specific tasks. This differences in training strategies highlights DeepSeek's remarkable ability to innovate efficiency. And by building on its foundational V3 model, it developed R1, a reasoning model that has already surpassed OpenAI's advanced systems in some key benchmarks. DeepSeek's focus on reinforcement learning has allowed it to carve out a unique position, directly challenging the dominance of United States AI giants. This approach demonstrates that with strategic, resource-conscious innovation, groundbreaking results are not only possible, but they are already happening. So what do you think? Does DeepSeek open source approach give it a long-term advantage? Or will OpenAI's heavy investment in research and proprietary models keep it ahead? Share your thoughts in the comments.
Let's explore the real-life rewards of generative AI. The first one is it automates and innovates the content generation. AI-driven tools create high-quality text, images, and videos, revolutionizing the content creation across the industry. It optimizes the product designs. AI enhances the product development by stimulating the refining designs, reducing cost and time to market. The next one is strengthens the cybersecurity efforts. AI detects and analyzes the threats against the cyber attacks. The next one is advances healthcare research. AI accelerates the drug discovery, medical imaging analysis, and personalized treatment plans, improving the patient's outcome. And the last one is drives digital transformation. AI integrates with businesses' system to automate the workflows, enhance the decision-making, and optimize the operational efficiency. So now let us look at some real-life examples. Recently, Walmart, in collaboration with Microsoft, announced a major AI-driven initiative. Walmart has partnered with Microsoft to integrate AI-powered solutions into retail operations. This collaboration aims to enhance both customer experience and employee efficiency by leveraging the advanced AI tools. So, what are the main benefits of AI-driven initiative? Here are some key points. The first one is personalized shopping experience. The next one is AI-powered associate support. The next one is content creation automation. Next on we have improved customer service. And last but not the least, operational efficiency. So this partnership showcases how AI is revolutionizing retail, making businesses smarter, faster, and more customer-centric. So now let's look at another exciting real-world application of AI, but this time it is the field of medicine. Scientists at Stanford had developed a tool called Synthemol, which is helping to create new antibiotics to fight drugs. This is a huge breakthrough because antibiotic resistance is a major global health challenge. So what has this AI tool achieved so far? Here are some key points. Scientists use Synthemol to design antibiotics that can fight resistant bacteria. It generated 25,000 possible antibiotics candidates, giving researchers a massive head start. It provided detailed recipes for making these drugs efficiently in the lab. Out of all candidates, scientists identified 6 compounds that actually work against the resistant bacteria. This technology isn't just limited to antibiotics, it's now being used to explore the treatments of heart disease and even fluorescent module design. So this is a game changer in medicine, providing that AI can do much more than just chatbots and automation. It can literally help to save a life. So now we have seen how AI is transforming the industry, but it also comes with an ethical challenges and risk. Let's take a look. One big issue is output quality. AI can produce incorrect or unreliable results. It can also generate made-up facts and hallucinations, creating false information. Another concern is biased output, where AI reflects biasness from its training data. There are also copyright and other legal risks. AI-generated content might violate the intellectual property laws. AI is also vulnerable to abuse, meaning it can be misused for misinformation and harmful purpose. Lastly, the cost of expertise and compute makes AI expensive and less accessible. These challenges highlight the need for responsible AI development. So now that we have seen the ethical challenges of generative AI, Let's look at some real-life examples where these risks have had significant impact. Recently, a report highlighted that DeepSeek's AI app is openly sending users' data from US to China. This has raised major concerns, especially in the light of past controversies surrounding the data security and privacy. This incident had drawn attention to ethical and security risk. This situation brings us several key challenges. The first one is data transmission to China. User data being directly sent raises concerns about the privacy and the control. The next one is lack of transparency. Users may not be fully aware of where their data is going and how it is being used. The next one is government scrutiny. Authorities may impose regulations or restrictions due to national security concerns. The next one is global backlash. Countries worldwide might be stricter against AI platforms handling the sensitive data. The next one is potential exploitation of third parties. There is a risk that collected data could be misused or shared with the other entities without consent. So now let's look at another major challenge, data leaks and their consequences. Recently, a report from Business Insider revealed that Amazon warned its employees not to share confidential data with ChatGPT. The concern arose after some AI-generated responses were found to closely match Amazon's internal information, highlighting the risk of sensitive data leaks. Such incidents bring several serious risks, for example, data privacy concern, intellectual property exposure, unintended data retention, regulatory compliance issues, and erosion of customer trust. So this case with Amazon is just one example of why companies must carefully manage the AI interaction to prevent the potential data leaks and security violations. So now let's look at another major risk of generative AI that's making headlines worldwide. That is deepfake. Deepfakes are one of the biggest risks of generative AI. AI-generated fake videos, audios, and images can be misused in dangerous ways. Scammers use them for fraud, identity theft, and misinformation, leading to financial losses and manipulations. Fake videos of public figures spread false narratives, while AI-generated explicit content violates the privacy. As deepfakes become more advanced, they are eroding trust in media and creating serious ethical challenges. While deepfakes highlights the dangers of generative AI, it's very important for us to focus on how we can develop and use AI ethically to minimize these risks. Ethical generative AI ensures that the technology benefits the society while preventing the harm. To achieve this, we must focus on key principles. The first one is transparency and accountability to ensure that the AI systems are open and responsible, bias and fairness to prevent the discrimination, privacy protection to safeguard the user data. Additionally, AI should prioritize avoiding harmful content and give users consent and control over how their data is used. By implementing these principles, we can build a future where generative AI is both powerful and ethical. So now that we have explored the ethical aspect of generative AI, let's look ahead and discuss what the future holds for the technology. The future of generative AI is filled with exciting possibilities. We can expect wider adoption across industries, transforming the field like healthcare, finance, and entertainment. AI will continue to enhance creativity and content generation, making it a valuable tool for artists, writers, and businesses. With the advancement, better customization will allow AI to generate more personalized experience. At the same time, human-AI collaboration will grow, enabling more seamless interaction. A key focus will be on responsible AI development, ensuring stronger ethical frameworks and regulations to create the safer and more trustworthy AI-driven future.
Before we dive into AI and culture, let's play a little game. I like games and I hope you do as well. So the name of the game is Guess the Title of the Movie. So I'm going to show you 4 different movie posters and your job is to guess the name of the movie. I hope that was clear, the instructions were clear. Guess the name of the movie as you see the posters. You can pause the screen and then go down to the comment section below and leave your answers there. So are you ready? 3, 2, 1. So I hope that you left your answers in the comments and I'm going to give you the titles, of course. So there they are on the screen. The point of this game is to see how many of you recognize the movies. And I think most of my viewers will at least recognize 2 out of the lot. Yeah, and all of these movies are based on artificial intelligence. And if you haven't watched any of these movies, I recommend that you find some time for them. They're mind-blowing. The Matrix is my personal favorite from the ones you see on the screen. But why did we play this game? Well, this is the easiest way to show you guys that people get excited when they hear the term AI thrown about because it is cool and it's everywhere and there's so much to talk about. People have so many different opinions and perspectives on the matter. So I think it is safe to agree that it's deeply embedded in not just the Western culture but cultures all over the world. Wouldn't it be cool to look at some of the factors or elements that led to such a widespread adoption of artificial intelligence in cultures? Well, first up, we're going to take a look at advancement in science. Movies like the one you see on the screen came out before World War One, and they inspired a whole generation of scientists who did some amazing work in the field of computer science and AI. So, what were the advancements that led to AI? The first computer was made in 1946 and was called ENIAC. It was enormous. It occupied a space of 50 by 30 foot, but could only do simple calculations. But the benefit was that it was reprogrammable. Following which in 1950, who is regarded as Alan Turing, who is regarded as the father of modern computer science, wrote in his paper how to build intelligent machines and how to test their intelligence. But as you know, computers weren't advanced to hold any instructions or data. But Turing's test for intelligence is still used today, over a half a century later. Isn't that amazing? Next, in 1956, at the Dartmouth Summer Research Project on Artificial Intelligence is where it all began. I mean, for artificial intelligence. As a matter of fact, this is where the term artificial intelligence was first used. From 1957 to 1974, AI flourished. It became the buzzword. And also, the computers could store more information, became faster, cheaper, and more accessible. Yet, they were too slow to exhibit any kind of intelligence. Remember the first movie and the game we played earlier? That came out in 1968. Since the computers were too slow and needed to catch up, the AI buzz started to quiet down. And that was until 1997 when IBM's supercomputer called Deep Blue beat Garry Kasparov at chess. And mind you, Gary was regarded as the grand master of chess. Here's a picture of Deep Blue on the right, so you get an idea of how compact the computers got by the year 1997. So I hope you had as much fun as I had by giving you a little bit of a history on AI. So this was the first element, advancement in science and technology, that influenced the culture around AI today. What's the second one? It is books and literature on AI. Literature can range from the ones that deal in facts, such as academic, scientific, or research papers, to the ones that are very imaginative and completely fictional, like comics. Inspired by the advancement in science and technology, written literature is where writers take the most complex and evolving ideas and present them in a way of stories so common folks can understand and relate to them. But the next element that we are about to see does this better than books, in my opinion: movies and television shows. Movies and TV shows have a wider audience than books. And like I said earlier, the right ones inspire the future scientists. And the advancements that they make inspire the next generation of movies. So it's like a cycle, you see. Let's move on to the next one. Different events such as conferences, seminars, webinars, trade shows and expos, awards and competitions, workshops, and others provided a platform to exchange ideas on artificial intelligence and connected like minded people. They range from highly academic events like the one we saw earlier, Dartmouth Summer Project on Artificial Intelligence, to things like Comic Con, where people attend as their favorite characters and meet movie stars. Next one is mainstream media like newspaper, news channels, and radio. Across the world, they have provided coverage on artificial intelligence and brought on experts to talk about it. The next one is normal everyday conversations. Yeah, if AI is going to be everywhere, then it will be part of everyday conversations. All of these different elements, and not to forget social media, have made AI incredibly famous in cultures across the world. But in the past few years, the buzz around AI is back, especially with companies like Amazon, Google, Facebook, Apple, Tesla, and two or three dozen research organizations making incredible progress in this field. So naturally, that will make you wonder, what is AI like right now? In this section, I have another surprise for you. But before we get to it, let's check out what are the different types of artificial intelligence. So there are three main categories of artificial intelligence: ANI, AGI, and ASI. So obviously the first thing that popped in your mind if you don't know about these categories is what are they? Well, let's briefly take a look. Artificial Narrow Intelligence is what ANI is. It is also known as weak intelligence. Artificial Narrow Intelligence refers to AI systems that can only perform a specific task on their own using human-like capabilities. They can learn from past experiences in regards to that specific task. Even the most complex AI that uses machine learning and deep learning to teach itself falls under ANI. This type of artificial intelligence represents all existing AI, including even the most complicated and capable AI that has ever been created to this date. Let me give you some examples. Google, Alexa, and Siri voice assistants use AI to detect speech and carry out commands. Today's security and surveillance systems uses facial recognition, which is a type of narrow AI. Social media platforms use it to learn about preferences and show you ads and content that you will enjoy. E-commerce websites like Amazon use it to learn about your shopping activities, where you are located, and so much more to recommend similar products. It also helps them figure out inventory for warehouses for different locations and their unbelievable two-day delivery. Banking and financial sector use it for fraud activity detection, loan approval, and so on. Last, but certainly not the least, autonomous vehicle use it to navigate the roads on their own. So I hope that you got a little bit of an idea of what ANI is. Let's move on to the second category, which is AGI, and it stands for Artificial General Intelligence, and it's also known as Strong AI. So you're probably wondering what it is. First, we talked about artificial narrow intelligence. Now we're talking about artificial general intelligence. Does it give you any idea? If you're thinking that this type of artificial intelligence is good at general tasks, meaning all tasks, instead of a specific task like we saw in the previous category, A and I, you would be right. So AGI will be able to better understand the humans it is interacting with by discerning their needs, emotions, beliefs, and thought processes. It will be able to learn things and apply a broad range of areas, just like human beings can, and unlike narrow artificial intelligence. Right now, AGI is the goal of the field of AI, a place where AI will become part of the physical world and will navigate it like we do. Quite a bit of leading AI researchers think we'll get there in a few decades. There's been a lot of research and development happening on AGI by organizations like OpenAI, DeepMind, Apprente, and many more. So I hope you got an idea about this one. Let's move on to the last type, which is ASI, and it stands for Artificial Super Intelligence. Judging by the name, super, you probably already got an idea that this will be the pinnacle of AI. ASI is where machines will become self-aware like us humans, and they will be overwhelmingly superior than humans at everything. That is, they will have greater memory, faster data processing and analysis, and decision-making capabilities. The potential of having such powerful machines at our disposal seems appealing, but these machines may also threaten our existence or, at the very least, our way of life. We don't have any examples of AI, thank God for that, because we aren't even ready for artificial general intelligence, the one before this one. Okay, let's switch gears and play a little game because the section after this is going to be a little tense. So let's disperse some tension before we get into dangers of AI. The name of the game is Guess the Type of AI. ANI, which is Artificial Narrow Intelligence, good at specific tasks. AGI is more like human capabilities, but it is not self-aware. And ASI, which is Artificial Superintelligence, which is where the machines become self-aware and get way better than human beings. So, I will put up a few pictures or videos and you will have to guess the type of AI. And if you want, you can comment your answers below. Let's see how many of you get them right. Sounds good? Okay, let's begin. First one here is an autonomous vehicle that can drive from point A to point B and even park itself without a human in it. If you guessed ANI, you'd be right. Second one is a Tesla bot. The robot will be able to perform basic repetitive tasks with the aim of eliminating the need for people to handle dangerous or boring work, like getting groceries from Walmart. If you guessed AGI, you wouldn't be completely wrong, but its capabilities will be limited, so it's A and I. These last ones are from Boston Dynamics. They've been making incredible strides in robots navigating the world. And personally, their robots give me the goosebumps. I mean, look at them move. But remember, even though they can navigate the world and obstacles around them, they are not able to understand the humans. So take that as a hint, if you will. So, any guesses? If you guessed AGI, again, you'd be wrong. The point of this game was to show you that everything that we have today is artificial narrow intelligence. All three examples that we saw were artificial narrow intelligence. But there are a lot of companies that are working on artificial general intelligence, and it is around the corner. So I wanted you guys to watch these two clips before we move on to the next section. Freaking goosebumps, right? I mean, imagine one day you go out for a stroll or a jog and you just see this thing just running loose. This is something from your worst nightmare. Robots taking over the world? That must make you wonder, what are the dangers of AI, doesn't it? Well, then let's talk about its dangers in this next section. So, what are the near to midterm dangers of AI? And when I say near to midterm, I mean from present day to 20 years in the future. Well, the first one we're going to take a look at is privacy. Imbalances of access to information has been exploited in the recent past and is probably being exploited as you watch this video. Let's see some of the examples to understand how everyone's privacy is always at stake. In 2018, news broke out that a data analytics firm, Cambridge Analytica, had analyzed the psychological and social behavior of users through Facebook's likes and targeted them with ad campaigns for the 2016 US presidential election. Now imagine being able to influence US presidential election. That is crazy. Second example is Clearview Face Recognition. Clearview is a company that created a face recognition system to help police officers identify criminals. They claimed that it only used publicly available images on social media platforms like Facebook, Instagram to identify criminals. But in January 2020, the New York Times reported that in a demo from Clearview, it scraped personal images from Instagram account of the show's producer. Next example is deepfake, and this is really concerning. Images and videos that are created using deep learning and contain a real person acting or saying things that they didn't do or say are called deepfakes. If you use it for entertainment purposes, deep fakes are fun. But people are creating deep fakes for fake news and information, and worse, deep fake porn. And the last example is mass surveillance in China. China uses over 200 million surveillance cameras and facial recognition to keep constant watch on their people and also mine their behavioral data captured on the cameras. China also implemented a social credit system to rate the trustworthiness of its citizens and give them ratings accordingly based on their surveillance. So on this system, if they rate higher, they get more benefits. And if they rate lower, well, you're out of luck. All of this was done without their knowledge or consent, and that is what is most concerning. As you can see, people's privacy is a big concern right now, and more so in the future years to come. Next one we are taking a look at is AI producing biases. Well, naturally you're going to say, Kevin, how does AI produce biases? Well, AI and machine learning models use parameters and the data it was trained with to make yes or no decisions. There have been many examples in which the parameters don't tell the full story, and the labeling of training data could be done with some sort of bias. So when AI is used for serious tasks like filtering job candidates, giving out loans, accepting or rejecting insurance requests, or even for medical diagnosis, it can have a tremendous impact on somebody's life. Here's just one for example. This image shows how one of these thermometer guns gets classified as a gun when it is held by a person of dark skin and as a monocular when it is held by a person of salmon or white skin. This happened in 2015 where Google's image recognition software made this bias. Now imagine something like this being used by law enforcement in real life scenarios. Ooh, I don't even want to think about that. The next one is centralization of AI. This danger deals with the fact that what if all the AI technological advancements always end up in the hands of a few people or groups? So we are already seeing this now to a certain degree. The amount of time that people spend on platforms like Facebook, Instagram, Twitter, YouTube is so ridiculous. And we're constantly giving data to these companies with each interaction. They all have gigantic oceans of data on their users, which along with their AI enables them to keep making advancement in technology, staying ahead of the curve and always on the top. But it is a very likely scenario that some of these companies will advance to extremely high-tech machines and the rest of the world wouldn't be able to keep up. Will they then become all-powerful like United States with atomic bombs in World War II? Or even worse, because AI can unlock a whole bunch of threats to humanity? Of course, there's this problem of rich getting richer. And also there's this issue of transparency where we don't know how much these organizations know about us and what they can do. Here's another scenario. What if one of these companies, just like in the movie Iron Man, where Tony Stark has his fancy high-tech AI-powered suits, and there's people that are always trying to steal it so that they can reverse engineer. And then there's bad people who want to use this technology to bring mayhem and destruction to the world. So it may not end up being that extreme, but it is entirely possible that these companies may have good motive and good intentions towards the world, but an entity with a bad intention can steal it and use it to cause harm to humanity. So centralization of AI in the hands of few people or group is a real threat. And we need to make sure that we always keep these threats in check. So the next danger is loss in jobs. It's also called AI dislocation. Use of AI in the workplace is expected to result in the elimination of large number of jobs. Though AI is expected to create and make better jobs, education and training will have a crucial role in preventing long-term unemployment. But initially, it will lead to a lot of lost jobs. It is a common misbelief that AI dislocation will only hold true for labor to semi-skilled jobs, but the truth of the matter is that it has already started displacing even high-skilled jobs that require master's and PhD degree. Let me give an example. One such job is consultants for companies to help them make decisions. They are being replaced by AI and machine learning softwares. Let's now talk a little bit about the long-term dangers. And by long-term, I mean 20 to 50 years into the future. So what's the first danger? Well, the first danger that we will talk about is safety and security. AI applications that are in physical contact with humans or integrated into human body could pose safety risks as they may be poorly designed and misused or hacked. Poorly regulated use of AI in weapons could lead to loss of human control over dangerous weapons. So the first example is Neuralink brain implants, and the second one is autonomous weapon system. The second danger, which is very real and it could happen, and I think it is going to happen at a certain degree at least, is the transformation of society. Remember the times when 3-4 generations would live under the same roof. And since the Silicon Revolution of 20th and 21st century has broken down families into nuclear units of 2 to 4 people on an average. Today you look around and you'll see everyone with their heads down and eyes glued to their phones. Most of the people prefer to spend their time on their phone than the world around them. And if you want proof of this, you only need to look around. Go to a public space and just observe people. With the AI revolution that we are in, we will see entire realities unfold in real time in augmented reality, and we will be able to interact with an intelligent projection in them that behave like humans. Also, we will be surrounded by robots that human beings will have relations and feelings towards. It is quite possible that on this course, we might forget what it is to be a human. And that brings us to the last danger, that is AI rise to power. I know a lot of people think that singularity or AI rise to power or taking over the world is not a likely scenario, but super intelligent AIs with real world traction, such as an access to pervasive data centers and autonomous robots, could radically alter their environment. Example, harnessing all available solar, chemical, and nuclear energy. If such AIs found uses for free energy that better furthered their goals than supporting human life, human survival would become unlikely. So these were some of the scenarios and dangers that we need to avoid while we go forward with the AI revolution. So let's now find out in this last and final section, what does the future hold for us? An important challenge is to determine who is responsible for damages caused by an AI-operated device or service. in an accident involving a self-driving car, for example? Should the damage be covered by the owner, the car manufacturer, the programmer, the person who trains the machines on data? It's really unclear right now. But with that being said, the future of AI is very promising, it's very bright, and it feels like a start of a revolution. World is also taking baby steps towards artificial general intelligence, and it is going to be really, really helpful for humankind. But that also means that we should tread really carefully. And we should take all the dangers as very real because this isn't something that human beings could control once it gets out of hand, as opposed to every other technology that we had previously. Okay, so how should we prepare ourselves for the future? Educating ourselves about AI or other tech is going to be absolutely paramount if we are going to make this AI revolution a net positive effect for the whole world. So for that, we need to have tough conversation and debates, especially when it comes to developments in artificial general intelligence. Artificial narrow intelligence is not as concerning as what we are trying to achieve right now. And then lastly, we need to ask difficult questions, keep the progress in check by establishing ethics and laws on AI. And if required, there should be licensing and registration of every single tech that we make. So here's my closing remark. With great power comes great responsibility. Just as the world thought that the development of nuclear weapons will wipe out the entire planet. But we now know that if handled with great care, responsibility, and universal cooperation, then it could not only lead to world peace, but resolve energy crisis of the world with nuclear power.
The first artificial intelligence project is Chatbot. Now, Chatbot is an AI software that can start a conversation or a chat with a user through messaging application, websites, mobile apps, or even through calls. Chatbots are increasingly becoming popular. Many companies' websites use chatbots to communicate with their customers. It's been used in almost all the fields, be it education, medical, IT, and even in banking websites, now they're using chatbots. For example, EVA by HDFC Bank. Now, if you're a beginner, then you can program a simple version of a chatbot. There are many chatbots available online. Just learn from them, identify the basic structure, and then build your own chatbot using that structure. You can then enhance it using your creativity and make it better. So this was the first AI project. The next AI project idea is Music Recommendation App. Now, due to AI, Music Recommendation App, which can also be known as Music Recommended Engine, makes it quicker and easier to show the music recommendation that are tailored to each user's interests and preferences. Now, how does this work? So first, it basically collects all the data, which is what the songs the user listens to the most, what is the genre of the song, which language that the user listens to, and so on. Next, it stores all this data and then analyzes it. It then recommends songs from the similar genres and the same language and the songs which have high ratings. You would have seen this in apps like Spotify or Wing, where they have the entire section of songs recommendation for you. So using artificial intelligence, online searching is improving as well, since it makes recommendation related to the user's visual preferences rather than the project description. You can program this music recommendation app by learning from some online blogs or watching some YouTube videos. The next project idea is stock prediction. Now, many people invest in stocks, and they need a stock predictor in order for them to know when to buy the stock. Now, although it is impossible to predict the future, we can make an estimation or guesses and an informed forecast based on the data we have in the present and the past regarding the stocks. This is known as technical analysis, which is used to predict the stock's price direction. Will it increase or decrease after a particular time? So for your project, you can create an application that analyzes the trend of the stock market and offers data-driven insights. You can start off by keeping your stock prediction cycle small and then go on and try for higher values and insights. Also, if you design a good stock prediction application, there'll be a great value and demand for such system and it will make your career. Now moving on to our fourth AI project idea, which is social media suggestions. Now, artificial intelligence has been used in all popular social media networks that we use on a day-to-day basis. Like for example, Facebook uses AI and advanced machine learning to serve you all the content based on your preferences and to recognize people's faces in photos. So you can tag them basically. And also target users for the right advertisement. Also, Instagram, which is owned by Facebook, uses artificial intelligence to identify visuals. Next, LinkedIn uses artificial intelligence to offer job recommendation based on your qualification and interest. It also suggests people to connect with. This also happens in Facebook. So these were just some of the examples of how social media uses artificial intelligence. Now, AI-powered research platform analyze a variety of social media analytics to understand which accounts can provide the most engagement, reach, and influence for a specific industry. So for your project, you can do any of the following tasks, like suggest to users to connect with people they might know, or suggest them some content they might like to watch, or suggest some product they might be interested in, and so on. So this was the social media suggestion project. So now let us move on to the next project idea, which is to identify inappropriate language and hate speech. Now this project sounds easy, but it is quite hard to identify all the hate speeches and inappropriate language. There are many companies like Facebook, Twitter, and YouTube who are trying to create a system like this. So for your project, you can use detection techniques which identify the characters in a context and then compares it to the content that has already been removed as hate speech. Now usually this would be used for identifying any hate speech in any post, like Facebook or Twitter posts. So design an artificial intelligence system that looks into things like the text in a post, the reaction and comment to the post, and how closely it matches the common phrases of a hate speech. Also, if it contains at least one appropriate word, then identify those words and report them. So this could be one of your AI project. Now let us move on to our next AI project, which is lane line detection. Now many of you know that self-driving cars are gaining a lot of popularity. Now as a beginner, it would be very hard to design this, but you can design a part of it which is lane line detection while driving. This lane line detection technique is used by many self-driving autonomous vehicles as well as line following robots. So you can use computer visual techniques and AI to teach the vehicle to go in a particular lane. You can use computer vision techniques such as color thresholding to detect the lane. So usually the lanes are colored in white color. And usually there are double lanes in the middle of the road which separates the direction the vehicle runs in. Then there is usually one white line at the end of the road, after which is the edge of the road. Using all this data, you can design an AI-powered system that detects the lane lines. Now let us move on to our next project idea, which is monitoring crop health. Artificial intelligence has been increasingly adopted as a part of agriculture industry evolution. Using AI, you can perform predictive analysis to determine what is the right date for sowing the seed to obtain maximum yield after the previous harvest. You can also get insights on the crop health, soil health, the fertilizer recommendation, and also the next 7 days weather forecast. So you can create a project which uses artificial intelligence to monitor the health of the crop and check for disease by using various images of the plant that has the same disease. So when a user collects the image of a plant, it will be matched with the images that has already been stored and then diagnose the particular disease, and then even maybe provide an intelligent spraying technique and treatment automatically. Our next project idea is using AI for medical diagnosis. AI has been used in medical industry for analyzing risk, identifying hotspot and chronic diseases, and accounting for social determinants of health. So for your project, you can use artificial intelligence to develop a software that can be programmed to accurately spot signs of a certain diseases in medical images such as MRI scans or X-rays and CT scans. For example, you can design a system that uses artificial intelligence for cancer diagnosis by processing photos of skin lesions. This project can be very helpful to diagnose patients more accurately and also prescribe the most suitable treatment. The next project idea is AI-powered search engine. You can design a search engine which is powered by artificial intelligence, which will scan billions of content available on the web and match the exact search sentence or keyword and will show the relevant information, images, videos, text, and other documents. You can also use ranking algorithms that will rank the content for a particular keyword based on various factors like engagement rate, that is for how long that the user spends on that website, is the content from a reliable website, and so many factors. To do this project, you can refer some online blogs or watch some videos to get started. Also for this project, you need to know a little bit about networks and how the data passes on the internet from one place to another. So this was about the AI-powered search engine. Now let us move on to our next project idea, which is AI-powered cleaning robots. Today's artificial intelligence-powered robots possess no natural general intelligence, but are capable of solving problems and thinking in a limited capacity. You can design a robot that uses artificial intelligence to clean a room by scanning the room size, identifying obstacles, and remembering the most effective routes for cleaning. For starters, you can design a robot that does only one of these things. Then you can enhance it until it effectively cleans the entire room properly. The next AI project idea is house security. Now this is a very interesting project. For this project, you can design a system that uses artificial intelligence to scan and identify the face of the visitor. First, the facial structure of the family members or someone who frequently visits the house can be scanned and stored. So every time a visitor comes near the gate, the system can scan the face, and if it matches the existing facial structure that is stored in the database, it can open the door and allow the person to pass. else the gate can remain shut and the people living in the house can be notified that the person is waiting outside. The next project idea is handwritten notes recognition. Handwriting note recognition refers to the computer's ability to detect and interpret alphabets and numbers. These inputs could be from various sources like paper document, notes on the phone, photos, and other sources. Note that handwriting characters remain complex since different individuals have different handwriting styles. So you can develop a system that uses artificial intelligence to scan the handwriting notes and convert them into digital format. You can use the artificial neural network, which is a field of study in artificial intelligence, to design the system. The next AI project idea is loan eligibility prediction. Nowadays, one of the major problems banking employees face in this ever-changing economy is the increasing rate of loan defaults. So the employees are finding it difficult to correctly access loan requests and decide whom to give loan and whom not to. So in order to determine whether an individual should be given a loan or no, you can create an AI program that will check a person's loan eligibility criteria by accessing certain attributes of an individual, such as the salary, the previous loan details, and so on, and then make a decision to approve a loan or not. This program will make the process a lot more easier by selecting suitable people from a given list of candidates who have applied for loan. So this was about loan eligibility prediction project idea. So now let us move on to our next project idea, which is AI powered voice assistant. So this is one of the interesting artificial intelligence project idea. You can create a voice-based personal assistant using artificial intelligence. So for this, you have to train the system to understand human language, so it can understand and save the command in the database. So next time you give the same command, it will identify the words and perform the necessary action. This can be very helpful, and you can enhance it to do various activities like searching for some information or item on the web, setting alarms, taking down notes, calling someone, playing songs, and many more. The next AI project idea is e-commerce recommendation engine. So in this project, you can build an e-commerce recommendation engine using the similarities among the background information of the items or users to propose the recommendation to the user. So in this project, you can build an e-commerce recommendation engine using the similarities among the background information of the items or users to propose recommendation to the user. So for example, if the user has searched for Apple phones, then you can design a recommendation engine that recommends only Apple phones to the user. Now the other way to do this is you can identify the trends and patterns in the previous and other user item interaction and advise similar recommendation to the present user based on his existing interactions. So an example for this would be if a person has bought a formal shirt, then you can design your recommendation engine to recommend more formal clothing and accessories. You can use artificial intelligence to recommend the user what exactly they need. The next AI project idea is AI-enabled maps. With artificial intelligence, you can create a project that scans the road information and uses algorithm to determine the optimal route to take in order to reach the destination faster. Also to determine which mode of transportation is the best to go to a destination. It could be on foot or in a car, bike, bus, or train. You can also use advanced artificial intelligence in the program by implementing voice assistant that will guide the users about the turns, the potential roadblocks, traffics, and create augmented reality map in real time. The next AI project idea is emotion detection. Now everything that's happening in a science fiction movie could be a future. There are varieties of fields where artificial intelligence is used. One such area of interest is detecting human emotions. There are many top companies investing a lot of money in doing this. So you can design a facial emotion detection and recognition system that can be used to identify human facial expressions. So for this, first the system would have to analyze the facial expression for some time and then perform facial feature extraction and classify the facial expression. For starters, you can design the system to identify only one expression, maybe just happy or normal. Then you can enhance it and try for different emotions. The next AI project idea is AI Health Engine. You can create a project that will use artificial intelligence to give personalized health guidance to a user. The user must provide all the medical reports, and based on that, the artificial intelligence system will check for any pre-existing condition, ongoing health concerns, and gaps in general health knowledge. Then the health engine could be programmed to combine both the personal data of the users and the external health data to provide informed advice to the user. It can also help the users with prescription support, vaccination advice, recommended doctor visits, and specific condition guidance. So this was about AI Health Engine project. Now let us move on to our next project idea, which is trying on online clothes and accessories. Now you would have already seen this feature if you ever visited the Lenskart app. For your project, you can design an artificial intelligence system that takes the input image and computes the person's body model, which would represent their posture and their shape. The segments can then be selected on which the dresses are going to be displayed on, like for example, shirt on the body, gloves for hands, and so on. And then when the user chooses a particular dress, the system can combine them with the body model and update the image's shape representation. Our 20th AI project idea is spam email detection. Spam email detection means detecting emails that are irrelevant to the user by understanding the text content of the email. You can create a project that uses artificial neural network to detect and block spam emails. Also, the newsletter or updates or any ad, you can also enhance it. Let's say the newsletters or updates or any ads which are received from emails can be liked by one person but disliked by another. So you can include this feature using artificial intelligence that will filter the email based on the individual user preferences.
At number 1, we have increased automation. Artificial intelligence can be used to automate anything ranging from tasks that involve extreme labor to the process of recruitment. That's right, there are n number of AI-based applications that can be used to automate the hiring or the recruitment process. Such tools help to free the employees from tedious manual tasks and allow them to focus on complex tasks like strategizing and decision making. An example of this is a conversational artificial intelligence recruiter called MYA. This application focuses on automating tedious parts of the recruitment process, such as scheduling, screening, and sourcing. MYA is trained by using advanced machine learning algorithms, and it also uses natural language processing to pick up on details that come up in a conversation. It is also responsible for creating candidate profiles, performing analytics, and finally shortlisting applications. It is a known fact that automating the recruitment process reduces time to hire by 50% and helps in finding key hires that impact profitability and growth. Our next benefit is increased productivity. Artificial intelligence has become a necessity in the business world. It is being used to manage highly computational tasks that require maximum effort and time. Did you know that 64% of businesses depend on AI-based applications for their increased productivity and growth? An example of such an application is a legal robot. I call it the Harvey Specter of the virtual world. This bot uses machine learning techniques like deep learning and natural language processing to understand and analyze legal documents, find and fix costly legal errors, collaborate with experienced legal professionals, clarify legal terms by implementing a AI-based scoring system on multiple scales. It also allows you to compare your contract with those in the same industry in order to make sure that yours is a standard document. Moving on to our next benefit, AI helps us in making smarter business decisions. One of the most important goals of artificial intelligence is to help in making smarter business decisions. Salesforce Einstein has managed to do that quite effectively. Following Albert Einstein's dictum that the definition of genius is taking the complex and making it simple, Salesforce Einstein is removing the complexity of artificial intelligence, enabling any company to deliver smarter, personalized, and more predictive customer experience. Salesforce Einstein is a comprehensive artificial intelligence for customer relationship management. Driven by advanced machine learning, deep learning, natural language processing, and predictive modeling, Einstein is implemented in large-scale businesses for discovering useful insights, focusing market behaviors, recommending the best possible solutions, and also automating tasks. Moving on to our next benefit, AI has been mainly used to solve complex problems that cannot be solved through other means. Throughout the years, artificial intelligence has progressed from simple machine learning algorithms to advanced machine learning concepts such as deep learning. This growth in AI has helped companies solve complex issues such as fraud detection, medical diagnosis, weather forecasting, and so on. Consider the use case of how PayPal uses artificial intelligence for fraud detection. Thanks to deep learning, PayPal is now able to identify possible fraudulent activities very precisely. The company processed over 235 billion in payments from 4 billion transactions by more than 170 million customers. Along with so much data, machine learning and deep learning algorithms were used to mine data from the customer's purchasing history in addition to reviewing patterns of likely fraud stored in databases. The derived insights and patterns were then used to predict whether a particular transaction is fraudulent or not. Coming to the next benefit of artificial intelligence, AI is used in strengthening the economy. Regardless of whether you think AI is a threat to the world, It is estimated to contribute over $15 trillion to the world's economy by the year 2030. According to a recent report by PwC, the progressive advances in artificial intelligence will increase the global GDP by up to 14% between now and 2030. It is also said that the most significant economic gains from AI will be in China and North America. These two countries will account for almost 70% of the global economic impact. The same report also reveals that the greatest impact of artificial intelligence will be in the field of healthcare and robotics. The report also precisely states that approximately 6.6 trillion of the expected GDP growth will come from productivity gains, especially in the coming years. Major contributors to this growth include automation of routine tasks and development of intelligent bots and tools that can perform all human-level tasks. Presently, most of the tech giants are already in the process of using AI as a solution to laborious tasks. However, companies that are slow to adopt these AI-based solutions will find themselves at a serious competitive disadvantage. Moving on to our next benefit, which is AI in performing repetitive tasks. So we all know that performing repetitive tasks can become very monotonous and time consuming. Not to forget, it's quite boring. So using artificial intelligence for tiresome and routine tasks can help us focus on the most important tasks in our to-do list. An example of such an AI is the virtual financial assistant used by the Bank of America called Edureka. Edureka implements artificial intelligence and machine learning techniques to cater the bank's customer service requirements. It does this by creating credit report updates, facilitating bill payments, and helping customers with simple transactions. Edureka's capabilities have recently been expanded to help clients make smarter financial decisions by providing them with personalized insights. As of 2019, Edureka has surpassed 6 million users and has serviced over 35 million customer service requests. Our next benefit of artificial intelligence lies in personalization. Research from McKinsey found that brands that excel at personalization deliver 5 to 8 times the marketing ROI and boost their sales by more than 10% over companies that don't personalize. Personalization can be an overwhelming and time-consuming task, but it can be simplified with the help of artificial intelligence. In fact, it's never been easier to target customers with the right product. An example of this is a UK-based fashion company called Thread that uses artificial intelligence to provide personalized clothing recommendations for each customer. Most customers would love a personal stylist, especially one that comes at no charge. But staffing enough stylists for 650,000 customers would be expensive. Now, instead, the UK-based fashion company Thread uses artificial intelligence to provide personalized clothing recommendations for each of its customers. Customers frequently take style quizzes to provide data about their personal style. Each week, customers receive personalized recommendations that they can upvote or downvote. Thread uses a machine learning algorithm called Thimble that uses customer data to find patterns and understand the likes of the buyer. It then suggests clothes based on the customer's taste. This is how personalization is performed in Thread. Moving on to our next benefit, which is artificial intelligence in global defense. The most advanced robots in the world are being built with global defense applications in mind. This is no surprise since any cutting-edge technology first gets implemented in military applications. Though most of these applications don't see the light of day, one example that we know of is the Ant bot. The AI-based robot developed by the Chinese is an armed police robot designed by the country's National Defense University. Capable of reaching maximum speed of 11 miles per hour, the machine is intended to patrol areas and, in the case of danger, deploy an electrically charged riot control tool. The intelligent machine stands at a height of 1.6 meter and can spot individuals with criminal records. The Antbot has contributed in enhancing security by keeping a track of any suspicious activity happening around its vicinity. Moving on to the next benefit, we have artificial intelligence in disaster management. For most of us, precise weather forecasting makes vacation planning easier. But even the smallest advancement in predicting the weather majorly impacts the market. Accurate weather forecasting allows farmers to make critical decisions about planting and harvesting. It also allows airlines to maximize the use of their planes. It makes shipping easier and safer. And most importantly, it can be used to predict natural disasters that impact the lives of millions. Among companies using artificial intelligence to predict the weather, only a few have invested as heavily as IBM. After years of research, IBM partnered with the weather company and acquired tons and tons of data. The acquisition gave IBM access to the weather company's impressive network of sensors and models, providing a massive pipeline of weather data it could feed into IBM's AI platform Watson in order to attempt to improve any predictions. In 2016, the weather company claimed that their models use more than 100 terabytes of third-party data every single day. The product of this merger is the AI-based IBM Deep Thunder. This system provides highly customized information for business clients by using hyper-local forecasts at a 0.2 to 1.2 mile resolution. This information is useful for transportation companies, utility companies, and even retailers. Moving on to the last benefit of artificial intelligence is that it enhances our lifestyle. And we're all aware of how AI is actually enhancing our life and changing our life. In the last decade, artificial intelligence has gone from a science fiction dream to a critical part of our everyday lives. We use AI systems to interact with our phones and speakers through voice assistants like Siri, Alexa, and Google. Cars made by Tesla interpret and analyze their surroundings to intelligently drive themselves. Amazon monitors our browsing habits and then serves up products it thinks we'd like to buy. And even Google decides what results to give us based on our search activity. Artificially intelligent algorithms are here, and they've already changed our lives for better or for worse. But this is only the beginning. And one day we'll look back at AI in 2019 and laugh about how primitive it was. Because in the future, artificial intelligence is going to change everything.
Generative AI is reshaping industries and economics at this staggering pace. Reports by Goldman Sachs and PwC Global highlights that AI has the potential to significantly boost global GDP and labor productivity while driving economic gains of up to 45% by 2030. So, let's dive into how you can prepare for a lucrative generative AI career. So to get started with GenAI, start with the natural language processing. Natural language processing is the branch of AI that focuses on the interaction between computers and human language. So here's what you need to learn. First, start with the basics of NLP. Learn how machines understand and process language. Next, parts of speech tagging, where you need to understand how to label words with grammatical tags. Next, text processing. Here, learn techniques for cleaning and preparing text data for models. Next, named entity recognition, where you need to learn to build models that identify entities like names and dates. Next, text vectorization. Study methods to convert text into numerical data using techniques like bag of words and embeddings. Next, learn about large language models. Well, large language models are powerful AI systems trained on massive datasets to understand and generate human-like text. Here, dive into different types of LLMs like Llama, Falcon, and Gemini. Next, transformers, where you need to learn about their architecture, including the encoder, decoder, and attention mechanism. Next, read the seminal paper, Attention is All You Need for the In-Depth Understanding. In this paper, you can read about the transformers in depth. Next, working with APIs. APIs, that stands for Application Programming Interfaces, allow you to integrate and extend functionality in your projects. And they can be paid or unpaid. So in this video, we will mostly tell you about free API sources. Use free API platforms like Glitch, Postman, Moki, Heroku, Rapid API, and Firebase functions. Also build APIs with platforms like Group to create generative AI integrations. And you can also use Hugging Face for free resources. Now, as you can see here, we are at the Group platform, and on the top, we have this developer option. And once you hover on it, you can see options like free API creation, and once you click on it, it will redirect you to this, where on your left you can see different options. Now if you want to check about the model, then click on the playground. Then on your right you have the llama model. So if you click on that, you can see different model group website provides, and these are all for free. Next, click on create API key, and here give any name to your API key, and that's it. You have your own API key now. So from here you can copy it and use it. Also, you can create as many API keys as you want. You can explore Hugging Face for pre-trained models and datasets. So now we are at the site of Hugging Face. You can see options like models, datasets, space, post, docs, etc. Now suppose you want to code for your model, then click on model and it will redirect you here, where you can see options like libraries, datasets, language or license models, etc. Now select the model according to your project. As you can see, we have different options here, so select your model and use this website as much as you want. Next, start building mini projects for practice. So here, start applying your knowledge with hands-on projects such as named entity recognition models, next translators and summarizer, sentiment analysis systems, also the text-to-speech or speech-to-text applications. After building mini projects, you can move on to advanced topics. So to enhance your skills in AI, focus on techniques like quantization to optimize models for faster and more efficient deployments, particularly in resource-constrained environments. Then, dive into fine-tuning large language models to customize pre-trained models for specific tasks, unlocking their full potential for tailored applications. Additionally, explore the LangChain framework, a powerful Python library for building generative AI pipelines. Practice using its comprehensive documentations and tutorial videos to deepen your understandings. So if you haven't already watched our video featuring to LangChain project, it provides valuable insights and practical examples to get you started with this versatile tool. And this, Edureka's Generative AI certification and training will teach you Python programming, data science, artificial intelligence, natural language processing, and many other updated technologies that a beginner or advanced learner is seeking. Now, after much practice, you must know how to develop a backend and a frontend. So, start with a backend, because when you start with the backend, you will deal with real-life problems and have a thorough knowledge of your coding language too. So, for backend development, you can leverage frameworks like Fast API, Django, and Flask to create robust and efficient server-side applications. These frameworks are well suited for handling API creation, request routing, and server-side logic, making them essential for modern web development. To manage and store data effectively, consider using databases such as MySQL or MongoDB, which offer reliable and scalable solutions for structured and unstructured data respectively. Combining these tools allows you to build powerful data-driven applications with ease and efficiency. Edureka's Python Developer Masters program, crafted by an industry expert, will give you extensive knowledge about Python and its libraries. Also, with a hands-on project, you will gain proficiency in data science, machine learning, deep learning, and natural language processing. So if you are a beginner and want to upskill yourself, you can check out this certification. You can also consider a Django certification training course, where you will be guided by industry experts and gain insights into Django REST framework, Django models, Django Ajax, Django query, and many other top technologies. Also, if you are looking for particular database certification courses, you can check out the MongoDB certification training course, which will give you deep insights into backend database technologies. When you are thorough with the backend, next, moving on to frontend. For front-end development, focus on creating user-friendly interfaces to complete your projects effectively. Start with basic web development by mastering foundational technologies like HTML, CSS, and JavaScript to build responsive and visually appealing designs. As you progress, explore advanced JavaScript frameworks such as React.js, Vue.js, or Angular, which provide powerful tools for building dynamic, interactive, and scalable web applications. These frameworks streamline the development process and enhance the user experience, making them essential for modern front-end development. Edureka's Web Developer Master Program will give you insights into HTML, CSS, and other web development tools. So if you are a beginner and want to upskill yourself, you can check out this certification course. Also, you can check out the Full Stack Web Development Program, which will teach you front-end and back-end development with the core technologies you need as a beginner. Now, having both front-end and back-end complete, you need one more thing for your journey, that is version control with Git and GitHub. Version control is essential for tracking changes in your projects and collaborating efficiently with others. And by learning to use Git commands, you can manage versioning, maintain a history of your work, and seamlessly revert to previous states if needed. Additionally, leveraging platforms like GitHub enables you to deploy and manage projects, collaborate with team members, and showcase your work to a broader audience, making it an indispensable skill for developers. Edureka's Git certification training will give you insights into version control, from scripting to Git workflow, everything you need to know about version control. So, if you're a beginner and want to upskill yourself, you can check out this certification training course. And by following this roadmap and practicing consistently, you will develop a strong foundation and advanced skills to excel in a high-paying career in generative AI. So start today, and remember, hands-on project and continuous learning are the key to success. Let's first look at the GenAI impact on the market. So here is the graph illustrating the potential impact of generative AI on the job market. It suggests that while generative AI will lead to the job losses, it will also create new job opportunities. The number of jobs influenced by generative AI is projected to increase significantly over the next few years, far exceeding the number of jobs lost. This indicates that while some jobs may be automated, generative AI is expected to drive overall job growth and create new economic opportunities. Next, the graph median salary of GenAI professionals across years of experience in India. This shows a clear upward trend in salaries with increasing experience. Professionals with 0 to 3 years of experience earn a median salary of around 10 lakhs per annum. This figure steadily increases to 12 lakhs for 3 to 6 years of experience, 16 lakhs for 6 to 10 years, and 19 lakhs for 10 to 12 years. The highest median salary at 23 lakhs is observed for professionals with 12 plus years of experience in the GenAI field. This indicates a strong correlation between experience and earning potential in India's field of generative AI. And last but not least, the graph Generative AI Market Size 2023 to 2033. And this illustrates the projected growth of the generative AI market. It shows a significant upward trend, with the market size expected to increase from $17.65 billion in 2023 to a staggering $803.90 billion by 2033. The market is projected to grow at a rapid pace, with substantial increases anticipated each year. This indicates a strong demand for generative AI solutions and its potential to revolutionize various industries. Now, the era of generative AI is leading in a new wave of career opportunities. From crafting prompts to managing AI products and ensuring ethical development, the demand for skilled professionals is surging. As AI continues to evolve, roles like generative AI research scientists and synthetic data engineers are emerging, promising exciting career paths at the forefront of technological innovation. So, embrace the future and explore these top 5 career opportunities to unlock your potential in the world of generative AI. Now, the first one we have is AI Prompt Engineer. An AI prompt engineer focuses on designing prompts to optimize AI outputs, ensuring that models generate accurate, relevant, and high-quality responses. This role involves crafting prompts for tools like ChatGPT to effectively solve specific business problems or creative writing tasks. Now that you know about AI prompt engineer, now let us explore the skills and tools required for it. First, talking about skills, prompt engineering involves crafting effective instructions for AI models like ChatGPT. A strong understanding of natural language processing is very essential for this, as it helps in guiding models to process and comprehend human language accurately. Creativity plays a vital role, enabling the development of innovative and imaginative prompts that lead to unique and valuable outputs from AI models. Next, let us talk about tools. Python, a versatile programming language, is widely used in AI and machine learning, including for building and interacting with AI models. Hugging Face, a popular platform, provides access to a vast collection of pre-trained AI models and tools for natural language processing and other AI tasks. Specialized prompt engineering tools assist users in crafting and refining prompts, offering suggestions and optimization techniques.
Additionally, LangChain can be used to integrate multiple AI models into more complex applications, further enhancing the capabilities of prompt engineering. Hence, by mastering these skills and utilizing these tools, AI prompt engineers can effectively harness the power of AI models to generate creative and valuable content. And with the rise of prompt-based AI tools, the demand for this role is rapidly growing across various industries. And the salary range for an AI prompt engineer in India is 6 to 10 lakhs per annum, and in the United States, they earn between $100,000 to $150,000 annually, depending on expertise and location. Now, we have the next career, which is AI Product Manager. An AI Product Manager leads the development of AI-driven products, aligning technical teams with business goals and user needs. This role involves managing the release of AI-powered tools such as customer service solutions or recommendation systems for e-commerce platforms. Now that you know about AI Product Manager, so let us explore the skills and tools required for it. First, talking about skills, product lifecycle management involves overseeing the entire journey of an AI product from ideation to post-launch support, including market research, planning, development, testing, and maintenance. A solid understanding of AI fundamentals such as machine learning, deep learning, and natural language processing is essential for managing AI product development effectively. Strong leadership skills are necessary for guiding cross-functional teams, including engineers, data scientists, and designers, ensuring clear communication, decision-making, and the ability to inspire and motivate team members throughout the process. Next, talking about tools, Agile development is a methodology that encourages iterative development and collaboration, making it ideal for AI product development due to its flexibility and adaptability in response to the rapid evolution of AI technologies. Jira is a widely used project management tool for tracking tasks, bugs, and features throughout the development process. Miro, a collaborative whiteboard tool, helps teams brainstorm, visualize, and organize ideas, facilitating effective collaboration during the product development journey. Hence, by mastering these skills and utilizing these tools, AI product managers can effectively lead the development and launch of successful AI products. And as organizations increasingly integrate AI into their products, there is a strong demand for skilled professionals to guide the process. And the salary range for an AI product manager in India ranges between 16 to 29 lakhs per annum. And in the United States, they earn between $100,000 to $200,000 annually. In our list, next we have AI Ethics Specialist. An AI Ethics Specialist ensures that AI systems comply with ethical guidelines and regulations, focusing on fairness, transparency, and accountability. This role involves auditing AI models to prevent bias in hiring tools or ensuring compliance with privacy laws like GDPR. Now that you know about AI Ethics Specialist, so let us explore the skills and tools required for an AI Ethics Specialist. First, talking about skills, a strong understanding of ethics in AI is crucial, covering principles like bias, fairness, transparency, and accountability in AI development and deployment. Knowledge of compliance standards such as GDPR and HIPAA ensures that AI systems are developed and used ethically and legally. Critical analysis is also vital, as the ability to assess AI systems and identify potential ethical risks and biases is a key skill for AI ethics specialists. Next, talking about tools, GDPR, that stands for General Data Protection Regulation, is a European Union law that governs the process of personal data, setting strict standards for data privacy and security, especially for AI systems handling personal data. HIPAA, that stands for Health Insurance Portability and Accountability Act, is a US law that establishes standards for protecting sensitive health information, requiring AI systems dealing with healthcare data to comply with its regulations. The OECD AI principles, developed by the Organization for Economic Cooperation and Development, offer a framework for ethical AI development, addressing topics such as human rights, inclusivity, and environmental impact. Hence, by mastering these skills and understanding these tools, AI ethics specialists can play a crucial role in ensuring that AI is developed and used responsibly, ethically, and in compliance with relevant regulations. As governments and organizations play a higher emphasis on responsible AI deployment,
The demand for AI ethics specialists is increasing, and the average salary in India for AI ethics specialist is 14,02,849 rupees annually. In the United States, for this role typically falls between $80,000 to $120,000 annually. Next on the list, we have Generative AI Research Scientist. Generative AI Research Scientist develops and fine-tunes new generative models like ChatGPT, Midjourney, or DALL-E to advance AI capabilities. And this role involves working on foundational models for text-to-image tools or improving large language models for tasks such as translation and summarization. Now that we know about Generative AI Research Scientist, so let us explore the skills and tools required to be a Generative AI Research Scientist. Well, first talking about skills, deep learning, a subset of machine learning, uses artificial neural networks to learn complex patterns from large datasets, and it's fundamental for developing generative AI models. Understanding neural networks, including their architecture and functioning, is crucial for designing and training these models. Additionally, a strong foundation in mathematics and statistics is essential for understanding and implementing the algorithms that power generative AI models. Now talking about tools, Python is a versatile programming language widely used in AI and machine learning, including for developing and training generative models. TensorFlow, an open source platform developed by Google, provides tools and libraries for building and training complex machine learning and deep learning models. PyTorch, another popular open source machine learning framework, is known for its flexibility and ease of use, making it a preferred choice for research and development. Hence, by mastering these skills and utilizing these tools, generative AI research scientists can push the boundaries of AI and develop innovative solutions for a wide range of applications. And due to the explosive growth of generative AI, there is a high demand for this role in tech companies and research institutions. The salary range for a generative AI research scientist in India is 19 to 30 lakhs per annum, and in the United States, they earn between $158,000 annually, with top companies offering even higher compensation. Finally, we have synthetic data engineer. A synthetic data engineer creates and manages synthetic data to train AI models when real-world data is unavailable, incomplete, or sensitive. This role involves generating synthetic data such as medical data to train healthcare diagnostic AI systems without risking patient privacy. Now that we know about synthetic data engineer, so let us explore the skills and tools required for a synthetic data engineer. First, talking about skills, a strong foundation in data science is crucial for understanding data, its distribution, and the techniques required to generate synthetic data that closely resembles real-world data. And knowledge of various data generation techniques such as statistical modeling, machine learning, and generative models is essential for creating high-quality synthetic datasets. Additionally, understanding data dynamics and how data evolves over time is important for generating synthetic data that accurately reflects real-world trends and patterns. Next, talking about tools, Python is a versatile programming language widely used in data science and machine learning, offering a rich ecosystem of libraries and frameworks for data generation and analysis. TensorFlow, an open source platform developed by Google, provides tools and libraries for building and training generative models. Additionally, various AI tools, including generative models and machine learning algorithms, are used to create synthetic data that is statistically similar to real-world data. Hence, by mastering these skills and utilizing these tools, synthetic data engineers can create high-quality synthetic data that can be used to train AI models, test algorithms, and conduct privacy-perceiving data analysis. Now that the demand for this role is growing in industries like healthcare, finance, and autonomous vehicles, where data privacy and scarcity present significant challenges. The salary range for a synthetic data engineer in India is 9 to 15 lakhs per annum, and in the United States, it is $106,000 annually. Now that we have a wealth of knowledge about career opportunities, and you might be wondering if they will continue to grow in the future. So to answer that, we have a few global reports from AI career growth. Well, global AI market growth says that in coming years, the global AI market is projected to reach a staggering of $190 billion, and this significant growth is expected to create millions of job opportunities worldwide. Also, the soaring demand for AI specialist report says that the demand for AI specialists has witnessed a remarkable surge, growing by 74% annually over the past 5 years. And this data is sourced from the LinkedIn Emerging Jobs report. And in industries driving AI demand, the report says that industries such as healthcare,
finance, and autonomous vehicles are experiencing significant growth, leading to a high demand for AI professionals to drive innovation and development in these sectors. Overall, this underscores the exciting future of AI careers, with numerous opportunities for skilled professionals to contribute to the advancement of technology and shape the industries of tomorrow. Since you are now familiar with most of the skill set and tools, you might be wondering where to find certifications, courses, and resources to master them. So we have resources to build skills. First, Prompt Engineering with Generative AI course offered by Edureka. This course is designed to teach learners how to effectively use prompts to generate desired outputs from artificial intelligence models. The course highlights the growing importance of prompt engineering in the field of AI and its potential to transform problem-solving and creative process. Next, Machine Learning Course Master's Program offered by Edureka. This course is designed to teach learners how to effectively use concepts like machine learning, deep learning, and data science along with some essential tools. Next, Artificial Intelligence Course for Beginners offered by Edureka. The course is designed by industry experts and focuses on helping learners improve their AI and machine learning skills. It covers fundamental concepts like classification and regression algorithms and prepares learners for roles like AI solution consultant, technical support engineer for AI products, and AI research assistant. Now, we have some recommendations for those who enjoy reading and hands-on practice through books. So first book on artificial intelligence, a guide for thinking humans that provides a comprehensive introduction to AI, making it accessible to a wide audience. Next, on deep learning, that is considered a foundational text in the field of deep learning. It covers the mathematical and computational underpinnings of deep learning techniques. Next, the Oxford Handbook of Ethics of AI, that explores the ethical implications of AI, addressing topics such as bias, fairness, accountability, and transparency. It offers valuable insights into the societal and ethical challenges posed by AI. And these books collectively provide a solid foundation in AI, covering both technical aspects and broader societal implications. They are valuable resources for anyone interested in learning more about AI and its potential impact on the future. So let's get started with our first question, that is, how traditional AI different from generative AI? Now, let's take a look at the differences between traditional AI and generative AI. Traditional AI relies on predefined algorithms and primarily works with labeled, supervised data to solve specific problems, whereas generative AI uses advanced learning techniques to understand data structures, train on datasets, reason, and create new and innovative solutions. This ability to generate fresh output sets generative AI apart from traditional methods. Let's compare traditional AI and generative AI based on their functioning. So in traditional AI, the process typically involves data collection, model selection, training the model, evaluation, feedback, and finally deployment. And on the other hand, generative AI starts with data preprocessing, followed by AI model training, data generation, identifying patterns, and iterative training that incorporates feedback and acknowledgement. Once defined, the model is then deployed. And this iterative and creative approach makes generative AI more dynamic in its application. Well, the key differences is that traditional AI works on predefined rules while generative AI does not. So here are some examples to differentiate traditional AI and generative AI. Traditional AI is used in applications like image detection, stock market prediction, fraud detection, and voice recognition. Whereas generative AI is utilized for tasks such as content creation, predictive fashion trends, code generation, and advancements in healthcare industries. Moving on to next question. How does generative AI help in scaling businesses? Well, generative AI helps businesses scale by automating and optimizing process, creating personalized customer experience, and generating data-driven insights. Here's a breakdown of how it contributes. First, efficiency and automation. Generative AI automates repetitive tasks such as content creation, customer service via chatbots, and report generation, freeing up human resources for strategic activities. Next, pattern recognition. By analyzing vast data sets, generative AI identifies trends and patterns, enabling businesses to make proactive decisions, optimize operations, and predict market shifts.
Next comes the content creation. It generates high-quality marketing materials, product descriptions, and creative assets at scale, which reduces the cost and production time. Next, personalized experience. AI customizes interactions and recommendations for customers, improving satisfaction and loyalty, which are critical for scaling. Next is the rapid prototyping and deployment. Generative models create simulations, prototypes, and even entire product designs, accelerating product development cycles and reducing time to market. And finally, enhanced decision making. AI-powered tools provide actionable insights and forecasts, guiding businesses in resource allocation, market strategy, and scaling efforts. Well, generative AI acts as a catalyst for growth by delivering scalable, innovative solutions that adapt to the dynamic demands of modern business environments. Moving on to our next question, what are some common applications of generative AI in real world? Generative AI has the wide range of application in real world like gaming. In the gaming industry, renowned companies like Nvidia and Ubisoft are utilizing generative AI to enhance various aspects of game development and player experience. Generative AI is being used to boost creativity, improve screen time dynamics, refine shadow techniques, and elevate the overall player experience, making games more impressive and engaging. Next, in content creation. So in the field of content creation, companies like Microsoft Azure and OpenAI, the creators of ChatGPT, are developing advanced algorithms to generate unique and innovative content. This content not only captivates audience but is also highly appreciated by critics, showcasing the transformative potentials of generative AI in creative industries. Next, in fashion and design. In the fashion and design industry, companies like H&M Group and Nike are leveraging generative AI to offer personalized clothing, shoes, and accessories online. This innovative use of AI has brought significant advancements, enabling these brands to enhance customer experience and set new standards in personalized fashion. Next, in healthcare industries. Well, in the healthcare industries, companies like Atomwise and In Silico Medicine are utilizing generative AI to enhance efficiency and accuracy in medical care. Given the critical importance of precision when it comes to saving lives, generative AI plays a pivotal role in advancing medical research, diagnostics, and treatment solutions. Next, in chatbots and virtual assistants. So to enhance user experience, major companies like Google, Microsoft, and IBM are developing advanced chatbots and virtual assistants. These AI-driven tools aims to provide personalized support, improve efficiency, and streamline communication, making interactions more initiative and engaging. So, our next question is, what are some popular generative AI models you know? So, first one we have is GPT. GPT stands for Generative Pre-trained Transformer Series, a series of language models designed to generate human-like text based on pre-trained data, enabling tasks like text generation, translation, and even summarization. Next, we have BERT, Bidirectional Encoder Representations from Transformers, a language model that understands context in both directions like left to right and right to left to improve tasks like question answering and language understanding. The next generative AI model is DAL-E and DAL-E 2, AI models capable of generating images from textual descriptions, with DAL-E 2 offering enhanced image quality and more accurate interpretations of complex prompts. Now, moving on to our next question, what are some challenges associated with generative AI? Some key challenges associated with generative AI include data privacy and security. Large dataset used for training may compromise user privacy or include sensitive information, leading to regulatory and ethical concerns. Next, bias and fairness. Generative AI can amplify biases present in the training data, resulting in outputs that are unfair or discriminatory. Next is the quality and accuracy. Ensuring the quality and factual accuracy of AI-generated content is difficult, especially with diverse and large datasets. And the next challenge is interpretability and transparency. Generated content can lack traceability, making it hard to explain or justify outputs. Potential for content to closely resemble on copyrighted material. And the next challenge is ethical concerns. misuse of generative AI for malicious purpose, such as creating deepfakes, spreading misinformation, or automating spam. Next, resource intensity. Training generative models requires significant computational resources, leading to high cost and environmental concerns. And finally, deployment challenges. So, ensuring robust, scalable, and safe deployment of generative AI models in real-world application is complex. And addressing these challenges requires a combination of technical solutions, ethical guidelines, and legal frameworks. Moving on to next question. What is the large language model and how is it used in generative AI? Well, a large language model is a type of artificial intelligence model that has been trained on vast amounts of text data to understand and generate human-like language. And these models are typically built using deep learning architectures such as transformer-based models like GPT, BERT, and T5, and contains billions to trillions of parameters that help them capture the details of natural language. And some of the key features of LLMs include the massive scale. LLMs are trained on extensive datasets that includes a variety of domains such as books, articles, websites, and more. The next feature is contextual understanding. LLMs can understand the context of words, phrases, and sentences by processing long-range dependencies, making them capable of generating coherent and contextually relevant text. Next, transfer learning. Pre-trained LLMs can be fine-tuned on specific tasks or datasets, allowing them to perform a wide range of language-related tasks with minimal task-specific data. But how LLMs are used in generative AI? Well, it is used in text generation. LLMs can generate coherent and human-like text based on the prompt. Like for example, GPT-3 can write articles, create dialogues, generate poetry, or even code. Example, given a prompt like write a story about a dragon and a wizard, the model generates a creative and coherent story. Next, it is used in text completion. LLMs can predict and complete sentences or paragraphs based on the initial input, making them useful in applications like auto-completion, chatbots, and writing assistants. Next, LLMs are used in translation and summarization. LLMs can translate text from one language to another or summarize long documents into concise summaries, making them valuable for tasks requiring cross-lingual understanding or information distillation. Next, in conversational agents. LLMs power conversational AI systems such as chatbots, virtual assistants that can understand and respond to user queries in natural language, offering more dynamic and human-like interactions. It is also used in creative content creation. LLMs are used to generate creative content such as articles, marketing copy, and even scripts for videos or films. Next, in sentiment analysis and classification. LLMs can be used to fine-tune to classify text, like example sentiment analysis, spam detection, by predicting labels based on context and training data. Next, what are some common applications of large language models? So some of the common applications of large language models include chatbots and conversational AI, powering virtual assistants and customer support bots to engage in natural language conversations. Next, language translation, translating text from one language to another while preserving meaning and context. Also, in summarization, automatically compressing large documents or articles into concise summaries. And you can also give examples of sentiment analysis, which determines the sentiment or emotional tone of text for applications in social media monitoring, customer feedback analysis, and more. Also in code generation, where it is assisting in programming by generating code snippets based on natural language descriptions. And the next question is, what is prompt engineering and why is it important in generative AI? Well, prompt engineering is the process of designing and refining prompts to effectively guide the output of a generative AI models, particularly language models like GPT. In the context of generative AI, a prompt is an input or instruction provided to the model, which it uses to generate a response or output. The quality, clarity, and structure of the prompt can significantly influence the model's output, making prompt engineering a critical skill in maximizing the performance and usefulness of these models. The image shows the concept of prompt engineering, emphasizing its role in optimizing interaction with AI systems. It highlights three key objectives: improving accuracy, which ensures precise responses; enhancing relevance, which tailors outputs to user needs; and increasing efficiency, which streamlines process for better performance. And together, these elements demonstrate how effective prompts design can significantly improve the overall functionality and outcomes of AI models. Next, how does generative AI handle the creation of text-based content? So, the generative AI generates text-based content through a process that involves several key steps. Here's a simplified explanation. First, training on large data sets. Pre-trained on large data sets, AI models like GPT are trained on vast amounts of text data from diverse sources such as books, articles, and websites. This extensive training helps the model to learn language patterns, context, and general knowledge, forming the foundation for its ability to perform various language tasks effectively. Next, the architecture of the model. Generative AI models are built on the transformer architecture, a highly effective framework for processing sequential data. It leverages mechanisms like self-attentions to understand context and relationships within text, enabling text such as language generation and comprehension. Next, generating responses. The generation process involves multiple stages, including structuring ideas, connecting relevant information, analyzing data, writing coherent content, and finally deploying or delivering the output in a meaningful and usable form. Next, iterative process. In simple terms, it means improving the model by training it, receiving feedback, and making adjustments based on that feedback to enhance its performance. So in summary, generative AI models like GPT generate text by predicting word sequence based on learned patterns from extensive training data, while understanding and maintaining context throughout the generation process. Examples of generative models include GPT-4, BERT, Transformers, and T5, which stands for Text-to-Text Transfer Transformer. Moving on to the next question, can you explain how generative AI is used in chatbots or language translation? Generative AI enables chatbots to produce contextually relevant, coherent, and human-like responses, improving the user experience. Key areas where generative AI contributes include generating responses. By leveraging large language models, generative AI can produce more natural and engaging responses, making chatbot interactions feel more human-like. Next, creativity. Generative AI can be used to generate creative content such as poems, stories, or scripts, which can be incorporated into chatbot conversations to make them more entertaining and engaging. Next, personalization. Generative AI can analyze user data to personalize chatbot responses, making the interaction feel more tailored to the individual user. And then we have context management. Generative AI can maintain context throughout a conversation, allowing chatbots to understand and respond appropriately to the user's evolving needs and preferences. These capabilities of generative AI are transforming how chatbots and language translation tools are used, making them more effective and user-friendly. Now, moving on to the advanced level questions in generative AI. And the question is, what is the role of the data in training generative AI models? Data plays a crucial role in training generative AI models as the quality, quantity, and diversity of the data significantly impact the model's performance and output. Here are some of the examples of data usage in generative AI models. First, in image generation. For models like GANs, large datasets of images are used to teach the models how to generate realistic images. Next, text generation. For models like GPT-4, vast text from various sources like books, articles, websites are used to train the model to understand and generate human-like text. And next, in music generation. Models trained on large collections of musical compositions learn patterns in melody, harmony, and rhythm to generate new music. Now moving on to next question. How do attention mechanisms enhance the performance of generative AI models? Well, attention mechanisms significantly enhance the performance of generative AI models by allowing them to focus on relevant parts of the input data when generating each part of the output. So here's how they work and contribute to improved performance. The text at the top states that the attention mechanism is a critical innovation that enhances the performance of generative AI models. The diagram shows how multiple attention heads process information in parallel. Each attention head focuses on different aspects of the input sequence, allowing the model to capture complex relationships and dependencies between different parts of the data.
The outputs of these attention heads are then concentrated and processed further to generate the final output. This multi-headed attention mechanism enables the model to learn more detailed representations of the input, leading to improved performance in tasks such as language translation, text summarization, and image generation. And the next question is, what is GANs, which stands for Generative Adversary Networks, and how do they function? GANs are the type of generative models that are particularly powerful for generating realistic data such as images, text, or audio. The diagram provides a clear visual representations of a GAN's architecture and its functioning. Well, GAN, which stands for Generative Adversarial Network, this is a central component. It highlights that a GAN is a system consisting of two main subnetworks. Next, generator. Generator is responsible for creating new data samples. Well, it takes input and attempts to generate realistic data points, example, images, text, that mimics the training data. Next is the discriminator. The discriminator acts as an evaluator. It takes an input both real data samples from the training set and the generated samples from the generator. Its task is to differentiate between the real and fake data, assigning a probability of being real to each sample. Now, let us see the functioning of GANs. GANs comprise two key components, a generator and a discriminator. The generator aims to create new data instances that closely resembles the training data, whereas the discriminator acts as a binary classifier tasked with differentiating between real data samples from the training set and synthetic data generated by the generator. The adversarial relationship between the generator and the discriminator drives the GANs to produce increasingly realistic synthetic data. So as you can see the screen, this image shows the functioning of a generative adversary network. It starts with random noise as input, which is fed into the generator network. This network attempts to generate a fake sample that resembles real data. The generated sample is then presented to the discriminator network alongside actual real samples from the training dataset. The discriminator's task is to classify each sample as either real or fake. So both the generator and discriminator networks learn and improve through this adversarial process, with the generator aiming to produce increasingly realistic samples that can fool the discriminator, while the discriminator strives to accurately distinguish between the real and fake data. Next, how do generative models like GANs help in image generation? Generative models like generative adversarial networks are powerful tools for image generation. GANs consist of two neural networks, the generator and the discriminator, which work together in a competitive process to create highly realistic images from random noises. Here's how GANs help in image generation. Generative models like GANs are powerful tools for creating realistic images. GANs use a dual network approach to achieve this. The generator network creates new images. The discriminator network evaluates these images, trying to distinguish between the real and generated images. This adversarial process forces the generator to create increasingly realistic images. Now, let's see the training process of GANs. In this process, the generator network strives to improve its ability to create realistic images that can deceive the discriminator. Conversely, the discriminator network focuses on enhancing its ability to detect fake images, leading to an ongoing improvement cycle for both networks. Through the continuous adversarial learning between the generator and discriminator, the generator eventually produces high-quality images that are so realistic that they can successfully deceive the discriminator. Moving on to next question, what are variational autoencoders and how do they differ from GANs? Well, variational autoencoders are a type of generative model that is built on the principles of autoencoders, a neural network architecture commonly used for unsupervised learning tasks like dimensionality reduction and feature learning. Key components are encoder. The encoder maps input data, for example an image, to a latent space, representing it as a distribution over latent variables. Next, the output. Instead of mapping to a single point in latent space, the encoder outputs the mean and variance of a Gaussian distribution. This distribution captures the uncertainty in the encoding process. Next, we have decoder. The purpose is the decoder takes the sample latent variables and maps it back to the data space, reconstructing the original input data or generating new data.
Output: the decoder produces a reconstruction of an original input or a new data point that lies within the learned distribution. Next, what role can generative AI play in education, especially in creating customized learning materials for students? Generative AI can play a transformative role in education by creating customized learning materials that cater to individual student needs. Here's how it can be utilized effectively. First, in personalized learning paths. Customized content. AI generates tailored content based on a student's learning pace, interest, and proficiency levels. For example, if a student struggles with a particular math concept, the AI can create additional exercise or explanations focused on that topic. Next, adaptive assessments. AI can design assessments that adapt in real time to a student's performance, offering more challenging problems as the student progresses or providing more foundational questions if they encounter difficulties. Next, interactive learning materials. It provides dynamic textbooks. AI can create interactive textbooks that update based on the latest research and educational trends. These materials could include simulations, quizzes, and other interactive elements that respond on how a student interacts with the content. Next, simulations and virtual labs. AI can generate virtual experiments and simulations, allowing students to explore complex scientific concepts in a safe, controlled environment. Next, language and writing support. In grammar and style suggestions, AI can assist students in improving their writing by providing real-time feedback on grammar, style, and clarity. It can also suggest alternative phrases or vocabulary based on the student's level. Next, essay generation assistance. For younger students or those learning new languages, AI can help generate essay outlines or suggest content structure, helping them organize their thoughts more effectively. Next, automated content creation. Lesson plans. AI assists teachers by generating lesson plans that align with curriculum standards, saving time and allowing teachers to focus more on student interaction. Next, practice problems and quizzes. AI can create endless variations of practice problems and quizzes, ensuring that students get the repetitions they need without encountering the same problem twice. Next, support for diverse learning styles. In visual and audio content, AI can generate visual aids like charts, graphs, and diagrams to produce audio explanations for students. Next, AI can also create educational games that are tailored to the curriculums, making learning more engaging and fun for students with the preferences for interactive learning. Well, generative AI in education has the potential to create more personalized, engaging, and effective learning experience for students while also supporting teachers with the tools they need to enhance their teaching. Next, what is the Gaussian mixture model and how is it used in generative AI? A Gaussian mixture model is a probabilistic model used in generative AI. It assumes that data points arises from a combination of multiple Gaussian distribution. The image visualizes the concept, and the first shows a single Gaussian distribution, the second shows a mixture of two Gaussian distributions, and the third row shows data points generated from various Gaussian mixture model configuration. Well, it is valuable in generative AI for tasks like clustering, density estimation, and generating synthetic data. The graph demonstrates data generation using a Gaussian mixture model. After training on a dataset, it can create a new data points by sampling from a learned Gaussian distribution. The graph compares a theoretical normal distribution to data points generated through Monte Carlo sampling from this distribution, showcasing the accuracy of the generated data in capturing the underlying distribution. This technique is crucial in generative AI for tasks like creating synthetic data that resembles real-world data. Next question is, can you describe the concept of a transformer model? The transformer model is a type of deep learning architecture that has transformed the field of natural language processing and more recently has been adapted to other domains like computer vision, introduced in the paper Attention is All You Need in 2017. The transformer model moved away from traditional recurrent neural networks and convolutional neural networks by relying entirely on a mechanism called self-attention. And this graph shows the increasing number of the model parameters in generative AI models over time. As the number of parameters grows, these models gain the capacity to process and learn from more complex data, leading to enhanced performance in tasks like text generation and image synthesis. However, this increase in parameters also comes with challenges such as increased computational cost and the risk of overfiltering, where the model performs well on training data but poorly on new unseen data. The next question is, what are model parameters and how do they affect the performance of generative AI models? Model parameters are crucial components of generative AI models that significantly influence their performance and output quality. These parameters are the internal settings that a model learns from the training data and uses to make predictions, generate content, or perform specific tasks. Process of optimizing model parameters in generative AI starts with importing training data and initializing the model's parameters. An optimization mechanism is then applied to the train and update the model's parameters iteratively. This process continues until the defined closing conditions are met. Finally, the optimized parameters are obtained, which are crucial for the model's performance in generating realistic outputs. Model parameters influence the content generation process, impacting the output quality. These parameters are crucial for feature learning, enabling the model to identify and utilize patterns in the data to generate realistic and meaningful outputs. And the next question is, how can generative AI be leveraged to create personalized experience for users in e-commerce? Generative AI can significantly enhance personalized experience in e-commerce by tailoring content, recommendations, and interactions to individual users. Here's how it can be leveraged. First, in personalized product recommendation. AI-powered recommendations personalize product suggestions by analyzing individual user data. By understanding browsing history, purchase patterns, and preferences, AI algorithms recommend products aligned with user interests, enhancing the shopping experience and driving sales. Next, customized marketing campaigns. AI enables personalized email marketing by analyzing user data to generate targeted content. By delivering messages with relevant products and promotions tailored to individual interest, AI enhances campaigns' effectiveness, increasing engagement and driving conversions. Next, tailored product descriptions and reviews. AI personalizes product descriptions by analyzing user data to highlight features most relevant to them. This enhances the shopping experience and increases purchase likelihood by providing targeted information. Next, virtual assistants and chatbots. AI-powered chatbots function as virtual shopping assistants. They provide personalized product recommendations, answer user queries, and guide them through their shopping journey based on individual preferences. Next, visual search and augmented reality. AI-driven visual search allows users to upload images of derived products. The AI then generates suggestions for similar items available in the e-commerce store, offering a highly personalized search experience. And by leveraging generative AI, e-commerce platforms can create a deeply personalized shopping experience that not only enhances customer satisfaction but also increases engagement, loyalty, and conversion rates. And with this, we have come to an end to this full course on generative AI. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.